All right, let's take a look at our quiz. For the first question, we're asked to solve each equation. We are given 4 times the absolute value of x squared, then minus 3x, then minus 2. Then we're going to have plus 2, and this equals 10. All right, so the first step here is just to isolate the absolute value operation. So I want this on one side by itself, and then I want a single number on the other side. So let's subtract 2 away from each side. This will cancel. We'll have 4 times the absolute value of x squared minus 3x minus 2. And this will be equal to 10 minus 2 is going to be 8. Now, I still haven't isolated this guy, right? So to do that, you notice that 4 is multiplying it. So I'm just going to divide both sides of the equation by 4. That way I can cancel this with this. And so now I have the absolute value of x squared minus 3x minus 2. So that's isolated on one side. And this now equals 8 divided by 4 is going to be 2. Okay, so once we have it in this form, basically you want to just drop the absolute value bars for the first case. So we would say x squared minus 3x minus 2 is equal to 2. Then we're going to say or. For the second case, you're going to drop the absolute value bars. So x squared minus 3x minus 2 is equal to, this 2 here, you're just going to make it into its opposite, so it's just going to be negative 2. So now we'll just solve each part separately. And let's start with this one on the top. So you have x squared minus 3x minus 2 is equal to 2. What I can do here is just subtract 2 away from each side. So this will be 0 over here. So I'll have x squared minus your 3x. Negative 2 minus 2 would be negative 4, so minus 4, and this equals 0. Now, is this something I can factor? Can you give me two integers whose sum is negative 3 and whose product is negative 4? Well, yeah, you could do negative 4 and positive 1. So you could do x minus 4 times x plus 1, and this would be equal to 0. So here, your solutions would be what? X minus 4, if you set that equal to 0 and solve, you get x equals 4. So x is 4. And then also, if you did x plus 1, set that equal to 0, you get x equals negative 1. So far, we have x equals 4 or x equals negative 1. But that's not the whole story because we have that other equation to solve. So let's just take this for now. And I'm just going to come back up here and put that there, and I'll put a comma, and we can get rid of this guy. We've already solved it, and let's just work on this guy now. So you have a negative 2 here and a negative 2 here. So again, if you have the same thing on each side of an equation, you can just get rid of it. You could also show this by just adding 2 to both sides, and so it's going to cancel in each case. So we'll say this is x squared minus 3x is equal to 0. You can solve this by factoring immediately. So you can say that this is x times a quantity, x minus 3. We'll set this equal to 0. So for this one, x would be set equal to 0. Then or your x minus 3 would be set equal to 0. So here you would get x is equal to 0. And then or if you add 3 to both sides, you get x is equal to 3. So let's grab these two other solutions. Let's come back up here. And I'm just going to add these in like this. We'll get rid of this. So this is what we're looking for. It might not be in this order. But let's see if we can find it. So we want x is equal to 4 and then negative 1. 0, and then 3. So this is not what we want. We want this one right here. So x is 4, you have negative 1, 0, and 3. So this is what we want right here. All right, let's take a look at question number 2 now. So again, we're asked to solve each equation, and we have 3 times the absolute value of 4x squared, then plus 19x. Then we have minus 1 outside, and this equals 14. Okay, so once again, I am trying to isolate this absolute value operation on one side of the equation, and I'm trying to get a single number on the other. So let's add 1 to both sides of this equation. Let's cancel this. We'll say this is 3 times the absolute value of 4x squared plus 19x, and this equals 14 plus 1 is 15. Okay, I still want to, again, isolate this guy. So you have 3 that is multiplying this, so I'm going to divide both sides by 3. Just so that this will cancel away. We're going to have the absolute value of 4x squared plus 19x, and this equals 15 divided by 3 would be 5. Once you have it into this form, this is a positive number here. So I'm just going to say 4x squared plus 19x is equal to 5. Then or you have 4x squared plus 19x is equal to, again, the negative of this, so negative 5. Okay, so for the top one, let's write 4x squared plus 19x. I'm going to subtract 5 away from each side, so this is minus 5, and this equals 0. So for this one, you might want to jump straight into the quadratic formula. I haven't tried to factor it yet, so I don't know if it's going to work out, but we can try it real quick. Again, if you don't want to waste time, you can just immediately go into the quadratic formula. 4 is 1 times 4, or it's 2 times 2, right? So you have to check things. Now, this is a minus here, so I know I have mixed signs, and I know I'm going to subtract. In terms of absolute value, I'm trying to get to 19. So can we do that? Well, if you put a 4x here and an x here, again, just put a 5 here and a 1 here. And I think we can make that work because this is going to be 20x, and this is going to be x. So if I make this a plus and this a minus, well, yeah, this would be plus 20x, and this would be minus x. That gets me to 19x. So this is what I'm looking for. Okay, let's go ahead and just say that 4x minus 1 would be equal to 0. Then or x plus 5 is equal to 0. Let's add 1 to both sides of the equation. This cancels. You get 4x is equal to 1. Divide both sides by 4. This cancels. So x is 1/4. So let's start with that. X is 1/4. X is equal to 1/4. Then here I would just subtract 5 away from each side of the equation. So also x could be negative 5. Okay, so what I'm going to do is just grab these. We'll just paste these up here, and we'll go back down. And I'm just going to get rid of this. We don't need this anymore. So this one right here, I'm just going to tell you in advance is not going to factor. So we're just going to add 5 to both sides. This will cancel and give me 0. So this is 4x squared plus 19x. Make this 5 a little bit better here. So plus 5 is equal to 0. So I'm just going to use the quadratic formula. So this is my a, this is my b, and this is my c. So we'll say that x is equal to the negative of b. So this is negative 19. Then plus or minus the square root of b squared. So what is 19 squared? That's going to give me 361. Then minus 4 times a, which is 4, times c, which is 5. Now, 4 times 5 would be 20. I would do that first. And then 20 times 4 is 80. So basically, this is minus 80 here. And if you want to just do this, 361 minus 80, that's going to be 281. So think about simplifying that in a moment. So let's put this over. We have 2 times a is 4, so this is over 8. Can I simplify the square root of 281? Well, it turns out that 281 is a prime number, so this is as good as we can do. So x will just be equal to negative 19 plus or minus the square root of 281 over 8. So coming back here, let's get rid of this, and I'll just put a comma here. And so I'm looking for this answer right here. I'm just going to circle it. Essentially, you have x is 1/4, then also negative 5, and then you have negative 19 plus the square root of 281 over 8, and then also negative 19 minus the square root of 281 over 8. All right, let's take a look at question 3 now. So we want to solve each equation. We are looking at 11 times the absolute value of 27x squared, then plus 3x, then we have minus 5, and this equals 17. Okay, what I'm going to do first, again, since I'm trying to isolate this absolute value operation, I'm going to add 5 to both sides of this equation. This will cancel. We're going to have 11 times the absolute value of 27x squared plus 3x. This will be equal to 17 plus 5. That's going to be 22. From here, I'm going to divide both sides of the equation by 11. So this will cancel. And I'm going to have the absolute value of 27x squared plus 3x. And this will be equal to 22 divided by 11 is 2. Now from here, I'll just basically say that 27x squared plus 3x is equal to 2. And then or, we'll say 27x squared plus 3x is equal to negative 2. Okay, let's start on the top one. So we'll say that 27x squared plus, we have 3x, and then I'm going to subtract 2 away from each side. So then minus 2, and this equals 0. Now, can you solve this with factoring? I don't know. I haven't tried this one yet. But let's just go ahead and set this up. Again, if you want to skip this and just use the quadratic formula, it's up to you. So I think that 27 and 1, that's likely not going to work. So I would start with 9x and 3x. And I know that this is a minus here, right? So that means I have mixed signs. It also means I want to subtract. In terms of absolute value, I want to get to 3. So for 2, it's just 1 times 2. So let's start with 2 here and 1 here. Now that's going to be 18 minus 3, which is 15. So that's not going to work. You could put the 1 here and the 2 here. Now this one would be 9x, and this one would be 6x. Now, what I could do is say this is plus and this is minus, and that would be plus 9x and then minus 6x. 9x minus 6x would be 3x, so this is what I'm looking for. Okay, so we want 9x minus 2 is equal to 0, then or we want 3x plus 1 is equal to 0. Let's add 2 to both sides of the equation. This will cancel. We'll get 9x is equal to 2. Let's divide both sides of the equation by 9. This cancels. We get x is equal to 2/9. Over here, let's subtract 1 away from each side. This cancels. You get 3x is equal to -1. Divide both sides by 3. This cancels. So x could also be -1/3. Okay, so coming back up here, I'll just drop this off. Okay, so coming back up here, let me get rid of this one. We no longer need it. I'm just going to add 2 to both sides. So let me just say that this is plus 2, and this equals 0. And this one I'm going to tell you in advance can't be factored. So we're just going to use the quadratic formula. So this is a, this is b, and this is c. X is equal to the negative of b, so the negative of 3, plus or minus the square root of b squared. So 3 squared is 9. Then minus 4 times a is 27, times c is 2. So this is going to be pretty big. Let's do that in a moment. So this is over 2 times a is 27. So 2 times 27, that's going to give me 54. So we have x is equal to -3, then plus or minus the square root of. So here, let's do 4 times 27. That's 108. Then times 2, that would be 216. So let's just say that we have 9 minus 216. And that's going to be -207. Okay, then this is over 54. Let me make this 0 a little bit better. Now, can we simplify this? Yeah, it turns out that 207, if you go 2 plus 0 plus 7, that's 9. So we know that this is divisible by 9. It turns out it's 9 times 23. So let's say this is -1 times 9 times 23. And so we'll say x is equal to, we'll go -3, then plus or minus, I'm going to say the square root of 9 is 3. And then the square root of -1 is I, and then times the square root of 23. And this is over 54. Now we're not done because 54 is divisible by 3, and you have a 3 here and a 3 here. So we could do some factoring. So let's say this is x is equal to, I'll pull a 3 out, so this will be -1 plus or minus I times the square root of 23, and then this would be over, this is 3 times 18. So this is going to cancel with this. X is equal to, we have -1 plus or minus I times the square root of 23, and this will be over 18. So this would be our answer. All right, so let's put this up here. I'm just going to erase that, put a comma here, fit this in the best that I can. So I'm not looking for this one. I'm looking for this one. So it's the second one that I want. So you want x equals 2/9, and then -1/3. And then you have -1 plus I times square root of 23 over 18. And then -1 minus I times square root of 23 over 18. All right, let's take a look at question 4 now. So again, we want to solve each equation. And we'll have the absolute value of 2x squared, then -1, and this is equal to the absolute value of x minus 5. Okay, for this scenario, you're just going to drop the absolute value bars. So we'll say 2x squared minus 1 is equal to x minus 5. Then we'll say or. You're going to drop the absolute value bars again. So we'll say 2x squared minus 1 is equal to x minus 5. In this second scenario, just pick one of these guys and make it into its opposite. So it doesn't matter which one you do. I always pick the one on the right, so wrap it with parentheses and put a negative out in front. And basically, you're just going to solve these two equations. That's all you have to do. So I'm going to grab this, and let's come over here. I'll start with the top one. So we have 2x squared minus 1 is equal to x minus 5. And so let's subtract x away from each side, and let's add 5 to both sides. So let's say this is 0 over here. So we'll have 2x squared, then minus x, and then -1 plus 5. That's going to be plus 4, and this equals 0. Now, I've already worked this problem, so I know this doesn't factor, so I'm not going to put you through trying to factor it. I'm just going to say that we need to use our quadratic formula. So we'll say that this is a. We'll put a -1 there. That'll be b, and then this will be c. So x is equal to the negative of b. So b is -1. So the negative of -1 is 1. Then plus or minus the square root of, you have b squared. So -1 being squared is 1. Then minus 4 times a is 2, times c is 4. This is all over 2a is 2, so 2 times 2 is 4. Now under my square root symbol, you could go 4 times 2, that's 8, and then 8 times 4 is 32. So this would be 1 minus 32, which is going to be -31. Now, basically, the only thing you can do here is pull out that square root of -1 and say this is I times square root of 31 there. But you really can't do anything else. So here we get x equals 1 plus or minus I times square root of 31 over 4. So I'm just going to throw this up here and put a comma. Okay, so coming back here, let me get rid of this. And I'm just going to solve this. So we have 2x squared minus 1 is equal to, you'll have negative x and then plus 5. Okay, let's get rid of this and drag this up here like this. So what I want to do first is just add x to both sides. Let me just put this over here. And I'll subtract 5 away from each side. This will cancel, give me 0. So we'll have 2x squared and then plus x. -1 minus 5 is -6, and this equals 0. Now this is one that you can factor. So I'm just going to set this up like this, and I'll say that this is 2x and this is x. And then let's say that this is a negative right here, so I know I'm going to have mixed signs. That also means I'm going to subtract. I'm trying to get to 1 in terms of absolute value. So what could I do? For 6, it's 1 times 6, or it's 2 times 3. Well, if you did 1 times 6, you can't put the 6 here, so you'd have to put it here, right? So you'd have to go like this, and this is going to be 12 minus 1, which is 11, so that doesn't work. You can't flip it around because if you put a 6 here, you'd have a common factor of 2. There's no common factor of 2 up here. Okay, so now you have 2 and 3. So you can't put the 2 here, but you can put it here, and you can put the 3 here. Let me make that 2 better. So for this one, you would have 4 minus 3, which would be 1. So let's make sure we put this as a plus, and this is a minus. So this will be 4x, and then this will be negative 3x. 4x minus 3x is x, or you could say 1x. Okay, this is what we're looking for here. So we want to say 2x minus 3 is equal to 0, then or x plus 2 is equal to 0. Let's add 3 to both sides of the equation. We'll cancel this. We have 2x is equal to 3. Divide both sides by 2. Let's cancel that. We'll say that x is equal to 3 halves. I'll put a comma. Here you could just subtract 2 away from each side. Let me show that real quick. We go minus 2 and then minus 2. This cancels. So x would also be negative 2. So let's grab this. So coming back here, let me just get rid of this part right here. So you see we have 4 answers. So x could be 1 plus I times square root of 31 over 4. Or it could be 1 minus I times square root of 31 over 4. Or it could be 3 halves, or then negative 2. So this is the one we want right here. Again, x could be 3 halves, or negative 2, or 1 plus I times square root of 31 over 4, or 1 minus I times square root of 31 over 4. All right, let's take a look at question 5. So we want to solve each equation. We're going to have the absolute value of 12 over x minus 3. This is set equal to the absolute value of 6 over x plus 9. All right, so we basically have 2 scenarios. And so the first scenario is just to drop the absolute value bars. So we have 12 over x minus 3 is equal to 6 over x plus 9. The other scenario is going to be to drop the absolute value bars. So you have your 12 over x minus 3 is equal to 6 over x plus 9. Just pick one of these guys and make it into its opposite. Now, because you have a rational expression here, you can either put the negative up here or put it down here. But if you put it down here, make sure you wrap this. Okay, that's very important. Just to keep it simple, I'm just going to put it up here. And I'm just going to put or right here. And we're going to grab this. To solve this, we're just going to cross multiply. You might want to note that your domain is the set of all x such that x is not 3 or negative 9. Again, you can write that out. I don't know if you need it or not. But let's just put it here for the sake of completeness. Set of all x such that x is not equal to, again, 3, which is found by setting x minus 3 equal to 0 and solving, or negative 9, which is found by setting x plus 9 equal to 0 and solving. So these are the 2 restricted values. Okay, so cross multiplying here, you're going to get 6 times the quantity x minus 3 is equal to, this would be 12 times the quantity x plus 9. Now you could distribute here, but I would divide both sides by 6 first. I think that would make it easier. This is going to be x minus 3 is equal to 12 divided by 6 is 2. So 2 times x is 2x, and then plus 2 times 9 is 18. Let's subtract 2x away from each side of the equation. Let's add 3 to both sides of the equation. Let's cancel this and cancel this. X minus 2x is negative x, and this equals 18 plus 3 is 21. So basically at this point, you could just divide both sides by negative 1. This negative would cancel with this negative 1. And so 21 over negative 1 is negative 21. So we'll say x is equal to negative 21. So that's one solution. So coming back up here, I'm just going to put x is equal to negative 21. I'll put a comma. All right, so coming back up here, I'm going to get rid of this one, and we'll just work on this one now. Okay, so once again, I'm just going to cross multiply. So this times this is equal to this times this. So 12 times the quantity x plus 9 is equal to negative 6 times the quantity x minus 3. And let me get rid of this right there. So what I would do again is just divide both sides of the equation by, you could do negative 6 or positive 6. Let me just do positive 6. I think that's maybe easier. And so this would cancel and give me 2. And so this would cancel and give me a negative 1. Okay, so don't forget the negative 1 there. So 2 times x is 2x, and then plus 2 times 9 is 18. This equals, again, this is a negative 1 that's going to multiply by each. So negative 1 times x is negative x, and then negative 1 times negative 3 is positive 3. Okay, from here I'm going to add x to both sides of the equation, and then I'm going to subtract 18 away from each side of the equation. This will cancel, and this will cancel. 2x plus x is going to be 3x, and this equals 3 minus 18 is going to be negative 15. We'll divide both sides of the equation by 3. We'll find that x is equal to negative 5, right? I'll show this is canceling. So coming back up, I'll just put this negative 5 in the mix. So x equals negative 21 or negative 5. So we want this guy right there. All right, let's take a look at our quiz. For the first question, we're asked to solve each equation. And we have the absolute value of 10, x plus 3, and then minus 8, and this equals 5. All right, when we're solving an absolute value equation and we have an absolute value nested inside of another one, you're going to consider the outer guy. So consider this guy right here. And again, we just say that the absolute value of some algebraic expression u, in this case, that algebraic expression would be the absolute value of 10x plus 3, then minus 8. This is equal to some positive number. Let's just use 5. Well, here u is equal to 5, or u is equal to negative 5. In other words, if I replace this guy right here with either a 5 or a negative 5, when I take the absolute value, I get 5 in each case. So that's what we're going to do to solve this guy. I'm just going to take this absolute value of 10x plus 3, and then minus 8. Let's make this 3 a little bit better here. And we'll set it equal to 5. Then we'll say, or the absolute value of 10x plus 3, and then minus 8 is equal to negative 5. So to solve this guy on the left, we would first want to isolate the absolute value operation. So I'm going to just add 8 to both sides of the equation. This will cancel. We'll have the absolute value of 10x plus 3. This is equal to 5 plus 8 is going to be 13. Then we'll say or. Over here, I'm going to do the same thing. So let me isolate this guy. So we'll have the absolute value of 10x plus 3 is equal to, let's add 8 to both sides. And basically, negative 5 plus 8 is going to be 3. Let me show that as canceling. So we have 2 equations to solve here. So we're going to end up with 4 solutions. And let's first say, again, this is isolated here, and it's equal to some positive number. So basically, you take what's inside. You say the 10x plus 3 is equal to 13. Then or you have 10x plus 3 is equal to negative 13. Okay, so that's the setup. We'll come back and do this one in a moment. And let's just say we're going to subtract 3 away from each side. This cancels. You get 10x is equal to 13 minus 3 is 10. Divide both sides by 10. This cancels. And you get 10 over 10 is 1. So we'll say x is equal to 1. So let me get rid of this. And I'm just going to put that x is equal to 1. And then over here, let's subtract 3 away from each side. This cancels. You get 10x is equal to negative 13 minus 3 is negative 16. Let's divide both sides of the equation by 10. This cancels. And so let me actually erase this so I can write this up here. I'm actually just going to get rid of this. We'll say that it's negative 16 over 10. That's negative. 16 divided by 2 is 8. And then 10 divided by 2 is 5. So it's negative 8/5. Okay, so that's only one guy. Let me actually erase this at this point. And I'm just going to paste this in here for now. So here, again, I would just set what's inside of the absolute value bars equal to 3. Then I would say, or it's equal to negative 3. So 10x plus 3 is equal to 3. Then or 10x plus 3 is equal to negative 3. Here you have 3 on each side, right? So if I subtract it away, basically this right-hand side is going to be 0. Over here, it's going to go away. Let me show that. So minus 3 over here, minus 3 over here. This cancels and this cancels, so this is 0. You get 10x is equal to 0. Divide both sides by 10, and you're going to get x is equal to 0. So that's one solution. So let's put x is equal to 0 here. And then over here, let's subtract 3 away from each side. We'll cancel that away. We'll say 10x is equal to negative 3 minus 3 is negative 6. Divide both sides by 10. This cancels. And you get x is equal to, Again, if you think about this, we know it's negative. 6 is 2 times 3, and 10 is 2 times 5. So if I cancel a common factor of 2, I'll go ahead and say this is negative. 6 divided by 2 is 3, and 10 divided by 2 is 5. So negative 3/5. And let me paste this in here. And I'm just going to put a comma and put 0, and then a comma and negative 3/5. And this might not be in the same order. We're just going to look through our solutions. It looks like it's going to be this one right here. So we have x is equal to negative 8/5. That's coming from right here. Negative 3/5. That's from right here. Then 0, which comes from right here. And then 1, which comes from right here. So that's going to be our solution. All right, let's take a look at question 2. So here we want to solve each equation. So we have the absolute value of, you have the absolute value of 3x minus 4. Then we have minus 7, and this equals 1. Okay, so again, the idea here is you're going to think about the outer guy here. And you would say the absolute value of some algebraic expression u, in this case, the algebraic expression, is the absolute value of 3x minus 4, then minus 7. If that was equal to some positive number, let's just say 1, then u equals 1 or u equals negative 1. So you see the setup. Let me grab this and go to another page. We can't fit it here. And so let's just set this up as the absolute value of 3x minus 4, then minus 7 is equal to 1. Then we'll say or, let me slide this over. We'll say the absolute value of 3x minus 4, then minus 7 is equal to negative 1. So let me just work on this one first, and then we'll come back to this one. So you want to isolate the absolute value operation, so I would just add 7 to both sides. This would cancel. You get the absolute value of 3x minus 4 is equal to 1 plus 7 is 8. So again, we're going to split this up and say that what's inside the absolute value bars, the 3x minus 4, could be equal to 8, or 3x minus 4 could be equal to negative 8. So I'd add 4 to both sides of the equation here. This cancels. You get 3x is equal to 8 plus 4 is 12. Divide both sides by 3. This cancels. You get x is equal to 4. Let me just write that over here. X is equal to 4. And I'm going to get rid of this just so we have some room to work. Let me add 4 to both sides over here. This cancels. You get 3x is equal to negative 8 plus 4 is going to be negative 4. Let's divide both sides of the equation by 3. This cancels. And I'll also put here that x could be negative 4/3. So let me get rid of all this. Come up here. I'm just going to paste this in, put a comma, and we'll be back. So again, I want to isolate the absolute value operation on one side. Let's add 7 to both sides of the equation. This cancels. So the absolute value of 3x minus 4 is equal to negative 1 plus 7 is going to be 6. So this right here is going to split up into 3x minus 4 is equal to 6, or 3x minus 4 is equal to negative 6. So let's add 4 to both sides of the equation. We'll cancel this. We'll say 3x is equal to 6 plus 4 is going to be 10. Let's divide both sides of the equation by 3. This cancels, and we get x is equal to 10/3. Okay, over here, let's add 4 to both sides of the equation. This cancels. We're going to say 3x is equal to negative 6 plus 4 is going to be negative 2. Let's divide both sides of the equation by 3. So we'll cancel this and say x could also be negative 2/3. So let's grab this. Okay, we'll come back here. I'll just put this in. So 10/3 and then negative 2/3. Okay, so let's get rid of this. Let's look for our answer. So again, it's not necessarily going to be in this order. It looks like it's going to be this one down here. So you have x equals negative 4/3. That's coming from here. Negative 2/3. That's coming from here. 10/3. That's coming from here. And then 4, which is coming from here. All right, let's take a look at question 3. So we want to solve each equation. So we have the absolute value of x minus 5, then plus the absolute value of 2x minus 3, and this equals 10. All right, so we know at this point when we want to solve something like this, we can't use our general strategy for easier equations with absolute value. We have to actually split this up into cases and do a lot more work. So what I'm going to do is think about where this expression here, the x minus 5 that's inside of the absolute value bars, where is that equal to 0? Where is it positive? And where is it negative? So we have x minus 5 is equal to 0. Let's add 5 to both sides. We would say x is equal to 5. Okay, so that's one guy that I'm looking for. The other guy is going to be inside of here. So this is 2x minus 3. So let's say 2x minus 3 is equal to 0. And if I add 3 to both sides, this cancels. Let me make that 3 better. And we would say 2x is equal to 3. Divide both sides by 2. And the other guy is going to be x is equal to 3 halves, or you could say 1.5 if you wanted to use a decimal. Okay. So this is going to allow us to split the number line, or you could say the table here, up into these different regions. Okay. So you take the leftmost value, in this case, that's 3/2, right? Because that's smaller than 5. And you're going to make an interval that's strictly less than that. Okay, so we would say coming from negative infinity, going up to and excluding 3/2. So this is always excluded here. Okay. Now you're going to make one that's between these. If you want to include 3/2, again, I talked about this in the practice test because a lot of people were confused on this. You can include this here. It's fine if you want to do that. So 3/2 and then 5. But my preference is to do it this way and to always exclude it and to think about these numbers here, what we call the breakpoints, separately. Okay, so I'm just going to show it both ways so that nobody's lost, and that if you want to do it this way, which is easier for a lot of students, it's completely fine. It's the same answer. So then you want to have something that's greater than 5. So let me do it this way for some of you, and then I'll do it this way for myself. Okay, so we want to think about, again, in this interval here, everything is negative, right? So if I want to drop the absolute value bars, I need the negative of this, and I need the negative of this, okay? So if I put a negative out in front of this x minus 5 quantity, it's negative x and then plus 5, okay? Just distributing that in. Let me put this up here. Now we know that in this interval, whether the 3/2 is included or not, it's still going to be less than 5, right? So 5 is not included here, so I know that this guy is still negative. So I'm going to put negative x and then plus 5. Now in this interval, whether you include the 5 or not, you're just going to drop the absolute value bars, right? So if it was 0 or some positive number, you would just take what's inside as your answer, right? So I could just say this is x minus 5. Okay. Now for the next one, we have the 2x minus 3. So here it's negative. So the negative of 2x and then the negative of negative 3 is plus 3. So I'm just distributing a negative to each term there. And then here, again, whether it's included or not included, this guy here, I could just drop the absolute value bars. It's 2x minus 3. And then here it's positive, so I could just say it's 2x minus 3. Okay. So this is what we're going to use to build our equation. We're going to basically replace this guy here with this guy or this guy or this guy. And then we're going to replace this guy here with this guy or this guy or this guy, just depending on which interval we're in, okay? And we're going to see the solution that we get, and if it's in that interval, we can accept it, and if it's not, then we will reject it. So let's build our equation. Let me just copy this and come down here. Unfortunately, some of this is going to get cut off. So let's write this. Again, I'm replacing this with this, so negative x plus 5. Then plus, I'm replacing this with this, so negative 2x plus 3, and this equals 10. So negative x plus negative 2x would be negative 3x. 5 plus 3 is 8, and this equals 10. Let's subtract 8 away from each side. We'll cancel this. We get negative 3x is equal to 10 minus 8 is going to be 2. Let's divide both sides by negative 3. And you're going to get that x is equal to negative 2/3. So coming back, let me just write this right here. So x is equal to negative 2/3. So you want to think about, is this in this interval? Yeah, negative 2/3 is less than 3/2, so I can accept this solution. Okay, so now I'm going to move on to the next interval. I'm going to do the exact same thing. I'm going to replace this with this, and I'm going to replace this with this. Okay, that's all I'm doing. So we'll have negative x plus 5, again for this. Then plus, we'll have 2x minus 3 for this, so 2x minus 3. And this equals 10. So if we see 2x minus x, that's just going to be x. And then 5 minus 3 is going to be 2. So x plus 2 is equal to 10. Subtract 2 away from each side. This cancels. You get x is equal to 10 minus 2 is going to be 8. So let's put up here x is equal to 8. Now, is 8 in this interval? This is between 3/2 and 5. Or again, if you wanted to include 3/2, that's fine. It's still not going to be in there. Either way, this has to be rejected, right? It has to be in that interval for you to accept it. So the next one is either including 5 out to infinity or excluding 5. Again, whatever you want to do. And I'm just going to drop the absolute value bars in this case. I'll just have x minus 5 and then plus 2x minus 3, and that equals 10. So since this is the last one, let's just get rid of this. We'll just solve it. X plus 2x is 3x. Negative 5 minus 3 is going to be negative 8. And this equals 10. Let me get rid of this so we have some room. I'm going to add 8 to both sides. This cancels. You're going to get 3x is equal to 18, right? 10 plus 8 is 18. Divide both sides by 3, you get x is equal to 6. When we come back here, if I put x equals 6, I'm going to accept that solution, right? It's in this interval. So the answer here would be x equals negative 2/3, then or x equals 6. Okay, so coming back, I want to circle this one, x equals 6 or x equals negative 2/3. All right, let's take a look at question 4. So here we want to solve each equation. We have the absolute value of 7x minus 5 then minus the absolute value of 4x minus 1, and this equals 12. So once again, I'm going to come down to a little table, and I'm going to think about where this guy is 0, negative, or positive, right? And the same thing for this one. So we have 7x minus 5. Let's just set it equal to 0. We'll add 5 to both sides. This will cancel. You get 7x is equal to 5. Divide both sides by 7. And you get x is 5/7. So x is 5/7. Let me make this better. Okay, the other guy, we're going to go 4x minus 1 is equal to 0. So I might as well just say 4x is equal to 1, right? Add 1 to both sides. Divide both sides by 4. And you're going to get x is equal to 1/4. This one is smaller. So I'm going to say, coming from negative infinity, going up to and excluding 1/4. And again, with 1/4, you can include it or you can exclude it. So I'm going to do it both ways. So 1/4 would be included here, and then I'm going to exclude 5/7 here, and then I'm going to exclude it in both cases here. And again, you just use whichever one you want, okay? Then for this one here, we're going to say that you could include 5/7 if you wanted to. So this is out to positive infinity, or you could exclude it like I'm going to do. Again, I'm just showing you both ways because people get confused if I just do it the normal way that I do it. Okay, so coming through here, again, in this interval, they're both negative, right? So I want the negative of the quantity 7x minus 5. So that's negative 7x and then plus 5. This guy's negative, so I want a negative 4x and then plus 1. Again, just distributing a negative to each. Now in this interval, this guy here is still negative. So I want negative 7x plus 5. And then this guy right here is either going to be non-negative if you choose this one, or it's going to be positive if you choose this one, right? Either way, you just drop the absolute value bars. So you get 4x minus 1. Here in this interval, it would be positive, so it's 4x minus 1. Okay, just drop the absolute value bars. Now in this interval, this guy, again, is either non-negative if this is included, or it's positive if it's not included. So I'm just going to drop the absolute value bars either way. So it's 7x minus 5. Let me paste this in here. And again, in each case, I'm just replacing this guy right here with this guy right here, and this guy right here with this guy right here. Be very careful because you have a minus sign there. So anything you make a replacement with, make sure you wrap it with parentheses. So the first one, I'm replacing it with negative 7x plus 5, then minus. I'm going to put this in parentheses, this negative 4x plus 1, and this should be equal to 12. All right, from here I have negative 7x, and then plus 5. This negative gets distributed to each. So this is plus 4x and then minus 1, and this equals 12. So negative 7x plus 4x is going to be negative 3x. So negative 3x, and then 5 minus 1 is 4. So plus 4, and this equals 12. So I'm going to subtract 4 away from each side. We'll cancel that. We get negative 3x is equal to 12 minus 4 is going to be 8. Divide both sides by negative 3. And we're going to say that x is equal to negative 8/3. Now the interval was anything less than a fourth, right? So this is definitely less than a fourth, so we can accept this solution. So let me write this in here. X equals negative 8/3. And again, we are going to accept this solution. In this interval here, we're looking for between 1/4 and 5/7. So let's say I'm going to replace this with this. So negative 7x plus 5, and then minus. Again, you have to be very careful here. This minus here will throw a lot of people off. So wrap this in parentheses. This 4x minus 1, I need to subtract the whole thing away. And this equals 12. So we have negative 7x plus 5. And then this negative gets distributed to each. So this is minus 4x and then plus 1. And this equals 12. So here we have negative 7x minus 4x. That's negative 11x. And then 5 plus 1 is going to be 6. And this equals 12. So let's subtract 6 away from each side. We'll cancel this. We get negative 11x is equal to 12 minus 6 is going to be 6. We'll divide both sides by negative 11. And we're going to cancel this and say that x is equal to negative 6/11. Now, is that a valid solution? If we come back up and we say x equals negative 6/11, well, that's not in this interval. Either this one or this one, however you choose to set it up. So this is going to get rejected, right? So that's not valid. Now for this one, again, we're just dropping the absolute value bars, but you still have to be careful here because you have this minus out in front, right? It's minus the absolute value of this guy, right? So if you're replacing this with the quantity 4x minus 1, you have to wrap this with parentheses, okay? This, again, throws a lot of people off. You have to be very careful. So this is 7x minus 5, then minus the quantity 4x minus 1 equals 12. So 7x minus 5, then minus 4x, then plus 1 equals 12. So here, 7x minus 4x would be 3x. Negative 5 plus 1 is going to be negative 4, and this equals 12. We would add 4 to both sides. This cancels. We get 3x is equal to 12 plus 4 is going to be 16. Divide both sides by 3. This cancels. You get x is equal to 16 over 3. So x equals 16 over 3. Is that a valid solution? Well, this interval is either anything greater than or equal to 5/7 or anything greater than 5/7. Either way, 16 over 3 is 5 1/3, right? So that's clearly in this interval, right? So we're going to accept this solution. So I'll say here that x is equal to negative 8/3 or 16/3. So coming back, I want this answer here. Again, x equals 16/3 or negative 8/3. All right, let's take a look at question 5. So again, we want to solve each equation. We have 21x squared, then minus 13 times the absolute value of x, and this equals negative 2. So again, when you solve this, I like to make a little substitution. You don't have to. You could consider that x could be positive or it could be negative. You could do it that way. But what I'm going to do is actually just say that this guy could be replaced with the absolute value of x being squared, right? It's the same thing. So then I could let u be equal to the absolute value of x, and I could say this is 21u squared minus 13u, and then I'm going to add 2 to both sides, so plus 2 is equal to 0. So this is something I can solve using factoring, and then basically what I can do is say that whatever I get for u, I could set it equal to the absolute value of x, and I could solve. So what I'll do here is try to factor this first. So 21 is either 1 times 21 or 7 times 3. I don't think 1 times 21 would work. Let's try 7 and 3. So 7u and 3u. Now think about the fact that this is negative and this is positive, right? So I know this is negative and this is negative. And for 2, just think about it as 1 times 2. So if you put the 2 here, 7 times 2 is 14. So that's already going to be too big, right? And I'm thinking about this in terms of absolute value. So if I put the 2 here and the 1 here, this is 7 plus 6. That's going to give me 13. Again, I'm thinking about this in terms of absolute value. If you think about the signs, this is negative 7u, and this is negative 6u, and negative 7u plus negative 6u will get you that negative 13u that you want. So then we'll have 7u minus 2 is equal to 0, or 3u minus 1 is equal to 0. So I'll add 2 to both sides of the equation here. We'll cancel this. We have 7u is equal to 2. Divide both sides by 7. We'll cancel this. We get u is equal to 2/7. Over here, we'll add 1 to both sides. We'll cancel this. We get 3u is equal to 1. Divide both sides by 3. Cancel that. So u could also be 1/3. Okay, let me get rid of everything and clean up. Coming back up here, we remember that we let u be equal to the absolute value of x. So I could basically say the absolute value of x is equal to 2/7, or the absolute value of x is equal to 1/3. And this is very easy to get our solution at this point. If the absolute value of x is equal to 2/7, that means that x is equal to plus or minus 2/7. Then over here, same thing, right? The absolute value of x, if that's equal to 1/3, then it's just plus or minus 1/3. So coming back, I want this answer right here. So x equals 1/3, negative 1/3, 2/7, or negative 2/7. All right, let's take a look at our quiz. For the first question, we're asked to solve each inequality. And here we have the absolute value of x plus 1 is greater than the absolute value of 3x plus 1. All right, so once again, for these types of problems, you want to come to a little table, or you could use a number line. And essentially, you want to think about where the expressions inside of the absolute value bars are going to be negative or then 0 or positive. So in other words, if I set x plus 1 equal to 0 and solve that, I subtract 1 away from each side. I would cancel this, and I would say x is equal to negative 1. What that means is that at negative 1, this expression is 0. And then anything above negative 1 or anything greater than negative 1, this expression is positive. So if it's 0 or positive, I can just drop the absolute value bars and I don't have to do anything else. But if it's less than negative 1, this guy's going to be negative, and in order to drop the absolute value bars, I have to replace this guy with its opposite. So we're just going to write x equals negative 1 for right now, and then let me solve this one real quick, and then we'll make our table. So we have 3x plus 1. We'll set that equal to 0. Subtract 1 away from each side. We'll cancel this. We get 3x is equal to negative 1. Divide both sides by 3. This will cancel. You get x is equal to negative 1/3. So again, the way we think about this is at negative 1/3, this guy right here, this expression is 0. Anything greater than negative 1/3, it would be positive. So if it's 0 or positive, I can just drop the absolute value bars. If it was something that was less than negative 1/3, Well, then, if I drop the absolute value bars, I have to change this expression, this 3x plus 1, into its opposite. So thinking about how to set up the table, again, you take your leftmost value on the number line. -1 is to the left of -1/3. So I want to put that one all the way over here. I want to say this is coming from negative infinity, going up to and excluding -1. So everything here is going to be negative. Then here you're going to be between -1 and -1/3. But I'm going to include -1, and I'm going to exclude -1/3. Then here I'm going to include -1/3, and we're going to go out to positive infinity. So I have the whole number line covered. And essentially, a lot of people ask, why is this included here, but this excluded here? Well, let's go through and fill out the table, and maybe we can make some sense out of that. In this leftmost column, we know that both of these guys are negative. So basically, you wrap your expression in parentheses, so x plus 1, and you put a negative out in front. You wrap this one in parentheses, so the quantity 3x plus 1, put a negative out in front. Okay. When we get into this column here, the reason that the -1 is included is because this guy right here at -1 is 0. It also would be positive anywhere that it's greater than -1. So whether it's 0 at -1 or some positive value, well, I can just drop the absolute value bars. So that's one rule. So I can just put x plus 1 there. But the reason I don't include -1/3 is because at -1/3, this guy right here is going to be 0. Now, it's a different rule where it's 0 or positive versus when it's negative. So at -1/3, it's 0, but anything less, it's going to be negative. So I want a clear rule based on the interval I'm in. So I want the negative of the quantity 3x plus 1, because here I'm between -1 and including -1 and going up to and excluding -1/3. Okay, so that's what's important there. Now in this interval here, everything is non-negative. So this guy is actually positive. You can just put x plus 1. And this guy right here, again, if it's at -1/3, it's 0, or anything above that, it's going to be positive. Either way, it's the same rule. So I'm just going to put 3x plus 1. Okay, so hopefully that makes sense at this point in time. Essentially, you're just going to go through and set up 3 different inequalities based on your rule in each interval. When you solve them, you look to see if that solution lies in that interval. If it does, you can accept it. If it doesn't, then you need to reject it. Let's start off with this one. And we'll say here, if I'm dropping the absolute value bars, I'm replacing that with the negative of the quantity x plus 1. This is greater than, if I'm dropping the absolute value bars, I'm replacing that with the negative of the quantity 3x plus 1. Okay, one thing you could do is divide both sides here by -1. Remember, if you divide both sides by a negative, you have to flip the direction of the inequality symbol. So this is going to cancel now, this with this and this with this. And so you can just say that this is x plus 1 is less than 3x plus 1 like this. Now you have 1 on each side of the inequality. So what I can do is just subtract that away from each side. That's going to cancel. Let me write this over here. We'll have x is less than 3x. So for this, let me subtract x away from each side. And this is going to cancel. And you'll basically have 0 is less than 3x minus x is going to be 2x. I'll divide both sides by 2. And so basically you'll have 0 is less than, let's cancel this, and you're going to have x. So you could just say x is greater than 0 there. So coming back, if we write something like, let's say x is greater than 0, is this in this interval? No. This interval is anything less than -1. X is greater than 0 is not in that interval, so we're going to reject this. Okay, let's move on to the next interval. So here, we're going to see that we are between -1 and -1/3, where -1 is included and -1/3 is excluded. So for dropping this one, we just want x plus 1. This is greater than. For dropping this one, you want the negative of the quantity 3x plus 1. So that's -3x minus 1. Let's add 3x to both sides of the inequality. This will cancel. And then what I'll do is subtract 1 away from each side of the inequality. Let's cancel this. So x plus 3x is 4x, and this is greater than. -1 minus 1 is -2. Let's divide both sides of the inequality by 4. And we'll say that this cancels. X is greater than. We know this is negative. 2 over 4 is 1/2. So we get x is greater than -1/2. So let me write that in here. So x is greater than -1/2. When we think about it, we would say, is this in this interval? Well, yeah, -1 is actually to the left of -1/2. So we're okay there. But since this is a greater than, we're only going to go up to and exclude -1/3. So you have to stay in the interval when you put your solution. So I'm going to say that basically x is going to be greater than this -1/2 and less than this -1/3. Okay, so it's this interval here. Now we're going to solve this here, and we're going to see that we need to merge things. We'll get to that in a moment. So for this interval here where we include negative 1/3 and go out to positive infinity, basically everything here is non-negative, so either 0 or some positive value. So we could just drop the absolute value bars. So this is x plus 1 is greater than 3x plus 1. So I'm going to subtract 3x away from each side of the inequality. Let's subtract 1 away from each side of the inequality. So this cancels and this cancels. So let me put a 0 over here. This cancels. We'll have x minus 3x, which is negative 2x, and this is greater than 0. So here it's easy to make a mistake. We're going to divide both sides by negative 2. Remember, you need to flip the direction of the inequality symbol. So we're going to divide by negative 2 here and divide by negative 2 here. This cancels. This gets flipped. So x is less than 0. So if I wrote x is less than 0 here, again, I have to consider the interval that I'm in. Now, 0 is greater than this negative 1/3, so I'm okay there. But what you'd want to do is say that x is greater than or equal to negative 1/3, because that's the smallest guy here in this interval, and then we'll say it's less than 0. So this is what I'm talking about when we say we're going to merge these two together. When you think about the full solution, you're going to say that x is greater than negative 1/2. Let me get rid of this so I have some more room. I'm just going to slide this up. And we'll say, and it's less than negative 1/3, then or. Here you have x is greater than or equal to negative 1/3, and then we'll say and less than 0. So basically, because of this part right here, where the negative 1/3 is included, you can basically get rid of this part and say that x is going to be greater than negative 1/2 and less than 0. Okay, so that's your solution. Let me get rid of this. Actually put this like this, and we can grab this and come back up here and circle our solution. Again, x is greater than negative 1/2 and less than 0. So you can always think about this guy graphically. So the guy in red is going to be this part right here, this absolute value of x plus 1. The guy in blue is going to be this part right here, which is the absolute value of 3x plus 1. So where's the guy in red above the guy in blue? Well, only between here and here. And those guys where they're equal, the x value here is negative 1/2, and the x value here is going to be 0. So you can see that this piece right here is what we're interested in, right? That's where the red guy is above the blue guy, right? Not equal, but above. So that's going to be where x is greater than this negative 1/2 and less than 0. Everywhere else, the blue guy is above the red guy. All right, let's take a look at question 2. So here we're asked to solve each inequality. So we have the absolute value of x plus 5. This is less than the absolute value of 7x minus 1. All right, so once again, we know the deal. We're going to take x plus 5 and set that equal to 0. That's going to give me x is equal to negative 5. Let me just write x equals negative 5 right here. And then this other one is a little bit more complex. So 7x minus 1, if we set that equal to 0, let's add 1 to both sides. This cancels. You'll get 7x is equal to 1. Divide both sides by 7. This cancels. So you get x is equal to 1/7. Okay, let's set up the intervals. Again, you're going to think about the leftmost value, which is negative 5. So here it's from negative infinity up to and excluding negative 5. And then the next interval would include negative 5 and go up to and exclude 1/7. And then the final interval would include 1/7 and then anything larger. Okay, so thinking about in the leftmost interval, they're both negative. So you're going to replace each one with the negative of the expression there. So the negative of the quantity x plus 5, and then the negative of the quantity 7x minus 1. Let me make that a little bit better. Then here, we know the rule because negative 5 here would make this 0, or anything larger going up to and excluding 1/7, this guy would be positive, right? So either way, you just drop the absolute value bars. And then here, this guy is still negative, okay? So we want to put the negative of the quantity 7x minus 1. And again, that's why this is not included here, because at 1/7, this guy would be 0, and you need a different rule, right? So you have to exclude this here. And then here it's included because at 1/7, this guy would be 0, and then anything larger would be some positive number. So you could just drop the absolute value bar. So this is 7x minus 1. And of course, for this guy here, and this interval is positive, so it's just x plus 5. You can just drop the absolute value bars. Okay, so let's start with the first guy. So you have the negative of the quantity x plus 5. This is less than the negative of the quantity 7x minus 1. And so what I'm going to do here is divide both sides by negative 1. And that's going to flip the direction of this guy. So this is a greater than now. This cancels. You have x plus 5 is greater than 7x minus 1. Let me show this is canceling. So what I'm going to do from here is subtract 7x away from each side and subtract 5 away from each side. And so this right here is going to cancel, and this is going to cancel. We'll say x minus 7x is negative 6x, and this is greater than negative 1 minus 5 is negative 6. Let's divide both sides of the inequality by negative 6. This will flip, so now it's going to be a less than. This cancels. You get x is less than. Negative 6 over negative 6 is 1. So here we have x is less than 1. All right, so let's write this in here. So we have x is less than 1. Now, this is a little bit tricky because you have to think about the interval that you're in. So if you think about 1, it's not in this interval, right? This is x is less than negative 5. But there are values from this solution that you could include because x is less than 1 includes negative 5 or anything smaller. So what you do is just include the parts that are in your interval. So you say x here is less than negative 5. Okay, let's move on to this interval here. And let's think about the first guy is x plus 5, and this is less than. We have the negative of the quantity 7x minus 1, so negative 7x plus 1. So I will add 7x to both sides of the inequality. I will subtract 5 away from each side of the inequality. This will cancel and this will cancel. X plus 7x is 8x. This is less than. 1 minus 5 is going to be negative 4. Let's divide both sides of the inequality by 8. We're going to cancel this, and we get x is less than. This is negative. 4 over 8 is 1/2. So x is less than negative 1/2. So we have x is less than negative 1/2. Okay. Again, this is in this interval. We have between negative 5 and 1/7, where negative 5 is included and 1/7 is excluded. But you have to think about the fact that you're just going to go down to and include negative 5. Okay. So I'm going to say that x is going to be greater than or equal to negative 5 and less than negative 1/2. In the last interval, everything is non-negative, so we can just drop the absolute value bars. We'll say that x plus 5 is less than 7x minus 1. Let's subtract 5 away from each side of the inequality. Let's cancel this. Let's subtract 7x away from each side of the inequality, and let's cancel this. So x minus 7x is going to be negative 6x, and this is less than. Negative 1 minus 5 is negative 6. I'm going to divide both sides of the inequality by negative 6. We're going to flip this and make this into a greater than here. So this cancels, and you get x is greater than. Negative 6 over negative 6 is 1. So we get x is greater than 1. So let's put x is greater than 1. Okay, so thinking about our solution, let me get rid of this. You're going to have x is less than negative 5, then or x is greater than or equal to negative 5 and less than negative 1/2, then or x is greater than 1. So when you think about these two together, here, this is the key, negative 5 is included, right? So basically, x is just less than negative 1/2. So what I'm going to do is get rid of this and put this like this for my solution. So x is less than negative 1/2 or x is greater than 1. So that's what we want. So coming back up here, I want this one. X is less than negative 1/2 or x is greater than 1. Again, thinking about this graphically, the guy in red is this absolute value of x plus 5. And the guy in blue is the absolute value of 7x minus 1. We're saying, where's the guy in red below the guy in blue? Well, basically, that's going to be anywhere where we're to the left of this guy and to the right of this guy. So if you come down here, this is going to be negative 1/2. And if you come down here, this is going to be positive 1, right? So you can see to the left of this guy, the red graph is going to be below the blue graph. And I know it's cut off a little bit, but you could type this into Desmos and see it for yourself. And then anywhere to the right of 1, well, the red guy is going to be below the blue guy. But between those two values, so between those two, the red guy is above the blue guy. So we don't want that. We want to say where x is less than negative 1/2 or x is greater than 1. All right, let's take a look at question 3 now. So we want to solve each inequality. And we have the absolute value of x minus 2 plus the absolute value of x minus 1. And this is greater than 12. All right, so x minus 2, if I set that equal to 0, I get x equals 2. And then x minus 1, if I set that equal to 0, I get x equals 1. So basically, you want from negative infinity going up to and excluding positive 1. And then you want from 1 and including 1 going up to and excluding 2. And then you want anything that is larger than 2. Okay, so let's think about in this interval, both of these guys are going to be negative. So I want the negative of the quantity x minus 2. So that's negative x plus 2. And then here it's still negative. So this is negative x plus 2. Here it's going to be 0 or some positive value. So this is just x minus 2. Okay. For this one, in this interval, it's going to be the negative of this quantity. So negative x plus 1. Then here, because of the 1, it's either 0 or anything larger going up to and excluding 2, it's going to be positive. So I can just say this is x minus 1. And here it's going to be positive, so this is just x minus 1. We have negative x plus 2, and then plus negative x plus 1. And this should be greater than 12. So negative x plus negative x is negative 2x. And then 2 plus 1 is 3. And this is greater than 12. So I'm going to subtract 3 away from each side. This is negative 2x is greater than 12 minus 3 is going to be 9. Let me divide both sides of the inequality by negative 2. I'm going to flip this direction here. So this cancels. And this is x is less than 9 divided by negative 2. You just say this is negative 9 halves or negative 4.5. So let's put x is less than negative 9 halves. And that's in this interval, so we're good to go. In this guy right here, I want negative x plus 2, then plus x minus 1, and this is greater than 12. So if I have negative x plus x, that's 0, right? So these are going to cancel. 2 minus 1 is going to be 1, so you get 1 is greater than 12, which is a false statement, right? So this is a false statement. So we can say there's no solution in that interval. If you want, you could just put no solution. No solution to make that clear. So over here, we're just going to drop the absolute value bars in each case. So let me actually just get rid of this. We won't need this anymore. So x plus x would be 2x, and then negative 2 minus 1 would be negative 3, and this is greater than 12. Let's add 3 to both sides of the inequality. This cancels. We get 2x is greater than 12 plus 3 is going to be 15. Let's divide both sides by 2. This cancels, and you get x is greater than 15 halves. So let's put x is greater than 15 halves. That's clearly in this interval because it's 2 or anything larger, and this is 7.5. So let's say that our solution is x is less than negative 9 halves, or x is greater than 15 halves. So coming up here, we want this solution. So x is less than negative 9 halves, or x is greater than 15 halves. Okay, so coming back here, if you graph the absolute value of x minus 2 plus the absolute value of x minus 1, you want to see where that's greater than 12. So where's the y value greater than 12? So here's where it's equal to 12, and here's where it's equal to 12. If you come down here, this is going to be your negative 4.5, or you could say your negative 9 halves, however you want to write that. Maybe I'll put negative 9 halves so that's consistent with the problem. And then coming down here, this is going to be 7.5, or again, your 15 halves. So where is it greater than 12? We're anywhere to the left of this negative 9 halves in terms of the x value, and anywhere to the right of this 15 halves in terms of the x value. So again, you just say x is less than negative 9 halves, then or x is greater than 15 halves. All right, let's take a look at question 4. So we want to solve each inequality. So we have the absolute value of x plus 9, then minus the absolute value of 2x plus 1. This is greater than 7. So we would, again, take x plus 9, set that equal to 0, and solve. You're going to get x is equal to negative 9. And then here you have 2x plus 1. If you set that equal to 0, you're going to subtract 1 away from each side. So this is 2x is equal to negative 1. Divide both sides by 2, and you get x is equal to negative 1/2. The leftmost value will be negative 9. So we're going to say this is from negative infinity, going up to and excluding negative 9. Then you're going to be between negative 9 and negative 1/2, where negative 9 is included and negative 1/2 is excluded. And then you're going to include negative 1/2 and then go out to positive infinity. Okay. In the first interval, we know that both of these are negative. So I'll just say this is the negative of x, then minus 9. And then I'll say this is the negative of 2x, and then minus 1. Okay, so I just distributed the negative to each. Now, here, we know that this guy is 0 at negative 9, or some positive value. So you can just say this is x plus 9, and here it's positive, so just x plus 9. And then here, we're still negative for this one. So negative 2x, and then minus 1. Let me make that a little bit better. And here we're non-negative, right? So at negative 1/2, we're 0. And then anything larger, we're positive. So it's 2x plus 1 either way. Okay. So in the first scenario, you're going to have negative x and then minus 9 and then minus. You're going to wrap this in parentheses, what you're plugging in here, because you have this minus here. So you have to be very careful. So we're going to say this is negative 2x minus 1, and this is greater than 7. So we have negative x minus 9. And then the negative of negative 2x is plus 2x. And then the negative of negative 1 is plus 1, and this is greater than 7. So negative x plus 2x is x. Negative 9 plus 1 is going to be negative 8, and this is greater than 7. So let's add 8 to both sides of the inequality. We'll cancel this. We get x is greater than 7 plus 8 is 15. So x is greater than 15. So we have x is greater than 15. Now, is that in this interval? No. So I'm going to reject this. So in this next interval, we're going to say x plus 9, then minus. Again, you've got to wrap this in parentheses because of the minus there. We have the quantity negative 2x minus 1, and this is greater than 7. So you have x plus 9. Then the negative of negative 2x is plus 2x. And then the negative of negative 1 is plus 1. And this is greater than 7. So x plus 2x is 3x. And then 9 plus 1 is going to be 10. So plus 10. This is greater than 7. And then we could subtract 10 away from each side. We'll cancel that. You get 3x is greater than 7 minus 10 is going to be negative 3. Divide both sides by 3. And you're going to see that x is greater than, let me show that as canceling, negative 3 over 3 is negative 1. So x is greater than negative 1. Now, is this in this interval? Yes. But you're only going to consider up to and excluding negative 1/2. So you're going to say x is greater than negative 1 and less than negative 1/2. Now, for this part right here, I'm just dropping the absolute value bars in each case. Again, be careful with that negative. So you have x plus 9 and then minus the quantity 2x plus 1. And this is greater than 7. So this will be x plus 9, then minus 2x, then minus 1 is greater than 7. So x minus 2x is negative x. 9 minus 1 is 8. So we'll go plus 8 is greater than 7. Let's subtract 8 away from each side of the inequality. This cancels. Let me erase this so I can just write this above. So we'll have negative x is greater than 7 minus 8 is negative 1. Let's get rid of this, and we don't need this anymore. So basically at this point, I would divide both sides by negative 1. You've got to flip the direction of this. So this is going to be a less than now. This cancels. So x is less than negative 1 over negative 1 is 1. So let's put x is less than 1 here. But again, you've got to be in this interval here, right? So 1 is greater than negative 1/2. So we're okay there. But we can only go down to and include negative 1/2. So I'm going to say that x is greater than or equal to negative 1/2 and less than 1. So putting the solutions together, let's write this out. So negative 1 is less than x, which is less than negative 1/2. Then or x is greater than or equal to negative 1/2 and less than 1. Now, this is tricky for a lot of people, but remember, this is included here, right? So it's almost like you can just get rid of this part right there, okay, and say that basically x is going to be greater than negative 1 and less than 1. So let me write that out. So x is greater than negative 1 and less than 1. So that's your solution. So coming back up here, this is what we want. So x is greater than negative 1 and less than 1. So for this one, it's the absolute value of x plus 9 minus the absolute value of 2x plus 1. That's what's graphed. We're trying to see where's that greater than 7. So if you come right here, these are the 2 points where it's equal to 7. So the x value here is negative 1. And then coming down here, the x value is positive 1. And then you're saying, where is it greater than 7? So it's basically this part of the graph right here. So it's going to be between negative 1 and 1, right? So x is greater than negative 1 and less than 1. All right, let's take a look at question 5 now. So again, we want to solve each inequality. And here we're going to have the absolute value of 7 over x minus 2. And this is less than 3. All right, so the rule we're going to use here, if we have something like the absolute value of u, and that's less than, let's say, 3, then we could say u is greater than the negative of 3 and less than 3. So we'll use that rule here. And our u will just be this 7 over x minus 2. So we'll say 7 over x minus 2 is greater than negative 3. Let me scooch this down here. I'm just going to write this with the keyword and. I think it's a little bit better. And then we'll say 7 over x minus 2 is less than 3. Okay, so the same setup as here. All right, so we're going to just solve each part separately. Then we'll put it together at the end with the keyword and. So that's the intersection of the two solution sets. So you have 7 over x minus 2. Then I'm going to add 3 to both sides of the inequality. And this is greater than 0. So from here, I'll have 7 over x minus 2. And then plus, you're going to have 3 times the quantity x minus 2 over x minus 2. And this is greater than 0. So we'll have 7 plus 3x. And then minus 3 times 2 is 6. So you can go ahead and do 7 minus 6. That's going to be positive 1. So this is 3x plus 1. And this will be over your common denominator of x minus 2. And this is greater than 0. Okay, so once we get to this point, you want to find your critical values. So you want to put the numerator is equal to 0, solve that. You want to put your denominator equal to 0 and solve that. So here we have 3x plus 1 is equal to 0. Subtract 1 away from each side. This cancels. You're going to get 3x is equal to negative 1. Divide both sides by 3. And you're going to find one critical value is x is equal to negative 1/3. Okay. Now I would note here that because we have a strict inequality, this is strictly greater than, that negative 1/3 is not going to work. You would have 0 on the left is greater than 0 on the right, which is a false statement. All right, the other guy is easy enough. You set x minus 2 equal to 0 and you solve that. You get x equals 2. Of course, 2 does not work because it makes the denominator 0 and division by 0 is undefined. So let's grab this and we're just going to come to a number line. I'll say this is negative 1/3 and this is 2. Let's get rid of this and maybe slide this down just a little bit. And the idea here is we're just going to test inside of these intervals. So let's say that a is anything less than negative 1/3. B is between negative 1/3 and 2, and C is greater than 2. So you have A, you have B, and you have C. Okay, for A, let's pick negative 1. So if I plugged in a negative 1 for x, what would I have? So 3 times negative 1 is negative 3, and then negative 3 plus 1 is negative 2. So you have negative 2 over. If you have negative 1 minus 2, that's negative 3. The main thing here is that you have a negative over a negative, which is a positive, and a positive is greater than 0, so this is true. You could also just say this is 2/3, and 2/3 is greater than 0. So either way, it's true. Then for B, you could pick 0 if you wanted to. So let's say I plugged in a 0 here. I would just have a 1 there. And then if I plug in a 0 here, you'd have a negative 2 there. So this is going to be a negative 1/2, and a negative is not greater than 0, so this is false. Okay, for C, let's pick 3. So 3 times 3 is 9. 9 plus 1 is 10. This is over. 3 minus 2 is 1. So 10 over 1 or just 10, is that greater than 0? Yeah, that's true, right? Any positive number is greater than 0. Okay, you can get rid of all this and just write your solution. So here, x is less than negative 1/3. Then, or we would say that x is greater than 2. And both are excluded here. Okay, coming back here, I'm just going to paste this in. So that's for this part. Now I need to work on this part. So we have 7 over x minus 2 is less than 3. So let me put minus 3 is less than 0. And let's just take this down here. So what I'm going to do is say 7 over x minus 2. Then minus, you have 3 times the quantity x minus 2. This is over x minus 2. And this is less than 0. Let me get rid of this. I'm just going to go above. So this is 7 and then minus. Here's where you got to be really careful. Whenever you have a minus sign out in front of this, go ahead and put yourself some brackets there so you don't make a mistake. I'm going to distribute the 3. So 3 times x is 3x, and then minus 3 times 2 is 6. And then this will be over the common denominator of x minus 2. So this will be over your x minus 2. And then, of course, it's going to be less than 0. So this is less than 0. So now you have 7 and then minus 3x. And then minus negative 6 is plus 6. So 7 plus 6 is 13. So let's put negative 3x plus 13. This is over x minus 2, and this is less than 0. Okay, let's get rid of this. So one critical value we already know. You set x minus 2 or the denominator equal to 0 and you solve. You get x is equal to 2. And of course, we know this is not going to work. Now for the numerator, you have negative 3x plus 13. You set that equal to 0. Let's subtract 13 away from each side. That cancels. You get negative 3x is equal to negative 13. We will divide both sides by negative 3. And so I'm going to cancel this with this, and we'll say x is equal to, negative over negative is positive, we have 13 over 3. So x equals 13 over 3. Now again, this is not going to work because this left side here would be 0, and the right side would be 0, and 0 is not less than 0. That's a false statement. So we'll put x is equal to 13 over 3. So let's put 2 here, and 13 over 3 here. And this is 4 1/3 if you were to punch that into your calculator. And let's get rid of these. We know neither is going to work. Let's just test. So let's grab this and move this down. Let's say this is A, this is B, and this is C. So A, B, and C. And then basically for A, let's pick 0. And so this would be gone here. You'd have 13 over negative 2. So is 13 over negative 2 less than 0? Yeah, that's going to be a true statement, right? Any negative is always going to be less than 0. Okay, for B, let's pick 3. So negative 3 times 3 is negative 9. And then negative 9 plus 13 is going to be positive 4. This is over. If you take 3 and you subtract away 2, you're going to get 1. So 4 over 1 is 4. So is 4 less than 0? No. 4 is positive, so that's not less than 0. So this is false. Okay, let's think about C. So this is, again, 4 1/3. So let's just pick 5. Negative 3 times 5 is negative 15. Negative 15 plus 13 is negative 2. So let's say this is negative 2 over. If you do 5 minus 2, that's 3. So this is negative 2/3. Is that less than 0? Yes, a negative is always less than 0. So this is true. What I would say here first is that x is less than 2. Then I'll say or. We'll say x is greater than 13/3. Okay, so let me put and in here. I'm just going to paste this in. So this is what we have to think about. So let's grab this and let's come to a number line. Now we have 3 different values we're going to work with. So the smallest is negative 1/3. That's the furthest to the left. Then 2 is going to be in the middle. And then 13/3 is going to be all the way on the right. So when I think about the first guy here, we're saying that x is less than and strictly less than negative 1/3. So that looks like this. And I'm going to use an open circle. I normally use a parenthesis, but I think this is better here. And then we say, or x is greater than 2. So I'm going to put an open circle here and shade everything to the right. So that's this solution here. So we also have to consider this solution here, right? We're looking for the intersection. So let's say x is less than 2. So I'm just going to put a circle like this, and I'm going to shade everything to the left like that. And then we're saying x is greater than 13/3. So let me put this like that and shade everything to the right. So where's the overlap? Where's the part of the number line that satisfies both? Well, we can see from negative 1/3 going up to and including this 2, things are not going to work in both. Okay, so that's going to be excluded from the solution. But you can see that going to the left of negative 1/3, things are going to work in both. So I would say x is less than negative 1/3. So that's the first part. Then over here, you can see that going to the right of 2, things don't work in both. Things don't work in both. And then right there, going to the right of 13/3, things are going to work in both. Okay, so we would say or x is greater than 13/3. So when you get something like this, I know it's a little bit complicated, but just make yourself a little graph and think about what's going on. And that'll make it easier to get your solution. So coming back here, we want to select x is less than negative 1/3 or x is greater than 13/3. All right, again, you can always look at these guys graphically. I know this guy's a little bit small in terms of the numbers, but this right here is going to be 3, and this is on your y-axis. Now we're saying, where is this guy right here? This is what I've graphed, the absolute value of 7 over x minus 2. Where is that less than 3? Well, if you look at the x value right there where they're equal, if I just come down here, this is going to be your negative 1/3. So you can see anywhere to the left of that, we're going to be less than 3. So that's where we get x is less than negative 1/3. Then or, if you come over here, this is where we're at 3 in terms of the y value. If you come down, well then your x value there is going to be 4 1/3, or as we wrote it, 13/3. So anything to the right of that in terms of the x value, your y value is going to be less than 3. So you would also say that x is greater than 13/3. So again, if you're lost in these problems, you can always graph them and think about what's going on. All right, let's take a look at the section quiz. For the first question, we're asked to solve each equation, and it looks like we have negative 4 times the absolute value of 7x squared, then plus 13x. Then we have plus 3, and this is equal to negative 5. Okay, so the first thing I'm going to do is try to isolate these absolute value bars here. So I'm going to subtract 3 away from each side of the equation. That would cancel. You're going to have negative 4 times the absolute value of 7x squared plus 13x. And this is equal to negative 5 minus 3 is negative 8. Again, I'm trying to isolate the absolute value bars here. So I'm going to divide both sides of the equation by negative 4. And what that's going to do is cancel this with this. And now I'll have the absolute value of 7x squared plus 13x is equal to negative 8 divided by negative 4 is going to be positive 2. Okay, so once we have it as the absolute value of some expression, let's just call it u, and that's equal to some positive number, let's just say it's 2, well, this splits up into 2 cases, right? We could say u is equal to 2 or u is equal to negative 2. So that's all we're going to do. So we're going to say that 7x squared plus 13x is equal to 2. Let me slide this down so it fits. Then we'll say or 7x squared plus 13x is equal to negative 2. All right, let's start on the one on the left here. I'm just going to subtract 2 away from each side. So let me show that here real quick. That would be 7x squared plus 13x minus 2. This would cancel and give me 0, so we'll say this equals 0. Now, can we solve this one using factoring? So let me set this up, and let's see if we can obtain a factorization here. Now, this last number here is 2, and more specifically here, it's negative 2. So if we think about a negative in the last position, that means I have mixed signs. So 2, if you just think about the number, it's 1 times 2 if you're just doing positive numbers. So just start by putting a 2 here and a 1 here. So this right here would give you 14, and this would be 1. So 14 minus 1 could get me to 13. I just have to play with the signs here and put a plus here and a minus here, right? So this is going to give me 14x, and this is going to give me negative x, and 14x minus x would be 13x. So this is what I want. So I'm going to say that 7x minus 1 is equal to 0, or x plus 2 is equal to 0. Let's add 1 to both sides of the equation. Let's cancel this. We have 7x is equal to 1. Divide both sides by 7. We'll cancel this and get x is equal to 1/7. Over here, let's subtract 2 away from each side, and we'll get x is equal to negative 2. So we get x equals 1/7 or negative 2. So I'm just going to come back up here and paste this for now, and I'll put a comma, and we'll go back down. So now we want to work on this part right here, and what I'll do is add 2 to both sides of the equation. This cancels. I have 7x squared, and then plus 13x, and then plus 2, and this equals 0. So the question is, can we factor the left side? The answer is going to be no, but we could just try it real quick just so I can show you that it's not going to work. So basically what happens is everything here is positive, right? So I know this is a plus and this is a plus. With 2, it's only 2 times 1, right? Forget about negative 2 times negative 1 because everything's positive. If you put the 2 here and the 1 here, this is 14, and then plus 1, that's 15. I'm trying to get to 13. If I put the 2 here and the 1 here, this is 7 plus 2, which is 9. Again, I'm trying to get to 13. So you can't solve this using factoring. What you're going to have to do is use your quadratic formula. So let me scooch this up here. So we remember that this is your a, the coefficient for x squared. This is your b, the coefficient for x to the first power. And this is your c, your constant. So we have x is equal to the negative of b plus or minus the square root of b squared minus 4ac. This is all over 2a. Okay, first we have the negative of b. B is 13, so this is negative 13. And then plus or minus the square root of, we have b squared. So 13 squared would be 169. And then minus 4 times a times c. So a is 7 and c is 2. 7 times 2 is 14. So let me write 4 times 14 here. And we could just do the calculation. 4 times 14, that's going to be 56. So if you had 169 minus 56, that's going to be 113. So this is the square root of 113 here. And then this right here is 2a. So a is 7. So let's say this is 2 times 7 or 14. For 113, it's going to be a prime number. So this is really as simple as you can make this answer. So let's grab this. And I'm just going to come back here and get rid of this. And you could write this more neatly if you want. So let's say this is negative 13. And then plus or minus the square root of this 113, and this is over 14. So what I'm looking for is this solution right here. So we want x is equal to 1/7, negative 2, and then you have negative 13 plus the square root of 113 over 14, and then negative 13 minus the square root of 113 over 14. All right, let's take a look at question 2 now. So again, we want to solve each equation. So we have the absolute value of 20 over 3x minus 1. This is equal to the absolute value of 15 over 2x plus 11. All right, so the rule we're going to use here is very straightforward. If you have the absolute value of some expression, let's call it u, and that's equal to the absolute value of some expression, let's call it w, well then u equals w. That's one possibility, so you can just drop the absolute value bars. Then or u is equal to the negative of w. So drop the absolute value bars and make one of them into its negative. So it doesn't matter if you make this a negative or this a negative, but only make one of them into its negative, or you could say its opposite. So for the first scenario, we're just going to drop the absolute value bars. So we have 20 over 3x minus 1, and this equals 15 over 2x plus 11. So that's scenario 1. And then we'll say or for scenario 2, drop the absolute value bar. So 20 over your 3x minus 1 is equal to 15 over 2x plus 11. You're just going to pick one of them. I always pick the one on the right, but you could do the one on the left and make it into its negative, or you could say its opposite. Because this is a rational expression, or you could think about it as a fraction, you're going to make either the numerator negative or the denominator negative, but don't do both, right? That's just going to cancel away. So I'm just going to make this negative right here, and I'm basically done. So let me take this part right here, and let's work on this one first. So you can just cross multiply. So you would do like this and set that equal to this. So we would have 15 times the quantity 3x minus 1. This equals 20 times the quantity 2x plus 11. I noticed before I distribute things that I could divide both sides of the equation by 5. So what I'm going to do here is cancel this with this, and this is a 3. Cancel this with this, and this is a 4. So 3 times 3x is 9x, and then minus 3 times 1 is 3. This equals 4 times 2x is 8x, and then plus 4 times 11 is 44. So from here, I'm just going to subtract 8x away from each side of the equation, and then I'm going to add 3 to both sides of the equation. So this is going to cancel, and this is going to cancel. 9x minus 8x is going to be x, and this equals 44 plus 3 is going to be 47. So I get x is equal to 47. That's one solution. So coming back up here, I'm just going to put x is equal to 47 and then put a comma. Now we're going to work on this one right here. So we're just going to cross multiply to set things up. So you have negative 15 times the quantity 3x minus 1 is equal to 20 times the quantity 2x plus 11. We can again divide both sides by 5. This would cancel with this and give me negative 3. This would cancel with this and give me a positive 4. So negative 3, let me make this negative a little bit more clear here. So negative 3 times 3x is negative 9x, and then negative 3 times negative 1 is positive 3, and this equals 4 times 2x is 8x, and then 4 times 11 is going to be 44. From here, I'm going to subtract 8x away from each side. This cancels, subtract 3 away from each side. This cancels. So negative 9x minus 8x is negative 17x, and this equals 44 minus 3 is 41. Let's divide both sides by negative 17. And so this right here is going to cancel. And I'm basically going to say that x is equal to positive over negative is negative. So negative 41 over 17. So coming back up, I'll throw in the negative 41 over 17. And so this is what we want as our solution. X is 47, or x is negative 41 over 17. All right, let's take a look at question 3 now. So again, we want to solve each equation. So we have the absolute value of 9x minus 2. Then we have plus 4, and this equals 13. Okay, so a problem with nested absolute value, again, you consider if you have the absolute value of u, and this equals, let's just say 13, then again, u equals 13, or u equals negative 13. Well, here, u is just going to be this guy right here. So the absolute value of 9x minus 2, then plus 4. So that's what we want to set equal to 13, then say, or it's equal to negative 13. So we'll take that guy, and we'll say that scenario 1, we have the absolute value of 9x minus 2, then plus 4 is equal to 13. Then or scenario 2, we have the absolute value of 9x minus 2, then plus 4, and this equals negative 13. Okay, let's start off with this one on the left. And so here we know that we want to isolate the absolute value bars on one side. So I'm just going to subtract 4 away from each side. This is the absolute value of 9x minus 2 is equal to 13 minus 4 is 9. So again, this has to split up into two cases. So we're going to say, let me put a little border here, that this 9x minus 2 is equal to 9, then or 9x minus 2 is equal to negative 9. So this is where things start to get really, really tedious. Let me actually get rid of this. We don't need this anymore. And I'm just going to start with this one right here. So if you have 9x minus 2 is equal to 9, just add 2 to both sides. This cancels. You get 9x is equal to 9 plus 2 is 11. Let's divide both sides of the equation by 9. This cancels. And we get x is equal to 11 ninths. For the other scenario, you have this one. So let's add 2 to both sides of the equation. This cancels. You're going to have 9x is equal to negative 9 plus 2 is going to be negative 7. Divide both sides by 9. And so this cancels, and you're going to find that x is equal to negative 7 ninths. So let me say that x is equal to negative 7 ninths, or 11 ninths, and just clean all this up. So let's grab this. So I'm just going to paste this in here for now, and then we will come back in a moment. So coming back here, we're going to see that there's a problem. If you try to isolate the absolute value bars, what's going to happen is we subtract 4 away from each side. You get the absolute value of 9x minus 2 is equal to negative 17. So we already know that the absolute value operation is going to give me something that's either 0 or some positive number, so some non-negative number. And we can't get a result of negative 17. It's impossible, right, no matter what we choose for x. So that part has no solution. So coming back up, we only want to select this one right here, where x is equal to negative 7/9 or x is equal to 11/9. All right, let's take a look at question number 4. So again, we want to solve each equation. And here we have 8x squared minus 38 times the absolute value of x. And this equals negative 9. Let me just put plus 9 equals 0 now, just to save a little bit of time. We'll grab this and we'll paste this in here. Now, I showed you in the lesson 2 different ways to solve this type of problem. You can use a substitution technique, or you can consider the negative case and then the positive case. Okay, so whatever you want to do. I'm just going to use a little simple substitution technique. Remember, if you have x squared, this is equal to or the same as the absolute value of x being squared, right? This will give you the same answer either way. So I'm just going to say that this right here is the absolute value of x being squared, and then I can let something like u or w or z or whatever you want to use be equal to the absolute value of x. So what I'll do here is say this is 8u, okay, just plugging that in for the absolute value of x being squared, then minus 38u, and then plus 9, and this equals 0. So let's solve this real quick. We'll come back, we'll substitute again, and we'll see what we have. So this is something that you can solve using factoring. Now 8 is either 8 times 1 or 4 times 2. So let's try 4 and 2 first. I don't know actually if that's going to work. I just know that you can factor this. Now this is a minus and this is a plus. So that tells me that both the signs are negative. But just think about things for right now in terms of absolute value. If you have 9, it's either 1 times 9 or it's 3 times 3. If I put a 9 here and I put a 1 here, right off the bat, that's going to work. So if you look at this, this is going to be negative 36u, and this is going to be negative 2u, and negative 36u plus negative 2u is negative 38u. So we're basically good to go with this factorization. So I'm going to say that 4u minus 1 is equal to 0. Then or 2u minus 9 is equal to 0. I want to add 1 to both sides of the equation. I want to cancel this. So 4u is equal to 1. We'll divide both sides by 4. Let's cancel this with this, and we'll say u is 1/4. So that's one solution. Let me get rid of this. I'll put a comma. Over here, let's add 9 to both sides. Cancel this. We get 2u is equal to 9. Divide both sides by 2. So u could also be 9/2. Let's put 9/2. At this point, we are not done, right? We want this in terms of x. Right now, we have it in terms of u. So what we'll need to do is make another substitution. Since u is equal to the absolute value of x, I can say the absolute value of x is equal to 1/4. Then or the absolute value of x is equal to 9/2. Okay, let me get rid of all this. And let's think about how we can solve these. These are really simple. If the absolute value of x is equal to 1/4, that just means that x is equal to plus or minus 1/4. Right? So it could be positive 1/4, take the absolute value, you get 1/4. It could be negative 1/4, take the absolute value, get 1/4 also. Then we'll say, or the absolute value of x is 9/2. So again, it's just plus or minus 9/2. So that's all you have to do. So that would be your full solution. It's 4 solutions. So let's grab this real quick. Come back up here. I'm looking for this answer right here. So x could be 1/4, negative 1/4, 9/2, or negative 9/2. All right, let's take a look at question 5 now. So we have 2x minus 5, then plus the absolute value of x minus 1, and this is equal to 6. All right, so we know at this point that for this scenario, because we have the absolute value operation here, and then we have a variable outside of that, we can't use our normal strategy. So normally we can just say something like the absolute value of, let's just call it u. It's just some algebraic expression with a variable involved. Let's say that was equal to 6. Well, u is equal to 6 or u is equal to negative 6. Well, you can't do that here because you can't isolate this guy right here and have all your variables be inside, right? Because you have this 2x outside. So that's your issue. So what you have to do is split this up into different cases. So in other words, you're going to first think about where is x minus 1 less than 0. So in that case, when you drop the absolute value bars, you have to make this guy into its opposite or its negative. So where is x minus 1 less than 0? Or you could just say where is it equal to 0 and just choose any value below that. So let's just add 1 to both sides. We'll cancel this and say x is equal to 1. So at 1, this is 0, but anything less than that, it would be negative. So we'd say coming from negative infinity, going up to and excluding 1. right? So in this case, this absolute value of x minus 1, you'd replace that with the negative of the quantity x minus 1. And of course, if you distribute that, that's negative x plus 1. So negative x plus 1. Okay. The other scenario is going to be that this guy is 0 or some positive number. In that case, when you work with absolute value, you could just drop the absolute value bars. So if we, for right now, let me include this, and I'll talk about this in a second. So let me put from 1 out to positive infinity. So here, you just drop the absolute value bar, so it's x minus 1. Now, in the lesson, in the practice test, we talked about this a lot. You've seen that I like to do it this way. Again, there is no right or wrong way to do this. This is scratch work, okay? The only time it really comes up is just if 1, which is a breakpoint, comes up as your answer. And we already talked about that in the practice test in terms of what to do. But for right now, because a lot of students prefer this, I'm just going to leave it this way. That way, nobody gets confused. Okay, so we have two different cases here. And so for the first case, I'm just going to say that this is 2x and then minus 5 and then plus, instead of the absolute value of x minus 1, I'm going to use negative x plus 1, and this equals 6. In the second case, I have 2x minus 5, and then plus, I'm just going to drop the absolute value bar, so x minus 1, and this equals 6. Okay, let me get rid of this. And let's solve this guy on the left. So we would say that negative 5 plus 1 is going to be negative 4. So let me just get rid of this. I'll just do this in line. And then I'm going to add 4 to both sides. This would cancel. 2x minus x would be x. So you have x is equal to 6 plus 4 is going to be 10. Now I have x equals 10. If we think about this interval, this is coming from negative infinity, going up to and excluding 1. So basically x is less than 1. Is 10 in that interval? No. So you have to reject this and say that there's no solution here. So in this interval, there is no solution. Okay. For this one, you have 2x plus x, that's 3x. Then negative 5 minus 1 is negative 6, and this equals 6. If you add 6 to both sides, this would be 3x is equal to 12. We would divide both sides by 3, and we would find that x is equal to 4. And let me show this canceling with this. So is that in this interval? Yes. We are anything greater than or equal to 1 here, and 4 is in that interval, so we will accept this as a valid solution. So coming back up here, I just want x equals 4. All right, let's take a look at question 6 now. So we want to solve each equation. So we have the absolute value of 12x minus 5, then plus the absolute value of 3x minus 1. This equals 19. All right, so thinking about this guy, remember, we want to take each guy inside of the absolute value bars, set it equal to 0, and solve so that we can set up our intervals on this little table here. So let's start with 12x minus 5, and that's equal to 0. Add 5 to each side. We'll cancel that. We get 12x is equal to 5. Let's divide both sides of the equation by 12. This cancels. And so we're going to have x is equal to 5/12. Okay, let's get rid of this. And now let's look at 3x minus 1. So we're going to set that equal to 0 and solve. Let's add 1 to both sides of the equation. This cancels. We get 3x is equal to 1. Divide both sides by 3. This cancels. You're going to have x is equal to 1/3. Okay, so 1/3 is the leftmost value, or you could say the smallest value. And so we're going to say coming from negative infinity, going up to and excluding 1/3. And then I'm going to include 1/3 here, and I'm going to exclude 5/12. And then I'm going to include 5/12, and I'm going to go out to positive infinity. And again, you can exclude everything here if you want. This is all personal preference. We've talked about this a lot at this point. But basically, you want to include 1/3 here because it would make this guy 0. So whether it's 0 or some positive number, it's the same rule. But you don't want to include this guy here because that would change your rule, right? At 5/12, this guy is going to be 0, but anything less, it's going to be negative, okay? So you want to make sure you have a consistent rule in each interval. So that's why we set it up this way. Okay, in the leftmost interval, everything is going to be negative. So I want the negative of the quantity 12x minus 5. And then I want, in this interval, it's still negative. So the negative of the quantity 12x minus 5. And in this interval, it's non-negative. It's 0 at 5/12, and it's positive anywhere else. So we would just drop the absolute value bars in each case. So it's just 12x minus 5. Okay. For this 3x minus 1, it's negative here. So the negative of the quantity 3x minus 1. And then in this case, it's going to be non-negative. So 0 at 1/3 or positive anywhere else. So just drop the absolute value bars. So 3x minus 1. And then here is positive. So 3x minus 1. Let's start out all the way on the left. I'm going to have negative 12x plus 5, just distributing that negative in. Then basically you have negative 3x plus 1, so minus 3x plus 1. This equals 19. So I'm going to say negative 12x minus 3x is negative 15x. And then 5 plus 1 is 6. And this equals 19. What we'll do is subtract 6 away from each side. We'll cancel that. Negative 15x is equal to 19 minus 6 is 13. Let's divide both sides of the equation by negative 15. And we can see that this is going to cancel with this. And we're going to have that x is equal to, you have 13 over negative 15. So let's just say 13 over 15 and put the negative out in front. So x is negative 13 over 15. So let's put x is equal to negative 13 over 15. Or again, you can put this out in front like I had it before. Either way. This is within this interval. We're in the interval where x is less than 1/3. So you can go ahead and check this solution off as valid. Now in this interval, you're going to have negative 12x and then plus 5, just distributing that negative. And then plus, you have the 3x minus 1, so plus 3x minus 1, and this equals 19. So what we'll do is negative 12x plus 3x, that's negative 9x. And then 5 minus 1 is 4, so plus 4, and this equals 19. Let's subtract 4 away from each side of the equation. This cancels. We're going to have negative 9x is equal to 19 minus 4 is going to be 15. Let's divide both sides of the equation by negative 9. So this is going to cancel. You're going to have x is equal to, we know this is negative. For 15, it's 5 times 3. Let me write that out. And for 9, it's 3 times 3. And let me cancel a common factor of 3 between numerator and denominator. So basically, x is negative 5/3. Let's put x is negative 5/3. And is this in this interval? Absolutely not, right? This interval starts with 1/3 and goes up to and excludes 5/12. So let's go ahead and reject that guy. It's not going to be a solution. Let's come down here for the final interval. And here we're just going to drop the absolute value bars. So let's just get rid of them from here. And so 12x plus 3x is 15x. Negative 5 minus 1 is minus 6. This equals 19. If I add 6 to both sides, this is going to cancel. And let's just go over here and say that 15x is equal to 19 plus 6 is 25. Let's divide both sides by 15. And let's go ahead and cancel this with this. Let me get rid of this so I have some room. We'll move this over. And I'll just say x is equal to, for 25, it's 5 times 5. And for 15, it's 5 times 3. So if I cancel a common factor of 5, this would be 5/3. So x equals 5/3 is our answer. Let's put x equals 5/3. Is this in this interval? Absolutely. So 5/3 is 1 2/3. And again, this starts with 5/12, which is less than 1. So you know that this guy right here is greater than this guy right here. And this continues out to positive infinity, so it goes to the right forever. So I'm going to go ahead and check this one off as a valid solution. So we'll say x is equal to negative 13 over 15, then or 5/3. Okay, so coming back up, we're going to want this answer. So x equals 5/3, that's this guy, or x equals negative 13 over 15, that's this guy. All right, let's take a look at question 7 now. So we want to solve each inequality. So you have the absolute value of 4x minus 1 is greater than the absolute value of x minus 5. Okay, so once again, you have to consider these on a case-by-case basis. So you would think about, where is 4x minus 1 equal to 0? Add 1 to both sides. You get 4x is equal to 1. Divide both sides by 4. This cancels, so x is 1/4. So x is 1/4. The other one, if you set x minus 5 equal to 0, you get x is equal to 5. All right, so let's get rid of this and set up our intervals. So the leftmost guy is 1/4. So I'm going to say that this is anything coming from negative infinity, going up to and excluding 1/4. So this has to be excluded here. Then for the next interval, I'm going to include 1/4. I always include things in the situation where I'm working with an inequality, because a lot of times you have to merge intervals and it's more complex than if you excluded everything. Okay, so I'm going to include 1/4 and I'm going to exclude 5. So remember, that's very important. Then here I'm going to include 5 and then go out to positive infinity. Okay, so we have the intervals set up. In this first interval, all the way to the left, everything's negative. So this is the negative of the quantity 4x minus 1. And this is the negative of the quantity x minus 5. In this interval, this guy is non-negative, so 0 or positive, and this guy is negative. So for this one, you just drop the absolute value bars. It's 4x minus 1. Here it's positive, so 4x minus 1. For this one, in this interval, it's still negative. So it's the negative of the quantity x minus 5. And then here it's going to be non-negative, either 0 if it's 5 or positive if it's greater. So here just drop the absolute value bar, so x minus 5. In the first scenario, you have the negative of the quantity 4x minus 1, and this is greater than the negative of the quantity x minus 5. Now, you could distribute the negative into each, but I think it's probably better just to divide both sides by -1. You just have to remember to flip the direction of the inequality symbol. So this cancels, and you get 4x minus 1 is less than, this cancels, and you have x minus 5. So what I would do here is subtract x away from each side. This cancels. Add 1 to both sides. This cancels. 4x minus x is 3x, and this is less than. -5 plus 1 is going to be -4. Let's divide both sides of the inequality by 3. So this cancels, and you get x is less than -4/3. So coming back here, x is less than -4/3. Can I accept this? Yes, this is in my interval, so I'm going to put a check mark there. Okay, for the next guy, I'm just going to have this 4x minus 1 is greater than the negative of the quantity x minus 5. Let's just say that's -x plus 5. So -x plus 5, just speed things up a little bit. So I'm going to add x to both sides of the inequality. This cancels. I'll add 1 to both sides of the inequality. This cancels. 4x plus x is going to be 5x. This is greater than. 5 plus 1 is 6. Let's divide both sides by 5. So this cancels, and you get x is greater than 6/5. So we have x is greater than 6/5. Now, is this in this interval? Yes, but only up to and excluding this 5. Okay, so you have to put this into the interval. So what I'm going to do is say that x is greater than 6/5, and you just have to make sure that that 6/5 number is greater than a fourth, which it is. And you're going to say it's less than this guy right here, this 5, because again, you have to stay in this interval. So then we're going to look at this over here and see what we get. So we're just dropping the absolute value bars in each case. So you have 4x minus 1 is greater than x minus 5. So let's add 1 to both sides. This cancels. Let's subtract x away from each side. This cancels. 4x minus x is 3x, and this is greater than. -5 plus 1 is going to be -4. Let's divide both sides by 3. This cancels. You get x is greater than -4/3. Okay, so let's put x is greater than -4/3. Now, a lot of people get confused here because they think that this number here, -4/3, that's not in this interval, so they have to reject this. But that's not actually true. If you have something like x is greater than -4/3, well, anything larger than -4/3 is going to work. So 5 would work, and anything larger than 5 would work. So you can include the parts from this interval, right? So in other words, here you would just say that x is greater than or equal to 5. So here, we'll say that x is greater than or equal to 5. We're just adjusting it for what works in this current interval. Okay, so hopefully that's not too confusing. All right, so now we're going to put everything together, and this is where a lot of students get lost. So this one, let me get rid of this inequality here. We don't need this anymore. This one's straightforward. So you're just going to say that x is less than -4/3. Then or, I put a check mark here, so maybe I should put a check mark here and here just for consistency, in case you're wondering why I did that. It's just to show that it's approved in that interval. Then over here, let's just say that this is x is greater than 6/5 and less than 5. Then or, here this is x is greater than or equal to 5. So in terms of the whole thing, the left part is pretty straightforward. X is just less than -4/3. When we get to this part right here, this is where people get lost. What you have to do is consider the fact that 5 is included here, right? And this is an or keyword, right? This is an or keyword. So if you say x is greater than 6/5 and less than 5, and then or x is greater than or equal to 5, well, you can just really get rid of this right here altogether, right? And just say x is going to be greater than 6/5, okay? So I know that is a bit confusing. You can pause the video and make a little number line and think about the two together and think it will make sense. Let me actually flip this around and say x is greater than 6/5. So x is greater than 6/5. And let's grab this answer. And so we have x is less than -4/3 or x is greater than 6/5. All right, let's take a look at question 8. So again, we want to solve each inequality. So here we have the absolute value of x plus 1, then minus the absolute value of x minus 2, and then this is less than -5. Okay, so we know the deal at this point. We're going to set each guy inside of the absolute value bars equal to 0, and we're going to solve. X plus 1, if you set that equal to 0 and you solve, you get x equals -1. So x equals -1. If you set x minus 2 equal to 0 and you solve, you get x is equal to 2. So the leftmost value is -1. So I'm going to say this is coming from -infinity, going up to and excluding -1. Then you have between -1 and 2. So I'm going to include -1 and exclude 2. Let me make sure I make this as a parenthesis there. And then in this guy right here, I'm going to include 2, and I'm going to go out to positive infinity. Okay, so we're done with that. And then essentially what you're going to do here, in the leftmost interval, everything is negative. So I want the negative of the quantity x plus 1, so negative x minus 1 if you just want to distribute that and speed it up. And here I want the negative of the quantity x minus 2, so that's negative x and then plus 2. Then in this guy right here, this one's going to be non-negative, so 0 or some positive value. So you can just drop the absolute value bars. It's just x plus 1. And this guy's still going to be negative, so we're going to have negative x and then plus 2. Okay, in this interval, everything is non-negative. So this guy's positive, it's x plus 1. And this guy's non-negative, so it's 0 at 2 or positive anywhere else. So we'll just drop the absolute value bars and say it's x minus 2. First scenario is we have this guy, so basically the negative of x minus 1. Be very careful with this minus sign. This trips up a lot of students. If you have a minus sign and you're going to plug something in, then just make sure you wrap whatever you're plugging in inside of parentheses so that you don't make a sign mistake. Okay, so we're going to basically go through here and say this is negative x minus 1, and the negative of negative x is plus x, the negative of 2 is minus 2, and this is going to be less than negative 5. Now, let's see what we have here. You have negative x plus x, so let me just cancel that away. And then you have negative 1 minus 2, and that's negative 3, and we're saying that's less than negative 5. This is a false statement. Okay, this is a false statement. Negative 3 is to the right of negative 5 on the number line, so it's a bigger number, right? It's a smaller negative, and therefore it's a bigger number. I know this one's a little bit confusing. So basically, this is a false statement. So we're going to come back up and just say in this interval, there is no solution. Okay, so let me make this O a little bit better. Now let's move into this interval here. So we're going to have x plus 1 and then minus. So be really careful. We're plugging in a negative x plus 2. Make sure you put that minus sign out in front of some parentheses. And this is less than negative 5 over here. So here we have x and then plus 1. The negative of negative x is just going to be x. So let's put plus x. And then the negative of 2 is just negative 2. And this is less than negative 5. So 1 minus 2 is negative 1. So let me actually just erase this and put this as negative 1 here. And x plus x is 2x. So you've got 2x minus 1 is less than negative 5. Let's add 1 to both sides. We get 2x is less than negative 5 plus 1 is going to be negative 4. Let me erase all this. Let's divide both sides by 2. This cancels. You get x is less than negative 4 divided by 2 is negative 2. So x is less than negative 2. So we have x is less than negative 2. Now, is this in this interval? No, right? So you have to reject this solution, right? This is not going to work. Okay, let's look at this interval right here. And so we're going to have that x plus 1, then minus, again, you've got to wrap this, so the quantity x minus 2, this should be less than negative 5. Okay, let's see what this gives us. So here we have x plus 1, and then minus x, and then plus 2 is less than negative 5. So again, you see you have sort of a problem here because this is going to cancel. And then 1 plus 2 is 3, and you've got 3 is less than negative 5, so that's another false statement. So this right here would also be no solution. So we would say no solution. So there's nothing in any interval that's going to work. So we would just come back up here and select no solution. Now, once again, I haven't done it for this quiz at all, but I want you to recall that you can always graph these things. You could take the left side here, this absolute value of x plus 1, then minus the absolute value of x minus 2, and just try to see where is this less than negative 5. You're going to see that that's not going to occur. Because if you look at the graph here, again, I've just keyed this into Desmos, you're looking for a y value that's less than negative 5. We can see that the lowest or the least y value here is going to be negative 3, right? So it's never going to be below negative 5. So that's why there's no solution. So again, if you're ever confused about something, just punch it into Desmos and take a look at what's going on graphically. A lot of times that'll make it make a little bit more sense for you. All right, let's take a look at question number 9 now. So here we want to solve each inequality. We're going to have the absolute value of 9 over x minus 5. And this is going to be less than 7. So hopefully you remember the rule at this point. If you have the absolute value of u, and that's less than 7, then u is greater than the negative of 7 and less than 7. So that's all we have to do here. You would say that it's going to be 9 over x minus 5. And first we'll say this is greater than negative 7. And then we'll put our keyword and. We'll go 9 over x minus 5, we'll say is less than positive 7. Let's start on this one on the left first. And so we'll add 7 to both sides. You'll have 9 over x minus 5. Then plus, you'll have 7. Now I'm going to multiply this by the quantity x minus 5 over the quantity x minus 5. So I can get a common denominator, and I don't need parentheses down here. And now this will be greater than 0. And in case anybody's lost, all I did was add 7 to both sides of this inequality. So that's how I got this. And then I'm multiplying by x minus 5 over x minus 5. That's just like multiplying by 1, so I can have a common denominator. We will continue now and say this is 9 plus 7 times x is 7x, and then 7 times negative 5 is negative 35. And let's say 9 minus 35, that's going to be negative 26. So let's say this is 7x minus 26. And this is over your common denominator of x minus 5. And we're saying this is greater than 0. Okay, so we need our critical values. So basically you set your numerator equal to 0. You say 7x minus 26 is equal to 0. We would add 26 to both sides of our equation. Cancel this. You get 7x is equal to 26. And then we can divide both sides by 7. We'll cancel this. We'll get x is equal to 26 over 7. Okay, so that's for the numerator. And essentially, you know already that that's not a solution because that would make the left side 0. And so you'd have 0 is greater than 0, which is a false statement, right? This is a strict inequality. Okay, in the denominator, x minus 5, if you set that equal to 0 and you solve, you get x is equal to 5. We know this doesn't work as a solution because that gives us division by 0, and that's undefined. Okay, so let's come to the number line, and we're going to do some testing. Now, if you're wondering which one is bigger, if you think about 5 or 26 over 7, well, just think about the fact that 28 divided by 7 would be 4. Right? So this is not quite 28, this is 26. So you know this is less than 4, so obviously this is going to be less than 5, right? So this would be 26 over 7, and this would be 5. And again, you can always use your calculator if you want. If you punch that up, you're going to get about 3.71. I think that's close enough if you just want an approximation of what the value of that is. Okay, let's get rid of this. We don't need it anymore. A, which is to the left of 26 over 7. B, which is between 26 over 7 and 5, and C, which is anything that's to the right of 5. So let me write A, B, and C here. And for A, I'm just going to pick 0. It's easy to work with. You would have negative 26 over negative 5. And so basically, we know that this is a negative over a negative, which is a positive, and so that is going to be greater than 0. So this is true. And then for B, you could pick something like 4. That would work. So 7 times 4 is 28. 28 minus 26 is 2. This is over. If you had 4 minus 5, that's negative 1. So this is negative 2. We're saying, is that greater than 0? The answer to that is no, so this is going to be false. A negative is never going to be greater than 0. So the next one, we want something in C, so something greater than 5. So let's pick 6. 7 times 6 is 42. 42 minus 26, that's going to be 16. And this will be over. 6 minus 5 is 1. So basically you get 16 is greater than 0, right? So this is a true statement. Okay, from here, we would just write our solution. We know that 26 over 7 and 5, those are both excluded. So we'll say that x is less than 26 over 7, and then or x is greater than 5. Okay, so let's stick that right there. Let's work on this one, and we'll come back, and we'll see what our solution is. Remember, these are combined with and, so they have to work in both. So let's take our 9 over x minus 5. Let's subtract 7 away from each side. And we'll say this is less than 0. Let me slide this down here so I can get a common denominator. Let me move this over here. So I'm going to multiply this by the quantity x minus 5 over this x minus 5. And here you have to be really careful because you're subtracting this away. So what I would do is say this is 9 minus, I'd put some brackets here. 7 times x is 7x, and then minus 7 times 5 is going to be 35. And then when I remove the brackets, I would just change the sign of everything. So this would be negative, and this right here would be positive. So now you want to do 9 plus 35. That's going to be 44. So negative 7x plus 44. And this is over your x minus 5, that common denominator. And this is less than 0. Okay, so you have to set the numerator equal to 0. So let's say negative 7x plus 44 is equal to 0. Subtract 44 away from each side of the equation. We're going to cancel this. We have negative 7x is equal to negative 44. So let's divide both sides by negative 7. Let's cancel this, and we get x is equal to, we're going to have 44 over 7. Okay, so that's one critical value. Again, this is not going to work because the left side would be 0, and the right side is 0. So you'd have 0 is less than 0, which is false. Then you would look at the denominator and say x minus 5 is equal to 0. You solve that, you get x is equal to 5. So 44 over 7 is a bigger number than 5. Again, if you don't know that, you can check something like 42 over 7, which would be 6. So obviously 6 is bigger than 5. And this is 44 over 7, so you know it's even bigger than 6. If you punch it into your calculator, you get about 6.29 in case you want an approximation. So let's say A is anything less than 5, B is between 5 and 44 sevenths, and C is anything greater than 44 sevenths. So you've got your A, your B, and your C. So let's look at what we have here. So first, I would pick something in A. Let's just pick 0. So that's going to be 44 over negative 5. So let me write that out. So 44 over negative 5. Is that less than 0? Well, yeah, this is negative, so it's going to be less than 0, so this is true. Okay, in B, let's pick 6. So negative 7 times 6 is negative 42. And then negative 42 plus 44 is 2. And this is over. 6 minus 5 would be 1. So this is positive 2. Is that less than 0? No, this is going to be false. So this is false because a positive is not less than 0. Okay. Then for C, let's just pick 7. So negative 7 times 7 is going to be negative 49. Then plus 44, that's negative 5. So you have negative 5 over. This guy right here, if you have 7 minus 5, that's going to be 2. So this is negative 5 halves. Is that less than 0? Yes, that's a true statement. A negative is always less than 0. Okay, let's get rid of all this. Remember that those guys, 5 and 44 over 7, do not work. So let's say that x is less than 5. Then or x is greater than 44 sevenths. Okay, so I'm going to write and here, and then I'm going to paste my solution in. And it's best to actually think about this on a number line. I think it can be a bit confusing if you don't use one, but if you're pretty good at working these problems, maybe you don't need one. So you have 3 values. You have 26 over 7. So that's going to be all the way over here. Remember, that was about 3.71. Then you have 5, and then you have 44 over 7. Remember, this was about 6.29. So thinking about this, the first solution here, we say x is less than, and strictly less than, this 26 over 7. So let me put an open circle here and shade to the left. Then we say or x is greater than 5. We put a circle here and shade to the right. Okay, for the other guy, we're saying x is less than 5. So let me put a circle here and shade to the left. And then we'll say or x is greater than 44 over 7. So now we want to look for the overlap. So thinking about what doesn't work, 26 over 7 does not work in both. Works in this one, but doesn't work in this one. So go ahead and mark that out. And none of this part right here is going to work in both. This doesn't work in both. 5 doesn't work in both. And you can say that things that are greater than 5 don't work in both. Going all the way here, 44 over 7 doesn't work in both. So basically what works in both is going to be anything that's less than 26 over 7. You can see that both of those guys are going to be satisfied for those values. So you'd say x is less than 26 over 7. Then or anything that's greater than 44 over 7. So x is greater than 44 over 7. Okay, coming back here, I want this one. So x is less than 26 over 7, or x is greater than 44 over 7. All right, let's take a look at question 10. So here we have the absolute value of 2x squared, then minus 7x, then plus 5. And this is greater than or equal to 5. Now this one's a bit tricky. And parts of this are things that we have not covered yet in this course. So if you struggled with this, let's go through this step by step here. So the first thing is, if you have something like the absolute value of u is greater than or equal to 5, that tells us that u is less than or equal to negative 5, or u is greater than or equal to 5. So we know this setup at this point. So here I'm just going to say that what's inside here, the 2x squared minus 7x plus 5, that's going to be my u. So I'm going to say 2x squared minus 7x plus 5, that's going to be less than or equal to negative 5, then or the 2x squared minus 7x plus 5 is greater than or equal to 5. Okay, let's work on the guy on the left first. This is the one you're going to have the most trouble with. So at this point, what I'm going to do is just add 5 to each side of the inequality. This would cancel and give me 0. So I'm just going to rewrite this and say that this is 2x squared minus 7x plus 10. Okay, so plus 10 there. And then what you would do is find the critical values. So you'd replace this with equals, and you would say this is 2x squared minus 7x plus 10. But there's a problem. This is going to give you 2 non-real complex solutions. First off, you can't factor this. If you tried, you put a 2x here and an x here. This is negative and this is positive, so this is minus and minus. 10 is 1 times 10 or 2 times 5. Now, you cannot put a 10 here because you'd have a common factor of 2. If you put a 10 here and a 1 here, that's not going to work, right? This is negative 20 minus 1, which is negative 21. That doesn't work. I'm trying to get to negative 7. If you switch this up and go with 5 and 2, well, I can't put the 2 here, so I'd have to put a 5 here and a 2 here. Now, this is going to be negative 4 minus 5, which is negative 9, so that doesn't work either. So this isn't something you can factor. Okay, so going to the quadratic formula, this is A, this is B, and this is C. So x is equal to the negative of b. So the negative of negative 7 is 7. Then plus or minus the square root of b squared. So negative 7 squared is 49. Then minus 4 times a is 2. Then times c is 10. 4 times 2 is 8. 8 times 10 is 80. So this is 80 here. And then 49 minus 80 is negative 31. So what is the square root of negative 31? Well, I'll just pull the I out, which is the square root of negative 1, and say this is I times the square root of 31. Okay, then this is over your 2a, a is 2, so 2 times 2 is 4. So obviously, these solutions here, these two non-real complex solutions, we've never seen that when solving a quadratic inequality. So what do you do? Well, to give you a little insight, I want you to first think about, what does this mean? Some of you have taken Algebra 2 before, so you know that when you set this guy equal to 0 and you're solving, you're finding the x-intercepts, right? Hopefully you remember that from basic algebra. But essentially, if you were to go to an online graphing calculator like Desmos, and you look at this guy graphically, the 2x squared minus 7x plus 10, you see that this graph does not impact the x-axis. Doesn't at all. So since we're trying to figure out where this graph is less than or equal to 0, well, you can look at the graph and you can see that that's never going to happen. It's always greater than or equal to 0, so this would never be true, right? There's no solution or no value that you could plug in for x such that this guy right here would be less than or equal to 0. Now, if you couldn't graph, what you would do, forget about this, let's get rid of this, we don't need this anymore. You come to that point and you come back and you say, okay, this is either going to always be true or never be true, right? Because again, with that type of solution, you're not going to have any x-intercepts, so you're either always above 0 or you're always below 0. So with this one, just pick any value you want and test. So let's say I pick something like 0, just to make it easy. This is gone, you would have 10 is less than or equal to 0, which is false. So if you test a value in the domain and it doesn't work, well, then you could just say it's no solution. If you test a value in the domain and it works, then you could say it's all real numbers, because no matter what x you plug in there, you're always going to satisfy that inequality. Okay, and we'll go deeper into this later on in the course. For right now, we're just going to leave it here and just say that there's no solution. Again, if you're a little bit confused, it's not that big of a deal. Again, it's something that does require a bit of thought. Okay, so then I'm going to say or. Now, because I have or, when you have no solution and then or, it's just the solution from this. I don't even need to consider this part. You can just get rid of it at this point. Over here, I have 2x squared and then minus 7x. I'm going to subtract 5 away from each side. So that's basically plus 0 is greater than or equal to 0. So I'll say this is greater than or equal to 0. So this is something I can factor pretty easily. I'll pull out an x and say this is 2x minus 7, like this, and this is greater than or equal to 0. Now for your critical values here, let's go ahead and say x times the quantity 2x minus 7 is equal to 0. So x here would be equal to 0, or 2x minus 7 would be equal to 0. Let's add 7 to both sides and cancel that. So you get 2x is equal to 7. Let's divide both sides by 2, and you get x is 7 halves. So x is 0 or x is 7 halves. And let's come down here and test. So again, these are the solutions from the related equation. So we're going to put 0 here and 7 halves here. You can delete this now, and you're just going to test. So this is A, anything that's less than 0. B is going to be between 0 and 7 halves. And C is going to be anything greater than 7 halves. So for A, let's pick -1. So you have -1 times the quantity. 2 times -1 is -2. And -2 minus 7 is -9. So we know -1 times -9 is 9. So this is a positive 9. Is that greater than or equal to 0? Yes, this is true. Okay, for B, let's pick 1. 2 times 1 is 2. Minus 7 is -5. And this is multiplied by 1. And of course, this is a negative. And a negative is not greater than 0. So this is false. And then let's think about 4. So 2 times 4 is 8. And then 8 minus 7 is 1. And this would be times 4. So this is 4. 4 is greater than 0. So this is true. We would say that x is less than or equal to 0, and this would be included because this is a non-strict inequality. Then we would say or x is greater than or equal to 7 halves. Again, it's included because it's a non-strict inequality. So let's grab this, and coming back up here, let's get rid of this. I'm just going to paste the solution. Again, if you have no solution or this solution, then you just take this solution. And coming back up here, you want this one. So x is less than or equal to 0, or x is greater than or equal to 7 halves. So again, this is a tough one. I would recommend graphing this one if you're still a bit lost. So here's the absolute value of 2x squared minus 7x plus 5. And you're looking for where that's greater than or equal to 5. So where is the y value of this function greater than or equal to 5? Well, it's equal to 5 here at 0. Anything to the left of 0, so saying x is less than or equal to 0, that would work. Then as we continue to the right, so values to the right of 0 don't work until we get back to an x value of 3.5, let me see if I can hit it. So 3.5 is 7 halves, and then anything to the right. So x is greater than or equal to 7 halves or 3.5, it's going to start working again. So this is how you could find your solution graphically if you're a little bit lost. All right, let's take a look at the quiz. For the first question, we see that we're given a coordinate plane, and we have a point that's labeled as A. So let's come down here, and it says to find the ordered pair that corresponds to the plotted point A and state the quadrant in which it is located. Okay, let's come back up here and think about this for a moment. So hopefully you understand at this point that this horizontal axis is the x-axis and this vertical axis is the y-axis. So if I look at this point right here, I can think about, well, what's the location on the x-axis? That's going to be 6. What's the location on the y-axis? Well, let me write this in. This is going to be a 5. So in other words, the x-coordinate is 6 and the y-coordinate is 5. We write that as an ordered pair as the x-coordinate, again, which is 6, comma, the y-coordinate, which is 5. So 6, 5, that would be my ordered pair. Now, in terms of the quadrant, you need to think about the fact that this guy right here in the top right-hand corner, that's going to be quadrant 1, and then you're going to rotate counterclockwise. So this would be 2, this would be 3, and this would be 4. Okay, so this guy right here, we're looking for 6, 5 for the ordered pair, and then the quadrant would be 1. So let me copy this, and I'll just paste this in here. So I am looking for this first answer right here, which says 6, 5, again, an x value or an x coordinate of 6, and then a y value or a y coordinate of 5, and then it's in the first quadrant. All right, let's take a look at question 2. So again, we're given a coordinate plane. We have this point, which is labeled as A. Coming down to the question, it says find the ordered pair that corresponds to the plotted point A and state the quadrant in which it is located. So let's come back up here, and let's remember again how this works. When you have an ordered pair, it's the x value or the x coordinate, comma, the y value or the y coordinate. Well, thinking about this, what's my x location? We can just kind of come down here to where I would be on the x axis, and that's going to be -6. Let me use a different color here. So that's going to be right there. And probably that one isn't the best color, so let me change that up and use this one. That looks like that shows up better. What's the y coordinate here? So going over to the y-axis, that's going to be right here. Let me put in a 7 there, and let me circle that there. So if we think about the coordinates for this point, the x-coordinate is -6, that's listed first, and then comma the y-coordinate is going to be 7, that's listed second. So this would be -6, 7. Now what quadrant am I in? Again, this is the first quadrant. Always remember, it's in the top right-hand corner. If you remember that, and that everything else is counterclockwise, you're good to go. This would be quadrant 2, then this would be quadrant 3, and this would be quadrant 4. So in this particular case, we're in quadrant 2. So this would be quadrant 2. Okay, so looking through my choices, it's going to be this one right here. So you have -6, 7, and then you're going to be in quadrant 2. All right, let's take a look at question 3. So here again, we have our coordinate plane, we have our point A, and we're asked to find the ordered pair that corresponds to the plotted point A and state the quadrant in which it is located. So coming back up here, again, think about the x coordinate or the x value, and then the y coordinate or the y value of this point. So thinking about this on the x-axis, just line things up. This is going to be, let me arrow to this, this is -4 here. So this right here would be -4. And then in terms of the y-axis, just coming down here and line this up, this is going to be -7. So this is -7 here. So the coordinates for this point, again, the x coordinate is listed first. So that's going to be -4. And then the y coordinate is listed second. So that's going to be -7. So this ordered pair would be -4, -7. And then again, what quadrant am I in? This is the first quadrant, always the top right, and it goes counterclockwise. So this is 2, and then this is going to be 3, and then this is going to be 4. So we're going to be in quadrant 3. So we'll say that the coordinates here, we'd have -4, -7. That's as an ordered pair. And then the quadrant is going to be 3. So let's grab this, and let's paste this in here. So I'm looking for -4, -7, and then quadrant 3. So this guy right there. All right, let's take a look at question 4. So here again, we have our coordinate plane and we have our point A, and we're asked to find the ordered pair that corresponds to the plotted point A and state the quadrant in which it is located. So we see that the x location, let me just write this in, is going to be at 8. And then the y location, that's going to be at -3. So for the coordinates for this point, again, the x coordinate is first, so that's going to be 8. And then comma, the y coordinate is second, so that's going to be -3. So this is 8, -3. Now, what quadrant are we going to be in? Again, the top right-hand corner is going to be quadrant 1, and then you're going to rotate counterclockwise. So this is going to be 2, this is going to be 3, and this is going to be 4. So this would be 8, -3, and then you're in quadrant 4. So looking through this is the answer we want. So it's 8, -3, and then you're in quadrant 4. Okay, let's take a look at question 5. So now we're given this, again, point A that's on the coordinate plane, and we're asked to find the ordered pair that corresponds to the plotted point A and state the quadrant in which it is located. So thinking about this point, notice that you're on the x-axis, meaning that your y-coordinate is going to be 0, right? If you think about the location coming from the origin, well, I just moved to the left by 7 units. This is going to be -7 here. And I'm not moving up at all, and I'm not moving down at all. So basically, the x-coordinate here would be -7. That's how far I moved to the left. I moved to the left by 7 units, so that's -7. And then I didn't move at all up or down, right? So my y-coordinate here is going to be 0. So this is -7, 0. Now, here's the tricky part and where you might have gotten stuck. This is quadrant 1 in the top right-hand corner. This is quadrant 2. We're rotating counterclockwise. This is quadrant 3, and this is quadrant 4. What happens if you're on the x-axis or the y-axis? Some people would say, okay, this is quadrant 2, and then some people are going to say, well, this is quadrant 3. Both of those answers are actually incorrect. So if you're on the x-axis or the y-axis, you're said to not be in any quadrant. Okay, so that's really important to know. So this is -7, 0, and we would say not in any quadrant, like that. So let's paste this in here. And so this is the answer we want. So -7, 0, and we're not in any quadrant. All right, let's take a look at the quiz. For the first question, we're asked to find the distance between each pair of points. So you have 3, 9, and then you have 6, 13. Okay, let's grab this real quick, and let's just paste this in here. So let's label the first point as x1 and then y1. And the second one will be x2 and then y2. So let's say the distance between the 2 points is equal to the square root of, for your x2, that's going to be 6, and then minus for your x1, that's going to be 3. So this is quantity squared. And then plus, you're going to have your y2, which is 13, and then minus your y1, which is 9. This is quantity squared. Okay, this equals the square root of 6 minus 3 is 3. 3 squared is 9. And then plus 13 minus 9 is 4. 4 squared is 16. So this is equal to the square root of 9 plus 16 is 25. So this equals 5. So coming back up, this would be 5. All right, for question 2, we're asked to find the distance between each pair of points. So what we have here is -11, 17, and then we also have -2, 57. So let me grab this real quick, and let's paste this in here. So let's just say this is x1 and this is y1. Let's say this is x2 and this is y2. All right, so let's plug into the formula. So the distance is equal to the square root of, for x2, that's -2. And then minus for x1, that's going to be -11. So minus a negative is plus a positive. So -2 minus a -11, like this, is going to turn into -2 plus 11. And let me close that down and say this is quantity squared. And then plus, now you've got this y2 minus y1. So y2 is 57. And then minus y1, which is 17, quantity squared. Okay, so this equals the square root of -2 plus 11 is 9. So this is 9 squared. So 9 squared. And then plus 57 minus 17 is 40. So this is 40 squared. Let me move this up a little bit so it's more clear. So this equals the square root of 9 squared is 81. And then plus 40 squared, that's going to be 1600. So let's say this is equal to, this would be the square root of 1600 plus 81 would be 1681. So let's punch this into the calculator and see if we get an integer. And I get exactly 41. Let's come back up here and say that it's 41. All right, let's take a look at question 3. So again, we're asked to find the distance between each pair of points. So we have negative 8, comma 20, and then we have negative 13, comma 15. So let's grab this and let's paste this in here. So let's go ahead and say that this is x sub 1 and this is y sub 1. Let's say that this is x sub 2 and this will be y sub 2. And then I'm just going to plug in. So the distance is equal to the square root of. You have x sub 2, which is negative 13. And then minus x sub 1, which is negative 8. So again, minus the negative is plus positive. So let's put plus 8 here, quantity squared. And then plus for y sub 2, that's 15. And then minus for y sub 1, that's going to be 20. And this is quantity squared. So this equals the square root of. Negative 13 plus 8 is negative 5. So this would be negative 5. Again, make sure to wrap this. And this is squared. Then plus 15 minus 20 is also negative 5. Again, make sure to wrap this. And this is squared. So this equals the square root of, basically negative 5 squared in each case is 25. So you're going to have 25 plus 25, which is 50. Now, you can simplify that because if you think about 50, it's going to be 25, which is a perfect square, times 2. So let's say the square root of 25 times the square root of 2. We know the square root of 25 is 5, so this is 5 times square root of 2. So let's come back up and look for 5 times square root of 2 as our answer. All right, let's take a look at question 4. So again, we're asked to find the distance between each pair of points. So you have negative 22, comma negative 1, and then you have a negative 31, comma negative 13. So let's grab this real quick, and let's paste this in here. So again, let's just say this is x sub 1, and this is y sub 1. Let's say this is x sub 2, and this is y sub 2. So the distance between the 2 points is equal to the square root of. For x sub 2, that's going to be negative 31. And then minus for x sub 1, that's negative 22. So again, minus a negative is plus a positive. So this is plus 22. This is quantity squared. And then plus you have y sub 2, which is negative 13. And then minus y sub 1, which is negative 1. Again, minus a negative is plus a positive. So that's plus 1, quantity squared. So this equals the square root of negative 31 plus 22. That's going to be negative 9. Again, make sure to wrap that in parentheses. So negative 9 squared. Then plus negative 13 plus 1, that's negative 12. Again, wrap that in parentheses. So this is squared. So let me come down a little bit. So this equals the square root of negative 9 being squared is 81. And then plus negative 12 being squared is 144. If you do 81 plus 144, you're going to get 225. So this is the square root of 225. And most of you know that the square root of 225 is 15. Let's come back up and say that this is 15. All right, let's take a look at question 5. So we're asked to find the distance between each pair of points. So we have 27, comma 14. And then we're going to have 38, comma 74. Okay, let's grab this real quick. So we'll say the distance is equal to the square root of, let's again just label this as x sub 1 and this as y sub 1. This will be x sub 2 and this will be y sub 2. So the quantity x sub 2, which is 38, minus x sub 1, which is 27, so quantity squared, then plus. Then we're going to have this quantity y sub 2, which is 74, and then minus y sub 1, which is 14, again, quantity squared, so this equals the square root of 38 minus 27 is 11, so we would have 11 squared, and then plus 74 minus 14 is going to be 60, so this is 60 squared. So definitely something you want to use a calculator for. So I would actually do this in one shot. So this equals the square root of, I would just key this in. So 11 squared is 121 and 60 squared is 3600. But again, just key it in one shot and you're going to get the square root of 3721. And then you could hit the square root key and you're going to get exactly 61. So let's come back up and say that 61 is the answer. All right, let's take a look at the quiz. For question 1, we want to determine if the points A, B, and C are the vertices of a right triangle. Let me write this out. So A, that's going to be negative 2, comma 3. And then for B, that's going to be 3, comma 6. And then for C, that's going to be negative 4, comma 1. Okay, let's grab this real quick. And let's come down here and paste this in. So the idea is that you want to find the distance between A and B, the distance between A and C, and then the distance between B and C, and you want to plug in to the Pythagorean theorem. So we know that A squared plus b squared is equal to c squared. Now, this a here is not related to this a here. This b here is not related to this b here. And this c here is not related to this c here. Okay, this is just me naming the points. This right here is from the Pythagorean theorem, where a and b, those are the lengths for the two shorter sides, known as legs. And then c here is the hypotenuse, which is the longest side in a right triangle. It's opposite of the 90-degree angle. So let me actually move this down here. We don't need this right now. Actually, I'll just erase it. I'll just write it in when we need it. Let's first figure out what is the distance between a and b. So this would be equal to the square root of, again, the distance formula is you have x sub 2 minus x sub 1 quantity squared, plus you have y sub 2 minus y sub 1, and I put x sub 1, so this should be y sub 1, and this is quantity squared. Okay, so for this, you're looking at a and b. You can label the points however you want. So you could say this is the first point and this is the second point, or you could say this is the second point and this is the first point. It doesn't matter. I'm just going to slide this down like this, and it looks like it didn't take that with it, so let me do that. And I'm just going to label this as x sub 1 and this is y sub 1, and then this as x sub 2 and this is y sub 2. And so for x sub 2, that's going to be 3. For x sub 1, that's going to be negative 2, so minus a negative 2 is plus 2. And then for y sub 2, that's going to be 6. And then for y sub 1, that's going to be 3. Okay, so 3 plus 2 is 5. 5 squared is 25. And then 6 minus 3 is 3. 3 squared is going to be 9. So 25 plus 9 is 34. So this right here is the square root of 34. Now, 34 is 17 times 2, so nothing you can really do with that. Okay, let's now go with the distance with, let's go a and c. So we'll go a and c. So that's equal to what? So the square root of, again, so you have your x sub 2 minus x sub 1 quantity squared, plus your y sub 2 minus your y sub 1 quantity squared. Okay, so let me actually just slide this down here. And it looks like it didn't take that, so I'll just rewrite it. So for x sub 2, it's negative 4. And then for x sub 1, it's negative 2. So minus a negative 2 is plus 2. For y sub 2, it's going to be 1. And then for y sub 1, it's going to be 3. So this right here, negative 4 plus 2 is going to be negative 2. So this is going to be negative 2 being squared. So negative 2 being squared is going to be 4. And then this, 1 minus 3 is going to be negative 2. So negative 2 being squared is going to be 4. So this right here is 4 plus 4, which is going to be 8. So the square root of 8 is basically going to be, let me just write this as 4 times 2 like this. The square root of 4 is 2, so this is 2 times square root of 2. So this is 2 times square root of 2. Okay, the last one we need, we did a and b, and then we did a and c, so now we need b and c. So the distance between b and c is equal to the square root of, so let me slide this down like this. And so for this one, you go x sub 2 minus x sub 1, quantity squared. Let me slide this up just a little bit so it fits, and it looks like I missed that, so move that up. And then plus, you have your y sub 2 minus y sub 1, quantity squared. Okay, so x sub 2 is negative 4, and then x sub 1 is 3, and then y sub 2 is 1, and then y sub 1 is going to be 6. All right, so looking at this, negative 4 minus 3 is negative 7. So this would be negative 7 being squared, which is going to be 49. And then this one is 1 minus 6, which is negative 5. And then negative 5 squared is going to be 25. So 49 plus 25, that's going to be 74. So this is the square root of 74. Now, thinking about 74, it's an even number. And if you divide it by 2, you get 37. So you're pretty much going to be stuck there. So this is just the square root of 74. Now, which one of these is going to be the largest? Let me actually get rid of this before we think about that. Well, this is the square root of 34, and this is the square root of 74. So clearly, this is larger than this. So really, you would just need to compare these two if you didn't know what 2 times the square root of 2 was. So let's go ahead and punch that into the calculator. And I get about, let's say, 2.8. I'm just going to say this is about 2.8. And for this one, I get about 8.6. So this one's clearly the largest. Let me get rid of this. And so when you do the a squared plus b squared equals c squared, the largest guy here has to go in the place of c, which is the hypotenuse for a right triangle, which means that it's going to be the longest side, right? So it has to be the largest value. So let's go ahead and say that this is the square root of 34 being squared plus 2 times square root of 2 being squared. And this equals the square root of 74 being squared. And let's go ahead and say that the square root of 34 being squared is 34. And then plus 2 squared would be 4. And then times the square root of 2 being squared is 2. 4 times 2 is going to be 8. And this equals the square root of 74 being squared is going to be 74. We can see that this is not going to work. 34 plus 8, that's going to be 42. So you would get 42 is equal to 74, and that's going to be a false statement. So I'm just going to say that these are not equal. So 42 is not equal to 74. So coming back up here, we would say no, these are not the endpoints of a right triangle. All right, let's take a look at question 2. So again, we are asked to determine if the points A, B, and C are the vertices of a right triangle. So let's go ahead and write down that A is negative 5, 6, and then B is going to be 8, 0, and then C is going to be 2, negative 13. Okay, let's grab this real quick. Come down here and let's paste this in. So we need to find the distance between A and B. We need to find the distance between A and C. And then we need to find the distance between B and C. Okay, so equals, equals, and equals. Let me slide these down here. So I'm just going to put the square root of this quantity x sub 2 minus x sub 1 squared plus this quantity y sub 2 minus y sub 1 squared. Okay, let me grab this and copy it. And let me paste this in here. And let me paste this in here. And let's just go ahead and start with the first one. I'll label this as x sub 1 and then y sub 1. And this can be x sub 2 and then y sub 2. So for x sub 2, you have 8. And then for x sub 1, you have negative 5. So minus negative 5 is plus 5. For y sub 2, you have 0. And then for y sub 1, you have 6. So this right here, 8 plus 5 is 13. 13 squared is 169. So this is 169. Then here, 0 minus 6 is negative 6. Negative 6 squared is 36. So this is plus 36. 169 plus 36, that's going to be 205. Now, for the square root of 205, you really can't simplify that because 205 is 41 times 5. Let me just shorten this a little bit and say this is the square root of 205. Okay, for this one, let me just slide this down a little bit. And so for x sub 2, this is going to be 2. And then for x sub 1, that's going to be negative 5. So minus the negative 5 is plus 5. For y sub 2, it's negative 13. And then for y sub 1, it's going to be 6. And so 2 plus 5 is 7. 7 squared is 49. And then for this one, negative 13 minus 6 is negative 19. So negative 19 squared, that's going to be 361. And 49 plus 361, that's going to be 410. All right, so you could write this as 41 times 5 times 2, and you're going to see that nothing's going to simplify. Basically, this is 205 times 2, right? You see that. So this is the square root of 410. Okay, for this one, we need B and C. So let me slide this over here. So we're going to say x sub 2 is 2, and then x sub 1 is 8. And then we're going to say for y sub 2, that's negative 13. And then for y sub 1, that's going to be 0. All right, so 2 minus 8 is negative 6. So this right here would be negative 6 being squared, which is 36. And then negative 13 minus 0 is negative 13. And negative 13 squared is 169. So 36 plus 169, that's 205. Let me shorten this. So this is also the square root of 205. And this one is the square root of 410. Let me make that a little bit shorter. Okay, so obviously this is the largest one. So when you plug into your formula, let me get rid of this. Your a squared plus b squared equals c squared. This guy right here needs to get plugged in for c, okay? This one and this one, the order is not going to matter. So we would have the square root of 205 being squared. Now, you could just multiply this by 2, or you could do it again. So plus the square root of 205 being squared is equal to the square root of 410 being squared. Now, you can see that this is going to work out. Let me put a little border here, like this. This right here, the square root of 205 being squared is 205. So you'd have 205 plus 205, which is 410. And this would be equal to the square root of 410 being squared is 410. So this is a true statement. So we'll come back up and say, yes, these are the endpoints of a right triangle. All right, let's take a look at question 3. So we're asked to determine if the points A, B, and C are the vertices of a right triangle. So let's copy. We have -4, 3. That's going to be for A. And then for B, we have 2, 5. And then for C, we have -1, -6. Okay, let's grab this real quick. And let's paste this in. So the distance between A and B, we need that. So let's put the square root of. We have this x sub 2 minus x sub 1 quantity squared, plus we have y sub 2 minus y sub 1 quantity squared. Then we need the distance between A and C. So this is, again, let me actually just copy this. I think this would be a little bit easier than just writing it 3 times. So let me just put that there. And I'll actually paste that again and put that there and say the distance between B and C is equal to this. Okay, let me slide this down just slightly so we can label the first guy. This is x sub 1, this is y sub 1, and then this is x sub 2, and this is y sub 2. Okay, for x sub 2, we have 2. And then for x sub 1, we have -4, so minus a -4 is +4. For y sub 2, we're going to have 5. And then for y sub 1, we're going to have 3. So 2 plus 4 is 6. 6 squared is 36. And then 5 minus 3 is 2. 2 squared is going to be 4. And so 36 plus 4 is 40. So you'd have the square root of 40. Let's write 40 as 4 times 10 because 4 is a perfect square. The square root of 4 is 2. So this right here would be 2 times the square root of 10. Okay, for this one, let me slide this over like this. And so for x sub 2, it's going to be -1. And for x sub 1, it's going to be -4. So minus a -4 is +4. For y sub 2, it's -6. And then for y sub 1, it's going to be 3. Okay, so -1 plus 4 is going to be 3. 3 squared is 9. And then -6 minus 3 is -9. So this is -9 being squared, and that's going to be 81. So this is plus 81. So 9 plus 81 is 90. And so for 90, let's think about it as 9 times 10, because 9 is a perfect square. So we think about the square root of 9 as 3, so this is 3 times square root of 10. So 3 times square root of 10. Okay, for this guy, let's slide this down here like this. And I didn't take that with me, so let me recopy that. And let's say x sub 2 is -1. And then x sub 1 is going to be 2. And then for y sub 2, that's going to be -6. And then for y sub 1, let's say that's going to be 5. So let's get rid of this and crank this out. So -1 minus 2 is going to be -3. So this is -3 being squared, which is going to be 9. And then for this guy, -6 minus 5, that's -11. So this is -11 being squared, which is going to be 121. And so for this one, 9 plus 121 is 130. So this is the square root of 130. And can you simplify that? 130 is 13 times 10, or 13 times 5 times 2. So no, that's as good as you can do. So this is the square root of 130. Now, you might be looking at this. You know that 3 times square root of 10 is larger than 2 times square root of 10. So this right here cannot be the hypotenuse. So it's either going to be this one or this one. This guy right here, if you punch it into your calculator, it's about 9.5. And then for this one, it's about 11.4. So this one is the largest. So when you plug into your formula, again, this is what you're going to plug in for C. So you have a squared plus b squared is equal to c squared. So for A, it's 2 times square root of 10. This is going to be squared. And then plus for B, it's going to be 3 times square root of 10. And this is going to be squared. And this equals, for C, it's going to be the square root of 130. And this is going to be squared. 2 squared is 4. The square root of 10 squared is 10. So this would be 4 times 10, which is 40. So we would have 40 here. And then plus 3 squared is 9. And then times the square root of 10 squared is 10. So 9 times 10 is going to be 90. Is this equal to the square root of 130 being squared is 130? Well, 40 plus 90 is 130. So you get 130 is equal to 130. So this does work. So we do have the endpoints or the vertices of a right triangle. All right, let's take a look at question 4 now. So we are asked to determine if the points A, B, and C are the vertices of a right triangle. So let's copy down that A is going to be 12, 5. Let's copy that B is going to be 1, 7. And then lastly, C is going to be 8, 10. All right, so let me write this out. So the distance between A and B, we want the distance between A and C, and then we want the distance between B and C. So let me put this equals the square root of. We'll go our x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Let's make that 2 a little bit better there. And I'm just going to copy this and paste that in there and then also there. And maybe I could scooch this up just a little bit. And I think that looks pretty good. Maybe I'll move that up a little bit more too. Okay, so starting with this first guy here, I'll label this as x sub 1 and this as y sub 1. And then this will be x sub 2 and then y sub 2. So just plug in. For x sub 2, you have 1. For x sub 1, you're going to have 12. And then for y sub 2, you're going to have 7. And then for y sub 1, you're going to have 5. So 1 minus 12 is negative 11. So this is negative 11. And then negative 11 squared is going to be 121. And then over here, 7 minus 5 is going to be 2. And 2 squared is going to be 4. So if we think about 121 plus 4, that's 125. And for 125, it's 5 cubed. So what I would do is say that this is the square root of 25 times 5. And the square root of 25 is 5. So this right here is going to be 5 times the square root of 5. Let me make that a little bit better there. Okay. For the next one, I'm just going to slide this over like this. And for x sub 2, now we're going to have 8. For x sub 1, we're going to have 12. For y sub 2, we're going to have 10. And then for y sub 1, we're going to have 5. So 8 minus 12 is going to be negative 4. And then negative 4 squared is going to be 16. Then over here, 10 minus 5 is going to be 5. And 5 squared is 25. So if we think about 16 plus 25, that's going to be 41. So this right here would be the square root of 41. Now let me slide this over so we can do the last guy here. So x sub 2 would now be 8. And then x sub 1 would be 1. And then over here, y sub 2 would be 10. And then y sub 1 would be 7. So 8 minus 1 is 7. 7 squared would be 49. And then here, 10 minus 7 would be 3. And 3 squared would be 9. So you have 49 plus 9. And that's going to be 58. So this would be the square root of 58. And let's write our formula. So a squared plus b squared is equal to c squared. Again, the most important thing here is that you figure out what is the largest value. You're going to plug that in for c, because again, if you do have a right triangle, c is the longest side because it's the hypotenuse, which is the side that is opposite of your 90-degree angle. So the square root of 58 is obviously greater than the square root of 41. But what about comparing it to 5 times the square root of 5? That's not so easy to do. So let's just use our calculator. If I punch up 5 times square root of 5 in my calculator, let's just say I get about 11.2. I'll just round to the nearest tenth. I would normally just forget about this, but because it's a tutorial, I'm just going to punch it into my calculator anyway. And let's say this is about 4. Just round to the nearest tenth. And then this one is about, let's say 7.6. Again, if you round to the nearest tenth. Okay, so obviously 5 times square root of 5 is the largest value here. So that needs to be plugged in for c. The other two, it doesn't matter the order. So I'm just going to say that you have the square root of 41 being squared. And then plus, you have the square root of 58 being squared. And this equals 5 times the square root of 5 being squared. Maybe I can make that 5 a little bit better there. So we really don't need this information anymore. We can get rid of it. And so it's fairly straightforward. The square root of 41 being squared is 41. And then plus the square root of 58 being squared is 58. Does this equal 5 times square root of 5 being squared? Well, 5 squared is 25. The square root of 5 being squared is 5. 25 times 5 is 125. Well, 41 plus 58, that's going to give me 99. So is 99 equal to 125? So this is not equal to here. So we can go back up and say, no, these are not the endpoints or the vertices of a right triangle. All right, let's take a look at question 5. So we want to determine if the points A, B, and C are the vertices of a right triangle. So let's say that A is going to be -2, 5, B is going to be 12, 3, and then C is going to be 10, -11. Okay, let's grab this real quick and let's paste this in. So let's just go ahead and set this up. So the distance between A and B, and then the distance between A and C, and then lastly, the distance between B and C. So let me just write this once. So we'll say equals the square root of, you have your x sub 2 minus x sub 1 quantity squared, plus your y sub 2 minus y sub 1 quantity squared. Okay, let me grab this, and I'm just going to paste it in here, like that. And then I'll paste it in again like that. All right, so I'm just going to slide this down just a little bit for labeling. And we'll go ahead and say that this right here would be x sub 1, and this would be y sub 1. And then this would be x sub 2, and this would be y sub 2. So let's plug in. For x sub 2, it's going to be 12. For x sub 1, it's going to be -2. So minus the -2 is plus 2. For y sub 2, it's going to be 3. And then for y sub 1, it's going to be 5. So what I do here is 12 plus 2 is 14. 14 squared is 196. And then over here, 3 minus 5 is -2. And then -2 squared is going to be 4. So 196 plus 4 is going to be 200. So what is the square root of 200? Well, let's write that as 100, which is a perfect square, times 2. Square root of 100 is 10. So this is 10 times square root of 2. So 10 times the square root of 2. Maybe that square root symbol can be a little bit better. All right, for the next guy, let's just go ahead and slide this down like this. And so we have x sub 2 as being 10, and then x sub 1 is going to be -2, so minus the -2 is plus 2. Y sub 2 is -11, and then y sub 1 is 5. If we look at 10 plus 2, that's 12. 12 squared is 144. And then -11 minus 5 is -16. So -16 squared, that's going to be 256. So 144 plus 256, that's 400. And the square root of 400 is going to be 20. So let's put 20 right there. And then over here, let me slide this down. So we can do this one. And maybe that needs to go a little bit further down. So for x sub 2, that's going to be 10. For x sub 1, that's going to be 12. For y sub 2, that's going to be -11. And then for y sub 1, that's going to be 3. So 10 minus 12 is going to be -2. So this is -2 being squared. And then -11 minus 3 is going to be -14. So -2 squared here is going to be 4. And then -14 squared is going to be 196. So we know that 4 plus 196 is 200. And we did this earlier. The square root of 200 is 10 times square root of 2. So this one is 10 times square root of 2. Maybe I can make that a little bit better. So 10 times square root of 2 is about 14.1. So it is less than this. So what you'd want to do is use 20 as the value for c in your Pythagorean theorem. So a squared plus b squared equals c squared. I think you can see this is going to work out. You're going to have 10 times the square root of 2 being squared, then plus 10 times the square root of 2 being squared, and this would be equal to 20 squared. Let me get rid of this. And so this would be 10 squared, which is 100, and then times the square root of 2 squared, which is 2. So this is 200 plus 200, which is 400, is equal to 20 squared is 400. So this is a check. So yes, these are the endpoints of a right triangle. All right, let's take a look at the quiz. For the first question, we're asked to determine whether the 3 points are collinear. That means they lie on the same line. So we have our point A, which is 6, 3. We have our point B, which is 2, 9. And then we have our point C, which is -4, 17. Okay, let's grab this real quick and let's paste this in. Now, I want to remind you that later on in the course, we are going to see a much faster method for this. So it's going to be with determinants and you're going to have a formula for finding the area of a triangle. Basically, you're going to plug in and see if it's 0. If it is, then the points are collinear. If it's not, then they're not. So it's a very simple formula. For right now, we're kind of stuck with this. So let's just go through it as quickly as we can. We know this is a very tedious process. So the distance between A and B, that's what we're going to find first. And then the distance, let's say A and C, and then the distance for B and C. So this is equal to, and then equal to. Let me go the square root of. So I'm going to put x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Okay, let me copy this part. And then I'm actually going to paste this in here and then paste this in here. All right, so what I'm going to do is label this as x sub 1, and this is y sub 1, and then this is x sub 2, and this is y sub 2, and just plug in. So x sub 2 is going to be 2, and then x sub 1 is going to be 6, then y sub 2 is going to be 9, and then y sub 1 is going to be 3. So 2 minus 6 is negative 4, negative 4 squared is 16. Then 9 minus 3 is 6, 6 squared is 36. So 16 plus 36, that's going to be 52. So 52 is 4 times 13. So this right here would be, the square root of 4 is 2, so this is 2 times square root of 13. So 2 times the square root of 13. For this one, let me slide this down like this. Your x sub 2 is negative 4. Your x sub 1 is going to be 6. Your y sub 2 is going to be 17. And your y sub 1 is going to be 3. So negative 4 minus 6 is negative 10. So you would have negative 10 being squared, which is 100. And then over here, 17 minus 3 is 14. So 14 squared, that's going to be 196. So 100 plus 196 is 296. So let's write this as 4 times 74. Square root of 4 is 2. So we'll say this is 2 times the square root of 74. Now 74 is 37 times 2. So we can't simplify that any further. All right, let me slide this down a little bit like this. I would say x sub 2 is negative 4. And then x sub 1 is 2. And then y sub 2 is 17. And then y sub 1 is going to be 9. So negative 4 minus 2 is negative 6. So you would have negative 6 being squared. That's 36. And then 17 minus 9, that's 8. And so 8 squared is going to be 64. So 36 plus 64, that's going to be 100. So the square root of 100 is going to be 10. Okay, let me approximate this real quick and approximate this real quick. So 2 times square root of 13 is about, let's say 7 point, I'm going to go 21. Let me move this decimal point over here. And then this guy right here is about 17 point, let's just go ahead and say 2. So I would want to sum these two smaller guys. Now don't do it with the approximation yet, because again, depending on how you approximate, sometimes these things are very close together. So let's just go ahead and say we have 2 times the square root of 13 plus 10. Is that equal to 2 times the square root of 74? Okay, I just estimated here to know what were the two smallest guys. So this guy and this guy's the largest. Let me actually get rid of this for right now and slide down here. Let's key this into the calculator and see what we get. So I'm going to round to the nearest, let's say 10,000th. So I get 17.21110.255. So to the nearest 10,000th, here's the tenths, hundredths, thousandths, 10,000ths. So this is a 0, so just cut these off. Is this equal to, so 2 times square root of 74, so I'm going to go 17.20465,053. That's where my calculator stops. So going to the nearest 10,000th, tenths, hundredths, thousandths, this is the 10,000ths. So this is your decision digit. So I'm going to round this up to a 7. So clearly these are not the same. They're very close, okay? So it's very easy to make a mistake here, but they are not the same. Okay, so make sure if you're looking at something and it's very close that you increase the number of decimal places that you're working with. I would do this calculation inside of your computer or calculator or whatever you're using to make it a little bit more accurate, but you can see that these two are not going to be equal. And so what we can say is that the points are not collinear. If you were to graph them, you would see that it makes a triangle. It's gonna be a little bit hard to make out, but it would be a triangle. So let's come back up here and say that no, these points are not collinear. All right, let's take a look at question 2 now. So we want to determine whether the 3 points are collinear. Again, this just means that they lie on the same line. So we have A, which is 0, -4. We have B, which is going to be 10, 0. And then we're going to have C, which is going to be 20, 4. All right, so we know this is very tedious. Let's go ahead and set this up. So we want the distance between A and B. We want the distance between A and C. And then we want the distance between B and C. So let me say this equals, and I'll do this one time and then I'll copy it. So we're going to say the square root of, we have x sub 2 minus x sub 1 quantity squared, plus we have y sub 2 minus y sub 1 quantity squared. So let me just grab this part real quick, and I will paste it in here. And then also, I will paste it in here. Okay, so we're just going to label, and I'll go ahead and start by saying that this is x sub 1 and this is y sub 1. And then over here, let's say this is x sub 2 and this is y sub 2. And we just plug in. So for x sub 2, we have 10. And then for x sub 1, we have 0. And then over here, for y sub 2, we have 0. And then for y sub 1, we have -4. So minus a -4 is going to be +4. So here you would have 10 minus 0, which is 10. 10 squared would be 100. And then over here, 0 plus 4 is 4. So 4 squared is going to be 16. So this right here would be 100 plus 16, which is 116. Now, to simplify this, I'm going to look at the last 2 digits of that number, which is the number 16. So because 16 is divisible by 4, 116 will be divisible by 4. And the reason I look at 4 is because it's a perfect square. So if you divide 116 by 4 in your calculator, you're going to get 29. So this is 4 times 29, and of course 29 is a prime number, so the square root of 4 is 2. So let's say that this is 2 times the square root of 29. Okay, let me slide this down so that we're now looking at the distance between A and C. And so for x sub 2, here you're going to have 20. For x sub 1, you're going to have 0. For y sub 2, you're going to have 4. And then for y sub 1, you're going to have -4, so minus a -4 is +4. 20 minus 0 is going to be 20, and 20 squared is 400. And then over here, 4 plus 4 is 8. And if we square 8, we're going to get 64. So this right here would be 400 plus 64, which is, of course, 464. Now, let's think about this. I know the final 2 digits of that number form a number, which is 64, which is divisible by 4. So you could start with that. If you divide 464 by 4, you're going to get 116. Now, we just saw that 116 was 4 times 29. So let me write this as 4 times 4 times 29. And really, 4 times 4, you could just write it as 16 if you wanted to. And the square root of 16 is going to be 4. So this is 4 times the square root of 29, if we want to simplify. Let me slide this down here, and we're going to look at the distance between B and C. So for x sub 2, we're going to have a 20. For x sub 1, we're going to have a 10. For y sub 2, we're going to have a 4. And for y sub 1, we're going to have a 0. So 20 minus 10 would be 10. 10 squared would be 100. So this right here would be 100. 4 minus 0 is 4. 4 squared is going to be 16. So we're back to 100 plus 16, which is 116. And we know that the square root of 116 is going to simplify to 2 times square root of 29. Again, this is 4 times 29. Square root of 4 is 2. So this is 2 times the square root of 29. So you can already see this is going to work out. Obviously, 2 times square root of 29 is smaller than 4 times square root of 29. So you want to add these two smaller guys together, so this one, and see if it equals this one, and obviously it does. Let me write this out. So 2 times square root of 29 plus 2 times square root of 29. Does that equal 4 times square root of 29? Yes, it does. So let's write 4 times square root of 29 is equal to 4 times square root of 29, and I'll just put a check mark there, and we'll come back up, and we'll say, yes, these points are collinear. All right, let's take a look at question 3. So here we want to determine whether the 3 points are collinear, again, meaning they lie on the same line. So for A, we have 28, 24. For B, we have 0, -8. And then let me slide this over here so it fits. For c, we have negative 14, comma, negative 24. Okay, so let's start out by doing our distance between A and B, and then we have the distance between A and C, and then lastly, the distance between B and C. And I'll just do this once and copy it. So this is the square root of, you have your x sub 2 minus x sub 1 quantity squared, then plus your y sub 2 minus y sub 1 quantity squared. So we'll just copy this real quick and paste it in twice. So there. And also, we'll do it again right there. Okay, let's come up here. And again, I'll just label this as x sub 1 and y sub 1, and this as x sub 2 and then y sub 2. We're just going to plug in. So for x sub 2, we have 0. For x sub 1, we have 28. Then over here, for y sub 2, we have negative 8. And then for y sub 1, we have 24. All right, so 0 minus 28 is negative 28. And negative 28 squared is 784. So let's write 784 there. Then negative 8 minus 24, that's going to be negative 32. And if I square that, let me write this in here first. So negative 32. If I square that, I get 1024. All right, so 784 plus 1024, that's going to be 1808. Now, this is a pretty big number to work with. And simplifying this might be a little bit tricky. So use your divisibility rules. If you're unfamiliar with them, then just think about the fact that this is an even number. So you could just start by dividing it by 2. But what I noticed right away is the number ends with an 8, right? So if the final 2 digits of the number form a number that's divisible by 4, the original number will be divisible by 4 as well. So this right here, I would divide by 4 first, and that gives me 452. So let me just start with 4 times 452. And this is an even number, so I could just divide it by 2. Or again, I noticed that 52 is divisible by 4, so that means 452 will be as well. And if you divide 452 by 4, you're going to get 113. So this is times 4 times 113, and 113 is a prime number. So really, you could just say this is 16, which is a perfect square. Obviously, it's 4 times 4. And then times 113 underneath the square root symbol. So the square root of 16 would be 4. So then this would be 4 times the square root of 113. Okay, so kind of tough to simplify that one. All right, let's slide this down now. And let's go ahead and say that x sub 2 will be negative 14. And then x sub 1 will be 28. And then y sub 2 will be negative 24. And then y sub 1 will be 24. And so negative 14 minus 28, that's going to be negative 42. And then negative 24 minus 24, that's going to be negative 48. Okay, you might want to just punch this into your calculator in one shot, but let's just do it individually in case you did it that way. You want to make sure you didn't make a mistake. So negative 42 being squared, that's going to be 1,764. Then negative 48 being squared, that is going to be 2,304. So really some big numbers here. So 1,764 plus 2,304, that's going to be 4,068. If I look at the final 2 digits of the number, I get 68. That's divisible by 4. So that means 4,068 will be divisible by 4 as well. So 4,068 divided by 4 would be 1,017. So right now I have 4 times 1,017. Now this is an odd number, so it's a little bit more tricky. But if you notice, you have 1 plus 0 plus 1 plus 7. So the sum of the digits is 9. Now, the divisibility rule for 9 tells us that if the sum of the digits of the number is divisible by 9, well then that number is divisible by 9. So I know that 1017 will be divisible by 9. And so actually, this is 9 times 113. So let me write 9 times 113, and we know 113 is a prime number. So this right here, 4 times 9 would be 36. Let me just write it that way. We know that that is a perfect square. The square root of 36 is 6. So this is 6 times the square root of 113. All right, that was pretty tricky. So let's move this one down here like that. And let's plug in for x sub 2. That's negative 14. Then for x sub 1, that's going to be 0. For y sub 2, that's going to be negative 24. And then for y sub 1, it's going to be negative 8. So minus the negative 8 is plus 8. So negative 14 minus 0 is negative 14. And negative 14 squared, that's going to be 196. And then over here, negative 24 plus 8, that's going to be negative 16. And if we square that, we're going to get 256. So 196 plus 256, that's going to give me 452. And we know already that this guy is 4 times 113. So this is 4 times 113. And so the square root of 4 is 2. So this is 2 times the square root of 113. So you can see that this is going to work itself out because this guy and this guy, these are the two smaller guys. Again, if you add the two smaller guys together and you get the larger guy, then you have collinear points. So let me slide down here and just show this officially. Obviously, it works. So 4 times the square root of 113 plus 2 times the square root of 113. Does that equal 6 times the square root of 113? And the answer is yes. So you get 6 times the square root of 113 equals 6 times the square root of 113. I'll just put a check mark. We'll come back up and say, yes, these points are collinear. All right, let's take a look at question 4. So here we're asked to determine whether the 3 points are collinear. That means, again, that they lie on the same line. So we have A, this is going to be 0, 3. Then we have B, this is going to be negative 2, negative 7. Let me slide this over so this is going to fit. And then we have C, which is going to be negative 15, and you can't see it because I covered it up, so let me slide this out of the way. So then this would be negative 20 here. So let me grab this real quick and paste this in. So we know the deal already. This is going to be very tedious. So the distance between A and B, and then the distance between A and C, and then the distance between B and C. Let me fix this C here. So this equals, let me do my square root symbol, and then this is x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Okay, let's grab this real quick, and we will paste this in here, and then paste that right there. And we'll label this as x sub 1, and this as y sub 1. Let me clean that up a little bit. We'll label this as x sub 2, and this as y sub 2. We're just going to plug in. And again, this is very tedious, so let's just take our time. So x sub 2 is negative 2, and then x sub 1 is 0. Y sub 2 is going to be negative 7, and then y sub 1 is going to be 3. So negative 2 minus 0 is going to be negative 2. So this is negative 2 squared, which is going to be 4. So here, negative 7 minus 3 is going to be negative 10. So this is negative 10 being squared, which is 100. So 100 plus 4 is 104. And 104 is going to be 26 times 4. So let's write that this is 26 times 4. 4 is a perfect square. So the square root of 4 is 2. So this is 2 times the square root of 26. Okay, let's slide this down like this. And for x sub 2, now we're going to say this is negative 15. For x sub 1, we're going to say this is 0. For y sub 2, we're going to say this is negative 20. And then for y sub 1, we're going to say this is 3. So negative 15 minus 0 is negative 15. Negative 15 squared is 225. Negative 20 minus 3 is negative 23. And then negative 23 squared, that's going to be 529. So 225 plus 529, that's going to be 754. Okay, so let's think about how we could simplify this. So for 754, you could divide that by 2 and get 377. You could divide 377 by 29, and you're going to get 13. But the problem is 2 is a prime number, 29 is a prime number, and 13 is a prime number. So there's really nothing you can do here. This is just going to be the square root of 754. Okay, let me slide this down here. For this one, you have x sub 2, which is negative 15. And then x sub 1, which is negative 2. So minus the negative 2 is plus 2. And then y sub 2, that's negative 20. And then y sub 1, that's going to be negative 7. So minus the negative 7 is plus 7. Negative 15 plus 2 is negative 13. So this is negative 13 squared, which is 169. And then negative 20 plus 7 is negative 13. So this is negative 13 squared, which again is going to be 169. So what you could do, instead of adding this together, you could say it's 2 times 169, because 169 is a perfect square. So basically this is 13, which is the square root of 169, times the square root of 2. So 13 times the square root of 2. So I'm just going to approximate these, and I'm just going to go to the hundredths place. So 2 times the square root of 26 is about, let's say, 10 point, well, this is going to end up giving me about 10.2, because you would get 10.19803. If I'm rounding to the nearest hundredth, well, this is a 9 here, and this is an 8, so basically I have to add 1 to this, so I have to carry that over, so I get 10.2. So for this one, the square root of 754, let's say that's going to be about 27.46 if I round to the nearest hundredth. And then 13 times the square root of 2, let's say that's going to be about 18.38. Okay, so looking at these, you would want to add these guys together. Clearly, it's not going to work, right? That's not going to sum to this. But again, you can do it in your calculator, make it a little bit more accurate. So say 2 times the square root of 26 plus, you want 13 times the square root of 2. Is that equal to your square root of 754? The answer is no, they're not equal. You can punch it into your calculator. This would be about, let's say, 28.58. We'll cut it off there. We already know that this one is about 27.46, so they are not going to be equal. So let's go back up and say that no, these points are not collinear. All right, let's take a look at question 5. So here we're asked to determine whether the 3 points are collinear. Again, that means they lie on the same line. So let me write that this is A. So we have -1, -3. And then B, we have -5, 12. And then C, we have 1, -11. Okay, let me grab this real quick and paste this in here. So once again, we want the distance between A and B. We want the distance between A and C. And then we want the distance between B and C. So let's put equals the square root of. We have x sub 2 minus x sub 1 quantity squared. Plus we have y sub 2 minus y sub 1 quantity squared. Okay, let's do some labeling. So I'll say this is x sub 1 and this is y sub 1. And let's say this is x sub 2 and this is y sub 2. So for x sub 2, let's say that this is -5. For x sub 1, it's -1. So minus a -1 is +1. For y sub 2, this is going to be 12. For y sub 1, it's -3. So minus a -3 is +3. -5 plus 1 is -4. So -4 being squared is +16. And then over here, 12 plus 3 is 15. So you would have 15 squared, which is 225. So 16 plus 225, that's going to be 241. And 241 is a prime number. So we'll go ahead and say this is the square root of 241. Let me just slide this down a little bit. And I'll move this down over here now. And so for my x sub 2, I'm going to have 1. For my x sub 1, I'm going to have -1. So minus a -1 is +1. For y sub 2, we're going to have -11. For y sub 1, we're going to have -3. So minus a -3 is +3. So 1 plus 1 here would be 2. 2 squared, let's just go ahead and put 4. Over here, -11 plus 3, that's going to be -8. And if I square -8, I'm going to get 64. So this right here would be 4 plus 64, which is 68. So this would be the square root of 68 here. Now 68 is 4 times 17. So if you write it that way, 4 is a perfect square. So the square root of 4 is 2. So this right here would be 2 times the square root of 17. All right, let's slide this down right here. And let's see what we get. So x sub 2 is 1. And then x sub 1 is going to be -5. So minus a -5 is +5. And then for y sub 2, we have -11. And then for y sub 1, we're going to have 12. So 1 plus 5 is 6. 6 squared would be 36. And then here, -11 minus 12, that's going to be -23. And definitely something you want to use your calculator for. Make sure you wrap this inside of parentheses. So -23 being squared is going to be 529. So this right here would give us 36 plus 529, which is 565. So this would be the square root of 565. Now, can you simplify this? The answer is no. And the reason is 565, if you divide that by 5, you get 113. And 5 is a prime number, and so is 113. So that's as good as you can do. Now, in terms of which number is the largest, you know that the square root of 565 is obviously larger than the square root of 241. Now, what about 2 times square root of 17? Can you think about, is that bigger than this? Of course, there's tricks to do this, but I'm not going to go into that. I'm just going to punch it into my calculator and save everybody a lot of time. And for this one, I'm going to get about, let's just go ahead and say 8 point, and I'll say 25. I'll go to the nearest hundredth, just rounding. For this one, we'll say this is about, let's go 23 point, I'll go 77 if I round to the nearest hundredth. So this guy is the largest. If you want this one, again, obviously this is larger than this, but the square root of 241, if you punch that into your calculator, let's say it's about 15.52. So you always want to take the two smaller guys, so this one and this one, add them together and see if it gives you the largest guy. Okay, so let me get rid of this. You can keep that approximation there. We're going to use it. Obviously, this is not going to work. I'm just going to tell you in advance. So the square root of 241, let's go plus 2 times the square root of 17. Is that equal to the square root of 565? I'm just going to write this approximation down here. So 23.77. We'll say, is this equal to? Just key this into your calculator. And actually, it's pretty close. Let me write out what my calculator gives me. So 23.77, and that part matches. So then if you keep going, let's write out 0.385 and then 9.5. So for this one, let me get a few more decimal places going. So let me redo this. So the square root of 565, let's go 23.76972865. So you can see that the 23 or the whole number part is the same. And then the tenths place is the same, but then when we get to the hundredths place, it's different. Okay, so they have to be exactly equal. They can't be close or really close or something like that. It just tells me that these points are semi-close to forming a line, but it's not going to quite be there. Okay, so when you get something like this, you just need to expand out to more decimal places. So what I would do is just round to the nearest, let's say 10,000th. Okay, so here's the tenths, hundredths, thousandths, 10,000ths. So let's maybe move this to be a 4 here. And this is the tenths, hundredths, thousandths, 10,000ths. So let's just cut this off here. So comparing them now, again, they're close, but they're not equal. So what you want to do is say that they're not equal, so they're not going to be collinear. Just be very careful with these problems. If you get something that's close, again, expand the decimal places out and see if they're exactly equal. If they're not, you're going to go back up and answer that no, these points are not collinear. Okay, and again, you can always put these on the coordinate plane and see how they match up, and you won't be able to form a line. What you're going to get is a triangle where the sides are very, very close together. All right, let's take a look at the quiz. For the first question, we're asked to use the midpoint formula to calculate the midpoint of each line segment PQ. So for point P, we have 3, 9. For point Q, we have 1, -1. So the midpoint formula, we use capital M, and it's equal to, inside of some parentheses, we'll put x sub 1 plus x sub 2 over 2. So the average of the x coordinates. And then over here, you're going to say y sub 1 plus y sub 2 over 2. So the average of the y coordinates. All right, so you could label either point either way. And so let's just say that this 3, 9, this is x sub 1 and this is y sub 1. And then this 1, -1, we'll say this is x sub 2, and this is y sub 2. So let's just plug in. For x sub 1, we have 3. And then for x sub 2, we have 1. And then for y sub 1, we have 9. And then for y sub 2, we have -1. Okay, so 3 plus 1 is 4, and 4 divided by 2 is 2. And then 9 plus -1 is 8. And then 8 divided by 2 is going to give me 4. So basically, it's going to be at 2, 4. So looking through my choices, I want this one right here. All right, for question 2, again, we are asked to use the midpoint formula to calculate the midpoint of each line segment PQ. So let's go capital M for midpoint is equal to, Again, you're going to take the average of the x coordinates, so x sub 1 plus x sub 2 over 2, and then the average of the y coordinates, so y sub 1 plus y sub 2 over 2. So either point could be labeled either way. It doesn't matter. We'll say that negative 8 comma negative 11. Let's just say that's x sub 1 and this is y sub 1. And then the other guy, which is 5 comma 6, let's say this is x sub 2 and this is y sub 2. So let's plug in. So for x sub 1 we have negative 8. And then for x sub 2 we have 5. And then for y sub 1 we have negative 11. And then for y sub 2 we have 6. So negative 8 plus 5 is negative 3. So this is negative 3 over 2. And you could also put negative 1.5, but the way that it's given here, the answers, we want negative 3 over 2. And then here we have negative 11 plus 6. That's going to be negative 5. So this is negative 5 halves, or again, you could put negative 2.5 if it wasn't multiple choice. So we're looking for negative 3 halves, comma negative 5 halves. So this guy right there. All right, let's take a look at question 3. So here we want to use the midpoint formula to calculate the midpoint of each line segment PQ. So we have P is given as 20 comma 10 and Q is given as 6 comma 4. Okay, so let's write out our midpoint formula. So M, we use a capital M here, is equal to, again, x sub 1 plus x sub 2 over 2, so the average of the x coordinates, and then comma, y sub 1 plus y sub 2 over 2, so the average of the y coordinates. So I'm going to take the first point, 20 comma 10, and I'll say that this is x sub 1 and this is y sub 1. And then for the second point, let's say 6 comma 4, let's say that this is x sub 2 and then y sub 2. So I'm just going to plug in. So for x sub 1, I have 20. And then for x sub 2, I have 6. For y sub 1, I have 10. And then for y sub 2, I have 4. So to simplify, 20 plus 6 is 26. And 26 divided by 2 is 13. And then here, 10 plus 4 is 14. So 14 divided by 2 would be 7. So this is 13 comma 7. So I'm looking for this guy right there. All right, for question 4, we're asked to use the midpoint formula to calculate the midpoint of each line segment PQ. So we have our point P, which is negative 2 comma 14, and then our point Q, which is 3 comma negative 1. So again, the midpoint formula, capital M, is equal to, you have x sub 1 plus x sub 2 over 2, so the average of the x coordinates, and then y sub 1 plus y sub 2 over 2, so the average of the y coordinates. So let's go ahead and say that the first point, negative 2 comma 14, is going to be my x sub 1 and then my y sub 1. And then the second point, which is 3 comma negative 1, that's going to be my x sub 2 and my y sub 2. So let's plug in. For x sub 1, we have negative 2. And then for x sub 2, we have 3. Now, negative 2 plus 3 is 1, so this is going to be 1/2 here. Now, for y sub 1, we have 14. And then for y sub 2, we have negative 1. So 14 plus negative 1 is 13. So this would be 13 over 2. So I'm looking for 1/2 comma 13 halves. So this guy right there. All right, let's take a look at question 5. So we're asked to use the midpoint formula to calculate the midpoint of each line segment PQ. So the point P, we have negative 5 comma negative 2. And the point Q, we have negative 11 comma negative 19. So let's just say the midpoint formula, we have capital M is equal to, again, the average of the x coordinates. So x sub 1 plus x sub 2 over 2. And then comma, the average of the y coordinates. So y sub 1 plus y sub 2 over 2. And then thinking about this, we can label either point either way. So I'm just going to take the first guy, which is negative 5 comma negative 2. And I'll label that as x sub 1, and this is y sub 1. The other guy is negative 11 comma negative 19. And I'll label this as x sub 2 and then y sub 2. So we just plug into the formula. So for this guy, x sub 1 is negative 5. And then x sub 2 is negative 11. And negative 5 plus negative 11 is negative 16. So negative 16 divided by 2 is negative 8. So this is negative 8. Over here, y sub 1 is going to be negative 2. So go ahead and plug that in. And then y sub 2 is going to be negative 19. So this is going to be negative 19 there. So negative 2 plus negative 19 is going to be negative 21. So let's say this part right here is negative 21 halves. So I'm looking for negative 8, comma, negative 21 halves. So this guy right there. All right, let's take a look at the quiz. For the first question, we're asked to determine the complex number that is associated with the plotted point in the complex plane. I'm just going to take my time in case you're a little bit lost. Let's start at the beginning. With a complex number, we have a plus bi. So a is the real part and b is the imaginary part. Always remember b is multiplying the imaginary unit I. Now, when we think about the complex plane, it looks like the coordinate plane we've been working with since Algebra 1. The difference is the labeling. Here, instead of this saying the x-axis, it says real for real axis. And then here, instead of it saying the y-axis, it says imaginary for imaginary axis. So if we looked at this point here, and let's say we're on the coordinate plane, well, from the origin, we went 7 units to the right and 4 units up. So that would be 7, 4. Well, how do we translate that over to a complex number? So my location on the real axis is what? It's 7. My location on the imaginary axis is what? It's 4. So remember, the real part here is the a. So let's put that first. So this is a 7. And then plus the imaginary part here is a 4. So let's put this 4 and then times the imaginary unit I. So this point right here represents the complex number 7. Again, that's your real part, plus 4, that's your imaginary part, times I, the imaginary unit. So let's come down here. We want 7 plus 4i. All right, for question 2, we're asked to determine the complex number that is associated with the plotted point in the complex plane. All right, so thinking about this again, let me just write out a plus bi, where a is the real part and b is the imaginary part. The location on the real axis is going to be 2. Let me write that in. The location on the imaginary axis is going to be 7. Let me write that in. So to get to this point, we went from the origin 2 units to the right and then 7 units up. So the real part is going to be 2. Let me write that here. And then plus your imaginary part is going to be 7. So let me write that here. And then times your imaginary unit I. So we get 2 plus 7i. That's the complex number that represents that point plotted in our complex plane. So let's come down here and say 2 plus 7i is what we want. All right, let's take a look at question 3. So we're asked to determine the complex number that is associated with the plotted point in the complex plane. So again, let me write out a plus bi like this. So a is the real part, b is the imaginary part. So if we look at our point here, it looks like from the origin, we did not move at all going left or right. So in other words, on the real axis, we're still at 0. So that means that the real part is going to be 0. Now the imaginary part, you can see that this point here, I'm at 4 on the imaginary axis. So basically this would be written as 0 plus 4i, or you could just write 4i. So I'm just going to write 4i like that, or again, it's just as valid to say 0 plus 4i. So let me come down here, and here it says 0 plus 4i, so we can just take that as our answer. But again, if you were on a take-home test and you didn't have multiple choice, you could also write just 4i. All right, let's take a look at question 4. So here we want to determine the complex number that is associated with the plotted point in the complex plane. All right, so let me write out again, a plus bi. And let's look at our point here. So it looks like from the origin, we've gone 7 units to the left. So let me write a negative 7 in there and just circle that. And then from the origin, we've gone 6 units down. So let me circle that. So the a, or the real part here, is negative 7. So let me write negative 7. And then the imaginary part is going to be negative 6. So let me write minus 6 and then times the imaginary unit I. So negative 7 minus 6i, that's the complex number that represents this point in the complex plane. So we want this right here, negative 7 minus 6i. All right, let's take a look at question 5. So here we're asked to determine the complex number that is associated with the plotted point in the complex plane. So let's think about the a plus bi, where a is the real part and b is the imaginary part. You'll notice that you're on the real axis. So that tells me that the imaginary part is going to be 0. So this right here would just be a location on the real axis of 8. So in other words, I could just say that this is 8 plus 0i, or just 8. So maybe we'll just put plus 0i like that. And we'll come down here, and you see we have 8 plus 0i, so we can circle that. Or again, if this is a take-home where it's not a multiple choice, you could also answer 8. So let me just put 8 in there as well. All right, let's take a look at the quiz. For the first question, we're asked to find the absolute value of each complex number. So if we have the absolute value of, let's say, the complex number a plus bi, we know this is equal to the square root of a squared plus b squared. So here we want to find the absolute value of a negative 10 plus 5i. So we know that negative 10 is the a value, and 5 is going to be the b value. So you just plug in. This is the square root of, so for a, again, that's negative 10. So negative 10, make sure to wrap that. That's squared. Then plus, for b, that's 5. So that's 5 squared. And this equals the square root of negative 10 squared is 100. And then plus 5 squared is 25. So this would be the square root of 125. Now, can we simplify this? Let me get rid of all this. And let me write the square root of 125. And let's think about this. We know the number ends with a 5. So it's going to be divisible by 5. So just punch in 125 divided by 5 in your calculator. And that's going to give you 25, which is a perfect square. So this is the square root of 25 times the square root of 5. So this becomes, we know the square root of 25 is 5. So 5 times square root of 5. So that's going to be the absolute value of this complex number. So down here, we want 5 times square root of 5. All right, let's take a look at question 2. So we want to find the absolute value of each complex number. So again, we know the absolute value of a plus bi, this complex number, is equal to the square root of a squared plus b squared. So for this one, the complex number is 4 minus 3i. So the absolute value of 4 minus 3i is equal to the square root of, for a, it's 4. So this is 4 squared, plus for b, let me go plus negative here so this is crystal clear, it's going to be negative 3. So make sure to wrap this. So this is negative 3 squared. So this would be equal to the square root of 4 squared is 16, and then plus negative 3 squared is 9. So this equals the square root of 16 plus 9 is 25, and we know the square root of 25 is going to be 5. So this is going to be my absolute value for the complex number. All right, let's take a look at question 3. So again, we want to find the absolute value of each complex number. So the absolute value of, let's say, a plus bi, this complex number, is the square root of a squared plus b squared. Okay, so the absolute value of 6 plus 3i, here a is 6, so this is the square root of 6 squared, plus b is 3, so 3 squared, and this equals the square root of 6 squared is 36, and then plus 3 squared is 9. So what is 36 plus 9? That's going to be 45, so this is the square root of 45. Okay, let me get rid of all this, and let me just simplify this up here. So the square root of 45, most of you know that 45 is going to be 5 times 9. So 9 is a perfect square, so you could say this is the square root of 9 times the square root of 5. And again, the square root of 9 is 3, so 3 times square root of 5. That would be your simplified answer for the absolute value of this complex number. So this guy right here, again, 3 times square root of 5. All right, let's take a look at question 4. So here we want to find the absolute value of each complex number. So again, the absolute value of some complex number a plus bi is equal to the square root of a squared plus b squared. All right, well here, you could really think about the negative 46i as 0 minus 46i. So we'll say this is the absolute value of 0. Let's go plus negative 46 times I, like that. So this is the square root of what? Well, a is 0, so 0 squared, you could just leave that off. And then plus, you'd have b squared, so negative 46 squared. Let me write that in there, would be equal to positive 46. And again, you could just punch it into the calculator and see that for yourself. Make sure you wrap this when you do that, okay? And we're going to say 46 is the answer for the absolute value of this complex number. All right, let's take a look at question 5. So we want to find the absolute value of each complex number. So the absolute value of a plus bi is equal to the square root of a squared plus b squared. For this one, we have the absolute value of negative 16 plus 10i is equal to the square root of, for a, it's negative 16. So negative 16, make sure to wrap that, being squared, plus, for b, it's 10, so 10 squared. So this is equal to what? So this is the square root of, negative 16 squared would be 256. and then plus 10 squared is 100. So this equals the square root of 256 plus 100 is 356. Now, this is something we can simplify. When you work with numbers like these, again, what I would do is first start by just taking my calculator, and I would see if I punch in square root of 356, do I get an integer? The answer is no. You're going to get about 18.87 if you want to round to the nearest hundredth. And then what I would do from there is just think about, okay, can I break this guy up? In other words, can I factor this and get a perfect square as one of the factors and simplify it that way? Well, looking at this, I know it's an even number, so I could start by dividing by 2, but you would also notice that this guy right here ends with 56, which is divisible by 4, so that tells me that the whole number, 356, will be divisible by 4. So punch that into your calculator, and you're going to get 89 times 4. So 89 times 4. Now, the square root of 4 is 2, so you can say this is 2 times square root of 89. Now, can you break the square root of 89 down further? Well, if you punch up square root of 89 in your calculator, you get about, let's say, 9.43. So basically, you would want to check all the numbers going up to 9 and see if you could find something that it's divisible by. So we know that it's an odd number, so it's not divisible by 2 or 4 or 6 or 8. So those are out. Then if you think about 3, 5, 7, and 9, well, 5 is really easy. If you look at the last digit, it's a 9, so 5 is out. And then 3 and 9 are also easy. You just sum the digits, so 8 plus 9 is 17. So we know that's out. It's not going to work. For 7, the rule is a little bit complicated, so you can just use your calculator. So 89 divided by 7 is 12 point, let's say 71, if you want to round to the nearest hundredth. So obviously this isn't going to work. Again, for the rule, in case you're curious, you would cut the last digit off. So you take 9 away and you double it. And so 9 times 2 would be 18. So you basically have that 8 minus that 18, which is going to give you negative 10. Okay, so this tells me that because this guy is not a number that is divisible by 7 or 0, it is not divisible by 7. So let's get rid of this and just say that this is going to be our simplified answer because 89 is a prime number. So this right here would be 2 times square root of 89 for the absolute value of our complex number. All right, let's take a look at the quiz. For the first question, we're asked to find the distance between z and w on the complex plane. So for z, let's say this is 6 plus 4i. So 6 plus 4i. Again, the real part is 6. The imaginary part is 4. Then for w, this is going to be equal to what? The real part is negative 5. And the imaginary part, let me do this in a different color. So again, this is negative 5. The imaginary part is 3. So this would be negative 5 plus 3i. What you're going to do is just label things. So this, let's just call it a sub 1. Let's call this b sub 1. This would be a sub 2. Let's call this b sub 2. And you're just going to plug into a modified distance formula. So the distance is equal to the square root of, you have a sub 2 minus a sub 1 quantity squared, plus you have b sub 2 minus b sub 1 quantity squared. So in this particular case, a sub 2 is going to be negative 5. And then a sub 1 is going to be 6. And then b sub 2 is going to be 3. And then b sub 1 is going to be 4. Okay, so let's say this is equal to the square root of negative 5 minus 6 is negative 11. Negative 11 squared is 121. And then this is plus 3 minus 4 is going to be negative 1. Negative 1 squared is going to be 1. So this is the square root of 122. Now let me come down here and write the square root of 122. Now, you see that you do have that as an answer, but first let me make sure that nothing is going to simplify. So let's divide 122 by 2, and we get 61, so we're really stuck there. So it's just going to be the square root of 122 for the distance between those 2 points on the complex plane. All right, let's take a look at question 2. So we want to find the distance between z and w on the complex plane. So for z, the real part is negative 2, and the imaginary part is 5. So this is negative 2 plus 5i. Let's just label this now and say this is a sub 1 and this is b sub 1. And let me put that this is z here. And then w is equal to, over here, we're going to say that the real part is negative 5 and the imaginary part is 8. So let's say this is negative 5 and then plus 8i. Let's label this as a sub 2 and this will be b sub 2. All right, for the distance formula, it's equal to the square root of, you have a sub 2 minus a sub 1 quantity squared plus you have b sub 2 minus b sub 1 quantity squared. So what is a sub 2? That is going to be negative 5. So let's plug that in there. What is a sub 1? That's going to be negative 2. So minus the negative 2 is plus 2. Then what is b sub 2? That is going to be 8. And then b sub 1 is going to be 5. All right, so negative 5 plus 2 is negative 3. Negative 3 squared is going to be 9. And then 8 minus 5 is 3. 3 squared is going to be 9 as well. 9 plus 9 is 18. So this would be, instead of 18, let's go 2 times 9 because 9 is a perfect square. So the square root of 9 is 3. So this is 3 times square root of 2. So coming down here, I want 3 times square root of 2 as my answer. All right, let's take a look at question 3. So we want to find the distance between z and w on the complex plane. So for z, this is equal to, the real part is 3 and the imaginary part is 2. So let's say 3 plus 2i. Again, I'll say this is a sub 1 and this is b sub 1. And then for the w here, we're going to say that the real part is negative 7 and the imaginary part is negative 3. So negative 7, I'll go plus negative 3 times I. So let's say that this is a sub 2 and this is b sub 2. So just plug in. The distance is equal to the square root of, you have a sub 2 minus a sub 1 quantity squared, plus you have b sub 2 minus b sub 1 quantity squared. So let's go ahead and say that a sub 2, that's going to be negative 7. And then a sub 1 is going to be 3. And then b sub 2 is going to be negative 3. And then b sub 1 is going to be 2. So negative 7 minus 3 is negative 10. Negative 10 squared is 100. So this is 100. And then negative 3 minus 2 is going to be negative 5. Negative 5 squared is 25. So this would be the square root of 125, which I'll write as the square root of 25 times 5. And we'll say that the square root of 25 is 5. So this is 5 times square root of 5. So coming down here, we want 5 times square root of 5. All right, let's take a look at question 4. So we want to find the midpoint of the line segment ZW. So here you have z is 5 minus 2i, and w is going to be 7 plus I. So let's just say that this first one, we'll go a sub 1 is 5, and we'll say b sub 1 is going to be negative 2. And then for the second one, we'll say a sub 2 is equal to 7. And then b sub 2, I just have I there, so there's a 1 that's in front of that I that you could put there. It's implied. So b sub 2 would be 1. So really the midpoint, you're using the same formula. It's just transformed a little bit. It's a sub 1 plus a sub 2 over 2. So the average of the real parts. And then b sub 1 plus b sub 2 over 2. So the average of the imaginary parts. So this is 5 plus 7, which is 12, divided by 2, which would be 6. So the real part would be 6. And this is negative 2 plus 1, which is negative 1, divided by 2. So just negative 1/2. So you would say this is 6 minus 1/2 I. So let's go 6 minus 1/2 I, like this. So this is what I'm looking for. So 6 minus 1/2 I. All right, for question 5, we're asked to find the midpoint of the line segment ZW. So again, I would say that a sub 1 is equal to, let's just take this real part here, negative 11. And then b sub 1 is going to be equal to negative 19. And then for this one, it's 4i, but you could write it as 0 plus 4i. So a sub 2, let's say that's 0. And then for b sub 2, let's just say that's 4. So again, for the midpoint, it's the average of the real parts. So you can write this out. Let's just go ahead and do it. So a sub 1 plus a sub 2 over 2. And then b sub 1 plus b sub 2 over 2. So this is the average of the imaginary parts. So here it's negative 11 plus 0 divided by 2. So basically negative 11 halves. Here it's going to be negative 19 plus 4, which is negative 15. So this is negative 15 halves. Okay, let me get rid of this. Let me write this as a complex number. So the real part is negative 11 halves. So negative 11 halves. And then the imaginary part is negative 15 halves. And then times the imaginary unit I. All right, so this is the one we want. So negative 11 halves minus 15 halves times the imaginary unit I. All right, let's take a look at the quiz. For the first question, we're asked to find the center radius form of each circle. We have x squared plus y squared minus 14x, then minus 2y, then plus 1, and this equals 0. All right, when we talk about the center radius form, otherwise known as the standard form of a circle, it's going to look like this. So we have x minus h quantity squared plus we have y minus k quantity squared is equal to the radius squared. So when I think about taking this and putting it into this form here, The first thing I would do is collect my x's together. So I would have x squared and then minus 14x. And then plus, I'm going to put a little blank there because I'm going to complete the square. In other words, I want to make a perfect square trinomial that can be factored into a binomial squared. So then plus, I'm going to go y squared minus 2y. So put the y's together and then plus a little blank there. Again, I just want to complete the square. I'll have a perfect square trinomial and factor to a binomial squared. And then what I'm going to do is say this is equal to, I'm going to subtract 1 away from each side of the equation. So this would be equal to negative 1. All right, let me move this down just a little bit out of our way. And so for completing the square, you first want to make sure that your coefficient on your squared variable, whatever that is, if it's x or y, whatever you're working with, you want to make sure that that's a 1. So here it's a 1 and here it's a 1, so we don't need to worry about that. So you move on to your next step, which is to take the coefficient of the variable raised to the first power. You want to cut it in half and then square it. So this, let's write this as plus a negative 14. So negative 14, cut it in half. You could divide by 2 or multiply by half, whatever you want to do, and then square it. So negative 14 divided by 2 is negative 7. So this is negative 7 squared, which is 49. So this is the value that I need to add to this to complete the square. So I put a 49 in here, and then to make this legal, I add a 49 over here on the right-hand side of the equation as well. Now take that value of negative 7 that you found by cutting this guy, this negative 14 in half, and use that to factor. So you're going to have x minus 7 quantity squared, and then plus, you're basically going to do the same thing over here. So let's go plus negative here. So you're going to take negative 2, and you're going to cut in half. Let me multiply by half like this. And you're going to square that. So this would be equal to what? So negative 2 divided by 2 would be negative 1. Negative 1 times 1 would be negative 1. So this is negative 1 being squared, which is 1. So you add 1 here, and this is getting really busy, so let me get rid of this, and you're going to add 1 over here. So to factor this, again, think about what this was when I cut it in half. It was negative 1. So I'm going to put the quantity y minus 1 squared, and this equals, just sum all these guys together. So negative 1 plus 1, that's 0. That's pretty easy to do. So this right here would be 49. So this would be your center radius form, otherwise known as the standard form. And from this, I can immediately say that the center occurs at, again, h comma k. So here it's 7 comma 1. So that's the center. And this is the radius squared. So the radius would be 7, right? 49 is 7 squared. So let me grab this real quick. And coming back up here, it looks like we are going to want this one right here. So the quantity x minus 7 squared plus the quantity y minus 1 squared is equal to 49. All right, let's take a look at question 2 now. So we want to find the center radius form of each circle. So let's write out 4x squared plus 4y squared, and then plus 80x plus 56y. Now we would put plus 496 is equal to 0, but what I'm going to do is actually just subtract 496 away from each side of the equation now. So I'm just going to say this is equal to negative 496. Okay, let's grab this real quick. And we're going to paste this in. And I'm going to remind you what we're trying to find here. So we want the quantity x minus h squared plus the quantity y minus k squared is equal to the radius squared. All right. Thinking about this, before we do anything, normally we group the x's together and we group the y's together and then we complete the square. But the problem is when you complete the square, the coefficient for the squared variable needs to be a 1. Okay, so if you had trouble with this problem, it was probably that. So what you would do is say, okay, well, this is a 4 and this is a 4, and those both are going to have to be a 1. So let me just fix that by dividing everything by 4, right? Remember, I can always multiply or divide both sides of an equation by the same non-zero number and not change my solution, okay? So I can say that 4 over 4 is 1, so this is x squared now. And then 4 over 4 is 1, so this is y squared now. 80 over 4 is going to be 20, so that's 20x. 56 divided by 4 is 14, so this is 14y. And then negative 496 divided by 4, that is going to be negative 124. Okay, from here, now we can go on to our normal procedure. So we would just group the x's together, so x squared and then plus 20x, and then plus, I think we can probably do this a little bit quicker now. So I would just say I'm going to cut 20 in half 20 divided by 2 is 10, and then I'm going to square that. So in other words, 10 squared would be 100. So I'm going to add 100 here. And I've got to also add 100 over here, but I haven't gotten over there yet. So maybe I'll go equals negative 124 and then plus 100 like this. And I'll just slide this down if I'm out of room. Let me actually move this over and down just a little bit so we have a little bit more room to work. So then I'm going to go plus. For this one, I would put the y's together. So y squared and then plus 14y. And I'm out of room. Let me move this down here and get rid of this and move this down. So then plus, again, to complete the square, take this coefficient here of 14, cut it in half. So divided by 2, that's going to be 7, and then square it. So 7 squared is 49. So I'm going to add 49 here, and then I'm going to add 49 here. So now just factor this because it's a perfect square trinomial. This is going to be x plus 10 quantity squared. Again, if you want to factor this, take this guy, cut in half, that's going to be 10. That's what you're using there. Okay, so x plus 10 quantity squared. Then plus, over here, I'm going to have y plus, again, when I cut this in half, it was 7. So y plus 7 quantity squared. And then this is going to be equal to, over here, just sum these guys. So negative 124 plus 100 is negative 24. And then negative 24 plus 49 is going to give me 25. So this guy right here would be your center radius form. Again, if you want to extract the information, you need to match this up perfectly. This is a plus sign, and this is a minus sign. This is a plus, and this is a minus. So you could write this as x minus a negative 10, quantity squared, plus y minus a negative 7, quantity squared. Let me make this 2 a little bit better here. And this would be equal to 5 squared. So this is the way I would write it if I wanted to extract the information. If I'm just asked for the equation in standard form or center radius form, I would give this one. But the center occurs at negative 10, comma negative 7, and the radius is going to be 5. So let me see if I can copy this. And let's come back up here, and let's see if we can find this. So it looks like we want this one right here. So the quantity x plus 10 squared plus the quantity y plus 7 squared is equal to 25. All right, let's take a look at question 3. So here we're asked to find the center and radius. So let's see, we have x squared plus y squared minus 22x minus 24y, then plus 249. Let me slide this over a little bit, and this equals 0. Well, let me save a little time and actually just say this is equal to negative 249, just subtracting 249 away from each side of the equation. So let me grab this real quick and paste this in here. And we're not asked for the equation in center radius form, but we would put it in center radius form so we can extract the center and the radius. So again, you want the x minus h quantity squared plus the y minus k quantity squared is equal to the radius squared. Okay, so x squared and then minus 22x, again, complete the square. So you're thinking about 1/2 of that coefficient there. So negative 22, if I cut that in half, it's negative 11. And then you would square that. Negative 11 squared is 121. So plus 121. Now, to factor this, again, you cut this in half, it was negative 11. So this is x minus 11 quantity squared. Okay, then plus. Now I've got to remember to add 121 over there. I'm just going to highlight this so I don't forget it. So let me go up here and go plus. You've got your y squared and then minus 24y. So I'm going to cut this in half. So negative 24, if I divide it by 2, it's negative 12. And negative 12, if I squared that, I get positive 144. So plus 144. Let me highlight this again so I don't forget to add it to the other side. So over here, I'm going to factor this into y minus 12. And this is quantity squared. Okay, so this is equal to, I've got my negative 249. And again, I highlighted these things to remind myself that because I added this here and added this here, I've got to do the same thing over here. So I've got to add 121 over here and then also 144 over here. So what's that going to give me? Let's pull out the calculator. So if I punch all this in, negative 249 plus 121 plus 144, I get 16. So let's say this is equal to 16. Okay, let's just grab this real quick. Okay, so let's paste this in here and let's try to match things up. So you have a minus here and a minus here, and then a minus here and a minus here. So your h is 11. Let me arrow to that. And your k is 12. So the center would occur at 11, comma 12. For the radius, remember, this is the radius squared, okay? So you want to change this into 4 squared so that you can say that the radius, your r, is going to be 4. okay? So I'm looking for 11, 12, not a radius of 16. That is the wrong answer, right? Because 16 is the radius squared. So 11, 12 down here with a radius of 4. So this is what I want for my answer. Okay, let's take a look at question 4. So we're asked to find the x and y intercepts. So we have this in general form, x squared plus y squared minus 12x plus 20y plus 111 is equal to 0. Well, let me actually speed this up and say this is equal to negative 111, just adding negative 111 to both sides of the equation or subtracting 111 away from each side of the equation, however you want to think about that. Let me grab this real quick and let me paste this in here. A lot of people struggle with this type of problem, especially when it's given to you in general form. I'm just going to tell you before we do this that there are no x or y intercepts, and I'll show you this graphically. Now, I think if you're struggling with this, you probably want to convert it over to the center radius form. You could also do it in this form here, but you have to use the quadratic formula, and so a lot of people do struggle with that. So I think I'll just do it both ways, okay? So the first way is the easiest way for me. I'm just going to complete the square, and we would say this is x squared minus 12x, and then plus, cut this in half. Negative 12 divided by 2 is negative 6. Square that, you get 36. So this is 36 right here. So this factors into x minus 6 quantity squared. Again, just take this, cut it in half. You get negative 6. That's how I got that there. So then plus, and then plus over here, you've got your y squared plus 20y. And then basically cut that in half. 20 divided by 2 is 10. 10 squared is 100. So plus 100. Okay. Let me highlight this and highlight this so I don't forget. And then basically I'm going to factor this into y plus, again, half of this was 10. So 10 quantity squared. Okay. Let me actually slide these over just a little bit. And I'm going to say this equals negative 111, then plus 36, then plus 100. So let's just say plus 136. Let's key that into the calculator, and I get 25. You could graph this, or let me actually do this real quick. Let me put this as 5 squared, and let me put this as minus a negative 10 like this, so that we know that the center is going to occur at 6, negative 10, and the radius is 5. Okay, let's just go to the graph real quick and see why we're not going to have any x or y intercepts, and then I'll come back up. So this is a rough graph. I don't know if you can even see it. You can go to Desmos and just plot this guy, this x squared plus y squared minus 12x plus 20y plus 111 is equal to 0. You're going to get the same graph. So the center, and I know this is hard to see, is at 6, negative 10. So it's going to be right there. And then the radius is 5. So go 5 units to the left, you're going to be right there. Okay, so this point right here, if I just subtract away 5 from this, would be 1, negative 10. Okay, then this point right here, if I went 5 units to the right, well, I would add 5 to this. So this would be 11, negative 10. And then if I went up 5, this point right here would be 6, negative 5. And then if I went down 5, this point right here would be 6, negative 15. Okay, so those points right there could be used to sketch this circle. And you see that the circle is not going to impact the y-axis or the x-axis, okay? So there will be no x or y intercepts. So we see that graphically. Now, let's go back up, and let's think about, I'm just going to get rid of this, and I'm actually going to put that back to 25, and I'm going to put this back to plus 10 here, quantity squared. And I'm just going to show you something. So if you wanted to figure out what are the x-intercepts, you would plug in a 0 for y, and you would solve for x. So essentially, you would have x minus 6, quantity squared, don't expand that, then plus the y would go away because you're plugging in a 0. So you just have 10 squared, which is 100, and this equals 25. The problem is going to be if you subtract 100 away from each side, this cancels. So you're going to have, let me just write this as the quantity x minus 6 squared is equal to 25 minus 100 is going to be negative 75. In the real number system, this is not possible. We're not talking about the complex number system where we have the imaginary unit I. In the real number system, this is not possible. You can't plug in something for x, subtract away 6, and square it and get a negative number. Nothing you can do. So we know that this is telling us that there will be no x-intercepts. Let's get rid of this, and I'll show you this. For the y-intercepts, just plug in a 0 for x, and you would basically have what? Negative 6 being squared, which is 36, and then plus this quantity y plus 10 being squared is equal to 25. because this guy right here is larger than this guy right here, well, when I subtract it away, what's going to happen is 25 minus 36, it's a negative value, so this is negative 11. Okay, so again, this is not possible in the real number system, so we would say that there are no y-intercepts. Okay, so that's one way to do it. Let me get rid of all of this. I'm just going to quickly show you this with the quadratic formula in case you don't want to go through all that. What you could do, let me actually move this back to being a plus and this being n equals 0 over here. We could say that we plug in a 0 for y and we get x squared minus 12x and then plus 111 is equal to 0. So here's where you would use your quadratic formula. A is 1, b is going to be negative 12, and c is 111. Now, if you check the discriminant, and the discriminant is negative, you have two non-real complex solutions. So let me just show you that real quick, rather than going through the whole thing. So the discriminant is b squared minus 4ac. Okay, so b is negative 12. Negative 12 squared is going to be 144. And then minus 4 times a is 1, so just get rid of it, times c is 111. So let me put 111 there instead of just 11. Okay, so we know that this guy right here is larger in terms of absolute value than this guy right here, so we're going to end up with a negative answer, right? This would be negative 4 times 111 is negative 444. If you do this subtraction, you're going to end up with negative 300. So again, if the discriminant is negative, that part underneath the square root symbol, the b squared minus 4ac, then you know you have two non-real complex solutions. Let me just show you that real quick with y. So if I plug in a 0 for x, trying to find the y-intercepts, then you'd have y squared plus 20y plus 111 is equal to 0. So here, your a is 1, your b is 20, and your c is 111. So again, check the discriminant. So b squared, 20 squared is 400. Then minus 4 times a is 1, just leave it off, times c is 111. We know 4 times 111 is 444. So this is going to give me negative 44 as my answer. So again, if this is negative for the discriminant, we have two non-real complex solutions, so we don't have any y-intercepts. So let's come back up here and just say that the graph of the circle does not intersect the x or y axis. It does not have any x or y intercepts. Okay, for question 5, we are asked which equation matches the given graph of a circle. So looking at this guy, you can see that the center occurs at negative 3, 4. So let me write that the center is going to occur at negative 3, 4. And what's the radius? Remember, the radius is the distance from the center to any point on that circle. So here is the center, again at negative 3, 4. And to get to this point on the circle here, let me do this in a different color, I would travel 1, 2, 3, 4, 5 units to the right. So the radius is 5. Okay, so how do I set up my equation? Again, it's the quantity x minus h squared plus the quantity y minus k squared is equal to the radius squared. So using this information, just plug in. This is the quantity x minus a negative 3. Minus a negative 3 is plus 3. So plus 3 being squared. And then plus y minus, in this case, 4. So y minus 4, quantity squared, is equal to your radius, which is 5 squared. So this is going to be 25, not 5. Again, this is the radius squared that we need. So let's grab this. We'll paste this in. And we're looking for this guy right here. So the quantity x plus 3 squared plus the quantity y minus 4 squared is equal to 25. So this guy right here. All right, for question 6, we're told that a circle has a diameter with endpoints negative 2, 2 and 20, 2. Find the center radius form of the equation of this circle. All right, so the first thing I would do here is think about what I'm being asked to find. We're normally working with a radius when we think about a circle. And with a radius, let's just say that this right here is your center. So this is the center. And let's say this right here is some point on the circle. You can call it x, y, whatever you want to do. Let's just say this is some point. Okay, this is some point, x, y. Well, the distance from the center to that point is your radius. Okay, the diameter is twice the radius. So I'm not going to do this to scale. Actually, maybe I can just copy this and paste this in. Okay, that's good enough. I think we understand what's going on. So this over here, that's some other point on the circle. And this would be the radius also. So 2 times the radius would be the diameter, right? So if I think about this whole thing right here, this would be the diameter, okay? So what we're told here is that we have a diameter with endpoints -2, 2. Let's say that's this point right here. So this is -2, 2. And then another guy with 20, 2. So notice that the y values are the same. So we would be at the same height. So basically, if you think about this line segment here, the y value is 2 throughout the whole thing, okay? But the x value here is -2. So I'm to the left of this other x value here, which is 20. If I want to find the center, then you would notice that this is actually the midpoint of the line segment with these given endpoints. So that is what I would do to figure out the center. Okay, that's the first part. So the midpoint is the average of the x values and the average of the y values. So -2 plus 20, that's going to be 18. And then 18 divided by 2 is 9. And then 2 plus 2 is going to be 4. And then 4 divided by 2 is 2. So it does make sense that this y coordinate is a 2 because on this line segment, every y value is a 2. Okay, so this is 9, 2. That's going to be the center of the circle. Now, let me actually just write that the center is at 9, 2. All right, so the next thing we need is the radius. So how do we figure that out? Well, you could just use the distance formula, and you could say that from the center, which is 9, 2, to any point on that circle, you could use this one or this one, is going to give you your radius. So you could use the distance formula. So let me do it that way first, and then I'll show you an alternative approach. So actually, let me get rid of this. I think we know what's going on at this point. And I'll just say that the distance, which I'll label as r for the radius, is equal to the square root of. You just pick a point. It doesn't matter which one. Let's just pick this second point. So I'm just going to say that 20, 2. Let's let that be x sub 1 and then y sub 1. And then we'll let the center be x sub 2 and then y sub 2. And just plug in. So x sub 2, which is 9, minus x sub 1, which is 20. This is quantity squared. And then plus y sub 2, which is 2, minus y sub 1, which is also 2. This is quantity squared. So 2 minus 2 is 0. 0 squared is 0. So get rid of this. 9 minus 20 is -11. And -11 squared is 121. So this right here is 121 underneath my square root symbol. And the square root of 121 is 11. Okay, so let's get rid of this. And now we're actually ready to write this. So it's x minus h. H is the x coordinate for the center. So x minus 9, quantity squared, plus y minus k. K is the y coordinate for the center. So this is going to be 2. That's squared. And this equals the radius squared. Okay, so not the radius squared. So the radius was 11. Square that, you get 121. So this is the one we want. So the quantity x minus 9 squared plus the quantity y minus 2 squared is equal to 121. Now, another way that you could have done this, you could have said in this formula x minus h quantity squared plus y minus k quantity squared is equal to the radius squared. You might like this a little bit more because it's a little bit faster. Plug in for the h and k. So plug in a 9 here, and then plug in a 2 here. And then once you've done that, just take one of the points and plug it in. So let's say I pick this first point. So it's -2, 2. So I'm plugging in a -2 for x, and I'm plugging in a 2 for y. So we know that this is going to be 0, so just get rid of it. -2 minus 9 is -11. -11 squared is 121. So now you've found that 121 is the radius squared. It's actually a little bit quicker than using the distance formula, and you have the radius squared right away, so you could just use it to set up your equation. So either way, you're going to end up with the quantity x minus 9 squared plus the quantity y minus 2 squared is equal to 121. All right, let's take a look at the section quiz. For the first question, we see that we have this plotted point A. Let's go down here where it says find the ordered pair that corresponds to the plotted point A and state the quadrant in which it is located. All right, so coming up here, again, this is my x-axis and my y-axis. So on the x-axis, the location is -6. On the y-axis, the location is 9. So from the origin, we went 6 units to the left and then 9 units up to get to this point A. So that means the ordered pair would be -6, that's the x value or the x coordinate, comma 9, that's the y value or the y coordinate. Now, what quadrant are we located in? Remember, the quadrants start in the upper right-hand corner. So here, the x values are positive and the y values are positive, and then you're going to go counterclockwise. So this would be quadrant 2, where the x values are negative and the y values are positive. Then down here, this would be quadrant 3, where the x and y values are both negative. And then here would be quadrant 4, where the x values are positive and the y values are negative. So this is the information we want. So it's going to be in quadrant 2, and the ordered pair is -6, 9. So let's grab this real quick. Let's paste that in there, and we want this one. So -6, 9, and we are located in quadrant 2. All right, let's take a look at question 2. So again, we have this point A that's plotted here, and the instructions again, find the ordered pair that corresponds to the plotted point A and state the quadrant in which it is located. So coming back here, you see that we are on the y-axis. So that means my x location is 0. So in other words, from the origin, I just went down by 5 units, right? So this right here is a -5 on the y-axis. So the ordered pair for that point is going to be 0 for the x location or the x value or the x coordinate, however you want to think about that. And then -5 for the y value or the y coordinate. So from the origin, just go down by 5 units. Now, this is the tricky one and the one where you might have gotten the wrong answer. What quadrant are we in? So we know that this is quadrant 1, and then we go counterclockwise. So this is quadrant 2, and this is quadrant 3, and this is quadrant 4. But here we're on the y-axis. So am I in quadrant 3? Am I in quadrant 4? What's going on here? Well, what's going on is if you're on the x or the y-axis, we say that you're not in any quadrant. Okay, so that's important to remember. So let's copy that we want 0, -5, and maybe we'll just say not in any quadrant, like that. Okay, we'll grab this real quick, come down here and paste this in, and it looks like we want this one right here. So 0, -5, and then we have does not belong in any quadrant. All right, let's take a look at question 3. So here we want to find the distance between each pair of points. So let me write the distance formula. So the distance is equal to the square root of, we have this x sub 2 minus x sub 1 quantity squared, plus we have our y sub 2 minus y sub 1 quantity squared. And then basically you just take these points, label one as x sub 1, y sub 1, and the other is x sub 2, y sub 2. It does not matter which point gets labeled as which. So let's write out -1, 5, and let's write out 9, 29. And I'm just going to label this one as x sub 1 and this as y sub 1. Then this would be x sub 2 and this would be y sub 2. So the distance is equal to the square root of, so x sub 2 is 9, so this is 9 minus, x sub 1 is going to be -1. So minus the -1 is +1, quantity squared, then plus. Y sub 2 is 29, and then minus y sub 1 is 5, and this is quantity squared. So 9 plus 1 is 10, 10 squared is 100, so this is 100. And then 29 minus 5 is 24, so this is 24 squared. So if I punch that into my calculator, I get 576. So we have 100 plus 576, which is 676. So just key this into the calculator. 676 is actually a perfect square. So the square root of 676 is going to give you exactly 26. And so we want this answer right here, okay? Some of you might choose this one, but remember you can't have a negative distance. So only 26 is what you want. So it's the principal square root of 676, which is going to be positive 26 as the answer. All right, let's take a look at question 4. So now we want to find the distance between each pair of points. So we have the distance formula D is equal to the square root of, we have the quantity x sub 2 minus x sub 1 being squared, then plus the quantity y sub 2 minus y sub 1 being squared. Okay, so let's go ahead and label this first point, -14, 15, as x sub 1 and then y sub 1. And then the second point, -10, 21. Let's say this is x sub 2 and then y sub 2. So let's plug in. The distance between those 2 points is equal to the square root of. For x sub 2, you have -10. And then minus for x sub 1, you have -14. So minus a negative is plus a positive, so plus 14, quantity squared. Then plus we have y sub 2, which is 21, minus y sub 1, which is 15, and this is quantity squared. So let me say this equals -10 plus 14 is positive 4. So you would basically have the square root of 4 squared, which is 16, plus 21 minus 15 is 6, and 6 squared is 36. So 16 plus 36, that's going to be 52. Now, most of you know that 52 is 4 which is a perfect square, times 13. So the square root of 4 is 2. So this is going to be 2 times the square root of 13 for our answer. So looking through, we want this one. So 2 times the square root of 13. All right, let's take a look at question 5. So here we want to determine if the points A, B, and C are the vertices of a right triangle. So let's write this out. So we have A, which is 1, 7. We have B, which is negative 8, 1. And then we have C, which is 4, 2. Let me grab this real quick and let's paste this in here. Now you could plot the points and get an idea of what it looks like. That's really up to you. I'm just going to go through and use the distance formula. So you need the distance between A and B. You need the distance between A and C. And you need the distance between B and C. Okay, so we're going to say this equals, I'm going to do the square root of, let me just write in x sub 2 minus x sub 1 quantity squared, plus we have y sub 2 minus y sub 1 quantity squared. So really it's just very tedious to set all this up. The process is very simple, so let me paste this in here. And let me paste this in here. Okay, so we have this. So the first thing is, I would label this first guy as, let's say, x sub 1 and then y sub 1. And this guy would be x sub 2 and then y sub 2. So you're just going to plug in for x sub 2, you're going to have negative 8. For x sub 1, you're going to have 1. And then for y sub 2, you're going to have a 1. And then for y sub 1, you're going to have a 7. Let's just keep going down. So let me move this over here. Just set everything up at once. So for x sub 2 here, you would have 4. And then for x sub 1, you would have 1. And then for y sub 2, you would have 2. And then for y sub 1, you would have 7. Let me slide this down now. And for some reason, it did not pick up the 1. So let me put that back in. So for the last one, we'll say that x sub 2 is 4. And then x sub 1 is negative 8. Minus the negative 8 is plus 8. And then for y sub 2, that's 2. And then for y sub 1, that's going to be 1. Okay, we're actually done with this now. You can get rid of it. Just go ahead and set everything up. So what I'm going to do is just crank this out. So negative 8 minus 1 is negative 9. Negative 9 squared is going to be positive 81. 1 minus 7 is negative 6. So then negative 6 squared is 36. So 81 plus 36, that's going to be 117. And that is divisible by 9. It's going to be 13 times 9. So 13 times 9. The square root of 9 is 3. So this would be 3 times the square root of 13. So 3 times the square root of 13. Okay, here we have 4 minus 1, which is 3. 3 squared is 9. And then here we have 2 minus 7, which is negative 5. And then negative 5 squared would be 25. So you have 9 plus 25, which is 34. So this would be the square root of 34. Now 34 is 2 times 17, so there's nothing you can do with that. Now down here, let me actually move this up just a little bit. 4 plus 8 is 12, and so 12 squared is 144. And then 2 minus 1 is 1, and we know that 1 squared is just going to be 1, so 144 plus 1 is 145. So let's think about that. Well, the square root of 145, you're not going to be able to simplify that because 145 is 29, which is a prime number, times 5, which is also a prime number. So this is just the square root of 145. Okay, so how do we determine if we have a right triangle? Again, you plug into the a squared plus b squared equals c squared. So this guy right here and this guy right here, the a and the b, those are the lengths for your legs, right? The two shorter sides of that right triangle. And then C is the hypotenuse, which is the longest side, okay? So you have to pick the largest value here and plug it in for C. The other two are going to be A and B. So I would approximate these just to see what you have, and then we'll just plug them in. So 3 times square root of 13, let's just say that's about 10.8. You don't need a lot of decimal places here. We're just determining which one's the largest. And then the square root of 34 is obviously going to be less than the square root of 145. But let's just do it anyway. This is about, let's say, 5.8. And the square root of 145, it's going to be about, let's just say 12. Okay, so obviously the square root of 145 is the largest. So you're going to use that for your C. Okay, so let's just plug in and see what we have. So we're going to have 3 times the square root of 13 being squared plus the square root of 34 being squared is equal to the square root of 145 squared. Let me slide down here a little bit. Maybe this 2 could be a little bit further over. So this right here would give us 117. 3 squared is 9. the square root of 13 squared is 13, and 9 times 13 is 117. So this is 117. Then plus, the square root of 34 squared is going to be 34. Does this equal the square root of 145 squared, which is 145? What is 117 plus 34? Well, that gives me 151, and that is not going to be equal to 145. So because these guys are not equal, or you could really say this is a false statement up here, we could say that these are not the vertices or the endpoints of a right triangle. So let's come back up and put no, these are not the endpoints of a right triangle. All right, let's take a look at question 6. So here we want to determine if the points A, B, and C are the vertices of a right triangle. So let's write A. This is going to be 4, 11. Let's write B. This is going to be 18, 9. And then let's write C, which is going to be 16, negative 5. So I brought this from the other guy, so this is already set up for us. So we'll say this is x sub 1, and this is y sub 1, and then this is x sub 2, and this is y sub 2, and just plug in. So x sub 2 is 18, x sub 1 is 4, y sub 2 is 9, and then y sub 1 is 11. So 18 minus 4 is 14. So this right here would be 14 squared. So 14 squared is 196. So let's put that in there. And then here we have 9 minus 11, which is negative 2. So we have negative 2 being squared, which is going to be 4. So 196 plus 4 is 200. So this right here is the square root of 200. I'll say this is 100 times 2 here. The square root of 100 is 10. So let's say that this right here is 10 times the square root of 2. Okay, moving on to this one. Let's slide this down here. And now we want to say that x sub 2 is 16, and x sub 1 is going to be 4. And let's say that y sub 2 is negative 5, and y sub 1 is going to be 11. So 16 minus 4 would be 12, and then 12 squared, that's going to be 144. And then here, negative 5 minus 11 would be negative 16, and negative 16 squared would be 256. So 144 plus 256, that's going to be 400. So this is the square root of 400, which is 20. Let's put 20 right there. Okay. For this last one, let's slide this down right there. For x sub 2, let's say that's 16. For x sub 1, let's say that's 18. For y sub 2, let's say that's negative 5. And then for y sub 1, let's say that's 9. So 16 minus 18 is going to be negative 2. So this right here is negative 2 that's being squared. So then negative 2 being squared would be 4. And then here you have negative 5 minus 9, which is negative 14. So you'd have negative 14 being squared, which is 196. So 4 plus 196 is 200. And again, the square root of 200 is going to be 10 times the square root of 2. So this is 10 times the square root of 2. So looking at these, this guy is going to be the largest. If you do 10 times square root of 2 on your calculator, you get about, let's say, 14.1. Of course, that's me rounding to the nearest tenth. You can go to as many decimal places as you want, but clearly this one is smaller than this one. So this right here, this 20 is what we're going to plug in for C. So you want a squared plus b squared is equal to c squared. Let's slide down here. And let's say that you have 10 times the square root of 2 being squared, and then plus 10 times the square root of 2 being squared, and this equals 20 squared. Might as well just write 400. Let me actually write it as 20 squared so nobody's lost. Okay, so a squared plus b squared equals c squared. So for this one, 10 squared is 100, and the square root of 2 squared is 2, and 100 times 2 is 200. So this would be 200 plus 200. Is that equal to 20 squared is 400? Yes, it is, right? So this is 400 equals 400. So this does work out. So these points are going to be the vertices of a right triangle. Let's come back up here and say, yes, these are the vertices, or you could say the endpoints of a right triangle. All right, let's take a look at question 7. So here we want to determine whether the 3 points are collinear. That means they lie on the same line. So we have A, which is 7, 4. We have B, which is 9, 6. And then we have C, which is negative 8, negative 11. Okay, let's grab this real quick. Come down here and paste this in. Now, with this one, I'm just going to tell you, later on in our course, we're going to learn how to do this with matrices. It's going to be much, much faster. You can also graph this and see if you can sketch a line. Okay, so plot each point. Can I make a line through it? Then there would be collinear. You could also compare the slopes. So there's a lot of ways that would be much quicker than what we're going to do here. But because this is covered this way in many textbooks, I want to make sure you understand how to do it this way. So the idea is you're going to find the distance between A and B, A and C, and then B and C. And then you're going to look at the two smaller distances. And if the sum is going to be the same as the largest distance, well, then you know that your points are going to be collinear, meaning they lie on the same line. In other words, what you're doing is you're saying, let's say that this is the line here. Let's say that this is a point, and this is a point, and this is a point. So let's say you look at this distance here, and you look at this distance here, okay? So those are the two smaller distances. The last distance that remains is this one to this one. So if these two sum to this guy right there, you know that those points are on that line, okay? They're collinear. All right, so let's get rid of this, and let's go ahead and crank this out. So I'm just going to, again, label this as x sub 1 and y sub 1, and this is x sub 2 and then y sub 2. So for x sub 2, it's going to be 9. For x sub 1, it's going to be 7. For y sub 2, it's going to be 6. And then for y sub 1, it's going to be 4. So 9 minus 7 is 2. 2 squared is 4. And then 6 minus 4 is 2. 2 squared is also 4. So if you have 4 plus 4, that's 8. But I would write that as 2 times 4 because 4 is a perfect square. So the square root of 4 is 2. So this is 2 times the square root of 2. Okay, let's shift this over right there. And so now x sub 2 is negative 8, and x sub 1 is going to be 7, and then y sub 2 is going to be negative 11, and then y sub 1 is going to be 4. So negative 8 minus 7 is negative 15. Negative 15 squared is 225, so this is 225. Over here, negative 11 minus 4 is negative 15. Negative 15 squared is 225. So again, what I would do here, instead of writing this as 450, I would say that this is 2 times 225 because 225 is a perfect square. The square root of 225 is 15. So this would be 15 times the square root of 2. All right, let's look at this one. We're going to slide this down like this and see what we get. So for x sub 2, we've got our negative 8. For x sub 1, we have 9. And then for y sub 2, we have negative 11. And then for y sub 1, we're going to have 6. So negative 8 minus 9 is negative 17. So this would be negative 17 squared. So that's going to be 289. Over here, you have negative 11 minus 6, which is negative 17. And we're going to square that as well. So that's going to be 289. So again, I would just write this as 2 times 289. And the square root of 289 is 17. So we would say this is 17 times the square root of 2. So obviously this is going to work. You're going to take this guy and sum it with this guy, and you're going to get this guy. So you can see that that works. So 2 times square root of 2 plus 15 times square root of 2. We know that there's a common radical here, right? So same index, they're both square roots. And then the radicand is 2 and the radicand is 2. So you're going to add 2 plus 15, that's going to give you 17, and then times the square root of 2. So that's exactly that part right there. So that tells me these points are going to be collinear. They do lie on the same line. So coming back up here, I'm just going to say, yes, these points are collinear. All right, for question 8, again, we're asked to determine whether the 3 points are collinear, meaning they lie on the same line. So we have point A, which is negative 1, negative 11. We have point B, which is 0, 15. And then we have point C, which is 2, 6. And let's paste this in here. For this one, let's label this as x sub 1 and then y sub 1. Let's label this as x sub 2 and then y sub 2. So coming down here for x sub 2, this is going to be a 0. For x sub 1, this is going to be negative 1. So minus a negative 1 is plus 1. For y sub 2, it's going to be 15. And then for y sub 1, it's going to be a negative 11. So minus a negative 11 is plus 11. So 0 plus 1 is 1. 1 squared is 1. So let's get rid of this and put a 1 there. 15 plus 11 is 26. And 26 squared is going to be 676. So if you add these together, 1 plus 676, that's 677. All right, now 677 is a prime number. So I'm just going to shorten this a little bit and say this is just the square root of 677. All right, let's slide this down like this. And we'll say that x sub 2 is now going to be 2. And x sub 1 is negative 1. So minus the negative 1 is plus 1. For y sub 2, it's going to be 6. For y sub 1, it's going to be negative 11. Minus the negative 11 is plus 11. Okay, so 2 plus 1 is 3. 3 squared is 9. And then 6 plus 11 is 17. 17 squared is 289. So 9 plus 289, that's going to be 298. So let's think about this for a moment. This is an even number, so you could divide 298 by 2, and that would give you 149, but that's a prime number, so this isn't going to simplify. Okay, let's slide this down, and I grabbed too much of this, so let me move this down like that. And our x sub 2 will now be 2, and our x sub 1 is 0. Our y sub 2 is going to be 6, and then our y sub 1 is going to be 15. So 2 minus 0 is 2. 2 squared is going to be 4. Then 6 minus 15, that's going to be negative 9. And so negative 9 squared is going to be 81. So 4 plus 81 is 85. Let's think about 85 for a moment. 85 is 5 times 17. 5 is a prime number, and so is 17. So nothing you can really do with that. So let's say this is the square root of 85. Now, looking at this, it's very obvious that the square root of 677 is the biggest, okay? Because you have the square root of 85, square root of 298, and the square root of 677. So obviously, the square root of 677 would be the largest or the biggest. So we want to add these two together. These are the two smaller ones. See if it equals this guy. So we're going to do the square root of 85 plus the square root of 298. Is that equal to the square root of 677? Let's punch this into the calculator, and I get about 26 point... Let's go ahead and say 48, and I'll just stop there, or round to the nearest hundredth. Is that equal to, what's the square root of 677? Well, I get about 26 point, let's go ahead and say 0.2. Okay, so these are not equal to each other. The 26 part, the whole number part, is the same. So maybe that would trip you up a little bit, but they're not equal. Clearly, they're not the same. They may be close enough to where the whole number part is the same, but if you look at the decimal part, it's not the same. So these are not going to be equal. So I'm going to put not equal here, and then we'll go back up and just say that no, these points are not collinear. All right, let's take a look at question 9. So we want to use the midpoint formula to calculate the midpoint of each line segment PQ. So we've got this point P, let me write it again, which is 7, negative 2. And then we have this point Q, which is negative 4, 3. Okay, so for the midpoint formula, let's say capital M is equal to, for the x coordinate, you just average the x coordinates here. Okay, so in other words, x sub 1 plus x sub 2 over 2. And then for the y coordinate here, you're going to average these y coordinates here. So y sub 1 plus y sub 2 over 2. Okay, so I'm going to label one of these points as x sub 1, y sub 1, and the other will be x sub 2, y sub 2. Does not matter how you do this. You will get the same answer either way. So I'm just going to pick the first point to be x sub 1, y sub 1, and the second point to be x sub 2, y sub 2, and just plug in. So this, again, is just the average of the x values. So it would be 7 for x sub 1, and then negative 4 for x sub 2. Let's put minus 4 here. And then here, y sub 1 is negative 2, and then y sub 2 is going to be 3. Okay, so 7 minus 4 is going to be 3, so this is just 3 halves. And negative 2 plus 3 is going to be 1, so this is 1 half. So I'm going to look for this guy right here. So the midpoint is going to occur at 3 halves, 1 half. All right, let's take a look at question 10. So we want to use the midpoint formula to calculate the midpoint of each line segment PQ. All right, so P is going to be 31, 19. And then Q is going to be 11, negative 14. Okay, so for the midpoint formula, again, it's just the average of the x values. So we say x sub 1 plus x sub 2 over 2. And then here it's going to be the average of the y values. So y sub 1 plus y sub 2 over 2. So really, really simple. Let me slide this down a little bit. Again, you can label these points however you want. Let's just label this as x sub 2, and this is y sub 2, and I'll label this as x sub 1, and this is y sub 1. Again, you can do it however you want. So I'm going to say that this one is x sub 1, which is 11, plus x sub 2, which is 31, over 2. So I'm just averaging the x values. Here, y sub 1 is going to be negative 14, and then y sub 2 is going to be 19. So I'm just averaging the y values. So 11 plus 31 is going to be 42, and 42 over 2 is going to be 21. Here, negative 14 plus 19, that's going to be 5. So this would be 5 halves. So the midpoint would occur at 21, 5 halves. So this guy right there. All right, for question 11, this might be a little bit hard to read, but it says determine the complex number that is associated with the plotted point in the complex plane. So looking on our complex plane, remember the horizontal axis is now the real axis, and the vertical axis is now the imaginary axis. So the complex numbers of the form a plus bi, where a is the real part and b is the imaginary part. So just matching this up, the real part is going to be 4, and the imaginary part is going to be negative 5. From the origin, we could go 4 units to the right and then 5 units down, or we could start at the origin and go 5 units down and then 4 units to the right. So the real part would be 4, and then the imaginary part is negative 5. So 4 minus 5i, you can go 4 plus negative 5i, whatever you want to do. But this is the complex number that we're looking for. So coming back, just pasting that in, it's this one right here. So 4 minus 5i, where 4 is the real part and negative 5 is the imaginary part. All right, for question 12, we are asked to determine the complex number that is associated with a plotted point in the complex plane. So again, looking at this on your real axis, you're looking at negative 5. On the imaginary axis, you're looking at negative 3. So from the origin, I'm going 5 units to the left and then 3 units down. So this is negative 5. You can go plus negative 3, or you could just go minus 3 and then times I. So again, a, the real part, plus b, the imaginary part, times I, the imaginary unit. So negative 5 minus 3i. So let's paste this in. So this is what you want. The negative 5 minus 3i, where negative 5 is the real part, and then negative 3 is the imaginary part. All right, let's take a look at question 13. We are asked to find the absolute value of each complex number. So again, the absolute value of, let's say, a plus bi is equal to the square root of, you have a squared plus b squared. So the square root of the real part squared plus the imaginary part squared. So that's how you get your absolute value of a complex number. We previously discussed where all this stuff comes from, so you can go back to the lesson if you need a little refresher on that. Basically, I'm just going to knock this out. So this is the absolute value of negative 23i. So this is going to be what? The square root of, well, first off, this can be written as, let me erase this, the absolute value of what? The a, or the real part, is 0. So you could say this is 0. I'm going to go plus negative 23 for clarity times the imaginary unit I. So this is equal to the square root of, a is 0. So this is 0 squared. You could put it in, or you could leave it off. Let's just put it in for the tutorial. And then we'll go plus, you would have negative 23. That guy would be squared. And make sure to wrap this in parentheses here. And so you can get rid of this. 0 squared is 0, and adding something to 0 would not change it. And remember, for this guy, we use our rule. If you have the square root of a squared, this is equal to the absolute value of a, right? So negative 23 gets squared first. That makes it a positive 529, and then you take the principal square root of that, and you get 23. So this would be the absolute value of negative 23, which is going to be 23. Okay, so that's how you do that. So looking at this, we want to say that the answer is going to be 23. And this should actually make sense, because if you plotted this on the complex plane, from the origin, you would just go down by 23 units. So if you think about the absolute value, or the distance from the origin to this point on the complex plane, it's just going to be 23 units away. So the answer would just be 23. All right, for question 14, we are asked again to find the absolute value of each complex number. So we want the absolute value of 7 minus 7i. So this equals the square root of. So again, it's going to be a squared plus b squared. So a here is 7, so 7 squared. And then plus b. b is negative 7. You can always go plus negative here. And always make sure to wrap these. So negative 7 being squared. So this would be equal to what? The square root of, well, 7 squared is 49, and negative 7 squared is also 49. So instead of writing 49 plus 49, let's say this is 2 times 49. And the reason I'm doing that is because 49 is a perfect square. So 49, if I take the square root of that, I get 7. So this would be equal to 7 times the square root of 2. So I'm looking through my answers. I want 7 times the square root of 2. Okay, let's look at question 15 now. So we're asked to find the distance between z and w on the complex plane. So this is pretty easy. You can actually use the regular distance formula if you want. What I like to do is just modify it to work on the complex plane. So we'll say that the distance between 2 points on the complex plane is equal to the square root of. Instead of x sub 2 minus x sub 1 quantity squared, remember the horizontal axis is now the real axis instead of the x-axis, and we call the real part a. So let's say this is a sub 2 minus a sub 1 quantity squared, and then plus, instead of y sub 2 minus y sub 1 quantity squared, let's think about this vertical axis as the imaginary axis, and the imaginary part of a complex number is labeled with b. So let's just say this is b sub 2 minus b sub 1 quantity squared. So basically the same thing, you're just changing up the terminology because you're now on the complex plane. So this right here, from the origin, I'm going 3 units to the left and then 5 units up. So let's say that this complex number z is equal to negative 3. And that kind of looks like a 3. Let me make that clear. That's a 5. So negative 3 plus 5i. Now for w, this other complex number, we are going from the origin 7 units to the right. Let me write a 7 in there. And then we are going 5 units down. Let me write a negative 5 there. So this is 7. You could put minus 5i, or let's put plus negative 5i like this. And then basically, you could label this as, let's say, a sub 1, and label this as b sub 1. And then this would be a sub 2, and this would be b sub 2. And then just plug in. So for a sub 2, it's 7. For a sub 1, it's negative 3. Minus the negative 3 is plus 3. And then for b sub 2, that's negative 5. And then for b sub 1, that's going to be 5. So 7 plus 3 is 10. 10 squared is 100. And then negative 5 minus 5 is negative 10. So this would be negative 10 being squared. And negative 10 squared is 100. So what I would do here, instead of writing 200, I would say it's 2 times 100, because 100 is a perfect square. So we can say that the square root of 100 is 10. So this is 10 times the square root of 2. So this is 10 times the square root of 2. And we'll just come down here, and we're looking for this answer. So 10 times the square root of 2. Okay, let's look at question 16. So here we're asked to find the midpoint of the line segment ZW. So again, with the midpoint formula, the midpoint is equal to, if you did it with complex numbers, all you would do is you would average the real parts. So let's say a sub 1 plus a sub 2 over 2. And then you would average the imaginary parts. So b sub 1 plus b sub 2 over 2. And then you would use these guys to rewrite your complex number. So really you could say that if you wanted to write it as a complex number, it would be a sub 1 plus a sub 2 over 2 plus b sub 1 plus b sub 2 over 2 times your imaginary unit I. Okay, so that would be your midpoint. Let me get rid of this, and we'll just plug in here. It's very, very simple. So let's just say that this first guy here, z, we'll say that's a sub 1 and b sub 1. And then the second guy, w, we'll say that's a sub 2 and then b sub 2. So for a sub 1, that's going to be negative 8. Again, I'm getting that from here. And then for a sub 2, I'm getting that from here. That's going to be 4. Then for b sub 1, I'm going to take this as negative 13. Let's put negative 13. For b sub 2, I'm going to take 17. Let's just crank this out. So negative 8 plus 4 is negative 4. And then negative 4 divided by 2 is negative 2. So this is negative 2. And then negative 13 plus 17 is going to be 4. And so 4 divided by 2 is going to be 2. So what you end up with here is negative 2 plus 2i. So this is what I want. So negative 2 plus 2i. All right, for question 17, we are asked to find the center radius form of each circle. So this is 2x squared plus 2y squared minus 4x plus 36y plus 52 is equal to 0. Let's grab this real quick, paste this in. So what you would want to do here is actually divide everything by 2 first. The reason I'm saying that is because we know we have to complete the square. Okay, so we're going to be looking at x squared and y squared, and you want the coefficient there to be 1. Okay, so to take care of that now, let's divide everything by 2. Remember, this is legal because you can multiply or divide both sides of an equation by the same non-zero number, and that's going to maintain your solution set. So we're going to get rid of this, then get rid of this, and this would be negative 2 right there. This would be 18. And then 52 divided by 2, that's going to be 26. And 0 divided by 2 is going to be 0. Okay, so at this point, all you really need to do is put your x's together, put your y's together, and then move your constant to the other side. So in other words, I would say this is x squared minus 2x, and then plus blank. Let me go plus negative here so that's crystal clear. I think it's a little bit easier if I write it like that for people. Then plus, you're going to say y squared plus 18y plus blank. Okay, and you're going to subtract 26 away from each side. So this equals negative 26. So basically, you just need to complete the square here and complete the square here. When I say complete the square, remember, I'm trying to add something here to where I create a perfect square trinomial. So this guy would be factored into a binomial squared because we want something of the form x minus h being squared plus y minus k being squared is equal to the radius squared. So this is the standard form or the center radius form for a circle. So you're just trying to match that. So here, what do? You look at the coefficient for x to the first power, you cut it in half, and then you square it, okay? But when you cut it in half, that's what you're going to use to factor. So negative 2, let me write this out. So negative 2 divided by 2, that's me cutting it in half. Negative 2 divided by 2 is negative 1. So this is, let me put the squared here. So this is negative 1 being squared, and negative 1 squared is 1. So I'm going to add a 1 here, and to make it legal, I'm going to add a 1 here. Now, use the negative 1 when you factor. So in other words, I want to factor this into x minus 1 quantity squared, okay? Let me get rid of this and make this a little bit neater here. And then let me go plus. Same thing here. I'm going to cut 18 in half. Let me get this out of the way so we have a little room. So if I divide that by 2, I get 9. So we would say that this is going to be 9 squared, which equals 81. You add that here, and then you add that here. Again, take that 9, the value you got from cutting this in half, and use that to factor. So this is y plus 9 quantity squared. So over here, let's say this equals negative 26 plus 1 is negative 25, and negative 25 plus 81 is going to be 56. So let's grab this, come back up and paste this in. So we want x minus 1 quantity squared plus y plus 9 quantity squared equals 56. So this guy right there. All right, let's take a look at question 18. So which equation matches the given graph of a circle? Okay, so let me write out the, again, center radius form. So x minus h quantity squared plus y minus k quantity squared is equal to the radius squared. So first off, where is the center? So it's at 6, 0, right? So I'm on the x-axis, it's 6, 0. So I'm going to plug in a 6 for h, and I'm going to plug in a 0 for k. Now, y minus 0 is just y, so this is going to be y squared here. And that's going to stay there. Now, what's the radius? Again, the radius is from the center to any point on that circle. So what is the distance from 6 to 9? Just traveling, this is 1, 2, 3 units away. So the radius is 3. Now, for the equation, you want the radius squared, right? So 3 squared would be 9. Let's go ahead and grab this real quick and paste this in. So I'm looking for this one right here. The quantity x minus 6 squared plus y squared is equal to 9. Okay, for question 19, we have that a circle has a diameter with endpoints negative 12, 0 and 14, 0. Find the center radius form of the equation of this circle. Okay, so the first thing is, if you realize, you could just draw a picture. So let me just say I draw a picture like this and this. Let's say this is negative 12, 0, and this is 14, 0. So thinking about the diameter, remember, this guy right here is going to be going through the center of the circle, right? And so the diameter is twice the radius. So we can say that the center is actually the midpoint of this line segment. And I don't know if that's the midpoint. It kind of doesn't look like it, but let's just assume it's right here. So this right here would be your center, which is the midpoint of these two guys right here. So you use your midpoint formula. So this equals, again, average the x values. You could write it out if you want. I'm just going to go negative 12 plus 14. That's going to be 2. And then divide by 2, and that's going to be 1. And then obviously, the y value is going to be 0 because you're on the x-axis here, okay? So it's 0 here and 0 here, so it's obviously going to be 0 here. So the center would occur at 1, 0. So that point is 1, 0. Now, if you want to find the center radius form of this equation, now I have to think about getting the radius. I know the center, so we have x minus, for h, I'm going to plug in a 1, this is quantity squared, and then plus, I'm going to have y minus, I'm going to have 0, quantity squared, so that's just y squared. And this equals the radius squared. Okay, there's a few different ways you could get this. I think the easiest one is just to plug in for x and y. You just pick a point. So let me just pick 14, 0 and just plug in. Okay, so what I'm going to do is say that this is 14 minus 1 quantity squared, plus I'm going to plug in a 0 for y, so that would just go away. So this would be equal to the radius squared. 14 minus 1 is 13. 13 squared is 169. So the radius squared is 169. And we know the radius would be 13. Okay. Now, another way you could have done that, let me erase this real quick. You could have used the distance formula, and you could have said, well, the center occurs at 1, 0, and a point we know would be either negative 12, 0 or 14, 0. That's on the circle. So the distance between these two guys, you're going to end up with 13. And of course, you square that to get 169. Let me just show you that real quick in case you want to do it that way. So you're going to find the distance between these 2 points. So let's say this is x sub 1 and this is y sub 1. This is x sub 2 and this is y sub 2. So you're going to have the distance is equal to the square root of course, because the y coordinates are the same, you don't even have to do this. This would just be the absolute value of 1 minus 14 or 14 minus 1, either way. But let's just do it this way. So x sub 2 is 14 minus x sub 1 is 1, quantity squared, plus you have 0 minus 0, quantity squared, so that's just 0, get rid of that. So this is the square root of 13 squared. And of course, that's going to be 13, right? So the distance between the 2 points is 13, and that gives you the radius, but this is the radius squared for the equation. So that's how we get 169. The other way that I did it, the first way, I think that's a little bit easier for people because you immediately get the radius squared. Sometimes when you do it the other way, you forget to square it and then you write down the wrong answer and you get points taken off your test. So for this one, let's go through and see if we can find it. So it looks like it's right there. So we want the quantity x minus 1 squared plus y squared equals 169. All right, let's take a look at the quiz. For the first question, we're asked to determine if each relation is a function. We also want to state the domain and range. So let me try to rewrite this because it's a bit small on the screen. So we have f is equal to, let me put this inside of set braces. We have 1, 3, and then we have 2, 4, and then we have 9, 7. We have 8, 1, and then lastly you have negative 5, 3. So let me close that down. I'm actually going to grab this real quick and just paste this in and we'll think about it here and then we'll go back and answer. So this is our relation. It's just a set of 5 ordered pairs. If you want to ask the question, is this a function? Well, again, you need to see if for each x there's one y. With this type of simple example, just look for a duplicate x value. If you have a duplicate x value, well then that given x value is associated with more than one y value and you don't have a function. If you don't have a duplicate x value, then basically you do have a function. So here you have a 1, a 2, a 9, an 8, and then a negative 5. So there's no duplicate x value. So yes, this is a function. So I'll just write function. So this is a function. Okay. In terms of the domain and the range, let's write here our domain like this. That is the set of x values. So just go into your ordered pairs and just grab the x values. So you have a 1 and then a 2, you have a 9, an 8, and then a negative 5. So that's the domain. In terms of the range, you're just going to go into the ordered pairs and grab the y values, right? Because the domain is a set of y values. So you have 3, 4, 7, 1, and then you have a 3 again. You don't want to double list things. So you're just going to put the 3 in once. So 3, and then 4, and then 7, and then 1. And again, just leave the 3 off because you've already listed it there. So basically we have a function. This is your domain or set of x values, and this is your range or set of y values. Now, one thing that may trip you up here, you will notice that you have a duplicate y value. So you have a 3 here and a 3 here. That does not violate the definition of a function. If I ask you, what is the y value when x is 1, you can give me a clear answer of 3. If I ask you, what is the y value when x is negative 5, again, you can give me a clear answer of 3. So for each x, there's one associated y value, so we're good to go. This is a function. Let's go ahead and grab this real quick, come back here and paste this in. Kind of hard to read. So this one says it's a function, and this one says it's a function. And so the domain, and this one it's right, so it's got the elements 1, 2, 9, 8, and negative 5. And the range is right, it's got the elements 3, 4, 7, and 1. So this is the answer that we want, the first one. All right, let's take a look at question 2. We want to determine if each relation is a function, state the domain and range. So now we're given g, and this equals, Again, this is going to be a set of 1, 2, 3, 4, 5 ordered pairs again. So you have -5, 7. Then you're going to have 1, -8. And then you're going to have 2, 1. Let me slide this down a little bit. And then we have a -5, 3. And then we have 11, 13. Okay, let me grab this real quick. And we'll just paste this in where there's some room. So first off, is this relation a function? In other words, we're asking, for each x value in the relation, is there one unique y value? Here you see that you have a duplicate x value. So a -5 and a -5. If you have a duplicate x value, you don't have a function. Because that given x value, in this case it's -5, it's associated with two different y values. Here it's associated with a y value of 7. Here it's associated with a y value of 3. So if I said, hey, what is y when x is -5? You don't have a clear answer. You don't know whether to answer 7 or 3. So this is not a function. So let's say not a function. Okay. The next thing is to write out the domain and range. So my domain is the set of x values. So you have a -5, you have a 1, you have a 2. Again, you don't want to double list things, so don't put a -5 in again. And then you have an 11. Okay, so then we have our range, or the set of y values. So here you have a 7, and then a -8, and then a 1, and then a 3, and then a 13. All right, let's grab this. Just going to paste this in and look through my answers. So I know it's not a function, so it's either this one or this one. Just looking at the domain, it looks like this one's going to match. So we see that this one says, let me make this a little bit wider here so it covers everything. No, this relation is not a function. And the domain has the elements -5, 1, 2, and 11. And the range has the elements 7, -8, 1, 3, and 13. All right, for question 3, we are asked to determine if each relation is a function. Also, we want to state the domain and range. So let me write this out. We have our relation H, which equals, we're going to have a set of 5 ordered pairs. So we have 5, 3. We're going to have 9, 3. We're going to have 7, 3. We're going to have 4, 3. And then we're going to have -8, 3. Okay, let me close this down. Let me grab this and paste this in here. Now, when we ask the question, is this relation a function? Again, you're asking, for every x in this guy, is there one unique y value? So here, you don't see any duplicate x values. You have a 5, a 9, a 7, a 4, and then a -8. But you do see duplicate y values. So this is going to throw a lot of people off. You have a 3 here, and here, and here, and here, and here. So is that okay? Does that violate the definition of a function? Yeah, it's okay. Because for each x, there's one y. It doesn't matter that it's the same y. If I said, hey, what is y when x is 5? You would answer 3. There's a clear answer. If I said, hey, what is y when x is 9? You would answer 3. The same thing goes for 7 or 4 or -8. It's okay. If you had something like, let's say I got rid of this and put a 5 in here, and maybe I changed this to like a 2 or something like that. Well, now for the given x value of 5, you don't know whether to answer that the associated y value is 3 or 2. So that's what breaks it, and you don't have a function there. But here, let me just go back to what we had. It's okay, right? Because if I said, hey, what's the y value when x is 5 or 9 or 7 or 4 or -8, you're just going to give a clear answer of 3. So yes, this is a function. So let me just write, this is a function. For the domain, again, this is the set of x values. So you have 5, 9, 7, 4, and -8. So 5, 9, 7, 4, and then -8. And then for the range, this is the set of y values. And what do you have? You just have a 3, right? So you just have to list that once because you have a 3 here and here and here and here and here. So just put a 3 and be done with it. So let's go ahead and grab this. Let's paste this in here. And we want to say that, yes, this is a function. So this one or this one. The domain is going to have the elements 5, 9, 7, 4, and -8. And the range is just going to contain 3. So it's just going to be this answer right here. All right, let's take a look at question 4. So here we want to determine if each relation is a function. So let's slide down here a little bit. So we are given a mapping diagram. So on the left, you have your domain, and on the right, you have your range. Now, typically you see numbers, but it's okay that we use cities. Sometimes your book will give you an example with capital letters or oceans or planets or something like that. The concept is the same. When I think about my domain and the elements in the domain, well, each element in that domain needs to be mapped to exactly one element in the range for this to be a function. So here, the domain element of Los Angeles is mapped to a range element of Long Beach. Here, a domain element of San Diego is mapped to a range element of Anaheim. Then here, a domain element of Sacramento is mapped to a range element of San Jose. And lastly, here, a domain element of Oakland is mapped to a range element of Oxnard. So for every element in this domain, it's mapped to one, and exactly one element from the range. So here we do have a function. So we can say, yes, this relation is a function. All right, let's take a look at question 5. So we are asked to determine if each relation is a function. On the left, we have our domain, and on the right, we have our range. So if we think about this domain element of Jason, it's mapped to this range element, which looks like a phone number 535, and then 1234. If we think about this domain element Beth, it's mapped to a range element of 915, and then 4567. If we think about this domain element of Heather, it's mapped to a range element that's 323 and then 6711. Then when we think about this final domain element of Larry, it's mapped to a range element 323 and then 6711. Now, is this a function or not? The problem is you think about this guy right here going here and this guy right here going here, but again, that does not violate the definition of a function. Larry, if I ask about his phone number, I'm going to get a clear answer, 323-6711. Heather, if I ask about her phone number, again, I'm going to get a clear answer, 323-6711. So this does not violate the definition of a function. For each domain element, it's going to correspond to exactly one range element. It's okay that two different domain elements correspond to the same range element. That does not violate the definition of a function. So if we come down here, we would just say, yes, this relation is a function. All right, let's take a look at the quiz. For the first question, we're asked to find the domain and range. So we are given y equals negative 4x and then minus 3. So you can do this by looking at the graph. You can also do this by looking at your equation. Let's just do it both ways. If we look at the graph and we think about the fact that this arrow here and this arrow here, that's telling me that this guy continues forever in each direction, right? So basically, in terms of the x values here, this is going to continue to the left forever, and this is going to continue to the right forever. So for the domain, it's the set of real numbers. And if you inspect the equation here, that should be obvious. We have this x here as our independent variable, and that's the only one there. And you just ask yourself the question, is there something I'm not allowed to do there? So in other words, in the real number system, what can I plug in for x? Well, I can plug in whatever I want because I'm just multiplying negative 4 by x. Once I have that product, I'm just subtracting 3 away. So really, there's nothing that would be a restriction there. So for the domain, I'll just go ahead and say, this is the set of all x such that x is a real number. So nice and simple. Now for the range, it's going to be exactly the same thing. Because I can plug in whatever I want for x, that means I can get out whatever I want for y. I can make it as small as I want. I can make it 0. I can make it as large as I want just by changing what I plug in for x. So the range would be the set of all y such that y is a real number. Okay, and it's just that simple in this one. Again, you can look at the graph and you can see that the y values would go up to positive infinity and go down to negative infinity. So let's go ahead and grab this and we'll just paste this in here. And so this is what we want for the domain. It's going to be all real numbers. And for the range, it would also be all real numbers. All right, for question 2, now again, we're asked to find the domain and range. We are given y equals the square root of x plus 3. Maybe I made that too long, so let me do that again. And then you have plus 3 here. So if you look at the graph, you can see that the furthest to the left in terms of the x values, that's going to occur at this negative 3 here, right? So this point right here would be 3 units to the left and 3 units up. So let me label that. This is negative 3, 3. So it looks like my domain from the graph would be the set of all x such that x is greater than or equal to negative 3. So what is causing that? Well, again, in the real number system, we cannot take the square root of a negative number. So we just think about the radicand there, and we say x plus 3 has to be non-negative. So it has to be greater than or equal to 0. What you would do is subtract 3 away from each side of the inequality. That cancels. You get x is greater than or equal to negative 3. So that's exactly what we see with the graph. Okay, in terms of the range, what you would do for this type of problem is you would think about, well, the smallest value I can get for y is by making this guy 0. So basically you make it 0 by plugging in a negative 3 for x. We just found that. So negative 3 plus 3 would be 0. The square root of 0 would be 0. And so you'd have 0 plus 3. You cannot get a negative out of this because, again, you're taking the square root and you're in the real number system. So the smallest you can get is 0. So that means the smallest y value is going to be 3. And then it can be anything that's larger. So we would say that for the range, actually, let me write range here. So for the range, it's going to be the set of all y such that y is greater than or equal to, and this is going to be positive 3 here. Okay, and you can see that from the graph. This point right here contains the smallest y value, and again, that's going to be 3. Okay, let's grab this, and let's look through the choices. It looks like we want this one right here. The domain is the set of all x such that x is greater than or equal to negative 3, and then the range is the set of all y such that y is greater than or equal to 3. All right, let's take a look at question 3. So here we want to find the domain and range. So we're given y is equal to, we have 1 over x plus 2. Now this one is a little bit tricky, especially if you don't have a graph. If you look at the graph and you're thinking about the domain, you can see that basically x can be any real number other than negative 2. So you can immediately just write that, and then we'll think about it with the equation. So domain, let's say that's going to be the set of all x such that x is not equal to negative 2. So I think it's obvious what's causing that. If you look at this, you have a fraction. And with a fraction, you're always thinking about, well, what would make the denominator 0? That's going to be excluded from the domain. So if you have y is equal to 1 over x plus 2, well, this guy right here can't be 0. So you say x plus 2 is equal to 0. Subtract 2 away from each side of the equation. That cancels. And you're going to end up with x is equal to negative 2. So if you plugged in a negative 2 for x, you would get 1 over 0, which is undefined. So that's what's creating this vertical asymptote here at x equals negative 2. So we know that the domain is the set of all x such that x is not negative 2, or basically saying that it can be any real number other than negative 2. Okay, now let's think about the range. So the range is a little bit more challenging, especially if you don't have a graph. If you have a graph, you can see that there's a horizontal asymptote here at y equals 0. So that really means that y can be anything other than 0. So let's go ahead and write that. It's a set of all y such that y is not equal to 0. Okay, and now let's think about it with the equation. What's creating this is you think about the fact that if I plug in bigger and bigger numbers for x, so in other words, as this graph goes this way, you see the y values are going to approach 0, but never actually touch it. Just think about starting with something like, let's say 8. So if you plugged in an 8 for x, you'd have 8 plus 2, which is 10. So you'd have y is equal to 1 over 10. Okay, so that's one scenario. If you do that on your calculator, you're going to get 0.1. Okay, but I can get much closer to 0. I could choose something bigger. Let's say now I choose 98. So 98 plus 2 is 100. So now I have 1 over 100. And you could do that on your calculator, or of course, it's just going to be 0.01. But the idea here is that as I choose bigger and bigger values for x, I'm going to get closer and closer to 0 for my value of y. So this would approach a y value of 0, but never touch it. Now, it's going to be the same thing over here, but what's going on is you're coming from a different direction. So in other words, you're choosing bigger and bigger negative values for x. So let me just give you a few examples. So let's say we said y was equal to 1 over, let's go ahead and pick negative 12 for x. So negative 12 plus 2 would be negative 10. So this right here would give me negative 0.1. Now, if I went through and changed that, let's say for x, now I plug in negative 102. Well, negative 102 plus 2 would be negative 100. So now I'd have y is equal to 1 over negative 100. And so this would give me negative 0.01. And as I choose bigger and bigger negative values for x, what's happening is now I'm getting closer and closer to a y value of 0. So that's why the range is going to be the set of all y such that y is not 0. It can be any number other than 0, but it just can't quite ever get to 0. So let's go ahead and grab this, and we'll paste this in here. And we are looking for this right here. So the domain is the set of all x such that x is not equal to negative 2, and the range is the set of all y such that y is not equal to 0. All right, let's take a look at question 4. Now we're just asked to find the domain, and we are given y is equal to 5 over x squared minus 4. Now I'll put a note here that says you can use the graph to verify your answer, but work the problem without the graph. I mean, I would just do it both ways. If you look at the graph, you can see that you have a vertical asymptote at x equals negative 2, and then a vertical asymptote at x equals 2. So that tells me that for the domain, it's a set of all x such that x is not negative 2, and it's not 2. So let me just write that out, and then we'll think about where this is coming from. So the set of all x such that x is not equal to, you'd have negative 2 or 2. It can be any other number that you want. So again, if you have a fraction, just think about where the denominator is going to be 0. Here you have x squared minus 4. You set that equal to 0 and solve. So you can solve this by factoring, or you can use the square root property. Let's go ahead and just add 4 to both sides and say x squared is equal to 4. So then x is equal to plus or minus the square root of 4, which is 2. So that means, again, x can't be negative 2 or 2. So you just have to restrict those guys from the domain. So this is what we're looking for here. Let's come down and paste this in. So the domain is the set of all x such that x is not equal to negative 2 or 2. All right, let's take a look at question 5. So here we want to find the domain. We are given y is equal to the square root of 5x minus 9. This would be over 2x squared minus 3x minus 5. Okay, we have a graph here, but what we're going to do is work this algebraically. Then we'll come back and verify things with the graph. Let's go ahead and grab this, and we'll come down here and paste this in. So this one's not that bad. You have two things that you have to consider. The first thing is that in the numerator, you have a square root operation. So the radicand here, or the 5x, let me put a little border here, the 5x minus 9, that needs to be greater than or equal to 0. Because again, we can't take the square root of a negative number in the real number system. So let me solve that real quick. I'm just going to add 9 to both sides of the inequality. So let me cancel that away and say 5x is greater than or equal to 9. Let me divide both sides of the inequality by 5. Let me cancel this away, and we'll say x is greater than or equal to 9/5. Okay, so we know that x needs to be 9/5 or anything larger for this guy right here to be non-negative. All right, let me get rid of this, and I'm actually just going to move this over here. So this is one thing that we have to consider. I'm just going to put a comma for right now. We'll put things together in the end. I'm going to think about this denominator now. So we have 2x squared minus 3x minus 5. So again, we want to figure out where would that denominator be 0, and then we want to restrict those values because we don't want to divide by 0. That's undefined. So let's solve this guy. We're going to set it equal to 0. And of course, you could solve this by factoring. You could complete the square if you wanted to. You could use the quadratic formula. Whatever you want to do. I think factoring is probably the easiest way here. So this is a 2. So that means it's coming from 2 times 1. So 2x and then x. So because this guy is a minus here, or you could say a negative, then basically you're going to have different signs. So a plus and a minus. And basically with 5, forget about the fact that it's negative. It's only 5 times 1. It's a prime number. So you could start with a 5 here and a 1 here and just see if things are going to work out. You're looking to subtract and see if you get 3. Forget about the fact that it's negative 3. This would be 10 and 1. 10 minus 1 is 9, so that's not going to work. So we could flip it and put the 5 here and the 1 here. This is 2 and 5. 5 minus 2 is 3. Again, in terms of absolute value, that's what I want. So I just got to work out the signs now. So I want this to be a plus, and then I want this to be a minus. In the end, that would give me a plus 2x, and this would give me minus 5x. So negative 5x plus 2x is negative 3x, and negative 5 times 1 is negative 5. Okay, so this is our factorization. Let me get rid of this. Don't need it anymore. And I'm just going to say that 2x minus 5 is equal to 0, or x plus 1 is equal to 0. Again, by the zero product property. Let me get rid of this, and I'm going to slide down here. And what I'm going to do is add 5 to both sides of the equation. Let's cancel this. We're going to get 2x is equal to 5. Let's divide both sides of the equation by 2. And so let's cancel this, and we're going to say that x is equal to 5 halves. Okay, over here, let's subtract 1 away from each side of the equation. This cancels, and we get x is equal to negative 1. Okay, let me write or here, x is equal to negative 1. Let me get rid of this, and let me come back up here and make sense of this. When we think about these values here, 5 halves and negative 1, they make the denominator 0, okay? So we would want to restrict them from the domain. So we would say that x is not equal to 5 halves, and then also I'm going to put negative 1, right? So it can't be equal to either of those. The thing is, you don't need to list this one here because it's already covered by this one. If we are saying that x is greater than or equal to 9/5, well, negative 1 is less than 9/5. So it's not going to be included here. So you can get rid of this, right? So 9/5 is 1.8 and 5 halves is 2.5. So this is good to go. So basically you can remove this and then you can write your domain with this. Let me get rid of this border here. I'll just say that the domain is the set of all x such that x is greater than or equal to 9/5. And then I'm going to put a comma here because also x cannot be 5 halves. Let me make that 5 better. So 5 halves. Okay, let me close that down. The idea here is that x could be anything you want, starting with a value of 9/5 and then going out to positive infinity with the exception of 5 halves. So let me grab this and let me come back here and just paste this in. Okay, so we are saying that the domain is a set of all x such that x is greater than or equal to 9/5, and then also x can't be 5 halves. So this point right here, I think it's hard to see because of the scaling, but this point right here would be 9/5, or you could also say 1.8, comma 0. So you can see that the x value that's the smallest, or the furthest to the left, is going to be 9/5. So that's where we start, and then it's anything larger going out to positive infinity with the exception of x being 5 halves. So you can see here that there's a vertical asymptote at x equals 5 halves. Let me mark that right there and say that that is 5 halves for the x value, okay? So you can see clearly that the domain would include all the x values from 9/5 going out to positive infinity with the exception of 5 halves. So let me copy this, let me paste this in, and let's look for the answer. So it looks like it's going to be this guy right here. So the domain is a set of all x such that x is greater than or equal to 9/5, and then x is not going to be 5 halves. All right, let's take a look at the quiz. For the first question, we're asked to use the vertical line test to determine if each relation is a function. So we're given a relation f is equal to, this is just going to be a set of ordered pairs. So you have 3, 1, which is going to be right here. So this is 3, 1. And then you're going to be given 2, 9. So 2, 9. So that's going to be right there. That's going to be 2, 9. And then you're also going to be given -1. So -1, 5. Let me slide this down here a little bit so it fits. And let me find -1, 5. So 1 unit to the left and 5 units up. So that's going to be right there. So that's -1, 5. And then lastly, you're going to have 3, 7. So 3, 7. Okay, let me close that down and find 3, 7. So that's going to be right there. So this is 3, 7. So obviously, just looking at the ordered pairs, you have this guy right here, which is 3, 1, and this guy right here, which is 3, 7. That's going to violate the definition of a function because, again, for each x, there's one y. An x value here of 3 is associated with a y value of 1. Here, an x value of 3 is associated with a y value of 7. So that violates the definition of a function. You can prove this, again, with a vertical line test. So you can sketch a little vertical line here, and this line would be x is equal to 3. And so this line here, x equals 3, impacts the graph in more than one location, right? So you can see here and then also here. So at 3, 7, and then also 3, 1. So that x value of 3 is associated with a y value of 7 and also a y value of 1. So this violates the definition of a function. So we would just say not a function. Come back down here. No, this relation is not a function. All right, for question 2, we are asked to use the vertical line test to determine if each relation is a function. It's hard to see, so let me write this again. So this is x minus 3 quantity squared plus you have y minus 4 quantity squared is equal to 25. So this is the equation of a circle with a center at 3, 4 and a radius of 5. So here's 3, 4. There's your center right there. And the radius is 5. So from the center, you can go 1, 2, 3, 4, 5 units to the right, or you can go 5 units up, or 5 units to the left, or 5 units down, and you'd be at a point on that circle. Obviously, this is not the graph of a function. I'm just going to draw one quick vertical line just for the sake of the tutorial. So this guy would be the line x is equal to 3. And you can see that this impacts the graph in 2 locations. So here and here. So that violates the definition of a function. All right, so if I come over here, this would be 3, 9. And then over here, this would be 3, negative 1. So if you plugged in a 3 here for x, 3 minus 3 is 0, 0 squared is 0. You would have y minus 4 being squared is equal to 25. So basically, you could solve that with the square root property and say that y minus 4 is equal to plus or minus the square root of 25. So basically, you get y minus 4 is equal to 5, then or y minus 4 is equal to negative 5. If you solve this for y, you add 4 to both sides, you get y equals 9. So y is equal to 9. So that gives me this 3, 9 up here. Then this one, if you solve for y, you add 4 to both sides, and you get y is equal to negative 1. So that's how you get this 3, negative 1 down here. Okay, so you can see that this is not a function. Let me get rid of this and just say that this is not a function, right? We failed the vertical line test. A vertical line of x equals 3 shows us that when x is 3, y is 9, and then also y is negative 1. Let's come down here and say, no, this relation is not a function. Okay, let's take a look at question 3. So it says, use the vertical line test to determine if each relation is a function. And we're given y is equal to the square root of x plus 1. So we have our graph here. Let me just draw a few for the sake of the tutorial. I think you can obviously see that no vertical line would impact the graph in more than one location. So again, sketching these vertical lines, you can see that no vertical line would impact the graph in more than one location. Here, this just hits here, and here, this just hits here. Okay, so this is going to be the graph of a function. So we'll just put, yes, this is a function. We'll come down here and just say, yes, this relation is a function. Okay, for question 4, again, we're asked to use the vertical line test to determine if each relation is a function. So we have y squared is equal to x minus 2. So immediately you see that this is not the graph of a function. So let me just draw one vertical line here. So this line right here would be x is equal to 6. And so you can see it impacts the graph here and then here. So this right here would be 6, 2. This right here would be 6, negative 2. So plugging in a 6 for x, this would be 6 minus 2, which is 4. So you would get y squared is equal to 4. And again, by the square root property, you could say y is equal to plus or minus the square root of 4. So y is equal to plus or minus 2. So if x is 6, y can be 2 or negative 2. Again, that's violating the definition of a function. For each x, there needs to be one y. So let's go ahead and say that this is not a function. So not a function. So let's come down here and just circle, no, this relation is not a function. Okay, let's take a look at question 5. So here we want to use the vertical line test to determine if each relation is a function. So we have y is equal to 1 over x minus 2 and then plus 2. So this one is a bit tricky. So when we look at the graph, again, as we approach an x value of 2 coming this way, you can see that it sort of looks like a vertical line, but it's actually not going to be, and I'll explain more in a moment. Additionally, this piece right here, this sort of looks like a vertical line, but it's not going to be. What's happening is you have a vertical asymptote at x equals 2. And what's creating that is, if you plugged in a 2 for x, well, 2 minus 2 is 0, and you'd have division by 0. So what creates this guy is, as we get closer and closer to 2, the y value is going to start to blow up. Okay, so what's creating this? Let's say that you plugged in something that was close to 2, but let's just say it's still within reason. So let's say I go let's just go 0, 1 for right now. So 2.01, let's say minus 2 would give me what? This would just be 0.01. Okay, so then I would have 1 divided by 0.01 and then plus 2. Okay, so let me get rid of this and let me pull this up here. And I'm going to say y is equal to this. So what would this give me as a value for y? Well, 1 divided by 0.01, that would be 100. And then if I added 2, well, that would be 102. Okay, so this is 102. So you can see for an x value that was 2.01, we got a y value that was 102. So you can see this is going up really, really quickly, right? So another one you could try, let's say you did 2.001. Okay, so now you plug that in, 2.001 minus 2, that's going to give you 0.001. And then if you do 1 divided by 0.001, you're going to get 1,000, and then 1,000 plus 2 would be 1,002. Okay, so you can see this is going up pretty fast. Again, you can get as close to 2 as you want. You can go 2.0000000. You can keep going on as long as you want, and then just put a 1 at the end. You're getting infinitely close to 2, but you can never actually touch it. The key thing here to understand, if you think about this, is that the x values are changing and the y values are changing. So for each x that you plug in, you're going to get one unique y value. Okay, and it's a little bit tough to see that from the graph. But it is true that no vertical line would impact the graph in more than one location. And I know I just talked about this part here, but for this part going down here, you would just think about values coming from this way that approach 2. So you could say something like, let's say 1.99. Let's just stop there. So 1.99 minus 2, that would be negative 0.01. So this would be 1 over negative 0.01 and then plus 2. Let's say y equals this. So 1 divided by negative 0.01, that's negative 100. So this would be negative 100 plus 2, which is negative 98. So again, that would be way, way, way down there. I don't have it on the screen, obviously. It would be way off the screen. But you can see that, again, as you get closer and closer to 2 from this way, so let's say you try something like 1.99999, and you can keep putting 9s out for as long as you want, you're going to really, really get a very negative value for y, right? So a really big negative value for y. So you're going to be way down there, approaching negative infinity. But again, as you look at a particular x value, you're getting a unique y value. So this is going to be a function. I'm just going to say, yes, this is a function. And maybe we could draw a few vertical lines in here for the sake of the tutorial. I wouldn't put them in here because it's a little bit unclear. I'll just draw one right there. And I'll just draw one right there. And again, this vertical line right here, this guy in purple, this is a vertical asymptote, and we will talk more about these later on in the course. So let's come down here and select, yes, this relation is a function. All right, let's take a look at the quiz. For the first question, we have for the given function, find f of 5, f of 0, and f of 2. So we're given this as a mapping diagram. So basically, the member of the domain or x value is mapped to or linked up with the associated member of the range or y value. So if you want to find f of 5, you could just come down here and look for 5 in the domain. You could say, well, what's the associated y value? Well, that's going to be 29. So let me write this off to the side. So f of 5 is going to be 29. We wanted f of 0. So that's going to be what? So I'm looking for 0 in the domain. The associated y value is going to be 3. And then lastly, I want f of 2. So an x value of 2 is linked up with a y value of 9. So that's going to be 9. So let me grab these and just slide them down. I'm not going to be able to fit everything on the screen at once. Let me slide down here to the answers. So I'm looking for f of 5 to be 29. So I have that here and here. And then I want f of 0 to be 3. So that's going to be there. And then f of 2 is 9. So that's going to be here. So this is the one we want. So f of 5 is 29. F of 0 is 3. And then f of 2 is 9. All right, let's take a look at question 2. So for the given function, we're asked to find, and this is a bit small to read, so let me write this out. We have f of a negative 5, we have f of 0, and then we're going to have f of 5. So we're given the graph of this function, and basically if you get this on a test, what you want to do is think about, okay, well, if I want f of negative 5, that means what is the function's value when the independent variable, in this case it's x, is negative 5. So just look on the x-axis for a value of negative 5. So we don't have that notch labeled, but we can put one in there. And just go up to the corresponding point. So that's going to be right there. So what's the point there if you wanted to give it as an ordered pair? Well, the x value is negative 5, and the y value is going to be 6. So if I said, what is f of negative 5? Well, that's, again, the function's value when x is negative 5. Well, that's going to be the y value, which is 6. So for f of 0, again, go on the x-axis to 0. Let's go up to the point right here. This would be 0, 4. So f of 0 would be what? What's the associated y value? It's 4, right? So the function's value is going to be 4 when x is 0. Then for f of 5, again, go to 5 right here. Then let's go up to this point right here. So this would be 5, 2. And so when x is 5, y is 2. Or you could say when x is 5, the function's value is 2. Now, another way you could do this is basically to rely on something that we haven't covered yet, but we will cover it shortly. And I know a lot of you know this from previous algebra courses, but essentially we can figure out what is the slope-intercept form of this line, because we know the y-intercept, that's where this graph crosses the y-axis, it occurs at 0, 4. So if you have slope-intercept form, it's y equals m the slope times x plus b, where b is the y-coordinate from the y-intercept. Well, here the y-coordinate from the y-intercept is 4, so you would just plug in a 4 there. And then for the slope, we use the concept of rise over run. So in other words, from this point to this point, how much do I rise and then how much do I run? So here I need to drop 1, 2 units. So my rise is negative 2. And then I'm going to run 1, 2, 3, 4, 5 units to the right. So that's a positive 5. So m, the slope, is negative 2 fifths like this. And you can replace y with f of x like this. And now you have something you could just plug into. So if you had f of negative 5, well, you would have this like this. And you would have negative 2 fifths. And then times negative 5 like that, plus 4. Let me make this 5 better here. So this right here would cancel with this right here and give me a negative 1. Negative 2 times negative 1 would be 2. So this would end up being 2 plus 4, which is going to give me 6. So you see that this matches with this. If you did f of 0, this would be what? Well, you'd have a 0 here, so this would go away. You just have 4. And then if you did f of 5, you'd have negative 2 fifths times 5 plus 4. Well, these are going to cancel and give you a 1. So you have negative 2 plus 4, which is going to be 2. So you see you get the same thing there. And at this point, you don't know this yet, or some of you don't know it yet. Some of you do know it, but it's just easier to just get it off of the graph, right? Like we did here. So let me go ahead and grab this and just paste this in. So we're looking for f of negative 5 to be 6. We're looking for f of 0 to be 4, and then f of 5 to be 2. So this guy right there. All right, let's take a look at question 3. So for the given function, find f of negative 1. Let's see, we have f of x is equal to x squared minus 9x plus 4. So if you want to find f of negative 1, again, all you're doing is plugging in a negative 1 everywhere there's an x. So my rule is to not make a sign mistake, always use parentheses. So we're just going to wrap this and square it, minus 9. We're going to wrap this and then plus 4. So everywhere I put parentheses here, plug in a negative 1. So that's going to go there and then also there, just replacing x. So put a negative 1 there and a negative 1 there. Okay, so negative 1 squared, again, because this is wrapped in parentheses, this would give you positive 1. Please remember that if you erase these parentheses, negative 1 squared like this, because of the rules that are associated with the order of operations, if you punch that into your calculator, you're going to get negative 1, you're going to have the wrong answer. So make sure to wrap this. So this would be negative 1 being squared, that's 1. And then let's go plus negative here. Negative 9 times negative 1 is going to be 9. So let's go plus 9 and then plus 4. So 1 plus 9 is 10. 10 plus 4 is 14. So this is 14. So f of negative 1 is 14. So this is what we're looking for. All right, let's take a look at question 4. So for the given function, we want to find f of 5. So let's write f of x is equal to, we have x plus 2 over x minus 5. So immediately you see a problem, right? If I say I want f of 5, well, you can't plug in a 5 there for x because you'd have division by 0. You would have, let me put some parentheses here, and let me put some parentheses here. And you're going to plug in a 5 here and here. Well, this numerator's fine, right? 5 plus 2 is going to be 7. But the denominator, 5 minus 5 is 0. And division by 0 is undefined. So we would just say that f of 5 is undefined. So let me circle undefined there. All right, let's take a look at question 5. So it says for the given function, find f of a plus 1. So this one's a little bit complicated. We have f of x is equal to the square root of, you have x squared minus 2x and then minus 5. Let me copy this. We'll go to another page. So f of a plus 1. So let me grab this and let me paste this in. So no matter how complicated the expression, the idea is always the same. So for this, all you're doing is everywhere there's an x, so here and here, you're just plugging in this expression a plus 1. That's all it is. So this would be equal to, let me write this down here. So the square root of, for this x, I'm just going to put some parentheses here. And again, I'm going to put a plus 1 inside. Maybe this is a little bit too far out. This would be squared. And then minus 2 times, again, this needs to be inside of parentheses. So a plus 1 and then minus 5. So here you need to make sure that you're using parentheses. A lot of times I tell students to just get in the habit of always using parentheses so that you don't make a mistake. Let's come down here a little bit and let's see how we can simplify. So this equals the square root of, so a plus 1 quantity squared, this is a squared plus 2 times a times 1. So that's 2a, and then plus 1 squared is 1. And then here, let's go plus negative 2. So I'm going to distribute this negative 2 to each guy. So negative 2 times a is negative 2a. Let's put minus 2a. And then negative 2 times 1 is negative 2. So let's put minus 2 and then minus 5. Okay, let's put equals here. And I'm just going to slide down. And we have this square root of, so you have a squared. So 2a minus 2a, let's go ahead and cancel those away. And then you have 1 minus 2, which is going to be negative 1. And then negative 1 minus 5 would be negative 6. So this is just the square root of a squared minus 6. Can I do anything to make that simpler? No. So let's come back up and I'll say that the f of a plus 1 is equal to the square root of a squared minus 6. So this guy right here. So your square root of a squared minus 6. All right, let's take a look at the quiz. For the first question, we have given the linear function. Let me write this out. So f of x is equal to 2x minus 7. We have find the x and y intercepts. What I'm going to do to make this a little bit easier, I'm going to replace f of x with y. So let's say we have y is equal to 2x minus 7. And actually, let me write this as plus negative 7 so that things are a little bit more clear. The first thing I'm going to do is match this up with slope-intercept form. So y equals mx plus b, where m is the slope. So let's just go ahead and say that m is going to be 2. And then b is the y coordinate from the y-intercept. So it's going to occur in terms of your y-intercept at 0, negative 7. So let me write here that the y-intercept would occur at 0, negative 7. Again, that's pretty easy to see because if you plugged in a 0 for x, well, 2 times 0 is 0, so this is gone, and you just have y is equal to negative 7. For the x-intercept, we do need to do a little bit of work. So let's say this occurs at blank, 0, meaning we're going to plug in a 0 for y. So let's just go ahead and erase this, and I'm just going to plug in a 0 here. And basically, you would have 0 equals 2x plus negative 7. So let's add 7 to both sides of the equation. Because I don't have a lot of room, let me just do this, and I'm just going to erase this and put this like this. So 2x would be equal to 7. Divide both sides of the equation by 2, and you're going to get that x is equal to 7 halves. So this right here would be 7 halves, or you could put 3.5 if you want. Really up to you. So let's maybe do that a little bit cleaner there. And then looking through my answers here, let me get rid of this. I want a y-intercept that's 0, negative 7. So let's see if we can find that. And it's going to be this choice, and this choice. And then I want an x-intercept that's 7 halves, 0. So that's only going to occur here. So this is what we want. The x-intercept is going to be at 7 halves, 0. Or again, you could say 3.5, 0. And the y-intercept would be at 0, negative 7. All right, let's take a look at question 2 now. So it says, given the linear function, we have 2x minus 5y is equal to 20. It says find the x and y intercepts. So to get the x-intercept, which I'm going to do first, I would plug in a 0 for y. So you'd have 2x minus 5 times 0 is equal to 20. Well, 5 times 0 is 0, and if you're subtracting away 0, it's just basically going to go away, right? 2x minus 0 is just 2x. So here we have 2x equals 20. Divide both sides by 2, and you get x is equal to 10, right? This is going to cancel. So if x is 10, y is 0. So that's your x-intercept. Let me write the x-intercept would occur at 10, 0. Now, in terms of the y-intercept, you could plug in a 0 for x here and solve for y, or you could solve the equation for y. It's really up to you. In this particular case, it's faster just to plug in a 0 for x. So you'd have 2 times 0 minus 5y is equal to 20. And then basically 2 times 0 is 0. So you'd have 0 minus 5y, which is just negative 5y. Let me slide this down so we have some room. And then at this point, to isolate y, just divide both sides of the equation by negative 5. So this is going to cancel with this, and you're going to get y is equal to 20 divided by negative 5 is negative 4. So if x is 0, y is negative 4. So let me write that the y-intercept would occur at 0, negative 4. Okay, looking through the choices, we see that here we have what we want. So the x-intercept would occur at 10, 0, and the y-intercept would occur at 0, negative 4. All right, for question 3, we are asked to find the linear function that matches the given graph. Let me slide down here real quick, and we see that the way we're given this is f of x equals mx plus b, or you could say y equals mx plus b. So basically, we're trying to find the slope-intercept form of the line. That's very easy to do from the graph. So the first thing I would do is locate the y-intercept. So that's going to be right here. So that is at 0, negative 3. Let me write this up here. So this is the y-intercept. So 0, negative 3. Now, when you write a line in slope-intercept form, it's y equals m the slope times x plus b. Here, we know b is going to be negative 3, right? It's the y-coordinate from the y-intercept. So I just need to figure out what is m, or the slope. Well, remember, m is equal to the rise over the run. So looking at this point and this point, think about the rise. I'm going to fall 1, 2 units. Okay, so I'm going to put a negative 2 for the rise. And then from this point right here, I'm going to run 1, 2, 3, 4, 5. So I'm going 5 units to the right, so that's going to be a 5. And you could also write this as 2 over negative 5 if you wanted to. So if I started here, I could go up 2 units, 1, 2, to the left 5. So 1, 2, 3, 4, 5, back on the line. So the slope here would be negative 2/5. So let me write y, or actually f of x, is equal to the slope negative 2/5 times x. And then the b is going to be negative 3, so you could write minus 3 or plus negative 3, whatever you want to do. So let's grab this and let's paste this in here. So I'm looking for this guy right here. So f of x, or you could put y if you wanted to, is equal to negative 2/5 times x minus 3. All right, let's take a look at question 4. So here we want to find the linear function that matches the given graph. All right, so again, I'm going to think about y equals mx plus b. And the first thing I'm going to figure out is, what is the y-intercept? So looking at the y-axis, I see my y-intercept would occur at 0, 3. Okay, so that means the b value here is 3. So let me write y equals mx plus, it's going to be a 3. Okay, I need to figure out what m is. So m, the slope, is equal to the rise over the run. So here, if I think about going from this point to this point, I'm going to fall 1, 2, 3, 4 units, and then I'm going to go to the right 1, right? So I could write that as negative 4 over 1. I could also write this as 4 over negative 1, right? So either way, it's negative 4. But if you think about it this way, I could start here and go up 4 units, 1, 2, 3, 4, and then to the left 1, back on the line. Okay, so either way. So this m here would just be negative 4. And again, using the function notation like we have in our answers, let's just say f of x is equal to negative 4x plus 3. Okay, so let's grab this and let's paste this in. So f of x here equals negative 4x plus 3. So I'm looking for this answer right here. Again, f of x, or again, you could say y, is equal to negative 4x plus 3. All right, let's take a look at question 5. So here we want to find the linear function that matches the given graph. So immediately when we look at this, we see that we have a special case. We basically have a horizontal line, and you can see that it impacts the graph at 0, 4. Okay, so that's your y-intercept. So the y-intercept is at 0, 4. So basically, no matter what the x value is, y is always 4. So you can say that this line is y is equal to 4, or you could say f of x is equal to 4, whatever you want to do. Let's come down here, and we want to look for f of x equals 4, so this guy right here. All right, let's take a look at the quiz. For the first question, we want to find the slope of the line that passes through the given points. So we're going to have 9, 4, and then we're going to have 2, 6. So I'm just going to label this as x sub 1 and this as y sub 1. And then I'll label this as x sub 2 and then y sub 2. Like I've said in every other video, you can switch the order here and you'll get the same answer. So let's plug into the slope formula. So m is equal to, you have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we know that x sub 2 is not going to be equal to x sub 1 in this formula because, again, if that happens, you're going to have division by 0, and so you'd say your slope is undefined. You'll know that right away because the x guy in each case would be the same. So let me get rid of this, and let's just plug in. So for y sub 2, we're going to have a 6. For y sub 1, we're going to have a 4. For x sub 2, we're going to have a 2. And for x sub 1, we're going to have a 9. So 6 minus 4 is going to be 2. And this is over. 2 minus 9, that's going to be negative 7. So this gives me negative 2 sevenths as my slope. So looking through my answers, I want m, the slope, is equal to negative 2 sevenths. All right, for question 2, we're asked to find the slope of the line that passes through the given points. So we are given 1, 4, and then we are given negative 5, 18. So let's say that this is x sub 1, and this is y sub 1, and then this is x sub 2, and this is y sub 2. And from here, just plug into the slope formula. So m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So for y sub 2, let's say that this is 18. For y sub 1, let's say this is 4. Then for x sub 2, we have a negative 5. And then for x sub 1, we have a 1. So 18 minus 4 is going to be 14. This is over negative 5 minus 1, which is negative 6. So let's say that this is going to be negative. We have a positive over a negative, which is a negative. And then each guy here is divisible by 2. So 14 divided by 2 is going to be 7. And then 6 divided by 2 is going to be 3. So this would be negative 7/3 for m, or your slope. So coming over here, I want m, the slope is negative 7/3. All right, let's take a look at question 3. So we want to find the slope of the line that passes through the given points. So we have negative 2, 5, and then we have negative 2, negative 11. So before you do anything here, what do you notice? This is negative 2 and this is negative 2. Again, that's going to give you division by 0. Okay, let's just go through it the long way. So let's say that you didn't realize that and you said this was x sub 1 and this is y sub 1 and this is x sub 2 and this is y sub 2, and you plug in. So m is equal to, you have your y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But again, this is for x sub 2 is not equal to x sub 1. Here, clearly, x sub 2 and x sub 1 are equal, so this is not going to work. When you plug this in here, you have a negative 2 minus a negative 2, which is plus 2. Okay, so this right here is going to end up being 0. We know division by 0 is undefined. Let me go ahead and just put this in for completeness. Y sub 2 is negative 11, and then y sub 1 is 5. So this would be negative 16 over 0, which again is just undefined. So for your answer, you'd want to erase this and just say that m is undefined. Or as we've put in the answer here, we could just say that there's an undefined slope. Either answer is fine. All right, for question 4, we're asked to find the slope of the line by placing the equation in slope-intercept form. So slope-intercept form is y equals m, the slope, times x plus you have b, which is the y coordinate from your y-intercept. So we think about 5x minus 12, y is equal to 24. All you need to do is solve this guy for y to put it in slope-intercept form, and then grab the coefficient of x, that m value there, that's your slope, okay? So quite an easy process. We're just going to subtract 5x away from each side of the equation. Let's go ahead and cancel this away. I'm going to run out of room, so I'm just going to erase things as I go. And let me just move this up here and just say this is plus 24 like that. Now, to get y by itself, you would just divide both sides by negative 12. So just divide this by negative 12, this by negative 12, and this by negative 12. Let me make that a little bit better. And so this is going to cancel. This right here, you can cancel the negatives away, and then 24 divided by negative 12 is going to be negative 2. So let's go ahead and say that y is equal to, this would be 5 over 12 times x, and then this would be negative 2, so minus 2. Let me get rid of this, and let me slide this up here. And you just want to match things up. So the m here is going to be 5/12. Again, the coefficient of x, whatever that is. So let's say m, the slope, is 5/12. And if you needed the y-intercepts, we don't need that here. It would be 0, comma b. So b here, you could say that's -2. So the y-intercept, let me just write it out in case you're curious. This would occur at 0, comma -2. Okay, so the slope m is 5/12, and that's what we're asked for. So that's going to be this guy right here. Our slope m is 5/12. All right, let's take a look at question 5. We are asked to use the graph to find the slope of the line. So I'm going to show you two different ways to do this. The first is by just using the slope formula. So let's just pick 2 points on the line. I'm just going to pick this point and this point. So this point right here is going to be 1, comma 1. And then this point right here, this is going to be -3, comma -3. So you can label this point right here as, let's say, x sub 2, and then y sub 2, and then this point right here, let's say this is x sub 1, and then y sub 1, and just plug in. So m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And for y sub 2, we have 1. For y sub 1, we have -3. So we know that minus a -3 is +3. So let's just go ahead and write that now. Over here, x sub 2 is going to also be 1, and x sub 1 is going to also be -3. So you have minus -3 again, which is +3. So you can see this is going to end up being 1, right? 1 plus 3 is 4, so you'd have 4 in each case. 4 over 4 is 1. So let's write 4 over 4, which equals 1. Okay, so that's one way to find the slope. The other way, again, is to do the rise over run. So m is equal to rise over run. So just start at a point, okay? Let's say we start at this point and go to this point. So I'm going to go up 1, 2 units. So my rise is 2. And then if I'm right there, I need to go 2 units to the right to return to the line. So my run is 2. So 2 over 2 is going to be 1. Okay, so that's another way. You could also say m is equal to rise over run. You could start here and go down by 1 unit and go to the left by 1 unit, or let's just stick with the points that are given. So let's fall by 1, 2 units, and then go to the left 1, 2 units. So my rise is -2, and my run is -2, which again, -2 divided by -2 is also 1. So however you do this here, you're going to get a slope m that's 1. Coming back, we just want to select that m, our slope is 1. All right, let's take a look at the quiz. For the first question, we're asked to write the equation of the line in slope-intercept form given the following information. So we have m, the slope, is equal to -3/2. And then we have that the y-intercept occurs at 0, -1. So my y-intercept is occurring at 0, -1. So for the slope-intercept form of the line, we have y is equal to m, the slope, times x plus b, where b is the y-coordinate from the y-intercept. So m is -3/2. Just plug that in. So this is -3/2. Let me make this 3 a little bit cleaner here. And then for b, again, this is the y-coordinate from the y-intercept, so that's -1. You could put plus -1 or just -1. So the slope-intercept form of the line is y equals -3/2 x minus 1. So we're looking for this guy right here. All right, let's take a look at question 2. So here we want to write the equation of the line in slope-intercept form given the following information. So m, the slope, is equal to -5/7. And then the y-intercept is going to occur at 0, 18. So for the slope-intercept form, it is y is equal to m, the slope, times x plus, you have your b, which again is the y-coordinate from the y-intercept. So just plug in the information you're given. So for m, the slope, we're given -5/7. Then for b, that's again the y-coordinate from the y-intercept, that's going to be 18. So looking through the answers, I'm looking for y is equal to -5/7 x plus 18. So it looks like this guy right here. All right, for question 3, we're asked to write the equation of the line in slope-intercept form given the following information. So we have m, the slope, is -9, and we're given a point on the line of 5, 4. Let me write this a little bit more cleanly. So m, the slope, is equal to -9, and then we have our point, which is going to occur at 5, 4. And I'm just going to label this as x sub 1 and y sub 1. So what we're going to do here is plug into the point slope form of the line. So this is y minus y sub 1 is equal to m the slope times the quantity x minus x sub 1. So you have your slope here and a point of the line here, which again is labeled as x sub 1 and then y sub 1. So just plug in. So for m, I'm going to plug in a -9. And then for y sub 1, I'm going to plug in a 4. And then for x sub 1, I'm going to plug in a 5. Okay, once you've done this, if you want the slope-intercept form, just solve for y. That's all you have to do. Let me get rid of this and drag this up here. And we're going to distribute the -9 to each guy inside the parentheses. So let me write, we have y minus 4 is equal to -9 times x is -9x. And then -9 times -5, let me go plus negative here so that's crystal clear. So again, -9 times -5, that's 45. So go plus 45 like this. And to solve for y, just add 4 to both sides of the equation. So this is going to cancel away. And we'll end up with y is equal to -9x. And then plus 45 plus 4 is going to be 49. So looking through my choices here, it looks like I want this guy right here. So y equals -9x plus 49. All right, let's take a look at question 4. So here we want to write the equation of the line in standard form given the following information. So we have points on the line. So one point, let me write this out. So 9, -7. And then another point is 27, 1. So what you do in this situation is you first find your slope using the slope formula. So let's say this is x sub 1 and this is y sub 1 and this is x sub 2 and this is y sub 2. Again, you can change the labeling and I'm just going to plug in. So m the slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So for y sub 2 we have 1. For y sub 1 we have -7. So minus the -7 is plus 7. For x sub 2 we have 27. And then for x sub 1 we have 9. So we know that 1 plus 7 is going to be 8. And then 27 minus 9, that's going to be 18. So 8 over 18, let's divide each guy there by 2. 8 divided by 2 is 4. And 18 divided by 2 is 9. So m, the slope is 4/9. So at this point, get rid of your labeling. And you're going to pick one of the points. It does not matter which point you choose. And label it as x sub 1, y sub 1. Okay, so I'm just going to go with the first point. Again, if you go with the second point, you're going to get the same result once you solve for y. When you plug in initially, it looks different, but once you solve for y, it's the same thing. So let me slide this over here. And it looks like I didn't take anything with me. So m is equal to 4/9. You can actually erase that point now if you want to, but I'm just going to leave it. So you plug into the point slope form. So y minus y sub 1 is equal to your m times the quantity x minus x sub 1. Okay, so what is m? That's going to be 4/9. What is y sub 1? Again, we're working over here. That's going to be -7. Minus the -7 is plus 7. And what is x sub 1? That's going to be 9. Okay, we've gotten all the information, so let's get rid of this. And let's slide this up. And the first thing we're going to do is we're going to solve for y. But specifically here, it asks for standard form, so we have to do more work than just solve for y and put it in slope-intercept form. But let's take it one step at a time. This is going to get distributed here and here. So we'd have y plus 7 is equal to 4/9 times x, and then minus 4/9 times 9. Well, let me write this out so nobody's lost. The 9s there are actually going to cancel, so you end up with -4 there. Okay, so this is -4. Now, the last thing I would do is subtract 7 away from each side of the equation, so that cancels away. Let me just get rid of this so we have enough room here without going to another page. I'll move this up here and just write that this is y is equal to 4/9 x, and then -4 minus 7 is going to be -11. Okay, let me get rid of this. Now, what we want is the standard form, okay? If you select this answer, y equals 4/9 x minus 11, that is the slope-intercept form of the line. Because this question is asking for the standard form, that is the wrong answer. So what you actually want to do is put this in the form of ax plus by equals c, where a, b, and c are the integers, okay? And then also, you want to say that there's no common factor other than 1 between a, b, and c. And lastly, a is going to be non-negative. Okay, so what we're going to do is we're going to subtract 4/9 x away from each side of the equation. Let me put the x here where it goes, and let's cancel this away. And so what you would have now is -4/9 x, and then plus y is equal to -11. Okay, so not quite there yet. What we need to do is get rid of this fraction here and basically make this into a positive. So how can we accomplish both of those in one shot? Well, if I multiply both sides of the equation by 9, I would clear this denominator here. But if I multiply both sides by -9, I would clear the denominator and I would make this into a positive. So let's go ahead and do that so that we can accomplish both of these at one time. So -9 would be distributed to each guy here. So basically, if you have -9 times -4/9, let me write this out so nobody is lost. The negatives would cancel, right? So let me show those as canceling. And then the 9s would cancel, so you're just left with 4. Let me get rid of this and just put that this would be 4x. And then -9 times y is just -9y. Or you can put plus -9y if you want to do it that way. And this equals -11 times -9 is 99. So at the end of the day, in standard form, we're going to want to put 4x minus 9y equals 99. So it's going to be this guy right here. All right, let's take a look at question 5 now. So again, we want to write the equation of the line in standard form, given the following information. So we have points on the line, 7, -12, and then also -7, -8. All right, let's grab this real quick. I think on the last one, we were a little bit jammed, so we had to keep erasing things. And on this one, I just want to be free to write things out. So let's just say this is x sub 1, and this is y sub 1, this is x sub 2, and this is y sub 2. And basically, I did that so I could find the slope first, because we have 2 points. We don't know the y-intercept or the x-intercept or anything. So just go ahead and grab the slope. We'll say m, the slope, is equal to, again, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So here, y sub 2 is going to be -8, and then y sub 1 is going to be -12. So minus a -12 is plus 12. And then over here, x sub 2 is going to be -7. And then x sub 1 is going to be positive 7. So for this one, -8 plus 12 is going to be 4. And then here, -7 minus 7 is going to be -14. Okay, so we have 4 over -14. Each guy here is divisible by 2. 4 divided by 2 would be 2, and -14 divided by 2 would be -7. So m, the slope, is equal to -2/7. Okay, now that we have the slope, you can actually get rid of this labeling here, and you have one point and the slope. You can use either point, it does not matter. You can use this point or this point, but just label one of them as x sub 1, y sub 1, and you're going to plug into the point slope form of the line. So y minus y sub 1 is equal to m, the slope, times the quantity x minus x sub 1. So for y sub 1, you have a -12. So minus a -12 is plus 12. For m, you have a -2/7. And then for x sub 1, it's just going to be 7. Okay, what I'm going to do here is distribute this to each guy inside. So y plus 12 is equal to -2/7 times x. That's -2/7 x. And then -2/7 times, I'm going to treat this as a -7 here. So let's go plus -2/7 times -7. All right. This right here would cancel with this right here. And then you can cancel the negatives away because negative times negative is positive. So you would just be left with a 2 right there. So let's go ahead and say that this is going to be y plus 12 is equal to -2/7 x, and then basically plus 2. From here, I'm going to subtract 12 away from each side of the equation. I'm going to cancel this away, and we'll say that y is equal to -2/7 x. And then 2 minus 12 is going to be -10. So let's say minus 10. All right, so this is the slope-intercept form of the line. So coming back up here, if you selected this one, it's incorrect because, again, let me highlight this. We want the standard form, okay? So the ax plus by equals c. So coming back down here, we have a little bit more work to do. I'm going to add 2/7 x to both sides of the equation. Let's go ahead and cancel this. And over here, let's say that this is 2/7 x plus y is equal to -10. So the last thing I'm going to do here is make this into an integer. And to do that, I'm just going to multiply both sides of the equation by 7 so that I can clear that denominator. So this is going to get distributed to here and here. So 7 times 2/7 is going to be 2. So this would be 2x, and then plus 7 times y is 7y. And this equals -10 times 7 is -70. So let me grab this real quick, And let me paste this in here. So we're looking for 2x plus 7y equals negative 70. So again, that's the standard form of the line. So this is the correct answer right here. So again, 2x plus 7y equals negative 70. All right, let's take a look at the quiz. For the first question, we're asked to determine if each pair of lines are parallel, perpendicular, or neither. So we're given 3x minus 7y is equal to 21. We are also given 7x minus 3y is equal to 15. Let me grab this real quick and let's paste this in here. Now, if you're given your lines in standard form, so ax plus by equals c, and let's just say a, b, and c are real numbers, well, again, you could solve this for y and give yourself a little formula to quickly find the slope, right? You don't have to solve this for y each time. You can do that if you want to, but it's just very time consuming. So you would say that m is equal to negative a over b. So how do I get that? Let me move this over here. Just in case you haven't watched any of the other videos, let me just quickly derive that for you. Subtract ax away from each side of the equation. This is going to cancel. You would get by is equal to negative a times x plus c. I'm just going to actually erase this. And I'm going to divide everything here by b. And this would actually cancel away. So you get y is equal to negative a over b times x plus c over b. Well, again, if you've solved the equation for y, you get y is equal to m the slope times x plus b the y-intercept. So here, the slope is going to be negative a over b, and the y-intercept would occur at 0, c over b. Okay, so you could take that information and put this into slope-intercept form very quickly, but we really just need the slope, right? So I'm just going to analyze that in each case. So let me get rid of this scratch work here. We know that m is equal to negative a over b. So let me move this over here. And I'm just going to arrow to this, and then I'll do another one over here. So m is equal to negative a over b. And so let me label things. So this is a, like this. And let me go plus negative and plus negative. So this is b, like this. And then this is c, like this. Now, we don't need c to determine if the lines are parallel or perpendicular. We only need a and b, right? But you might want c if you want to sketch a graph. So it's really up to you. So I'm going to plug in for a. Here it's 3, and here it's 7. So this is 3, and this is going to be 7. Let me make this 3 a little bit better. And then I'm going to plug in for b. So here it's negative 7, and here it's negative 3. So this is negative 7, and this is negative 3. Okay, so looking at this, a negative over a negative is a positive, so this is 3/7. And then looking at this, negative 7 over negative 3 is going to be 7/3. So the slope of this guy is 3/7, and the slope of this guy is 7/3. So are they parallel lines? Well, we know that two non-vertical lines that have the same slope and different y-intercepts would be parallel. The slopes here are not the same, so they're not parallel lines. Are they perpendicular? Two non-vertical lines that have slopes where the product is -1, those are going to be perpendicular lines. If I multiply 3/7 by 7/3, do I get -1? No, I get 1, right? These are reciprocals. This would cancel and give me a big fat 1. Right? So this is 1 and not -1. So coming back up here, you would say neither parallel nor perpendicular. All right, let's take a look at question 2. So again, we want to determine if each pair of lines are parallel, perpendicular, or neither. So we are given 15x minus 9y is equal to 54. Let me go plus negative here to make things more clear. And then negative 5x plus 3y is equal to 21. So let me grab this. Come down here and paste this in, and let me actually move this down. So I'm going to say that this is A, and this is B, and this is C, and just arrow down here as well. And again, to find the slope, you could solve for y if you wanted to. That's up to you. I'm going to say m is equal to negative a over b. So if it's given in standard form, and I know there's different definitions of standard form, but ax plus by equals c, where a, b, and c are real numbers, whatever they are, then you can use the m, the slope is equal to negative a over b. So here, m, the slope is equal to negative a over b. All right. So for this guy, the a is 15. So this would be negative 15. And then the b is -9. So this is -9. Down here, a is -5. So be very, very careful here. This is the negative of -5. So the negative of -5. And then b is going to be 3. All right. So what is this going to give me? Negative over negative is positive. With 15 and 9, they're each divisible by 3. 15 divided by 3, you're going to get 5. And then 9 divided by 3 is 3. So this is 5/3. Here, this is a negative of a negative. So the negative of -5, or the opposite of -5, is +5, and this is over 3. So this is 5/3, and this is 5/3. Slopes are the same, different y-intercepts. These are parallel lines. So coming back up, we can say the lines are parallel. All right, let's take a look at question 3 now. So we want to determine if each pair of lines are parallel, perpendicular, or neither. We have 2x plus 5y is equal to -15. And then we have 10x. Instead of -4y, let's put plus -4y. This equals -76. Okay, let's grab this. And I'll just paste this in here. I'm going to use my little shortcut here. Again, m, the slope is equal to -a/b. And let's do that here as well. So m is equal to -a/b. So this guy right here, let me just label these at the same time. So a is going to be 2 here, and then 10 here. And then b is going to be 5 here, and then -4 here. And then c is going to be -15 here, and then -76 here. Again, you don't need c, but I just do it for completeness. So up here, if you plug in a 2 for a, you'd have -2. And then for b, you'd plug in a 5. So this is -2/5. Then down here, you'd plug in a 10 for a. So this is -10. And then for b, you're going to plug in a -4. So this right here, you could simplify. Negative over negative is positive. And then with 10 and 4, they're each divisible by 2. So 10 divided by 2 would be 5. 4 divided by 2 would be 2. So this slope is -2/5, and this slope is 5/2. And so, of course, those are negative reciprocals. So the product would be -1. So these guys are going to be perpendicular. Let me show you this. So -2/5 times 5/2. So you can cancel this with this and this with this. Let's just say this is a 1 times a -1, which would be -1. So they're perpendicular. Let's come back up here and just say they are perpendicular lines. All right, for question 4, we are asked to write the equation of the line in standard form given the following information. So we have a point, which is 4, -2. I'm just going to label that now as x1 and then y1. And then we're told that it's perpendicular to this 4x minus 5y is equal to 10. So let me write m is equal to question mark here. And I'm going to grab this real quick, come down here and paste this in. So the first thing is I need to work out the slope. So I'm going to do that with this guy right here. So we're told that they're perpendicular lines. So that means that basically the slope of this guy times this m, the slope of this guy, should be -1. Let me do that over here. So this guy right here. So basically blank times m is equal to -1. Let me figure out this blank here. Again, because this is in the ax plus by equals c, the standard form, let me go plus negative here. You could say the slope m is -a/b. So here a is 4. So this would be -4. And b is -5. So this is -5. -4 over -5 is 4/5. So just plug that in here. This is 4/5. And then basically if I take the 4/5, the slope of this line right here, and multiply it by m, the slope of this line that I'm trying to figure out the equation for, I should get -1. Get rid of this. You don't need the information anymore. Don't clutter things up. And basically all you would do here is multiply both sides by 5/4. Again, you're trying to find negative reciprocals. So this is going to cancel. You're going to get m is equal to -5/4. Okay, so now we know our unknown slope, which is -5/4. So what do we do? Again, we plug into the point slope form of the line, we solve for y and get slope intercept form, and then we put it into standard form. So quite a bit of work. So let me come over here and say that the point slope form of the line is y minus y1 is equal to m, the slope, times the quantity x minus x1. Well, we just plug in what we have. So this right here is -5/4. For x1, you're going to have 4. For y1, you're going to have -2. So minus the -2 is +2. Okay, now we just distribute this to each guy so that we can get our slope-intercept form. Let me actually get rid of this labeling here because we're going to turn it into slope-intercept form, and I don't want anything to be inaccurate there. So I'm going to say this is y plus 2 is equal to -5/4 times x is -5/4 x. And then negative times negative is positive. You have 5/4 times 4. Well, the 4s are going to cancel, and I'm going to be left with a 5. So let's subtract 2 away from each side. That cancels. And we'll say that y is equal to negative 5/4 x, and then plus 5 minus 2 is 3. Okay, from here, I want to put this into standard form. So again, the ax plus by equals c. So let's add 5/4 x to both sides of the equation. You're going to get 5/4 x plus y is equal to 3. What I'm going to do at this point is clear this fraction. Remember, with standard form, with the stricter definition, you want a, b, and c to be integers. You want a, b, and c to not have a common factor other than 1, and you want a to be non-negative. Well, really, all I have to do is clear this fraction, and I'm good to go with that definition. So multiply both sides by 4 to clear that denominator. This is going to get distributed in here. So we're going to have 4 times 5/4, which is 5, then times x, and then plus 4 times y is 4y, and this equals 3 times 4 is 12. So this is the standard form of that line we were looking for. So 5x plus 4y equals 12. So coming back, I want this one. So 5x plus 4y equals 12. All right, let's take a look at question 5. So here we want to write the equation of the line in standard form given the following information. So we have a given point, which is negative 3, 3. Let's go ahead and label that as x sub 1 and then y sub 1. And then we have that it's parallel to this 14x plus 6y equals 24. So 14x plus 6y equals 24. Let's put m is equal to question mark. Okay, let me grab this real quick. Come down here and paste this in. Now, with parallel lines, the slopes are the same. So I can just find the slope of this and then put that in for there. Now this guy, you could, if you wanted to, divide everything by 2, make it a little bit simpler. But you don't have to because, again, the m here, the slope is equal to negative a over b. It's the same whether you simplify it or not. So I'm just going to take this as a and this as b. So negative 14, again, 14 is a, and then over b is 6. Okay, so you can see that you can simplify this. You could divide both the numerator and denominator by 2 because, again, there's a common factor of 2 in this equation. Okay, so negative 14 over 6 we'll write as negative 14 divided by 2 is 7, and then 6 divided by 2 is 3, so it's negative 7/3. So let's write our slope here as negative 7/3. And again, once you've gotten this information, just go ahead and get rid of this or turn the page. A lot of people will mess themselves up by constantly looking back and forth at different pieces of information in the problem, and you only need the point and the slope to plug into the point slope form. So point slope form, again, is the y minus y sub 1 is equal to m times the quantity x minus x sub 1. And for this guy, you have negative 7/3 for your slope m. For x sub 1, you have a negative 3 minus a negative 3 is plus 3. And then for y sub 1, that's going to be 3. Okay, let's get rid of this and come down here. I'm going to distribute this to each guy there. So y minus 3 is equal to negative 7/3 times x is negative 7/3 x. And then negative 7/3 times 3 is going to be negative. The 3's would cancel, so you just have 7. All right, let's solve this for y. I'm just going to add 3 to both sides of the equation. That's going to cancel. Y is equal to negative 7/3 x. And then negative 7 plus 3 is negative 4. So that's your slope-intercept form. Again, you want the standard form, so the ax plus by equals c. So go ahead and add 7/3 x to both sides of the equation. This right here would cancel. So you would get 7/3 x plus y is equal to negative 4. What I'm going to do at this point is get rid of this fraction. Again, you want a, b, and c to be integers. You want a, b, and c to not have a common factor other than 1. And you want a to be non-negative. Okay, so I'm going to multiply everything here by 3 just to clear this denominator, get rid of that fraction. This is going to get distributed in like that. So we're going to have 3 times 7/3, which is 7, then times x, and then plus 3 times y is 3y. And this equals negative 4 times 3 is going to be negative 12. So that's your standard form for the line. Let's go ahead and grab it, paste this in. So this is the answer we want. So 7x plus 3y is equal to negative 12. All right, let's take a look at the section quiz. For the first question, we're asked to determine if each relation is a function. Additionally, we want to state the domain and range. All right, let me write this. We have our f, which we know is a relation, but is it a function? So it's just a set of 5 ordered pairs. I'm just going to copy this so we can see it. So it's 9, negative 1, and then it's 5, 3. and then it's 8, comma 7. And then we have 9, comma negative 4. Let me slide this over here so it fits. Then lastly, you have 16, comma 15. Okay, let me close this down. I'm just going to grab this real quick and paste this on a new sheet so we have a lot of room to work. When we have a function, for each x, there's one y. So when you get a simple problem like this that comes up when you first start looking at functions, all you have to do is look for a duplicate x value. That's all you need to do. So I look here and I have a 9, and then I also have a 9. So I know immediately this is not a function because I have an x value of 9 that corresponds to two different y values. Here it's negative 1, and here it's negative 4. So this is not a function. So you can immediately say not a function. Now, we can still list the domain, which is the set of x values. So just go ahead and grab those. So it's going to be 9. It's going to be 5. It's going to be 8. You don't double list things, so you don't put another 9 in. And then you'd put a 16 there. Okay, so let's close that down. And then the range is your set of y values. So you have negative 1, you have 3, you have 7, you have negative 4, and then you have 15. Okay, let's close that down. Let's grab this, come back up here and paste this in. So I'm looking for no, this relation is not a function. The domain would contain the elements 9, 5, 8, and 16, just like we have here. And the range would have the elements negative 1, 3, 7, negative 4, and 15, just like we have here. This 3 looks pretty terrible, so let me fix that in case you're a little bit confused. So this is the answer we want. All right, let's take a look at question 2. So here we're asked to determine if the given relation is a function. So this is a mapping diagram. You'll see this when you study functions. On the left, you have your members of the domain. On the right, you have your members of the range. So basically, you could think about this as maybe flight plans to where you have a takeoff city and then an arrival city or a destination city, however you want to think about that. So let's say that a domain element of Detroit is mapped to a range element of San Francisco. So I take off in Detroit, and I'm definitely going to land in San Francisco. Then a domain element of Baltimore is mapped to a range element of Atlanta. So I take off in Baltimore, I land for sure in Atlanta. But here's where there's a problem. A domain element of Boston is mapped to a range element of Dallas and then also Austin. So if I take off from Boston, I don't know if I'm landing in Dallas or Austin. So which one am I going to go to? So this is not going to be a function. For each member of the domain, it needs to be mapped to, or you could say correspond to, one and only one member from the range. So here we violate that definition because a member from the domain of Boston is mapped to two different members from the range. So we have Dallas and then also Austin. So let's put no, this relation is not a function. All right, for question 3, we have given the linear function 13x minus 12y is equal to negative 156. We want to find the x and y intercepts. So if you want to find the x-intercept, or the place where the graph is going to cross the x-axis, well then y needs to be 0. So let's just go ahead and plug in a 0 for y there. You basically can get rid of this, but let me just show you this fully. So 13x minus 12 times 0 is equal to negative 156. So this part right there, because you're multiplying by 0, is just going to go away. And you would have 13x is equal to negative 156. Let's divide both sides of the equation by 13. So negative 156 divided by 13, that's going to give me negative 12. So let me put x is equal to negative 12. So in other words, we would say that one point on this line would be negative 12, comma 0. So this right here would be your x-intercept. Okay. To find the y-intercept, now we're going to let x be equal to 0 and solve for y. So we'd have 13 times 0. Of course, this is just going to go away. Then you have minus 12y is equal to negative 156. So because we're multiplying by 0, this will go away. 13 times 0 is just 0. So you're going to have negative 12y is equal to negative 156. Let's divide both sides of the equation by negative 12. Let me actually erase this so I can keep this without going to another page. Move this up here. So this would cancel, and you get y is equal to negative 156 divided by negative 12. That would give me positive 13. So another point on this line which would be the y-intercept, would occur at 0, 13. So this is my y-intercept. Okay, so looking through the choices, it looks like we want this one right here. So the x-intercept would occur at negative 12, 0, and the y-intercept would occur at 0, 13. All right, for question 4, we want to find the linear function that matches the given graph. So when we think about this, remember you have your slope-intercept form, which you can write as y equals m the slope times x plus b, where b is the y-coordinate from the y-intercept. So the y-intercept is at 0, b. You could also write this with function notation as f of x in the place of y is equal to mx plus b. So the first thing I would do is figure out where's the y-intercept. So that's going to occur here. So that's at 0, negative 2. Let me arrow to this and say this is 0, negative 2. And then basically you can replace your b. Let me just do it in this form first and then I'll replace it in a moment. You can replace your b with a negative 2. So you can go plus negative 2 or you can just say minus 2. The only other thing we have to do is figure out what is the slope. So basically for that, you say your m, your slope, is your rise over your run. So just grab one point and then another point and then determine how much do I have to rise and then how much do I have to run to get from the first point to the second point. And it doesn't really matter how you go. You can go from this guy to this guy or from this guy to this guy. It's going to work out the same in the end. Let me do that in a different color. So I'm going to rise 1, 2, 3 units. So let me say my rise is 3. And then I'm going to run 1, 2, 3, 4 units. So that's going to be 4. So your slope, m, is 3/4. And you could have also gone the other way. So you can drop 1, 2, 3, and then go to the left 1, 2, 3, 4. So in that case, it would be negative 3 over negative 4, which is still 3/4. So let's just go ahead and say that y is equal to, for m, it's going to be 3/4, and then times x, and then minus 2. So let me get rid of all of this. And let me grab this real quick. Come down here and paste this in. So we want this in terms of f of x. So just replace y with f of x. So we'll say f of x is equal to 3/4 x minus 2. So I'm looking for this guy right here. So f of x equals 3/4 x minus 2. All right, for question 5, we are asked to find the slope of the line that passes through the given points. So we have 5, 4, and then we have negative 13, 4. Now, normally I would say pick one of the points and label it as x sub 1, y sub 1, and the other as x sub 2, y sub 2. Let me actually do that real quick. So let's say this is x sub 1 and y sub 1, and this is x sub 2 and y sub 2. And of course, you could change that around. It would make no difference to your final answer. What you notice here, what you probably noticed, is that you have a y value of 4, and then you have a y value of 4 again. So what does that tell me? It tells me that for different x values, I have the same y value, and that's only going to happen if I have a horizontal line. So basically, this is the line, y is equal to 4, right? So the slope here would be 0. You could write this as y is equal to 0x plus 4. So m, the slope, is 0 there, okay? So let's get rid of this. This is going to be our correct answer, m equals 0. But we can actually show this with the slope formula. So m, the slope, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So for y sub 2, it's 4. And then for y sub 1, it's also 4. And then for x sub 2, it's going to be negative 13. And then for x sub 1, it's going to be 5. Now, it doesn't really matter what this denominator is as long as it's not 0, because this is 0. 0 divided by something that's not 0 is going to give you 0. But let's just do the calculations anyway. 4 minus 4 is 0. This would be over. Negative 13 minus 5 is negative 18. And of course, 0 divided by negative 18 is 0. So m, the slope, is 0, which we selected there. All right, let's take a look at question 6. So we want to use the graph to find the slope of the line. All right, so just pick any 2 points on the line. I'm just going to pick this one and then this one. And of course, you could do this by using rise over run. You could also just pick those 2 points and use the slope formula. I'll just do it both ways for you. So this point right here is 0, negative 4. And then this point right here, let's see, I'm going 5 units to the right and then 7 units down. So this one is 5, negative 7. Maybe this could be labeled a little bit better. Let me arrow from here so it's not blocking things. And of course, you can use your slope formula. So m, the slope, is equal to, we'll have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let's go ahead and say that this is x sub 1 and y sub 1. And let's say that this is x sub 2 and then y sub 2. And let's just plug in. So y sub 2 is going to be negative 7. And then y sub 1 is going to be negative 4. So minus the negative 4 is plus 4. For x sub 2, it's going to be 5. And then for x sub 1, it's going to be 0. So 5 minus 0 is just 5. So negative 7 plus 4 is negative 3. So the slope here, m, is negative 3/5. Okay. The other way to do this is with the rise over run. So let's go m, the slope is equal to the rise over the run. So you can start here and go 1, 2, 3 units down. So that's negative 3. And then I'm going to run to the right 1, 2, 3, 4, 5 units. So that's a positive 5. So this is negative 3 over 5, or you could put negative 3/5, whatever you want to do. Remember, you can always go backwards. So you can go 1, 2, 3, 4, 5 units to the left. So that would be negative 5. And then you can go up 1, 2, 3. So in that case, you would basically have a positive 3. So let me write this like this. You could have a positive 3 over a negative 5. So let me change this up here like this to make that more clear. So starting from here, I could drop 3 units, 1, 2, 3. Go to the right 5, 1, 2, 3, 4, 5. Or I could start here and go up 3, 1, 2, 3. And then go to the left 5, 1, 2, 3, 4, 5. Whatever you want to do, it's going to be negative 3/5 either way. So let's come back here and say m equals negative 3/5. All right, for question 7, it's asking us to write the equation of the line in slope-intercept form given the following information. So we have m, which is the slope, is equal to negative 4. And then a point on the line is going to be 3, 7. So for this, you want to use your point slope form. Okay, so that's when you have a point and then the slope. So what I would do is say this is y minus y sub 1 is equal to m times the quantity x minus x sub 1. So the x sub 1 and y sub 1, that's coming from this known point. So this is x sub 1 and this is y sub 1. All right, I'm just going to plug in. So for x sub 1, I'm going to put a 3 in. For y sub 1, I'm going to put a 7 in. And then for m, the slope, I'm going to put in a negative 4. So at this point, all you have to do is solve this for y, and you'll have the slope-intercept form. I'm going to distribute the negative 4 to each guy inside. So I'd have y minus 7 is equal to negative 4 times x is just negative 4x. And then negative 4 times negative 3 would be plus 12. Okay, let's get rid of this. And let's just add 7 to both sides of the equation. So this would cancel away. And you're going to get y is equal to negative 4x, and then 12 plus 7 is 19, so plus 19. So this is the slope-intercept form of the line. So basically you have y equals m. Again, m, the slope is negative 4, x plus b. Here the y-intercept would occur at 0, 19, right? So b is 19. So looking through my choices, I want this one right here. So y equals negative 4x plus 19. All right, let's take a look at question 8 now. So it says write the equation of the line in standard form. Let me highlight that. So standard form, given the following information. Points on the line. So we have 1, 6, and then we have 13, 21. Okay, let me grab this and come down here. So if you're given 2 points, it does take a little bit of time because first you have to generate the slope. So I'm going to label this as x sub 1 and y sub 1. And then this as x sub 2 and then y sub 2. And then we'll just plug into the slope formula. So m, the slope, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So for y sub 2, it's going to be 21. So let me just plug that in there. For y sub 1, it's going to be 6. For x sub 2, it's going to be 13. And then for x sub 1, it's going to be 1. So what I would have here is 21 minus 6, which is going to be 15. This would be over 13 minus 1, which is going to be 12. Now, each of these guys would be divisible by 3. So 15 divided by 3 is 5. And then 12 divided by 3 is 4. So the slope m here is 5/4. So that's what we need. This is 5/4. Now, this is the tricky part. Once you've got your slope, you can pick either point and plug into point slope form. It does not matter which one you choose. You're going to get the same answer when you solve for y. So just pick either one. I think this first one is easier to work with. I'm just going to erase the other point so that we're not focused on it. So I'm going to move this up here. and just plug into the y minus y sub 1 is equal to m times the quantity x minus x sub 1. So that's the point slope form. All right, for m, we have 5/4. And then for x sub 1, we have 1. And then for y sub 1, we have 6. Okay, let me distribute this into each guy. So you can have y minus 6 is equal to 5/4 times x, and then minus 5/4 times 1, which is just 5/4. Okay, I'm going to clear all of this information just so we have room to work. Get rid of this. I just want to solve for y. So I'm going to add 6 to both sides of the equation. That'll cancel. You get y is equal to 5/4 x, and then basically you have minus 5/4. Now you're adding 6, so basically you want to get a common denominator. So let me go plus. I'm going to multiply this by 4/4. So this would be 24/4. So now what I can do, let me go plus negative here. Negative 5 plus 24 would be 19. So this would end up being y equals 5/4 x plus 19/4. Okay, so this right here, let me just go back up for a second and show you where you could have made a mistake. Let's go back up and let's paste this in. Now, you see that you have this as an option, y equals 5/4 x plus 19/4. But this is not the correct answer. So if you mark this, what you've given is slope-intercept form. Remember, that's y equals mx plus b, okay? This specifically asks for standard form, okay? Now, this definition does vary based on what textbook you're using, but in most cases, especially if you're in a lower-level algebra course, you're going to be asked for ax plus by equals c, where a, b, and c are integers. A is greater than or equal to 0, so basically it's non-negative. So the way I would get this into standard form, I would subtract 5/4 x away from each side. So let me do that over here as well. And this is going to cancel. So what you'll have is negative 5/4 x plus y is equal to 19/4. Okay, let me get rid of this. And basically, I think it's pretty easy to see what you want to do. You need to clear the denominators of 4. So you have a 4 there and a 4 there. So multiplying both sides by 4 would do that. But you also want to get rid of that negative. So what I would do is multiply both sides of the equation by negative 4. So let me do that over here as well. Maybe that parenthesis could be a little bit cleaner there. So this gets distributed to each guy inside. So you'd have negative 4 times negative 5/4. So the 4s would cancel. Negative times negative is positive. You're just basically going to have 5. So this is 5x. And then negative 4 times y, you could put plus negative 4y or just minus 4y. And this would be equal to. Here the 4s would cancel. And basically you could think about that as negative 1 times 19, which is negative 19. So this is going to be the correct answer. Again, given the fact that we want the standard form. So this guy right there. All right, for question 9, we are asked, for the given function, find f of negative 3. So we have f of x is equal to x squared plus 7x minus 13. So we are asked for f of a negative 3. So what does that mean? It means that you're plugging in a negative 3 everywhere there's an x. So here and here. Now, my rule for this so that you don't make sign mistakes, whenever you're plugging in for a variable, always wrap it in parentheses. Always. So that's going to keep you from making a sign mistake. Because if you just punch in negative 3 squared like this in your calculator, it's going to give you negative 9, right? Because of the rules and how it works, right? Because this is really negative 1 times 3 squared, which is negative 1 times 9, which is negative 9. That is not what we want, right? We want this to be a positive 9 because whatever x is, we want it to be squared. So we want negative 3 to be squared. So make sure you wrap that if you're punching this into your calculator so you get the right answer. So then plus 7 times negative 3 and then minus 13. Okay, let's put equals. Negative 3, again, being wrapped, squared is going to be 9. And then 7 times negative 3 is negative 21. So let's go minus 21 and then minus 13. Let's go plus negative here and plus negative here. Let's do negative 21 plus negative 13 first. That's going to give me negative 34. And then I add 9 to that, and that's going to give me a final answer of negative 25. So f of negative 3 is going to be negative 25. All right, let's take a look at question 10. So now it says for the given function, find f of 9. So we have f of x is equal to the square root of x squared minus 8x minus 9. So we want to find f of 9. Again, just plug in for your variable. So this is the square root of. So I'm still going to use parentheses here, although because this number is a positive number, it won't really change anything. But it's just a good habit to get into, just so you don't make a sign mistake. Let me actually get rid of this, and we'll just evaluate this. So let me bring this up here so we have enough room to work. So I'll go ahead and say this equals the square root of. We know 9 squared is 81, and then minus 8 times 9 is 72, and then minus 9. Well, you could treat this as, again, plus negative and plus negative. Negative 72 plus negative 9, that's going to give you negative 81. So this is plus negative 81, or of course you could say minus 81, whatever you want to do. At the end of the day, this is going to be 0 underneath the square root symbol or for the radicand. So this is going to be equal to 0, right? Square root of 0 is 0. So we're looking for this guy right here. So f of 9 is 0. All right, for question 11, we are asked to find the domain. So we have y is equal to 1 over, we have 10x squared minus 17x and then plus 3. Okay, let me extend that like that. So we know if we're trying to find the domain, it's basically what can I plug in for x? Again, this is always in terms of the real number system. So here we have a fraction. So I'm thinking about division by 0. There's nothing else that would stop me from plugging in something for x. So basically I would say the denominator is 10x squared minus 17x plus 3. So basically just set that equal to 0 and solve. And then whatever you get for the solutions, you want to restrict that from the domain. Let me actually get rid of this. We don't need this anymore. I'm going to come down here so we have a little bit of room to work. Now, I don't know if I can factor this or not, but you probably can. So let's just try it that way first. Of course, you can use the quadratic formula if you want. So for 10, the problem comes from it could be 1 times 10 or it could be 5 times 2. Now, I never start with 1 times 10 or something like that because it's just too extreme. I'm going to start with 5x and 2x. Now, I don't know if this is going to work, but that's what I'm going to start with. 3 is a prime number, so it can only come from 1 times 3. Now, this is a minus and this is a plus. So what does that tell me? It tells me that I have a minus here and a minus here because negative times negative is positive and negative plus negative is negative. So I just have to work out, okay, would I put a 3 here and a 1 here? Does that work? So this would be negative 15x, and then this right here would be negative 2x. Yeah, that actually works. So right off the bat, so negative 15x plus negative 2x would be negative 17x. So this would be good to go. All right, let me get rid of this, and we can just solve this by saying that 5x minus 1 is equal to 0, then or 2x minus 3 is equal to 0. I'm going to get rid of this, and I'm going to add 1 to both sides here and say this is 5x is equal to 1. Divide both sides of the equation by 5. This cancels, and you get x is equal to 1/5. Okay, let me get rid of this, and I'm just going to leave this over here for right now. For this one, let's add 3 to both sides of the equation. Cancel this. You're going to get 2x is equal to 3. Divide both sides by 2. Cancel this. You get x is 3/2. Okay, let me get rid of this, and let's paste this in. Okay, so we have to make sense of this. Again, these values here will make the denominator 0. Division by 0 is undefined. So we will say that the domain is the set of all x such that x is not equal to, we'll put 1/5 and then comma 3/2. So let's look for this. So it looks like this is what we want, right? So the domain is the set of all x such that x is not 1/5 or 3/2. All right, for question 12, we are asked again to find the domain. We have y is equal to x squared over the square root of x minus 3. Okay, in the numerator, there's nothing I can't do. I have x squared. I can plug in whatever I want for x. In the denominator, again, you have to think about division by 0, and then you also have to think about the square root operation. So in the real number system, we cannot take the square root of a negative number, so we want the radicand to be non-negative. So first I would say that x minus 3 needs to be non-negative, so greater than or equal to 0, but combine that with the fact that you're in the denominator, well, I can't actually get 0, right? If I plugged in a 3, because that's going to solve x minus 3 equals 0. If I plugged in a 3 for x, 3 minus 3 is 0. The square root of 0 is 0. And then I have division by 0, which is undefined. So you have to tighten this up and say that x minus 3 needs to be strictly greater than 0. We would just add 3 to both sides of the inequality and get x is greater than 3. So basically, x can be any value that's greater than 3. So we'll say that the domain is the set of all x such that x is greater than 3. Okay, let's put this like this. Let's look for this. So you don't want this one, right? Because x can't be actually equal to 3. So if you said the set of all x such that x is greater than or equal to 3, again, if x was 3, you'd have division by 0, which is not defined. So don't pick this one. You want to pick this one right here. So the domain is the set of all x such that x is strictly greater than 3. All right, for question 13, we are asked to determine if each pair of lines are parallel, perpendicular, or neither. So we have 3x minus 15y is equal to 80. And then I'm going to write this a little bit differently. I'm going to say 9x minus 20y is equal to 100. Okay, let me grab this real quick. Let me paste this in here. Now, when you try to get the slope from an equation, a lot of people will solve for y, but if it's in the form, let me make a little border here, of ax plus by equals c. So basically, you could subtract ax away from each side, cancel that away, and say you have by is equal to negative ax plus c, and then divide everything here by b. And so this cancels, and you would get y is equal to negative a over b times x plus c over b. Okay, let me get rid of this. So if I started with ax plus by equals c, well, then what's going to happen is I'm going to end up with a slope m that's negative a over b and a y-intercept that would occur at 0, c over b. Okay, let me get rid of this. And let me just arrow over here and say m is equal to what? So negative a over b. So what's a here? A is the coefficient of x, so that's 3. So this is negative 3. And then what's b? B is the coefficient of y. So let me go plus negative here. So that would be negative 15. So basically, m, the slope, is negative 3 over negative 15, which would be 1/5. Negative over negative is positive. 3 divided by 3 is 1. 15 divided by 3 is 5. Okay, over here, let's do the same thing. So m is equal to negative a over b. So a here is the coefficient of x, so that's 9. So that would be negative 9. And then b here, let's go plus negative, would be negative 20. Again, that's the coefficient of y. For this one, you really can't do anything to simplify other than to say that it's positive, because if you think about negative over negative, it's positive. But with 9 and 20, the greatest common factor is going to be 1, right? 9 is 3 times 3. 20 is 2 times 2 or 4 times 5. Okay, so we can see that the slope here is 1/5, and the slope here is 9 over 20. So are the slopes the same? No. Are the slopes going to have a product that's going to be -1? No, these guys are not negative reciprocals. So coming back up here, they're not going to be parallel lines because they don't have the same slope, and they're not going to be perpendicular lines because when you multiply the slopes together, you do not get -1. So we will say that they're neither parallel nor perpendicular. All right, let's take a look at question 14. So we're asked to write the equation of the line in standard form and given the following information. So we have a given point, which is -5, 0. And then we're saying it's perpendicular to 15x minus 12y equals -12. Okay, let me actually grab, well, I'll take both of these at the same time. Come down here. So this problem is a little bit of work because you first have to get the slope. So I want to find the slope of this guy, and then I need to have it to where the slope of the line that I'm trying to find times the slope of this guy would give me -1, right? So those guys have to be negative reciprocals. So for this, again, if it's in the form of ax plus by equals c, like we talked about in the last problem, so ax plus by equals c, then the slope, m, is equal to -a over b, right? So here's a, and here's b. Let me go plus negative here. Let me make that actually into a negative. And basically, here you would have m, the slope, being equal to the negative of a, so here a is 15, so -15, over b, b is -12. Okay, so that's all you need. You could also solve this for y if you wanted to. It would be the coefficient of x in that case. All right, let me move this down here. We know that negative over negative is positive, and then 15 divided by 3 would be 5. 12 divided by 3 would be 4. Okay, so we have m, the slope is 5/4. But again, that's not the slope of this line. Okay, these guys are not parallel, they're perpendicular. So basically you have to take this 5/4 and multiply it by some unknown slope. Let's just call it m. That's going to be the slope for the line we're trying to find. That should be equal to -1. A lot of you can eyeball that and say, okay, it's going to be -4/5 because they're negative reciprocals. But again, you can solve this by multiplying both sides by 4/5. So let me do that over here. This would cancel, become 1. So you'd have m is equal to the negative of 4/5. And always a lot of work to set these problems up. So now what do you have? You have a point on the line and the slope. So you would say that y minus y sub 1 is equal to m the slope times the quantity x minus x sub 1. So this is the point slope form. So for y sub 1, we have 0. For x sub 1, we have a -5. So minus a -5 is +5. And then for m the slope, we have a -4/5. Y minus 0 is just y. Get rid of that. And let's get rid of this as well. So you just have to distribute this to each guy here. So this is y is equal to -4/5 x. And then -4/5 times 5. So let me put plus -4/5 times 5. The 5s would cancel. So this is basically -4. So -4. Now, I don't remember if they asked us for slope-intercept form or standard form. And of course, it's asking for standard form. So pay close attention there. Standard form. So looking at this, if you chose this answer down here, y equals -4/5 x minus 4, that's actually going to be wrong because we're asked for standard form, right? The ax plus by equals c. So we need to do a little bit more work here. And I don't know if I can fit this on this page. Maybe I'll go to the next page. Let me paste this in here. What I'm going to do is add 4/5 x to both sides of the equation. Let me cancel this. And let's say that we have 4/5 x plus y is equal to -4. Let me get rid of this. And all you need to do at this point is get rid of this fraction. And I can do that by just multiplying both sides of the equation by 5. So 5 times 4/5 would be 4. So this would be 4x. And then 5 times y would be plus 5y. And this equals -4 times 5 would be -20. So in standard form, you get 4x plus 5y equals -20. Let me paste that in here. So again, 4x plus 5y equals -20. So looking through my choices, I want this one. 4x plus 5y equals -20. All right, for question 15, we are asked to use the vertical line test to determine if each relation is a function. So we have y, or you could put f of x because this is a function. So y is equal to 2/3 x minus 4. So with the vertical line test, essentially you're proving visually that for each x, there's one y. So if I look at this guy here and you think about it with either the equation or the graph, you would clearly see that for each x value, there's one corresponding y value. Now we can make some vertical lines. And we just do that for the sake of the tutorial. Again, if you were to see this graph on your test, you don't need to make any vertical lines. Nothing is going to impact the graph in more than one location. Here it hits once, here it hits once, and here it hits once. It's just a visual inspection to see if you have a function. So here clearly we do. So we would say, yes, this relation is a function. All right, let's take a look at question 16. So here we are asked again to use the vertical line test to determine if each relation is a function. Let me slide down here a little bit. So we're given y cubed is equal to x. So I have a hint here that says solve the equation for y. Well, if this is y cubed and I want y by itself, I would take the cube root of each side. So the cube root of y cubed would be y, and this would be equal to the cube root of x. So you can graph this on Desmos like this or like this. It's the same graph either way. But I like to solve it for y to think about what's going on. Remember, if you have a function, for each x, there's going to be one and only one y value. So is that the case with this guy? Well, if you make some vertical lines over here, let's just say I make one for the sake of the tutorial, you would see that this is only going to impact the graph in one spot. So again, it only impacts the graph in one spot. The problem with this particular equation is that when you get close to an x value of 0, it looks like a vertical line that would basically be x equals 0 would impact the graph in more than one location. That's why I said you really want to think closely about what's going on where x is close to 0. are we getting more than one y value for a given x value? The answer is no. If you plug in a 0 for x, the cube root of 0 is 0. So you're only getting one y value. So for each x, there's one y. And you can see that if you really go closely here, as I pick different values for x, I'm only getting one value for y. So each x corresponds to one and only one value for y. So you draw that piece like that, and then this piece would be like that, okay? So basically, this is going to be a function. For each x, there's one y. I know it's a little bit hard to see on this particular graph, but you can always go to Desmos and just really zoom in and see what's going on. You can also, again, just think about this by saying, okay, if I plugged in a 0 for x, am I going to get one and only one value for y? And the answer is yes. So a vertical line at x equals 0 would not impact that graph in more than one location. So let's come down here and say, yes, this relation is a function. All right, let's take a look at the quiz. For the first question, we're asked to identify the function of the given graph, state the domain and range. So these are graphs that we already seen in the lesson and the practice test. So hopefully you know when you look at this graph at this point that this is the identity function. So this is our f of x is equal to x. It pairs every real number with itself. So you have something like -6, -6, 0, 0, 6, 6. Again, any real number would be paired with itself. So the domain here, the domain is going to be all real numbers. So from -infinity to +infinity. And the range is the same. So it's just all real numbers. So from -infinity to +infinity. So we're looking for f of x equals x. So that's this one right here. And the domain is all real numbers and the range is all real numbers. So this is the one that we want. All right, let's take a look at question 2. So it says, identify the function of the given graph, state the domain and range. So looking at this, hopefully you remember from the lesson that this is the graph of f of x is equal to 1 over x. This is known as the reciprocal function. So it's going to pair every real number with its reciprocal. So some points that you can look at, and these are kind of hard to see here. You might want to go to Desmos if that makes it a little bit easier for you. But let's just say x and y here. So something like, let's say 1/2 for x. Well, 1 over 1/2 is going to be 2. So you're taking the reciprocal of this, the reciprocal of 1/2 is 2. If we look at something like 1, the reciprocal of that is 1. If you look at something like, let's say 2, well, the reciprocal of that is 1/2. And then you could just match these up over here. You're just working with negatives now. So something like -1/2 for x, that would be -2 for y. Then something like -1 for x, that would be -1 for y. And then something like -2 for x, that would be -1/2 for y. So those would be the points that we've shown here. I'm just going to get rid of this real quick, just so I have room for the domain and range. For this one, remember, you can't divide by 0. That's going to be undefined. So you just want to exclude 0. You want to say that for the domain, you're going to put from -infinity going up to and excluding 0. And then you'll use your union notation. So then we'll say from 0 out to +infinity. So 0 is excluded. That's why you have this open notation here, or the parenthesis here and the parenthesis here. So 0 is not included. In terms of the range, it's going to be the same thing. So for the range, we're just going to have, again, from -infinity going up to and excluding 0, and then union with anything that's larger than 0. So it won't be included. This is f of x equals 1 over x, and the domain is all real numbers except for 0 here, and the range is all real numbers except for 0 here. So that's exactly what we want, this guy right here. All right, for question 3, we want to identify the function of the given graph, state the domain and range. So looking at this, it should be obvious at this point because we've done it again in the lesson and the practice test. This is your square root function. So this is your f of x is equal to the square root of x. So something like the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. So that's where you're getting those points from. Again, I can do a t-table here if you need that. So let's go 0, 0. We have 1, 1. We have 4, 2. And we have 9, 3. So that's where those points are coming from. So again, that's going to give you that general shape right there. Now, when we think about the domain and range, remember that in terms of the domain, it's always we're thinking about the real number system. So in the real number system, we cannot take the square root of a negative number. So we want to say that this is going to be from 0 and including 0. I can take the square root of 0, that's 0, going out to +infinity. And then in terms of the range, it's going to be the same thing because if I take the square root of 0, I get 0. If I take the square root of a positive number, I get a positive number, and I can make this as large of a positive number as I want. So this right here would be from 0 and including 0 going out to positive infinity. Okay, so looking through the choices, we see that this one and this one, they're each f of x equals the square root of x. Looking at the range here, this would be wrong. So this range here says it goes from negative infinity to 0, and then a union with 0 to positive infinity. So this one says that it's all real numbers except for 0. This one would be wrong. I'm just going to mark it out. This one right here is f of x equals the square root of x. The domain is from 0 and including 0, going out to positive infinity, and the range is from 0, including 0, going out to positive infinity. This is the one you want. Okay, so you don't want this one, you want this one. All right, for question 4, we are asked to identify the function of the given graph, state the domain, and range. Let me come down here. So of course, this is our f of x equals x squared, or the squaring function. This is a parabola shape. It's our basic parabola. So f of x equals x squared. This is going to pair every real number with its square. So some basic points here. Again, you could do the t-table if you want. I think I'll just skip it for this one. So you have something like negative 3, 9. You have something like negative 2, 4. You have negative 1, 1, 0, 0, 1, 1, 2, 4, and then you have 3, 9. Now, when we think about the domain of this guy, remember, you can plug in anything you want for x and square it. You can plug in a negative, 0, or a positive. So this is going to be all real numbers from negative infinity to positive infinity. And then in terms of the range, so this is our range. This is not going to be all real numbers, because when you square something, you get a result that's non-negative. If you square a negative, you get a positive. If you square 0, you get 0. If you square a positive, you get a positive. So this will be from 0 and including 0 going out to positive infinity. And when you look at the graph, again, you can see that the smallest y value would be 0, and this goes up to positive infinity. So we are seeing right here, f of x equals x squared, with a domain that's all real numbers and a range that's from 0 and including 0 going out to positive infinity. So this is the one that we want. All right, for question 5, we want to identify the function of the given graph, state the domain, and range. All right, so looking at this, you should know this is our cubing function. So f of x is equal to x cubed. So every real number is paired with its cube. So something like, let's say negative 2. If I plug that in for x, I'm going to get negative 8 for y. Negative 2 cubed is negative 8. So this is 2 units to the left, 8 units down. Then something like negative 1, negative 1. Something like 0, 0, although it's not shown. Something like 1, 1. Something like 2, 8. Again, as you get bigger numbers for x, let's say you picked 3, well, now the y value is really big. It's 27. So that's pretty hard to do on a hand-drawn graph. Again, if you're using graphing software like Desmos or something like that, you can do those points as well. So I'm just going to say here that the domain, of course, we can plug in whatever we want. So it's just all real numbers. So from negative infinity to positive infinity. And then for the range, it's going to be the same as well. Because I can plug in whatever I want for x, a negative, 0, a positive, I can make this from negative infinity to positive infinity. So let me go ahead and put that in. It's just all real numbers as well. That could be better. So let me fix that. So I'm looking for f of x equals x cubed, so that guy right there. Again, the domain is all real numbers and the range is all real numbers, so this is the one that we want. All right, let's take a look at the quiz. For the first question, we're asked to find f of negative 5, and this notation here, I had to write it that way because of the limitations of the Udemy platform. Essentially, what it would look like is f of x is equal to, you would have this right here, and you would say negative 2x plus 3, and then you could say if x is less than or equal to 0, and then x squared minus 1 if x is greater than 0. Well, in this case, we have f of negative 5. Negative 5 is going to fall in the category where x is less than or equal to 0, so we want to use this rule right here. So we're going to say f of negative 5 is equal to negative 2, and you're going to plug in for x, you're going to plug in that negative 5, and then plus 3. Well, negative 2 times negative 5 is positive 10, so you have 10 plus 3, which is 13. So f of negative 5 is this one right here, positive 13. You don't want this one that's negative 13, you want positive 13. So this is the correct answer. All right, for question 2, we're asked to find f of 0. So we have f of x is equal to, again, because of the limitations of Udemy, I had to write it this way. Let me make this actually a little bit longer, like that, so it all fits. So you have x cubed minus 1, and this is if x is less than or equal to negative 3. Then you have only 1, just 1, if x is greater than negative 3, that's strictly greater than, and less than or equal to positive 3. And then we have negative x if you have x where it's greater than 3. Okay, so here we have f of 0. So where is 0? 0 is going to fall into this case right here. 0 is greater than negative 3 and less than or equal to positive 3. So we just want to say it's 1. That's all it is. So f of 0 would just be 1. All right, let's take a look at question 3. So we're looking at the greatest integer function, and we want to find f of negative 2.7. So remember, for the greatest integer function, it's going to pair every real number x with the greatest integer less than or equal to x. So if you plug in an integer, something like, let's say, negative 2, you're going to get negative 2 back. But if you plug in something like negative 2.7, you're looking for the integer moving to the left on the number line. So let me actually paste this in so this is clear. Let me put this, I guess, right here. It's going to be on top of everything. But we want f of negative 2.7. So let's say that that is about right there. Doesn't have to be perfect. Again, you can just draw a little sample number line and say this is negative 2.7. Again, in terms of what I'm trying to do, I'm trying to go to the left to the nearest integer. So the nearest integer, if I'm going to the left, I'm trying to go down. That's going to be negative 3. Okay, so f of negative 2.7 would be negative 3. Let me actually delete this. It's going to be in the way. Get rid of this. And so you want this one. F of negative 2.7 is equal to negative 3. Okay, let's take a look at question 4. So we want to use the graph to determine the rule for each interval of the piecewise-defined function. All right, let's slide down here a little bit. Let's start with this piece in green. So I just want you to pretend when you look at something like this as if this was a full line. So if this continued this way, what would we have? Well, right here at an x value of 0, the y value would be negative 3. Now again, because you have an open circle there, the x value of 0 is not included. So this right here specifically would be for x values that are less than 0. So just keep that in mind. So just pretend again that you had a full line there. What would the equation be? Well, the y-intercept would occur at 0, negative 3. So let's put y-intercept. This is 0, negative 3. And then what is m, the slope? Well, if we look at any 2 points, you can go this way or this way, it doesn't matter. Let's just start here and go down 1, 2, 3, and then go to the left 1, 2. So that's negative 3 over negative 2, which is 3/2. So m, your slope, is going to be 3/2. Okay, so putting this together, just using slope-intercept form, that is y is equal to m, the slope, that's 3/2, times x, and then minus 3. Again, that y-coordinate from the y-intercept, if we had it. In this case, we don't, but if we had it, it would be there. So this is what we're going to use. And you can change y to f of x if you want. That's up to you. So f of x equals 3/2 x minus 3. And this is specifically, let me put a little comma here. This is specifically for where x is less than 0. If x is 0, so right there, or anything to the right of 0, we're going to have a different rule. And that rule is going to be this guy right here. Now this one is a little bit easier to figure out. If you notice, you have the points 0, 0, 1, 1. This is 4, 2. This is 9, 3. So obviously this is the square root function. This right here would be f of x is equal to the square root of x. Let me make this x better. And of course, this is where x is greater than or equal to 0. Even if we weren't working with a piecewise-defined function, we would know that because in the real number system, we're not going to take the square root of a negative. All right, let me go ahead and grab these two things. And let me paste this in here. And I'm just going to write this using my notation. So f of x is equal to, let me make one big bracket here. And let me try that again, like that. So we're going to say that it is the square root of x if x is greater than or equal to 0. Let's make that better. And then we're going to say that it's 3/2 times x minus 3 if x is less than 0. So this is how you would want to set that up. Again, if you got this, you could easily create the two graphs that we just saw. So let's look through and see if we can get a solution. It looks like it's going to be this first one. So f of x equals, you can have the square root of x if x is greater than or equal to 0. And then it would be 3/2 x minus 3 if x is less than 0. All right, for question 5, we want to use the graph to determine the rule for each interval of the piecewise-defined function. Looking at the graph, I'm just going to start with this piece right here. So you'll see the x value there is negative 2. And this point right here is going to be included. So negative 2 as an x value would be included. And then anything going to the left down to negative infinity. So let's say for this part right here, x is less than or equal to negative 2. Now, how do you figure out this guy right here? A lot of you can eyeball that and see it's y equals negative x, but if you can't, you could look at the slope of this guy. So you're going from this point to this point, you're going down 1, 2 to the right 1, 2. So that means the slope, if you have negative 2 over 2, that's negative 1. So m, the slope, is negative 1, and the y-intercept, again, just following that thought process, if I go down 1, 2, I go to the right 1, 2. So we know that would occur at 0, 0. Okay, so in slope-intercept form, this is y equals, the slope is negative 1, so just put negative x, and then plus 0, so you can just leave that off. So when x is less than or equal to negative 2, you get y equals negative x. Let me put this like this. Actually, I'll just take this down here to the answer page because I want to build up a formal answer. So let's say f of x is equal to, I'll put this in like this. So let's go negative x, and we'll put if x is less than or equal to negative 2. We'll just erase this. It's just scratch work. We'll go back up, and let's think about this piece right here. So this one's really simple. You see that an x value of negative 2 is not included. Again, that's why you have the open circle. And then here at 0, the x value, that's not included. That's why you have the open circle. So where x is greater than negative 2 and less than 0, well, we have a constant y value of 1, right? So it's always 1. So you could just say y is equal to 1. Let me grab this and come down here, and I'll just write 1. So we'll say if x is strictly greater than negative 2 and less than 0. Okay, so there's one more part. Let's go back up, and that's going to be for this right here. Again, you can eyeball that and see it's y equals x. You have 0, 0, you have 2, 2, you have 4, 4, so on and so forth. But again, if you don't know that, again, you can use the fact that the slope is 1 and the y-intercept is 0, 0, so you get y equals x for your line. So let's go ahead and say that if x is greater than or equal to 0, we get y is equal to x. Let's grab this, and I'm just going to put x if x is greater than or equal to 0. So in terms of what we're looking for, it's going to be this one right here. So your f of x is going to be x if x is greater than or equal to 0. It's going to be 1 if x is greater than negative 2 and less than 0. And it's going to be negative x if x is less than or equal to negative 2. All right, let's take a look at the quiz. For the first question, we're asked to use the graph to find the intervals on which the function is increasing, decreasing, or constant. So again, if you look at this guy, coming from an x value of negative infinity, going to an x value of 0, this guy is decreasing. Again, if you need to, you can always draw the stick figure in and think about, okay, he's walking down. So the y values are decreasing as the x values are increasing, again, from negative infinity to 0. So I'm just going to put decreasing on negative infinity, and then going to 0. Again, nothing's going to be included here. So you have a parenthesis here and then here. And then you're increasing from 0 out to positive infinity. So we're going to put increasing on, and we're going to go 0 to positive infinity. Again, nothing's included. You can always draw this stick figure in if you need him. He is going up. So looking through the choices, this is the one you want. Decreasing on, you have from negative infinity to 0, again, both being excluded. And then increasing on 0 to positive infinity, both being excluded. All right, for question 2, we are asked to use the graph to find the intervals on which the function is increasing, decreasing, or constant. So we're looking at the x values, again, moving from left to right. And again, coming from negative infinity, going to an x value of 3, we're going to be decreasing here. So let me put decreasing on. So this is from negative infinity to positive 3. Neither one's going to be included when we do this. Again, if you need to, you can always draw your stick figure in to help you out. And then from 3 out to positive infinity, we're going to be increasing. The y values are getting larger. So you can do this with your stick figure. He's walking up. So let's say that we're increasing on. So we'll have from 3 out to positive infinity. Again, nothing's included here. So let me grab this and let me come back here. So we have decreasing on negative infinity to 3, and then increasing on 3 to positive infinity. This is the one that we want. All right, let's take a look at question 3. So we want to use the graph to find intervals on which the function is increasing, decreasing, or constant. So this guy right here, I think you know from the lesson that it's always increasing. Again, you could just draw a stick figure here and think about him walking. Again, as the x values go from left to right, well, he's always going to be walking up. Here he would have a little bit of a turn, but this is always increasing throughout the entire domain here. So you would say that it's increasing on. You would go negative infinity to positive infinity. So let's paste that in, and this is the one you want. So increasing on from negative infinity to positive infinity. All right, for question 4, we're asked to use the graph to find the intervals on which the function is increasing, decreasing, or constant. So looking at this again, going left to right in terms of the x values, you'll notice that this guy is increasing until we get to an x value of 5. Let me arrow to that and say that's 5. Again, you can always put in the stick figure and think about him walking. He's going up. Then when you get to an x value of 5, this guy's going to be decreasing until you get to an x value of, let's just put 7. Let me erase this and put a 5 here and put a 7 here so that's more clear. So this guy at this point would be walking down. Then after 7, going out to positive infinity, he's walking up again. So this is increasing once again. Maybe the legs could be better. So he's going to go this way. He's going to go that way. Okay, so let's put that we're increasing on. So this interval here would be from negative infinity going up to positive 5. Again, nothing's going to be included. The common mistake here is to put a union in. Again, we're asking for the intervals. Okay, so this is an interval here. And then the other interval would be 7 to positive infinity. So don't join that with a union symbol. And we'll say 7 out to positive infinity. Maybe that infinity symbol could be better there. And then we have decreasing. So decreasing on. And that's just going to be this here. So from 5 to 7. So 5 to 7. So from negative infinity to 5, we're increasing. This guy's walking up. The y values are getting larger. Then from 5 to 7, the y values are getting smaller. So this guy's walking down. Again, the function's decreasing. And then from 7 out to positive infinity, this guy's walking up. The y values are getting larger. So it's increasing. And we'll paste this in here. So what we see is this one right here is increasing on from negative infinity to 5, and then from 7 to positive infinity, and then decreasing on between 5 and 7. So this guy right there. All right, for question 5, we're asked to use the graph to find the intervals on which the function is increasing, decreasing, or constant. All right, this one has a lot of stuff going on. You're going to notice that this guy right here is decreasing until you get to this x value right here. Let me arrow to it, is negative 7. So then you'd be increasing until you get to this x value right here, which you could write in as negative 1. Then you're decreasing until you get this x value of 2. Then you're constant until you get to this x value of 5. And then you're increasing out to positive infinity. Let me put in my little stick figure in each case. So here you're walking down, so you're decreasing. And then that's going to happen again right here. Put in my stick figure going down. So let's start with decreasing on. So this interval here is from negative infinity going to negative 7. Again, nothing's included. And then I don't want a union symbol. I'm going to put and, or you could just put a comma, whatever you want there. You're going to have, this is an x value of negative 1. This is an x value of 2. So between negative 1 and 2. Again, nothing's included. Then you have increasing. So increasing on. This could be better. Let me change my color. So now this is going up in terms of the y values. So you could put in, and that color is not going to work too well. Let me put in this color here. You can put in your stick figure, and he's walking up. And again, right here, he is also walking up like that. So this interval right here would be negative 7 to negative 1. So negative 7 to negative 1. So between those values, we're increasing in terms of the y values. And then again, you would use the keyword and, don't use a union symbol. You would have this part right here. So 5 out to positive infinity. So that's what you want there for increasing. Now you do have an interval where things are constant. So I will write constant on. Let me slide down a little bit. So this is between 2 and 5. 2 and 5. And let me draw my little guy in there, just walking flat. He's just going straight. So if we think about it again, the decreasing intervals, you have between negative infinity and negative 7. So again, the x value there is negative 7. Then you also have between negative 1 and 2. That's why we have this decreasing on, again, from negative infinity to negative 7, and then from negative 1 to 2. Then increasing on, you have from negative 7 to negative 1. This guy's going up. Then 5 right here to positive infinity. So this guy's going up. And then constant on, you have between 2 and 5. So that guy right there. So let me go ahead and grab this. Well, this is the only one that mentions constant, so I know that's going to be the right one. But let's go ahead and check it. So we're going to start with increasing on. You have this interval between -7 and -1, and then 5 and infinity. So that's this guy right here. And then decreasing on, you have from -infinity to -7 and -1 to 2. Again, nothing's included here. And then constant on, you have this interval from 2 to 5. Again, nothing's included. So this is the answer that we want. All right, let's take a look at the quiz. So for the first question, we're asked to transform f of x as described to find g of x. And so we have f of x is equal to x squared. So just the squaring function. We're going to vertically stretch by a factor of 5. So remember, your g of x here would just be equal to 5 times f of x. And so 5 times f of x, that would just be 5x squared. So in other words, you could say g of x is equal to 5x squared. So looking through my choices, it's just going to be this one right here. So g of x is equal to 5x squared. All right, let's take a look at question 2. So once again, we want to transform f of x as described to find g of x. So f of x is the cube root function. So this equals the cube root of x. So we're told here to horizontally compress by a factor of 3. So let's say that g of x would be equal to f of 3x. And so g of x would be equal to the cube root of 3x. So that's really all it is. So I'm looking for g of x is equal to the cube root of 3x. So that one right there. All right, for question 3, we are asked, how does g of x compare to the function f of x? And we have f of x is equal to 2 minus x cubed. And then for g of x, we're given that it's f of 3x. So again, this is on the inside. When we think about the inside, we have to undo what's being done to x. How do I undo multiplication by 3? Well, I can divide by 3 or multiply by a third. So that's giving me a horizontal compression, and you can say by a factor of 3. Some people would also say it's a horizontal shrink by a factor of a third. So whatever terminology you want to use, here we're on a multiple choice test, so we have to match what's given. So we want to say horizontally compressed by a factor of 3. All right, for question 4. We are asked, how does g of x compare to the function f of x? And then for f of x, we are given x cubed minus 2x. And then for g of x, we are given 1/3. That 3 is terrible. Let me fix that. And then times f of x. Well, this right here, you're multiplying your y values by a third. In other words, for a given x value, the y value will now be divided by 3 or multiplied by a third. That's going to give you a vertical compression by a factor of 3, or again, if you want to say a vertical shrink by a factor of a third, that's fine as well. But again, we've got to match what's given to us on the test here. So we're going to say that it's vertically compressed by a factor of 3. All right, let's take a look at question 5. So it says, based on the original function f of x, for a given y value, how could we obtain the x values for the function g of x? So you see we're given that f of x is equal to x cubed and then minus 5x. And then for g of x, this is equal to f of 5x. So this guy right here, because it's on the inside, again, you have to undo what's being done to x. 5 is multiplying x. To undo that, you would divide by 5, or you could multiply by a fifth. So that's giving me a horizontal compression by a factor of 5. Let me write that out. So there's a horizontal compression by a factor of 5. So what that means is that for a given y value, the x value would need to be divided by 5 or multiplied by a fifth. So here it says, again, for a given y value, how could we obtain the x values for the function g of x? Well, you would need to multiply the x values by a fifth. So this is what you're looking for right there. For a given x comma y in f of x, the x comma y in g of x can be found as 1/5 times x comma y. So that's what you want. Let me circle this one right here. All right, let's take a look at the quiz. For the first question, we have f of x equals x squared and g of x equals negative 5x squared. So the question is, how could we graph g of x based on the graph of f of x? So really, if you think about g of x, it's equal to negative 5 times f of x. And if you want to break this up like we did in the practice test, you can, but I think at this point you probably can get it with just looking at it this way. The 5 that's multiplying your function f of x, that's giving you a vertical stretch by a factor of 5. And the negative out in front, that's reflecting across the x-axis. So what you want to look for is a vertical stretch by a factor of 5. So let me see. So you do have that here. Let me see. You also have that here. And then you want to look for a reflection across the x-axis. This one says y-axis, so that would be wrong. So this is what you want. This guy right here. Again, if you need to go to Desmos and type these things in, you could do h of x as being 5 times f of x. That's giving you your vertical stretch by a factor of 5. And then you could do your g of x as being the negative of h of x, and that's going to reflect across the x-axis. All right, for question 2, we have f of x equals x cubed minus x squared minus x, and then g of x equals f of negative 3x. Let me write this out so it's crystal clear. So f of x equals x cubed minus x squared minus x, and then we have g of x is equal to f of negative 3x. Again, if you want to break this up into 2 different steps, you can, but I think we can get it. So forget about the negative for a moment. The 3 on the inside that's multiplying x, you need to undo that. So to undo multiplication by 3, you can divide by 3 or multiply by a third. So if I'm dividing by 3, that's a horizontal compression by a factor of 3. Some people will say it's a horizontal shrink by a factor of a third, but we have to go with the way the answers are given. So let's go with a horizontal compression by a factor of 3. So we have that here, and then we don't have that anywhere else. So we know this is going to be the answer. The negative on the inside, again, that's going to reflect across the y-axis. So this right here is the answer. So horizontally compress f of x by a factor of 3, then reflect the graph across the y-axis. Let me erase this and just circle this as the answer that we want. All right, for question 3, we have f of x equals the square root of x, and g of x equals f of negative 7x. Let me write this out. So f of x equals the square root of x, and then g of x is equal to f of negative 7x. A given point x comma y on the graph of f of x will be located where on the graph of g of x? Well, what you have here is you have to undo this right here. So this negative 7 that's multiplying x, so how would you do that? Well, you would multiply by negative 1/7. In other words, for a given y value, the x value needs to be multiplied by negative 1/7. So let's look through here and look for the same y value. So you have that right there. See how y is unchanged? And the x value is being multiplied by negative 1/7. That's going to undo this right here and give me back to x. So that's what I want. So this right here, again, when you get a problem like that and it's on the inside, just say, how can I undo what's being done to x? Well, negative 7 times negative 1/7, that's going to be 1, and 1 times x is just x. So for a given y value, I now need to multiply the x value by negative 1/7 to get that. So this is the answer that you want. All right, for question 4, we have f of x is equal to x cubed minus x. It says find the function g of x that is obtained from the following transformations. Number 1, vertically stretched by a factor of 3. So since we're going to get the g of x in the end, let's just use h of x. Again, you don't have to do this, but I'm just going to do this one step at a time. Vertically stretched by a factor of 3, that is the same thing as 3 times your function f of x. In other words, you could say this is 3 times this right here. So this quantity, x cubed minus x, which is going to give me 3x cubed minus 3x. So that is what happens when you vertically stretch by a factor of 3. So let me move this up here. Now, the second thing it tells us is that it's reflected across the y-axis. So that means you're going to replace x with negative x. So for g of x, this is equal to h of negative x. So this is your h of x here. All you're going to do is you're going to plug in a negative x everywhere there's an x. So you would have 3 times negative x cubed, and then minus 3 times negative x. And so this would be equal to, this negative here, if it's cubed, would still be a negative. If you need to, you could write that as negative 1 being cubed, which is negative 1. So of course, this becomes negative 3 and then x cubed. This right here, you could write as plus negative. Negative 3 times negative x is plus 3x. So that's all it is. You can get rid of this middle step now. You have what you need. So this is your g of x. Let's move this up here. So g of x would be equal to negative 3x cubed plus 3x. So it's not this one, but it's this one. So again, g of x is equal to negative 3x cubed plus 3x. Okay, for question 5, we are given this graph. So in orange, we have f of x. Of course, this is the square root function. You'll notice this is 0, 0, 1, 1. This is 4, 2, 9, 3, so on and so forth. This right here is f of x is equal to the square root of x. And what we need to do is figure out this g of x guy here. It says G of x is the function in light blue, f of x is the function in orange. What is g of x in terms of f of x? And I have a Desmos link here if you're having trouble with that graph. Sometimes on the Udemy platform, when you click on that guy, it just becomes very, very big and you can't control the size. So just go to Desmos if you're having trouble with it. This right here, I could just take this point, just as an example. This is 9, 3. So 9, 3. Well, I notice that this is over here as -9, -3. So this is -9, -3. So how can I go from here to here? Well, I could reflect across the y-axis if I wanted to, and then reflect across the x-axis. So in other words, I could say that I had a function, let's call it h of x, which is equal to, if I want to reflect across the y-axis, well, what I could do is say that I'm going to have f of -x. So you would have this point right here reflecting over here. So now this would be -9, +3. So in other words, for a given y value like 3, the x value is now its opposite. That would end up being h of x being the square root of -x. Now, when you look at g of x, so g of x, now we're reflecting from here going down to here. So we're reflecting across the x-axis. So all this is we're saying it's the negative of h of x. So g of x is really the negative of the square root of -x. So that's all it is. You're going to reflect across the y-axis and then the x-axis. So the negative of the square root of -x. So let's come down and look for g of x is equal to the negative of f of -x. And that's exactly what you want. All right, let's take a look at the quiz. For the first question, we are asked to determine if the function is even, odd, or neither. So let's write out that we have f of x is equal to x cubed and then times the square root of x plus 3. So first let's check and see if it's even. So if it's even, we can do f of -x and we'll get the same thing as f of x. Of course, you can eyeball this and see that it's not going to work out that way, because when you plug something in here, again, if this exponent is odd, well, you know you're going to get the opposite sign. Because if I said that this is -x being cubed, well, really, this becomes -1 cubed, which is -1, times x cubed, which is just x cubed. So this becomes, you can just say, -x cubed like that. Then times the square root of, this is going to get replaced with -x, and then plus 3. So this is not a match with this. That's obvious, so it's not an even function. So you could mark that out. The next thing is you would check to see if it's odd. So if it's odd, well, then you do the negative of f of x, and you see if it matches with f of -x. So this would be equal to, you just put a negative out in front of this. So this is -x cubed times the square root of x plus 3. This and this do not match, right? Here, this part matches, but inside, this doesn't match. So in other words, the radicand here is going to be your -x plus 3. The radicand here is x plus 3. That does not match. So f of -x is not the same as the negative of f of x. So this function is definitely not odd. Again, we're going to conclude that this function is neither even nor odd. All right, for question 2, we are asked to determine if the function is even, odd, or neither. So we have f of x is equal to, this right here is going to be x over, we're going to have x squared minus 1. Okay, so we know already, again, if this exponent is a 1 and this exponent is a 2, you're going to have a sign change here, but no sign change here if you do f of -x. So f of -x would be equal to, again, this would be -x, so the sign is changing. Here, if you had -x being squared, again, that's just x squared, and then minus 1. What I would do is bring this out in front, like this, and let me see if I can get this to line up better. Of course, I grab both of them, so let me write it again as negative, and then you have x over x squared minus 1. So obviously, these don't match, so the function is not going to be even, but if you looked at the negative of f of x, you're going to see they do match. In other words, you just put a negative out in front here. So this is the negative of, you can get rid of that. And this is just x over x squared minus 1. So this matches this. So f of -x is the same as the negative of f of x. So we can say this function is odd. All right, for question 3, we are asked to determine if each function is even, odd, or neither. So we are given f of x is equal to, we have 2x over, this right here is going to be the absolute value of x. So this one, immediately you should be thinking that it's going to be odd. The reason is if you replace this with -x, so in other words, if you go f of -x here, this is going to be a sign change. So this would be -2x up here. But down here, it's not going to change. This would still be the absolute value of x, because again, if you had the absolute value of negative x, you could say this is the absolute value of negative 1 times the absolute value of x. You can legally break that up. So this would be equal to, the absolute value of negative 1 is 1, so you don't have to write that. And so you would just have the absolute value of x. So this isn't going to change at all. So let me get rid of this right here. And so basically, if you looked at this and this, again, they're not going to match, but you are going to have a match if you look at the negative of f of x and f of negative x, because you just put a negative out in front. So this is the negative of 2x over the absolute value of x like that. You can move this down here like that if you want. Let me see if I can line this up. I can never grab these things together. So let me just erase it and redo it. So let me put a negative of 2x over the absolute value of x like that. So this guy matches this guy. Again, f of negative x is the same as negative of f of x. So this is an odd function. All right, for question 4, we are asked to determine if each function is even, odd, or neither. So we have f of x is equal to 4x to the power of 2/3. Now with the fractional exponents, it's a little bit tricky. You might want to write it in a different way. You could put this as x to the 1/3 power like this, and then square it like that. You could do that. And I think it'd be a little bit easier to work with it in that form. So let's say that we want f of negative x here. So this would be 4, and then you're plugging in a negative, let's just go ahead and say it's negative 1 raised to the 1/3 power. Let me move this 4 out here. And let me put some brackets, and maybe we don't need the multiplication sign. So this would be squared, and then you would have, you can just say it's x to the 2/3 power. You don't need to do anything else there. And then basically you're just thinking about what is the result of this? Well, negative 1 to the 1/3 power, remember that's the cube root of negative 1, which is negative 1. But then that's going to be squared. So again, this right here, it really wouldn't matter if it's negative 1 or positive 1. When you square that, you're going to get 1, right? So if you square negative 1, you get 1. If you square positive 1, you get 1. So we know the result of this is 1. So really what you end up with is you could say that this becomes 4 times, you could write 1 if you want, but really it's just x to the 2/3 power. So this right here, this f of x is the same as f of negative x. In each case, it's 4x to the 2/3 power. So you could say this function is even. All right, for question 5, again, we want to determine if each function is even, odd, or neither. We are given f of x is equal to the quantity x minus 5 squared plus 7. So this right here, what I would do before I do any plugging in, I would expand this. Again, remember, you have to use your formula here. You cannot say this is x squared minus 25. That's incorrect. A lot of people make that mistake in this section. You have to remember that this is x squared minus 2 times this times this. So 2 times 5 is 10. So that would be 10 and then times x, and then plus this guy squared, which is 25. So then you have plus 7. So if you do 25 plus 7, that is going to give you 32. So let me put 32 here. So you can really erase this right here and just drag this up here. That makes it a little bit easier because otherwise you might make a mistake. So if you look at f of negative x, well, again, the sign here is not going to change. This would still be x squared. The sign here will change, right? Because you'd have negative 10 times negative x. You might as well just say that's plus 10x now, and then plus 32. So this does not match this. So the function is definitely not even. If you want to think about if it's odd, again, you could factor out a negative if you want. I like to do it the other way. So the negative of f of x is equal to, just put a negative out in front of this. So the negative of x squared minus 10x plus 32. Obviously, this is not going to match this. This would be negative x squared plus 10x minus 32. Again, if you want to, you can get rid of this and move it up here so it's easier to see. But you can see that, first and foremost, the f of x does not match f of negative x. So the function is not even. And then f of negative x does not match negative f of x. So the function is not odd. So really what we find, let me get rid of all this, is that this is the answer we want. This function is neither even nor odd. All right, let's take a look at the quiz. For the first question, we're asked to describe the shift of g of x based on the parent function f of x. So we have f of x is equal to x squared. And then we have g of x is equal to, you have this quantity x minus 5 squared, and then minus 3. Okay, so when we think about this again on the inside, you want to undo what's being done to x. So you have minus 5 there. So you're going to need to do plus 5. That's going to shift me to the right by 5 units. So let's see, we have shifted right 5, and we have shifted right 5. The other two are going to be out. Then when you think about this minus 3, This on the outside is very straightforward. That's just going to shift me down 3 units. So this says down 3 units, this says up 3 units. So this is the one that you want. So based on the graph of f of x, g of x is shifted right 5 units, again, because you have that minus 5 there and you need to undo that, and down 3 units, that's coming from that minus 3 there on the outside. All right, for question 2, we are again asked to describe the shift of g of x based on the parent function f of x. So we have our f of x is equal to x cubed, and then we have our g of x is equal to, we're going to have this quantity x plus 11 cubed, and then plus 12. Again, very straightforward here. You want to undo what's being done to x on the inside. So if you have that plus 11 there, to undo that, you need to subtract away 11. And so that's going to shift me to the left 11 units. So let's see. This one says shifted left 11 units. None of the other ones say that, so we know that's the answer. This plus 12 on the outside, again, this is just shifting me up by 12 units. So this is the answer we want. So based on the graph of f of x, g of x is shifted left 11 units. So again, that's coming from undoing this plus 11 here. And then up 12 units, that's coming from this plus 12 right here. All right, for question 3, we are asked to describe the shift of g of x based on the parent function f of x. So we have f of x is equal to, you have your cube root of x, and then you have g of x is equal to, you have your cube root of x plus 7, and then minus 8. Okay, so looking at this guy, again, you want to think about what's being done to x on the inside. I am adding 7 to x. So to undo that, I need to subtract away 7. So that's going to give me a shift to the left 7 units. So you see here it says shifted left 7 units, and none of the other ones say that, so I know that's the right answer. When I think about this minus 8, again, this is on the outside. It's very straightforward. This is just shifting me down by 8 units. So this is the one we want right here. So we're going to say that based on the graph of f of x, g of x is shifted left 7 units. Again, that's coming from undoing this plus 7 here on the inside, and then down 8 units, that's coming from this minus 8 right here on the outside. All right, for question 4, we're told given the original function f of x equals the absolute value of x, the graph below of g of x was sketched by applying a horizontal and vertical shift. Find the correct function g of x that matches the given graph below. So all I would do here is just make a rough sketch of the basic absolute value function. So you can just start with this point right here, which is 0, 0. You could do something like 4, 4, and let's do negative 4, 4 like that. And I'm just going to draw that V shape in there real quick. So something like that. It's not perfect, hand-drawn graph, but you get the idea. So let's label this and say this is f of x equals the absolute value of x. Let's just take this point right here, which is given to us as 1, negative 4. So 1, negative 4. We know that this guy is coming from this guy right here, which is 0, 0. So this right here, and that's a terrible color. So let me update that with this. This right here, this is 0, 0. So look at the x value here and here. It's been increased by 1, and the y value has been decreased by 4. So that tells me that for this guy, g of x, it's equal to, again, if the x value has been increased by 1, that means that I need to do x minus 1 on the inside. Again, because the shift is going to undo what was done to x. Here you need x minus 1 because to undo that, you want to add 1, which is going to shift me to the right by 1 unit. So this 0 for the x coordinate here is going to become 1. I'm going to go right by 1 unit. And then you think about the fact that you're going to subtract away 4. You do that on the outside. So this is the function that you would want. Again, you could match up some of these points. Say this point right here, which is 4, 4. If you think about shifting to the right by 1, you're going to go right here where the x value would be 5. And then if you shift down by 4, you're going to come down here to this point right there. And so this point is going to be 5, 0. So this is 5, 0. And again, that's just me shifting to the right by 1 unit and then down 4 units. Again, you can always go to Desmos and key these in if you want and just play around with some of the points, but you're going to have a shift that's going to be 1 unit to the right and 4 units down. Now it doesn't ask us for that, so I'm not going to write it down, but basically I'm just going to copy this, come down here and paste this in, and look for a match here. So we want g of x to be equal to the absolute value of x minus 1 and then minus 4. So this is the one that we want. All right, for question 5, it says, given the original function, f of x equals x squared, the graph below of g of x was sketched by applying a horizontal and vertical shift. Find the correct function g of x that matches the given graph below. Okay, so again, this is not that bad. Just think about your squaring function. You can just get a few basic points. So you have 0, 0, you have 1, 1, you have 2, 4, you have 3, 9. Let me see if I can line that up. So that's going to be right there. And then you have negative 1, 1, you have negative 2, 4. Then you have negative 3, 9. So that's going to be right there. Again, I'm not really good at drawing, but I'll do my best. Let me say we do this piece like that. And this would look something like that. Something like that. Again, not perfect. You can go to Desmos if you want something computer generated. For right now, we're just trying to label this one. Let me put that this one is f of x is equal to x squared. And for this one, again, if you just look at this point right here, which is well known, this is 0, 0, well, where does it go to here? Well, basically, you've gone 6 units to the right and 1 unit up. So this right here is going to be 6, 1. Again, if I'm adding 6 to my x coordinate, that had to be undoing something when I had my function set up. So this g of x is equal to the quantity. It's not going to be x plus 6. It's going to be x minus 6. Again, you've got to undo what's being done to x. Then this would be squared. Then the fact that I'm adding 1 here, I just want a plus 1 here. Again, if you plugged in a 6 here, 6 minus 6 would be 0. 0 squared would be 0. And then you add 1, and you get right there. This is 6, 1. So that's what we want for the function. Again, you can play around with more of these points if you want. Let's say you take this point right here, which is 1, 1. If I go 6 units to the right, well, now I'm going to be at an x value of 7. And then if I go 1 unit up, I'm going to be right there. So this point would be 7, 2. And again, you can do the rest of them on your own just by visiting Desmos. But this is the function that we want. So looking through the choices, this is the one you want. This g of x is equal to the quantity x minus 6 squared and then plus 1. All right, let's take a look at the quiz. So for the first question, we have f of x is equal to x cubed and then plus 2x plus 4. We're also given g of x is equal to negative x plus 4. We want to find f minus g of x and state the domain. So all you're going to do is start with this right here. So your f of x is x cubed plus 2x plus 4. So just write that. So let me put x cubed plus 2x plus 4. And what you're going to do is you're going to subtract away your g of x, which is negative x plus 4. So when you subtract this away, make sure you use parentheses. Let me see if I can grab this. It doesn't want to do it. Let me just rewrite this down here so that this fits. So let me write x cubed plus 2x plus 4 and then minus. So this will be inside of parentheses because we're subtracting the whole thing away. So minus x and then plus 4. To remove the parentheses, you want to distribute a negative 1, or you could just say distribute the negative to each guy. I always go plus negative 1 and then show that as being distributed, just so nobody forgets. So this would be equal to x cubed plus 2x plus 4, and then negative 1 times negative x is plus x, and then negative 1 times 4 is minus 4. Okay, let me get rid of this scratch work here, and get rid of this, and let me just move this up here so we have a little bit more room. So I'll say this is equal to, you have your x cubed there, you have 2x plus x, that's going to be 3x, and then you have 4 minus 4, which is 0, so that would just be gone. So really your f minus g of x is going to be x cubed plus 3x. So you see that's going to be right here. So x cubed plus 3x, this guy right here. Now, in terms of the domain, remember when you set this up, you want the intersection of the two domains. So the domain here is all real numbers. You have f of x equals x cubed plus 2x plus 4. I can plug in whatever I want for x. Negative, 0, positive, whatever I want. Then for this one, the domain is also all real numbers. So it's g of x equals negative x plus 4. Again, I can plug in whatever I want for x. So the intersection between the two domains would still be all real numbers, or an interval notation from negative infinity to positive infinity. So that's how we get that answer right there. So x cubed plus 3x with the domain that is all real numbers. All right, let's take a look at question 2. So here we're given f of x is equal to 2x plus 1, and then g of x is equal to 3x squared minus x. So we're told to find fg of x. So you're just going to multiply these together. So let me put fg of x. You're just going to go 2x plus 1, so that quantity, times the quantity 3x squared minus x. So this is something you could just use FOIL for and make that better there. So first terms, 2x times 3x squared. We're looking at 2 times 3, which is 6. X times x squared is x cubed. Then for the outer, 2x times negative x. that's minus 2x squared. And then for the inner, you have 1 times 3x squared, that's just 3x squared. And then for the last, 1 times negative x is negative x. Let me make this 2 better here. So looking at what we can combine, you'll notice that you have negative 2x squared plus 3x squared, so that would give me x squared. So I can just write this as 6x cubed, and then plus x squared, and then minus x. So let me get rid of this. Don't need that anymore. And we'll move this up here like that. And just looking through the answers, it looks like we're going to want this one right here. So 6x cubed, and then plus x squared minus x. And notice your domain, again, is all real numbers. So from negative infinity to positive infinity, that's coming from the fact that, again, you want the intersection of these domains. This one's going to be all real numbers because you have f of x equals 2x plus 1. I can plug in whatever I want for x. This one is also all real numbers. You have g of x equals 3x squared minus x. I can plug in whatever I want for x. So the intersection of those two domains, all real numbers and all real numbers, is going to give you all real numbers. So that's why the domain, again, is all real numbers, or in this interval notation from negative infinity to positive infinity. All right, for question 3, we have f of x equals 2x minus 3, and then g of x equals x plus 3. So we want to find 3f minus 2g of x and state the domain. Okay, so all you're going to do is, let me write out f of x real quick so it's more clear. So this is 2x minus 3, and then g of x is x plus 3. If you want 3f, all this is you could say this is equal to 3 times f of x, and basically this is just 3 times this guy right here. So 3 times the quantity 2x minus 3, and so this would be equal to 3 times 2x is 6x, and then minus 3 times 3 is 9. I make this better here. If you're looking at the other part, which was 2g, so 2g is equal to 2 times g of x, which is equal to 2 times the quantity. Again, you're just having x plus 3 inside there, so this gets distributed. 2 times x is 2x, and then plus 2 times 3 is 6. At this point, you just want to subtract. Let me actually get rid of this, and we're going to say that 3f minus 2g of x like this would be equal to, you've got your 6x minus 9, and then minus, again, you've got to subtract away this whole quantity, so you make sure you wrap this in parentheses. That's extremely important. Usually when somebody makes a mistake on a subtraction problem like this, it's because they didn't wrap this in parentheses. That's all you need to do. Again, you can go plus negative 1 here and just distribute this like this for clarity. So this is 6x minus 9, and then negative 1 times 2x is minus 2x, and then negative 1 times 6 is minus 6. And so 6x minus 2x, that's going to give me 4x. Negative 9 minus 6, that's going to be negative 15. All right, so we end up with 4x minus 15. So that's going to be this one right here. And again, the domain of all real numbers, or from negative infinity to positive infinity, if you look at the domain for each one of these guys, again, it's going to be all real numbers. So when you look at the intersection of the domains, you're going to end up with all real numbers, or from negative infinity to positive infinity. All right, for question 4, we are given f of x is equal to the square root of 2x minus 5. We're given g of x is equal to 8x plus 1. We are told to find fg of negative 4. Well, basically what you would do is you would multiply these guys together, and then with that product, you would plug in a negative 4 for x. The problem is when you look at the domain here, so let's say you look at the radicand, so this guy right there, well, again, using real numbers, so we're not involving the complex number system or the imaginary unit I, we know that we can't take the square root of a negative number. So we would want to say that 2x minus 5 is greater than or equal to 0. Add 5 to each side here. This cancels. You get 2x is greater than or equal to 5. Divide both sides by 2. This cancels. And you're going to get that x is greater than or equal to 5 halves. So for the domain there, you're going to get the set of all x such that x is greater than or equal to 5 halves. Okay, if we think about the other guy, the domain right here, of course it's all real numbers. So the domain for this guy, this is, you could say, the set of all x such that x is an element of the real numbers. Again, in interval notation, you could say from negative infinity to positive infinity, whatever you want to do. But the idea here is that I cannot plug in a negative 4 here because that's going to violate the domain. I know you could do it with a complex number system, but we're not involving that here. So we're just going to say that if you plugged in a negative 4 there, Well, 2 times negative 4 is negative 8. Negative 8 minus 5 is negative 13. And again, in the real number system, you can't take the square root of negative 13. So this right here, we're just going to say it's undefined. So this is undefined. Again, if you want to go through and multiply these guys together, you can, but you're going to get the same result. If I did fg of x, all it is just putting these guys together. You could write it like this. So 8x plus 1, like this. So this quantity, and then times the square root of 2x minus 5. But again, it doesn't matter. When I try to plug in a negative 4 right there, that's where it's going to fail and become undefined. So that's the answer. All right, let's take a look at question 5. So here we're given f of x is equal to 2x minus 3, and then g of x is equal to x over 3x minus 1. So we want to find f over g of 3. Let's just start by finding f over g of x and see where that leads us. So this is your f of x. Let's put 2x minus 3. We're going to be dividing by a fraction here, so let me write this over 1. And I'm going to multiply by the reciprocal of this guy, so times 3x minus 1 over x. Before we go any further, again, think about the domain. The domain for this is all real numbers. So the domain here is going to be the set of all x such that x is an element of the real numbers. The domain for this, at this point, you have 3x minus 1 in the denominator. So you don't want to divide by 0. So you could say 3x minus 1 is equal to 0. Add 1 to each side. This becomes 3x is equal to 1. Divide both sides by 3. And so you get x is equal to 1/3. So if x is 1/3 there, you get division by 0, which is undefined. So for this one, you'd say the domain is going to be the set of all x such that x is not equal to 1/3. Okay, so thinking about this, I'm asked to plug in a 3, so I'm okay there, right, so far. Now, when you look at these guys being put together, you're going to do an additional analysis to make sure the denominator is not 0, and we're going to do that in a moment. I think you can see that it can't be 0 because you just have an x down there. But let's go ahead and multiply these guys together. In this part right here, we're just going to use FOIL. So 2x times 3x, that's going to be 6x squared. The outer would be negative 2x. The inner would be negative 9x. So that would combine to be negative 11x. And then the last here would be negative 3 times negative 1. That's plus 3. And this is over x. Now, again, when we think about the domain for this guy, you want to have the intersection of these, which is going to be this one. Let me arrow to this and say that the domain is going to be the set of all x such that x is not equal to 1/3. But then also here, let me slide this over, otherwise it won't fit. Also here, you have to realize that you can't plug in a 0 for x, right? Because if you did, you'd have division by 0, which is undefined. So you have to also put that in there. So x cannot be 1/3, and it also cannot be 0. Okay, so looking at this now, we want to plug in a 3, so that's okay. We're not violating the domain. Everything will be fine. So let me slide down here a little bit and just say that f over g of 3 would be equal to, so you'd have 6 times 3 squared minus 11 times 3 plus 3 over 3. Let me slide down here a little bit. I'll come back up in a moment. 3 squared is 9. 9 times 6 is 54. So you've got 54 minus 11 times 3 is 33. And then plus 3. And this is over 3. So 54 minus 33, that's 21. Plus 3 is 24. So you get 24 over 3, which is 8. So that's going to be the answer we're looking for. Let me erase all this. And so f over g of 3 is going to be equal to 8. So this is the answer that we want. All right, let's take a look at the quiz. We're told for each function find, and this is the difference quotient. So we have f of x plus h minus f of x all over h. Let me write this out. So f of x plus h minus f of x over h. So this would be equal to, in this case, we have f of x, which is 4x minus 1. So if you wanted f of x plus h, this would be 4 times the quantity x plus h, then minus 1. Again, you're just plugging in an x plus h where there's an x there. So let me actually get rid of this, and let me move this right here. So this is your f of x plus h. Then minus your f of x is just 4x minus 1. Be very careful. You need to subtract the whole thing away. So you want some parentheses. So you're going to plug in 4x minus 1 there. This is all over h. So this is equal to, let me come down here a little bit. So this is going to get distributed into each guy. Let me go plus -1 here and distribute this into each guy. So 4 times x is 4x, and then plus. 4 times h is 4h, and then minus 1. Here you have -1 times 4x, that's minus 4x, and then -1 times -1, that's plus 1, and this is all over h. Now you're going to see a lot of stuff cancel here. So 4x minus 4x, that's going to cancel. You have -1 plus 1, that's going to cancel. So you're left with 4h. So let's say this is 4h over h, and of course, the h's are going to cancel, and you're just left with 4. So the difference quotient here is going to be 4. No need to slide back up. We can see the answer right here. So I'm just going to select 4. That's the difference quotient. All right, for question 2, we are asked for each function find, again, the difference quotient. So f of x plus h minus f of x over h. Not going to be able to fit this one on this page. Let me put this in here, and let me come back. So you have your f of x, which equals 9x squared minus 6x minus 1. And then your f of x plus h, this is 9 times, again, where there's an x, you're plugging in x plus h. So this is a quantity squared, minus 6 times the quantity x plus h, then minus 1. So this one, again, you have to expand this. So x plus h quantity squared, let me put, this is equal to, don't forget about the 9. So times, inside of parentheses, this would be x squared plus 2 times this guy, so 2xh plus this guy squared, so h squared. Then this would be distributed to each guy. Let me go plus -6 here. So -6 times x is minus 6x, and then -6 times h, that's -6h, and then you have minus 1. So the last thing here is let me distribute this in. So 9 times x squared is 9x squared, and then plus 9 times 2xh, that's 18xh, and then plus 9 times h squared, that's 9h squared. Let me make this a little bit better there. And then we have minus 6x minus 6h minus 1. That is very long, so let me get rid of all of this. Let's see if we can maybe just line this up like that. So basically, you're going to want these two. Let me just grab them both. And let me paste this in here. So you want to say that this is equal to, you have your f of x plus h, so that's this one. So let me erase this. And actually, let me move this over here real quick. Move this like that. And then what we're going to do is subtract away the f of x. So let me get rid of this and go minus. And let me move this up here. Now, here's where you want to, again, make sure you have some parentheses so you don't have sign mistakes. You need to subtract away the whole thing. So you're subtracting away f of x, so all of this. And then we're going to say this is all over your h. So really the only thing you have to do here, let's go plus -1. You're going to distribute this to each guy inside the parentheses. So let me write that we have 9x squared plus 18xh plus 9h squared minus 6x minus 6h minus 1. -1 times 9x squared is -9x squared. -1 times -6x is plus 6x. Then -1 times -1 is plus 1 all over h. So it looks like I missed an equal sign. So I have one there. Let me put one here. So that's consistent. Let me come down and let me put one right here. And we're looking for this 9x squared minus 9x squared. That's going to cancel. And then we have this minus 6x and plus 6x. That's going to cancel. You have -1 and plus 1. That's going to cancel. So what you have in the numerator now is 18xh plus 9h squared minus 6h all over h. So what you want to do is cancel away this h in the denominator. To do that, you're going to factor out the h from the numerator. You got one there, this is h squared, and this is h. So let's go ahead and say this is h times the quantity, 18x plus, this would be 9h, and then minus 6. Let's close that down and put this over h. And then, of course, these are going to cancel. And let's say for the difference quotient, the answer is going to be 18x plus 9h minus 6. Okay, let's grab this. We'll come back up here and paste this in. So it looks like I'm going to want this answer right here. So the difference quotient is going to be 18x plus 9h minus 6. All right, for question 3. Again, for each function, we want to find the difference quotient. So we have our f of x plus h minus f of x, and this is over h. This is one I think we could do on this page. It's probably better to go to another one, though. Let's come over here. Let me paste this in. So your f of x plus h, let me just start with that. So f of x is x squared minus 9. So f of x plus h would be, again, in the place of x, you want to say it's x plus h, and this is quantity squared minus 9. So this becomes, again, when you expand it, x squared plus 2xh plus h squared, and then you have minus 9. So let's copy this, and remember that f of x is x squared minus 9. So we're going to come down here, and let's just paste this part in. So then minus, again, your f of x, that's x squared minus 9. Make sure to wrap that in parentheses. You're subtracting away the whole thing. Let's put equals here, and let's slide down. So this is going to get distributed. Again, I can go plus -1 here to make that clear, and this is going to get distributed to each guy. So basically, you're going to have x squared plus 2xh plus h squared minus 9. And then again, I've got this -1. Let me actually move it a little bit down. Let me go plus -1 like that. So -1 times x squared is negative x squared. And then -1 times -9, that's plus 9. And this is all over h. So what's going to cancel here? You have x squared minus x squared. You have -9 plus 9. And so what I'm left with here, let's go ahead and write, we have 2xh. So 2xh, and then plus h squared over h. So go ahead and factor this h out from the numerator. You would have h times the quantity 2x plus h, and this is over h. And so this is going to cancel. And let me slide down here a little bit. You will end up with 2x plus h. So that's going to be your difference quotient. Let's go back up. So we want to select this one, the 2x plus h. All right, for question 4, once again, for each function, we're asked to find the difference quotient. So that's our f of x plus h minus f of x over h. Let me grab this and put it down here. We won't be able to fit that on that page. Let's put equals. Let's come back and start with, what is f of x plus h? Well, f of x is 4 over x minus 12. So it's just 4 over, in the place of x, you're just writing x plus h, and then you have minus 12. That's all it is. And we're going to come down and just paste this in. So this is your f of x plus h. Then you want minus f of x. So that is 4 over x minus 12. And then this is all over h. Now this is a complex fraction. Again, just think about this denominator here and this denominator here. The LCD is just the product of those two denominators. So you're going to multiply the numerator and denominator of the complex fraction by that LCD. So this would be the quantity x plus h minus 12 times the quantity x minus 12. So then over, you want this x plus h minus 12 times the quantity x minus 12. So when this gets multiplied by this, notice that this right here is going to cancel with this right here. So in other words, you're going to have 4 times the quantity x minus 12. Then minus. Here's where I would use some brackets or something like that, because you're going to subtract away what you have here. So this is getting multiplied by this. Now the x minus 12 is going to cancel with the x minus 12, and you have 4 times the quantity x plus h minus 12. Okay, close that down. This is all over. You have h times this quantity x plus h minus 12 times the quantity x minus 12. Don't distribute this in. You don't need to. The reason is because your goal is to cancel the h here. So just leave it like that. And let me put equals here. And let me put equals here. Okay, so at this point, again, you can go plus -1 like that. That's going to get distributed. So you need to distribute the 4 in. So just distributing this in to each guy. This is 4x. So 4x plus 4h and then minus 48. So all I did was I multiplied everything by 4. That's it. Then the -1 is going to multiply by everything. And that's just going to change the sign of everything. So let's say this is minus 4x, minus 4h, and then plus 48. So you can get rid of this. And this would need to be distributed. So that's 4x minus 48. So 4x minus 48. So looking at this, a lot of stuff's going to cancel. You have 4x and negative 4x. You have negative 48 and 48. So what you're left with in the numerator is just negative 4h. In the denominator, you have h times the quantity x plus h minus 12. And then times the quantity x minus 12. So this right here, this h would cancel with this one. And so this equals, for the difference quotient, you have -4 over, you have the quantity x plus h minus 12 times the quantity x minus 12. So this is what you want for your answer. So coming back up here, let's paste this in. It's going to be this one right here. So you want -4 over, you have the quantity x plus h minus 12 times the quantity x minus 12. All right, for question 5, again, for each function, we're asked to find the difference quotient, which is f of x plus h minus your f of x, and this is over your h. So let me grab this, and let me come down here and paste this in. Let's grab f of x plus h first. So f of x is equal to the square root of x plus 3. And so f of x plus h is just equal to, again, where there's an x, just plug in x plus h. So you have x plus h and then plus, and make this better here, so plus your 3. And then h could be a lot better. So basically, let me copy this and come down here. So we'll put equals and just paste this in. We're subtracting away, again, for f of x, that's the square root of x plus 3, and this is over h. Now let me go back up. You'll see here that I have a hint, and if you've worked through the lesson and the practice test, then you already know this, but it says, don't forget to multiply by the conjugate as shown in the lesson. For this type of problem, again, you're trying to cancel h away from the denominator, and so to do that, we're going to rationalize the numerator. So when you think about conjugates, again, if you do a plus b, that quantity, times the quantity a minus b, this is equal to a squared minus b squared. So all you're going to do here is multiply this by, you treat this as a and this is b, so you'd say this is the square root of x plus h plus 3. This minus will become a plus, and then this right here just stays the same. So this is the square root of x plus 3. In other words, this is a minus b, and then times a plus b. That's all it is. So you're just following this formula. So get rid of this, and to make this legal, we're going to write this down here. So we have the square root of x plus h plus 3, and then plus the square root of x plus 3. Okay, at this point, it's fairly straightforward. You're just going to follow that formula. Again, if I multiply this times this, I'm just going to get the radicand. Let's say that's x plus h plus 3. And then your outer and your inner, that's going to cancel. So you're just looking at this times this. Again, you're just going to get the radicand. But you have to subtract it away, so be really careful. You're going to subtract away the x plus 3. If you don't do this, again, you're going to make a sign mistake, so this is important. I'm just going to distribute this now. Again, this is just negative x and then minus 3. That's all it is. So let's put this over. Now you have h times the quantity. You'd have the square root of x plus h plus 3, and then plus the square root of x plus 3. Let me close this down and make that a little bit longer. So coming down here to finish things up, you're going to cancel some stuff. So you have 3 and negative 3. You have x and negative x. So what you have here is h. Let me write this on a new line. So h over, you have h times the quantity, the square root of x plus h plus 3, and then plus the square root of x plus 3. So we see that, let me make this a little bit better here. So we see that this over this would cancel, right? H over h is 1. Go ahead and write a 1 up there. So this is equal to 1 over, you're going to have the square root of x plus h plus 3, and then plus the square root of x plus 3. Okay, let's go ahead and grab this, and we're going to come up here and look for this. So we want this one right here. So we want 1 over the square root of x plus h plus 3 plus the square root of x plus 3. This is the one that we want. All right, let's take a look at the quiz. For the first question, we're asked to find f of g of x and then f of g of 3. So for f of g of x, that's real simple. For g of x, you have 3x minus 7. And all you're going to do is you're going to plug that in for x in that f of x, which is 2x squared. That's it. So basically, you would have 2, open some parentheses. You're going to plug in the 3x minus 7, and this is going to be squared. So going through this, again, you want to expand this, but you have this 2 out in front. So what I would do is use some brackets. You could use parentheses if you want. I'm just going to go 2, open up some brackets, and then just use your formula for this. So 3x is squared. So basically that's 3 squared, which is 9. And then, of course, x squared. And then minus 2 times this guy times this guy. 2 times 3 is 6. 6 times 7 is 42. So this would be 42. And then don't forget about the x. And then plus, you have this last guy, 7 squared. So that's 49. Okay, close this down. This equals. We're going to distribute this to each guy inside of the parentheses. So 2 times 9x squared is 18x squared. And then minus 2 times 42x. That's going to be 84x. And then plus 2 times 49 is going to be 98. Let's get rid of all of the middle steps here. We don't need those anymore. And just drag this up here. Now the next part is very, very simple. It's asking for f of g of 3. So all we're going to do is plug in a 3 for x in this guy right here. So there and there. This is something I would just use a calculator for. So you have 18 times, you're going to plug in a 3 for x, so this would be 3 squared, minus 84 times, you're going to plug in a 3, and then plus your 98. So let me put equals here. 3 squared would be 9, and let's go ahead and say that 9 times 18, that is 162, and then minus, let me fix this 6 here. You have 84 times 3, that's going to be 252, and then you have plus 98. Again, just something you can punch into the calculator. 162 minus 252, that's going to be negative 90, and then you have plus 98, and of course, negative 90 plus 98, that's going to be 8. So looking through the choices, this is the one that you're going to want. You want your f of g of x to be equal to 18x squared minus 84x plus 98. Let me erase this and just make this a little bit cleaner. So then we're also going to say that the f of g of 3 is going to be equal to 8. All right, let's take a look at question 2. So here we're asked again to find f of g of x and then f of g of negative 5. So for f of g of x, this is equal to, again, everywhere there's an x in this f of x here, so there and there, you're plugging in the g of x. So you're going to have 2, and then in the place of x, you're going to plug in the absolute value of x, and this would be squared. Then minus 5 times the absolute value of x, and then minus 1. For this one, it's pretty easy to simplify. If you have the absolute value of x, and you square that, that's the same thing as x squared. Because if you took an x value and squared it, or if you took the absolute value of x and then squared it, you would get the same result. If this was positive, it'd be the same thing as this. Let's say you have something like 3. 3 squared is equal to 9, and then the absolute value of 3, if that was squared, this would be 3 squared, it's still 9. If you had a negative number, let's say you used negative 3. Well, if you had negative 3, again, make sure to wrap this in parentheses and you square that, that's positive 9. If you had the absolute value of negative 3, like this, squared, this becomes positive 3 squared, which becomes 9. So these two are the same. You could just say it's x squared. Let's get rid of this and just put it like that. Let me tighten this up a little bit. So what you end up with is 2x squared minus 5 times the absolute value of x and then minus 1. So that's as simple as you can get that. Now in terms of the other guy, we want f of g of negative 5. So all I'm going to do is plug in a negative 5 here and then here. So let's see what that gives me. You have 2 times negative 5, plug that in, and you're going to square that. Make sure to wrap this in parentheses. Minus 5, and then times the absolute value of negative 5, and then minus 1. Okay, so this right here, negative 5, again, because it's wrapped, it's being squared, that's 25. And you do 25 times 2, that's going to be 50. So then you have minus, you have 5 times. The absolute value of negative 5 is 5. You can do that now. So negative 5 times 5, that's negative 25. So you can say this is minus 25. And then you have minus 1. So 50 minus 25 is 25, then minus 1. So this is going to be 24. Let me get rid of the middle steps here and just say that this is 24. Okay, so looking through the choices, it looks like we want this one right here. So this one's wrong. You have the absolute value bars out in front of all of this. That would be incorrect. So you want to say that f of g of x is equal to 2x squared minus 5 times the absolute value of x minus 1. And then f of g of negative 5 is equal to 24. All right, for question 3, we are asked to find the domain of f of g of x. So first let's find f of g of x. Let's start with that. So this is going to be what? Let me fix this x here. Well, you're going to take this g of x, which is 1 over x, and plug it in. So this right here is going to get plugged in for x right there. So you're going to have 2 over. This is x plus 3 in the denominator. So for x, you're plugging in 1 over x, and then you have your plus 3. Okay, so thinking about this, again, you want the intersection of the domain from the inside function, which is 1 over x, and the simplified composite function, which is 2 over, then you have 1 over x plus 3. Okay, let's start with the g of x. So if I look at g of x, the domain, so the domain for that is the set of all x such that, again, if you have 1 over x, x just can't be 0. So such that x is not equal to 0. So that's all it is. For this one, you would want to set this equal to 0 and solve it. So 1 over x plus 3, well, I would multiply this by x over x, and so that would be 1 plus 3x over x. So 1 plus 3x over x, where's that equal to 0? Well, this guy's going to be equal to 0, where the numerator is 0 and the denominator is not 0. So we know that x can't be 0. We already established that here. But we want to say, where is 1 plus 3x, 1 plus 3x equal to 0? Subtract 1 away from each side. This cancels. And so you would get 3x is equal to negative 1. Let me get rid of this. And actually, you can get rid of this. Divide both sides by 3, and you're going to get x equals negative 1/3. So you see how if you put in a negative 1/3 there, 1 divided by negative 1/3 would actually give you negative 3. Negative 3 plus 3 would be 0. Division by 0 is undefined. So what you'd have to do is, for this one, you want to take this domain here and then add on to it the restriction you got from here. It is the intersection of the two. So we're going to say the domain is going to be the set of all x such that x is not equal to, so you can start with this one, 0, and then also the one that we just found, which is negative 1/3. So you have to exclude both of those from the domain because, again, the 0 is from the inside function. You can't plug that in. So if I plugged in a 0 there, this part right here would be undefined. And then the negative 1/3, that's from this composite function here. You can't plug that in because you get division by 0, which is undefined. So we don't need this one anymore. We already incorporated it into this one. So when we look through our choices, this is the one we want. We want to say the domain is the set of all x such that x is not equal to negative 1/3, and then also it can't be 0. All right, let's take a look at question 4. So here we're again asked to find the domain of f of g of x. So first let's find f of g of x and see what that gives us. And make this x better here. So the f of x is x squared plus 4, and the g of x is square root of 1 minus x. So this square root of 1 minus x is going to get plugged in for x right there. So you'd have the square root of 1 minus x, and that would be squared, and then you would add 4. So the squaring would undo the square root operation, and you'd have the radicand. So you could say this is 1 minus x, and then plus 4. So 1 plus 4 would be 5. So let's say it's negative x plus 5. So I'm going to write this as negative x plus 5. Now again, when you think about the domain for this, you want to start with your g of x is equal to the square root of 1 minus x. In the real number system, we cannot take the square root of a negative number. So that means that that radicand there, which is 1 minus x, has to be greater than or equal to 0. So it has to be non-negative. Go ahead and subtract 1 away from each side of the inequality. This would go away. Let's write this as negative 1. You can divide both sides by negative 1, but remember you have to flip the direction of the inequality symbol. So this becomes a less than or equal to. This, you could put a negative 1 here and just cancel this away. So x is less than or equal to negative 1 over negative 1. That's 1. So that's going to be your domain for this guy. So the domain, let's say, is the set of all x such that x is less than or equal to 1. Okay, let's get rid of this. Actually, I'm just going to say this is the domain. Let me move this over here. And this is for g of x is equal to the square root of 1 minus x. Just rewrite it because I didn't mean to erase it. Now, what's the domain for this composite guy? You have f of g of x equals negative x plus 5. Well, just looking at it, it's all real numbers. But again, you can't come to that conclusion because on the inside, what was being plugged in to create this, we had a restriction, so we have to carry that through. So really, when I look at the composite, I need to say that the domain is going to be the same thing as this. So it's going to be the set of all x such that x is less than or equal to 1. So at this point, you can get rid of this. You don't need it anymore. This is the one we're looking for. So looking through the choices, this is what you want. So you want to say that the domain is the set of all x such that x is less than or equal to 1. All right, for question 5, we want to find f of x and g of x. So this is where we're going to do some function decomposition. So let me write this out again. So we have f of g of x. And we have here that this is h of x, but you could just write it like this. So f of g of x is equal to, you have this quantity x squared minus 2 to the 5th power minus 2 times the quantity x squared minus 2 and then plus 1. So what I see immediately is that you have this right here and this right here. So that's a duplicate. And so if I was plugging something in for x, in other words, if I had an x here and an x here, and if I was plugging in that x squared minus 2, that would give me this. In other words, what I can do is say that f of x is equal to, this would be an x to the 5th power, and then minus 2 times this would be another x, and then you just have plus 1. And then g of x would be equal to, again, this guy right here, that's the duplicate, what I'm going to be plugging in. So that's x squared minus 2. Now, There's other ways that you can do this, but in this case, we have a multiple choice test. So we're just going to go with the choice that matches here. And so for that, we want to select this one right here. So f of x equals x to the fifth power minus 2x plus 1, and then g of x equals x squared minus 2. So this is the answer that we want. All right, let's take a look at the quiz. For the first question, we're asked to describe the transformation from f of x to g of x. We're given that f of x here is equal to the absolute value of x. We're given that g of x here is equal to 2 times the absolute value of 3x minus 9, and then we have plus 4. So the first thing that I like to do is write things in terms of f of x, so it makes it crystal clear what the transformations are, and then we can just figure out the order. So for this, I like to factor out the coefficient of x. That makes the order much more straightforward. Again, that allows you to do all these stretches, compressions, and reflections before you do any shifts. So first, I'm just going to say that g of x is equal to 2 times the absolute value of, go ahead and put the 3 out in front, and then you can have this quantity x minus 3 like that. We'll close this down, and then we have plus 4. So you can get rid of this form if you want. And now I'm just going to write this in terms of f of x. So keep in mind that f of x is the absolute value of x. So really you could say that your g of x is equal to, we have 2 out in front. So 2 times f of, what am I plugging in for x there? Well, this guy right here. This is on the inside. So 3 times the quantity x minus 3, like that. And we'll close that down. And if you want, you can use brackets here. It doesn't really matter. I think a lot of people prefer this. And then you have your plus 4. So when you look at things, you know that this is on the outside and this is on the outside. So this is going to impact y, and so will this. And then these guys are on the inside. So those are going to impact x. When you have factored it, again, you can go left to right. So in other words, you could just say, okay, this is first, this is going to be second, this is going to be third, and this is going to be fourth. If you don't factor it, you're going to get a different order. Again, we've discussed this a lot in the lesson and the practice test, so I'm not going to go over that again. But basically, if you factored it, you can just go left to right. So the first thing is I have this multiplication by 2. And again, this is vertical, so it's going to give me a vertical stretch by a factor of 2. So the first thing is a vertical stretch by a factor of 2. Okay, for the second thing here, we're coming on the inside. So again, when you get on the inside, you have to undo what's being done to x. So this is multiplication by 3. I undo that with division by 3. So that's going to give me a horizontal compression by a factor of 3. Again, you could also say there's a horizontal shrink by a factor of a third. Some books will use that terminology. Okay, so for this one right here, you have x minus 3. Again, you want to undo the minus 3. That means you're going to add 3, and that's going to shift you to the right 3 units. So the third thing is we're going to shift right by 3 units. Then the fourth thing, we're just on the outside here, we have this plus 4. That's just going to shift me up by 4 units. So we're going to say we're going to shift up by 4 units. And that's basically it. Now, if you're a little bit unsure of this, I left you a graph, so you can just click that link and go to it. Again, I would just start with something on f of x, so some x comma y, and then you're going to go to, again, what happens to x? We're going to horizontally compress by a factor of 3, so that means we divide by 3, so x over 3. And then we shift right by 3 units, so we add 3 to that. In terms of y, we vertically stretch by a factor of 2, so that's just 2 times y. And then we shift up by 4 units, so we're going to add 4. So this is a good way to check your work. Let me go ahead and copy this, and let me come down here. I think it's a bit hard to read these graphs here, so again, just click the link if you want to follow along. But basically, you have this point on this red graph, which is your f of x equals the absolute value of x. This right here is 3, 3, in case you can't read it. And then we're going to go to this point right here, which is 4, 10. That's on your g of x equals 2 times the absolute value of 3x minus 9, and then plus 4. So just start with the 3, 3. And just plug in, again, to check your work. Well, this 3 gets plugged in for x. 3 over 3 is 1. 1 plus 3 is 4. Then you go to this 3. Plug that in for y. 2 times 3 is 6. 6 plus 4 is 10. So this does go to 4, 10. So again, this is one way you can check things. Let me go back up. This first one says vertically compressed by a factor of 2. We want a vertical stretch by a factor of 2. So this is out, These all say vertically stretched by a factor of 2. Then we want a horizontal compression by a factor of 3. This one says horizontally stretched by a factor of 3, and so does this one. So this is out and this is out. This one does say horizontally compressed by a factor of 3. It says shifted right 3 units and shifted up 4 units. So that does match what we have there. So this one right here is the one that you want. All right, let's take a look at question 2 now. So we want to describe the transformation from f of x to g of x. And so we're given f of x is equal to x squared, and then g of x is equal to -3, and then times the quantity 1/4 x minus 2. Let's close that down. This is squared, and then plus 1. So again, the first thing I'm going to do is factor. So we have this coefficient of x that's 1/4. So go ahead and just pull that out. We'll write this as g of x is equal to -3, and then let's go ahead and say, I'll just use brackets here. I'll pull my 1/4 out. So inside you'd have x and then minus. How do I undo multiplication by a fourth? Well, I would want to multiply by 4. 4 times a fourth is 1. So in other words, I want to take this 2 right here, and I want to multiply by 4, so that's going to give me 8. In other words, when you go back through and say 1/4 times x, that's 1/4 x, and then you have minus and minus, 1/4 times 8, again, that's going to get me back to 2. So this is what you want. Then let's go ahead and square this, and we have plus 1. Okay, let's get rid of this, and let's move this up here. All right, the next thing I'm going to do is I'm going to say g of x is equal to, just putting this in terms of f of x. So you have the -3, that's going to be out in front. So then times f of, again, this all right here is getting plugged in for x right there. So that's all we're doing. We're going to take this right in there. So 1/4, and then actually let me switch this to brackets. So then times the quantity x minus 8 like that. Let me make this better. Close that down and then close this down. And then you'd have the plus 1. Now we can go ahead and get rid of this. We don't need it anymore. And we can drag this up here. So put that like that. And now because we've factored, you could just work left to right. So this right here, this negative, that's going to give me a reflection across the x-axis. So let me just go ahead and label that as number 1. This will be number 2. We'll just do them separately. This will be number 3. This will be 4. And this will be 5. So the first thing is, again, this negative out in front, we have a vertical reflection or a reflection across the x-axis. I'm just going to put reflect across the x-axis. Second thing is we have the 3. Again, multiplying by 3 is giving me a vertical stretch by a factor of 3. So vertical stretch by a factor of 3. All right, then for number 3, let me slide down here a little bit. You have to undo this multiplication by a fourth because you're on the inside. So to do that, we would multiply by 4, and that's going to give me a horizontal stretch by a factor of 4. And then on the inside here, you want to undo this subtraction of 8. That means I want to add 8, so that's going to shift me to the right by 8 units. So I want to shift right by 8 units. Then lastly, you have this plus 1 on the outside here. Again, that's just going to shift me up by 1 unit. So we're just going to shift up by 1 unit. So again, if you want to check this with the graph I gave you, you can. Again, if you have some x comma y that's on your original, f of x equals x squared, well, when you go to this other one, again, for the horizontal, you're going to have a horizontal stretch by a factor of 4. So just take the x value multiplied by 4, so 4x. Then you're going to shift to the right by 8 units, so then plus 8. Okay, then for the y, you have a reflection across the x-axis and a vertical stretch by a factor of 3. So just multiply by -3, so -3y. And then you're going to shift up by 1 unit, so plus 1. And let's close that down. And let's come here and paste this in. So again, pretty hard to read this. Let me fix this actually, make this a little bit better. But you can just click the link to follow me on Desmos. So f of x equals x squared. That's going to be this guy in red. You have this point which is -1 comma 1. So -1 comma 1. And this is going to go to, again, when we get to this graph right here, which is g of x equals -3 times the quantity 1/4 x minus 2 squared plus 1, you're going to get this 4 comma -2. Again, all you're doing is you're plugging in this x value here right there. So 4 times -1 is -4. -4 plus 8 is +4. Then comma, if you think about -3 times, again, you're going to plug this in for y. So this 1, -3 times 1 is -3. Then plus 1, that's going to be -2. So that's how you go to this 4 comma -2. Again, you can play around with as many points as you want once you have this little formula set up just to check your work. So the first thing is we want to reflect across the x-axis. This one says y-axis, so you can get rid of that. And this one says y-axis, so get rid of that. Then it says vertically stretched by a factor of 3. I know you can't see this one, but that does say that. This is vertically stretched. This is vertically stretched. So those are okay. Horizontally stretched by a factor of 4. So this one's okay. This one's compressed and this one's compressed. So this one's out and this one's out. So it's going to have to be this one, the one that's covered up. So let me move this out of the way so you can read that. Maybe I'll slide down a little bit. So if you go through it, it says reflected across the x-axis, vertically stretched by a factor of 3, horizontally stretched by a factor of 4, shifted right 8 units, and then shifted up 1 unit. And this is the one that we want. All right, let's take a look at question 3. So we're asked to describe the transformation from f of x to g of x. We're given f of x is equal to the cube root of x. Let me fix this real quick. And then we have g of x is equal to negative 2 times the cube root of 1/2 x and then minus 1. Then you have this plus 3. Let me fix this 3 right here so that's clear. So again, I would factor on the inside first. So you want to factor this part right here out. So let's say that we have g of x is equal to negative 2 times the cube root of, you have the 1/2 being pulled out. So inside you're going to have x and then minus. Again, how do I undo multiplication by a half? I want to multiply by 2. So 1 times 2 is 2. So this would be a 2 right there. Close that down. And then you have this plus 3. So again, if you want to write this in terms of your f of x, so it's more clear, you could say that g of x is equal to negative 2 times, you're going to have f of, again, this right here is going to go right there. So let's actually use brackets here. Again, I think that's a little bit easier to use. So we'll have this 1/2 times the quantity x minus 2. We'll close all that down. And then you can have this plus 3. Okay, so you can get rid of this now. And basically, once you have this, again, you can just go left to right. That's why I like to do this. So this would be 1, 2, 3, 4, and then 5. That's all it is. So the first thing is you have this negative out in front. That's going to be a vertical reflection. Or again, you're going to reflect across the x-axis. Second thing, you have this 2 here. Again, you're multiplying by 2 out in front. That's a vertical stretch by a factor of 2. So vertical stretch by a factor of 2. Third thing, you're on the inside and you're multiplying by a half. So you need to undo that. How do you undo multiplying by a half? You're going to multiply by 2. So here, you're going to have a horizontal stretch by a factor of 2. Then you have this minus 2 on the inside right here. You want to undo that. So that means you want to add 2. That's going to shift me to the right by 2 units. So we're going to shift right by 2 units. And then the last thing, you have this plus 3 on the outside. That's going to shift me up by 3 units. So let's say that we're going to shift up by 3 units. Let me make this better here. Again, if you want to check this, you have some x comma y that's on the graph of f of x equals the cube root of x. This is going to go to what? So for x, you're going to horizontally stretch by a factor of 2 and then shift right by 2 units. So let's write that as 2x plus 2. And then for y, you have this reflection across the x-axis and then the vertical stretch by a factor of 2. So just put those together and say I'm going to multiply by negative 2. So negative 2 times y. And then we're going to shift up by 3 units. So then plus 3. Okay, close that down. Let's come in here and paste this in. So again, hard to see the graph. You can click the link, but the one in red, that's your f of x equals the cube root of x. And you have a point there that's 1, 1. So 1, 1. Again, the cube root of 1 would give you 1. So this is going to go to, again, this guy in blue here, this is g of x equals negative 2 times the cube root of 1/2 x minus 1, and then you have plus 3. Just take the x value of 1 and plug it in. So 2 times 1 is 2, plus 2 is 4. And then you're going to plug in the y value of 1. So negative 2 times 1 is negative 2. And then negative 2 plus 3, that's going to be 1. So you see that at this point right here, it's going to be 4, 1. Again, you can play around with more points if you want. It's just a great way to check this. All right, coming back here, the first thing we're looking for is a reflection across the x-axis. If you look at all of these, they all say reflected across the x-axis. Then the next thing is it says it's vertically stretched by a factor of 2. I know this is covered up right here, but it does say vertically stretched by a factor of 2. And this one says that, so does this one, so does this one, so does this one. So then we're going to move on to horizontally stretched by a factor of 2. This one right here, it's covered up. It says horizontally compressed by a factor of 2. So you can mark that one out. This one right here is horizontally stretched, horizontally stretched, horizontally stretched. So these three are good. This one says horizontally compressed by a factor of 2. So you can mark that one out. Okay, next we're going to have shift right by 2 units. So this one says shifted right by 2 units. This one also says shifted right by 2 units. This one says shifted right by 1 unit. So you can get rid of that. And then lastly, it says shift up by 3 units. So this one right here is shifted up by 3 units. If you look at this one, it says shifted down by 3 units. So this is out. This is the one that you want. So if you go through everything, it's reflected across the x-axis, vertically stretched by a factor of 2, horizontally stretched by a factor of 2, shifted right by 2 units, and then shifted up by 3 units. All right, let's take a look at question 4. So again, we want to describe the transformation from f of x to g of x. So let's write that we have f of x is equal to the square root of x, and then g of x is equal to, let me fix this g here, we have 1/2 times the square root of, let me factor out this -2 now just to speed this up. So you'd have -2 times the quantity x plus 2. Again, -2 times x is -2x. -2 times +2 would be -4. So that is a match. And then we're going to have -1. Come down here and paste this in. And so once again, I'm just going to write this in terms of f of x. So g of x is equal to, this is +1/2 times f of, actually let me use the brackets there. And I'm just going to throw this in. So -2 times the quantity x plus 2. We'll close all those down. Then -1. Let me get rid of this. And again, once you've factored it, you can just go left to right. So it's very straightforward. So I'm going to take this first. I'm going to take this negative here second. This 2 that's multiplying this guy third. This guy would be fourth. And then this guy would be fifth. So first you have this 1/2 that's multiplying this function. Again, that's going to compress me vertically. So in other words, I'm taking the y coordinate and you could say multiplying it by 1/2. So you could say there's a vertical shrink by a factor of 1/2. Or you could say I'm dividing each y coordinate by 2. So there's a vertical compression by a factor of 2. So let me write that there's a vertical compression by a factor of 2. So however you want to say that, that's up to you. This is what I'm going to go with. The second thing is you have this negative on the inside. And so that's going to be a horizontal reflection or a reflection across the y-axis. So let's say that we have a reflection across the y-axis. Let me make this better here. Third thing is we have this 2 that's multiplying this guy. Again, on the inside, you have to undo things. How do I undo multiplication by 2? I would want to multiply by 1/2 or divide by 2. So you could say there's a horizontal shrink by a factor of 1/2, but we'll say there's a horizontal compression by a factor of 2. Fourth thing, you have to undo this addition of 2 here, so you're going to subtract 2. That's going to shift left by 2. And then the final thing is, for number 5, we have this -1 on the outside. That's going to shift me down by 1 unit. So we're going to say that we're going to shift down by 1. And let me put 2 units here. And here I'll put 1 unit. All right, so once again, if you want to check this, we have some x comma y. That's going to be on the f of x equals the square root of x. This is going to go to what? In terms of x, again, this negative and this 2 right here, these are going to be put together. Remember, you're undoing things, so you'd want to multiply by -1/2. Or in other words, you're saying that you're reflecting across the y-axis. That's the negative part. And you have a horizontal compression by a factor of 2. That's the dividing by 2 part, or you could say multiplying by 1/2. So let's just say this is going to be -x/2, just putting that together. And then basically you have this shift left by 2 units. So then that's just -2. Then for the y, you have a vertical compression by a factor of 2. Again, that's just me taking y and either multiplying by 1/2 or dividing by 2. So let's go y/2. And then we have a shift down by 1 unit. So that's -1. Okay, let's go ahead and grab this. And just come down here. Again, I have this for you on Desmos. This guy in red, that's your f of x equals the square root of x. This guy in blue, this is your g of x equals 1/2 times the square root of -2x minus 4, then -1. So you pick some point, and you could just use this 4, 2, but pick whichever one you want. And again, you're just going to go through this, and verify that it's on the graph over here. So if you take an x value of 4 and you plug that in there, well, you'd have the negative of 4 over 2. So think about it as negative 4 divided by 2. That's negative 2. And then minus 2. That's going to be negative 4. So that's a match for that x value right there. Then you have your y over 2 minus 1. So y here is 2. 2 over 2 is 1. 1 minus 1 is 0. And again, you see this point right here is negative 4 comma 0. So this 4 comma 2 is going to go to negative 4 comma 0. Again, you can play around with more points if you want. Kind of hard to read, but let's just go through it. So this one says vertically compressed by a factor of 2. This one, this one, this one. So those all say the same thing. Then we're looking for a reflection across the y-axis. Again, I know you can't read it, but that's what this says, this says, this says, and this says, but this one doesn't. This says reflected across the x-axis, so this one will be wrong. Then you have a horizontal compression by a factor of 2. So this says horizontally stretched by a factor of 2. This is out. Horizontally stretched, out. Horizontally compressed by a factor of 2. Horizontally compressed by a factor of 2. So these two are in the running. Then we have a shift left by 2 units. So this one says shifted left by 4 units. That's out. This one says shifted left by 2 units. And then we have shifted down by 1 unit. So that matches there. So this is the one that we want. So it's vertically compressed by a factor of 2, reflected across the y-axis, horizontally compressed by a factor of 2, shifted left by 2 units, and then shifted down by 1 unit. All right, let's take a look at question 5. So here we want to describe the transformation from f of x to g of x. And we are given that f of x is equal to 1 over x, and then g of x is equal to, let's go ahead and write this as negative 2 over, let me pull out the 1/4 now, so 1/4 times the quantity, x plus, again, how do I undo multiplication by a fourth? We would multiply by 4. So 1 times 4 would be 4. Again, if you want to check that, a fourth times x is 1/4 x, and then plus and plus, 1/4 times 4 would be 1. So then you have this minus 1 right here. Okay, let's go ahead and grab this, and let's paste this in right here. So once again, I'm just going to write this in terms of f of x. So I'm going to say that my g of x is equal to, you could put this negative 2 out in front and say it's multiplying f of, again, I keep putting the parentheses there. Let me put the brackets. You're going to throw this in. So we're going to say 1/4 times the quantity x plus 4. Close all that down. And then you have the minus 1 on the outside. So you can get rid of this form. Again, once you rewrite it, it makes it a lot easier to think about what's going on. Again, because it's factored here, you can just go left to right. So I can take this as first, second, this would be third, this would be fourth, and then this would be fifth. Okay, so the first thing is you're going to deal with that negative out in front. So we're going to say that's a vertical reflection or a reflection across the x-axis. So we're going to reflect across the x-axis. Second thing, you have this multiplication by 2. Again, this is vertical, so it's going to be a vertical stretch by a factor of 2. So vertical stretch by a factor of 2. Third thing, when you look on the inside of the function, you have to undo things. How do I undo multiplication by a fourth? You want to multiply by 4. So that's going to give me a horizontal stretch by a factor of 4. So horizontal stretch by a factor of 4. Fourth thing, you want to undo this plus 4 here on the inside. Again, you want to subtract 4. That's going to shift me to the left by 4. So we're going to say shift left by 4. Then on the outside here, you have this minus 1. That's going to shift me down by 1 unit. So this is going to shift down by 1. Let me put 4 units here. Let me put 1 unit here, just to make that crystal clear. Again, to check this, we're going to use our graph. So if we have x comma y, that's on the f of x equals 1 over x, what's it going to go to when we get to our g of x function? Well, again, in terms of x, you're going to horizontally stretch by a factor of 4 and shift left by 4 units. So that means you have 4x minus 4. In terms of y, let me fix this. In terms of y, you're going to reflect across the x-axis and vertically stretch by a factor of 2. So we're just going to multiply y by negative 2. So let's write negative 2y. And then you have this shift down by 1 unit, so minus 1. Again, we'll come down here. So f of x equals 1 over x. That's this guy in red. You have this point 1 comma 1. This guy in blue, this is going to be your g of x equals the negative of 2 over 1/4 x plus 1. And then you have minus 1. So we're going to take this point right here, which is 1 comma 1. And we're going to show that it's going to go to this point right here, which is 0 comma negative 3. Again, take the 1 for x and plug it in. 4 times 1 is 4. Minus 4 is 0. Take this 1 for y and plug it in. Negative 2 times 1 is negative 2. Negative 2 minus 1 is negative 3. So this point's going to go to that point. Again, it's a good way to check things. Now, when we look through what we have, everything says reflected across the x-axis, so we don't have to worry about that. And in terms of the next thing, we want something where it's vertically stretched by a factor of 2. So that's here. I know you can't read it, but that's here, and then that's here. This one says vertically compressed by a factor of 2, and so does this one. So you're going to mark these out. Next, you have a horizontal stretch by a factor of 4. So this one says horizontally stretched by a factor of 4, so that one's okay. Horizontally stretched by a factor of 4, and then this one is horizontally stretched by a factor of 4. So those are all okay. Then it says we're going to shift left by 4 units. This one, you have a shifted right by 4 units. That's out. This one is shifted left by 4 units. This one says shifted right by 1 unit, so this is out. And then lastly, you have and shifted down by 1 unit. This is the one that you want. You start with this reflected across the x-axis. Then you have vertically stretched by a factor of 2, horizontally stretched by a factor of 4, shifted left by 4 units, and shifted down by 1 unit. All right, let's take a look at the section quiz. For the first question, we're asked to identify the function of the given graph and state the domain and range. So this function right here is one that you should know at this point. Just from the lesson we did on the graphs of the basic functions, this is going to be your cube root function. So this is f of x is equal to the cube root of x. Again, you can prove that with these points that I've given you here. Something like negative 8 comma negative 2. If you did f of negative 8, so f of negative 8, this is equal to the cube root of a negative 8 gets plugged in for x, and so this gives me negative 2. And you could do the same thing with this negative 1 here. F of negative 1 would be negative 1. F of 1 would be 1. F of 8 would be 2, so on and so forth. So this is your cube root function, where f of x equals the cube root of x. Now, in terms of the domain and range, it's going to be all real numbers for each. You can plug in any real number that you want here. You can plug in a negative, 0, positive, and you can get out any real number that you want. You can get out a negative, 0, or positive. So both the domain and range would be all real numbers. So coming down here, this is the one that we want. We're going to say that f of x equals the cube root of x, where again, the domain is all real numbers, and the range is also all real numbers. All right, for question 2, we have a piecewise-defined function. So f of x is equal to, we have negative 2x squared plus 1 if x is less than or equal to 0, and then we're given 4x squared plus 5 if x is greater than 0. So we want to find f of 7. So first think about the fact that 7 is in the category where x is greater than 0. So you're going to use this guy right here, and you're just going to plug in for x. So f of 7 is going to be equal to 4 times, plug in a 7 there for x, this would be squared, and then plus 5. So you're going to square 7 first. That's going to give us 49. So this is 4 times 49, and then plus 5. So now we're going to do 4 times 49. The way I would do that is 4 times 50, that's 200, and then just take 4 away. So that's 196. Again, if that's a little bit complicated for you, you can just do it either with a vertical multiplication or use a calculator. It doesn't matter. Then we're going to add 5. So this would give me 201. So this is the one we want. So f of 7 is 201. All right, for question 3, we are asked to use the graph to determine the rule for each interval of the piecewise-defined function. So the first thing that comes to my attention is you have this piece right here, which is where x is less than or equal to 0. You have your squaring function, so f of x equals x squared. If you look at the points, you have 0, 0, negative 1, 1, negative 2, 4, negative 3, 9. So again, that matches f of x equals x squared. Let's come down here and write this up. So f of x is equal to, let me put this like this, and let me make that a little bit better. So I'll do that one more time like that. So let's just say x squared, and we'll put this down here. So if x is less than or equal to 0. So for any x that's 0 or less, we're using x squared as the rule. What you'll notice here is that for x values that are greater than 0 and less than or equal to 4, there's nothing. So you would say undefined there. So let's write undefined, and we can abbreviate. So this would be for undefined, and we'll say if your x is strictly greater than 0 and less than or equal to 4. Now, the last one is going to be if x is strictly greater than 4. So let's go back up, and let's think about this right here. So we've done a lot of work with lines at this point, and so we know that we could get the slope of the line by just saying that m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's say I label this point as the first point and this point as the second point. So my m here would be equal to, the y sub 2 would be 4, and then minus the y sub 1 would be 6 over your x sub 2 would be 5, and then minus your x sub 1, that would be 6. Okay, let me get rid of this and just crank that out real quick. So 4 minus 6 is negative 2. This is over. 5 minus 6, that's negative 1. So the slope here is 2. And that does make sense. If I start here and I go up 2, 1, 2, to the right 1, I'm back at that point. So the slope is 2. Now that we have the slope, let me put m is equal to 2. Again, you can use your point slope form. So you say y minus y sub 1. Again, you could pick either of these points. Let me just pick this one. So that'll be my point. So y sub 1 would be 4. And this would be equal to m, which we know is 2, times the quantity. You have x minus x sub 1. X sub 1 there would be 5. Again, this would work the same, no matter if you use this point or this point. This is something we learned earlier on in the course. So let me just add 4 to both sides now and get that out of the way. And so this becomes y is equal to, let's distribute this in. So you have 2 times x, which is just 2x, and then minus 2 times 5, that's 10. And then you have plus 4. Let me get rid of this form right here. And so this negative 10 plus 4, that would be negative 6. So you get y equals 2x minus 6. And you could just change that over to f of x to use that notation. And you could check that if you want. Let's say you had an x value of 6. 2 times 6 would be 12. 12 minus 6 would be 6. Let's say an x value of 5. 2 times 5 would be 10. 10 minus 6 would be 4. So that does match. So this is 2x minus 6. This is the one you want. And I didn't do the notation like this because the text inputs on Udemy don't allow for that. So this is how I had to write it. But basically, f of x is equal to x squared if x is less or equal to 0. Then it's going to be undefined if x is greater than 0, and that's strictly greater than 0, and less than or equal to 4. Then it's going to be 2x minus 6 if x is strictly greater than 4. This is the answer that you want. All right, for question 4, we want to use the graph to find the intervals on which the function is increasing, decreasing, or constant. We are given f of x equals 1 over x minus 4. Again, with this function right here, we know that we cannot divide by 0, and so where x would be 4, you get 4 minus 4, which is 0. Division by 0 is undefined. So that's why you have this vertical asymptote here where x is equal to 4. What you'll notice is that this guy is basically going to be decreasing anywhere where x is not 4. Because if you start right here, and let's say your guy is walking, so he's coming from negative infinity, as he goes this way, so as we go to the right, this function is always decreasing. So until we get to this spot right here, again, where x is 4, this is going to be undefined. So when you come back over on the other side of that vertical asymptote, your guy is now going to be up here. And you can be as close to an x value of 4 on the other side of it. So something like 4.01 or 4.000001 or something like that. You can get as close as you want, but you can't actually get to 4. So starting wherever you want as close to that 4, as you go to the right, again, this guy is decreasing, right? So he's always decreasing here. So what you would say is that this is decreasing over the interval. You go from negative infinity going up to and excluding positive 4. And then we'll put a comma here and we'll say that also for anything where it's greater than 4. So greater than 4 going out to positive infinity. So this is the answer we want. So decreasing on, you have from negative infinity going up to and excluding 4. And then you also have anything larger than 4, so going out to positive infinity. All right, let's take a look at question 5. So use the graph to find the intervals on which the function is increasing, decreasing, or constant. So again, you're going left to right. So I'm going to start here with my guy. I always draw this in. He is decreasing here until he gets to this point right here. So that's going to be from negative infinity. Let me write this out. So decreasing, you have from negative infinity going up to, and again, we're going to exclude this. So this is negative 4. So negative 4. And then he's going to decrease again. Let me put this guy right there. From 0 to 4, again, excluding both. So let's put a comma, and then we're going to do 0 and then 4. Okay, in terms of increasing, that's going to be this piece and then this piece. So let me draw this in a different color. Maybe I'll use green. So this guy right here would be increasing. So this is from negative 4 to 0. So increasing, we'll go negative 4 to 0. Again, both of those are excluded, and that's going to happen again for this interval right here. So this is from positive 4 going out to positive infinity. So 4 to infinity. So looking at the choices, we want this one right here. So increasing on, you have from negative 4 to 0, again, both being excluded. And then you also have from 4 to positive infinity, again, both being excluded. And then decreasing on, you have from negative infinity going up to and excluding negative 4, again, nothing is included. And then you also have between 0 and 4, again, nothing is included. Okay, for question 6, how does the graph of g of x compare to f of x? So we're given f of x equals x squared, and then g of x equals 1/9 times f of x. This right here, when it's multiplying the function, again, this is going to affect you vertically. Now, again, we talked about this a lot in the lesson. When you have certain functions, it can really go either way. So this right here, if I had written, let's say this is g of x is equal to 1/9 x squared. That's basically what we wrote here. Well, I could produce the same thing by saying that, let's go g of x is equal to the quantity 1/3 x like this squared. So if I carried out this operation, this would give me 1/9 x squared. So really, I could look at this and say that there's a horizontal stretch by a factor of 3. But that's not the way the problem was given to us. So the way you want to answer is in terms of how it's given to you. And so you want to go with this guy being vertical. And so because it's a 1/9, you want to say there's a vertical shrink by a factor of 1/9, or we could say a vertical compression by a factor of 9. Again, however you want to say that is fine. Different terminology, same meaning. We got to go with the answer given in the quiz here. So it says the graph of g of x is vertically compressed by a factor of 9 when compared to the graph of f of x. So this is the one that you want. All right, let's take a look at question 7. So based on the original function f of x, for a given y value, how could we obtain the x values for the function g of x? So we have f of x equals x squared, and then g of x equals f of 1/3 x. So we know already that this right here, it's on the inside, that's going to give me a horizontal stretch by a factor of 3. Again, things need to be undone on the inside. So if I'm multiplying 1/3 by x, to undo that, I need to multiply by 3. That gives me the horizontal stretch by a factor of 3. But what it's asking for here is basically if I have some x comma y on the graph of f of x equals x squared, what's that going to go to on the graph of, well, this would be g of x is equal to, just like we saw in the last one, again, if you plug in a 1/3 x there, so this is 1/3 x squared, this becomes 1/9 x squared, right? You square 1/3, you get 1/9, you square x, you get x squared. So when we think about this, it means that the x comma y on f of x equals x squared is now going to be 3x comma y. So it's this one right here, this one right here. Again, you can prove that to yourself by saying that, let's say you had something like 2 comma 4. What is that going to go to? Well, I would multiply this x value by 3, so that would be 6, and then comma 4. Again, we're trying to keep the same y value. I know there's different ways you could do this. You could interpret it also by saying that x comma y is going to go to the same x value. Now the y value is divided by 9, so it's y over 9. But again, it's how the problem was set up. It said for a given y value, how could we obtain the x values for the function g of x? So this is how you want to answer. And again, you could plug that in and see it works. If you took 6 there and you squared it, you'd get 36, and then 36 divided by 9 will give you 4. So this is the answer that you want. You want to say for a given x comma y and f of x, the x comma y and g of x can be found as 3x comma y. All right, for question 8, how could we graph g of x based on the graph of f of x? So you have f of x equals the absolute value of x, and then g of x equals negative f of 3x. Again, there's different ways to write this and different ways to answer, but based on the choices given and how the problem is presented, you want to say that this right here is a reflection across the x-axis. It's a vertical reflection. And then this right here, again, it's on the inside. You want to undo that. How do I undo multiplication by 3? Well, I want to divide by 3 or multiply by 1/3. So this gives me a horizontal compression by a factor of 3. This right here is a reflection across the x-axis. So if I look at the choices, this one right here says reflect across the x-axis, horizontally compressed by a factor of 3. So this is the one that you want. If you look at the other ones, I know you could rewrite this. Well, I could go g of x is equal to the negative of, let's say you plugged in a 3x there, so the absolute value of 3x. Well, by rule, this is equal to the negative of the absolute value of 3 times the absolute value of x. Well, the absolute value of 3 is 3. So really, I could write this as being equal to the negative of 3 times the absolute value of x. Well, if you view it that way, now this guy is a reflection across the x-axis still, but this 3 right here is going to be vertical, right? So it's a vertical stretch by a factor of 3. So you'll notice that this answer right here says reflect across the y-axis. So this part right here is wrong. Then we have vertically stretched by a factor of 3. So this would be okay, but this makes it wrong. So you want to make sure you choose this answer. All right, for question 9, determine if the following equation is symmetric with respect to the x-axis, y-axis, or the origin. So we have x equals y squared over 2 minus 1. And if we think about this, immediately you can tell that this is symmetric with respect to the x-axis, because again, if we can replace y with negative y and we get the same equation, that means we're symmetric with respect to the x-axis. In other words, if I say x is equal to, and I plug in a negative y there, again, wrap this with parentheses because I'm replacing this right here with negative y, and that would be squared. This is over 2, and then minus 1. Well, the negative is going to go away. So this is going to end up just giving me the same equation, right? So this will end up giving me this x equals y squared over 2 minus 1. So this is symmetric with respect to the x-axis. Again, you can also see this graphically. If you look at this guy, I could take this point right here, reflect across the x-axis. I'm going to get this point right here. In other words, if you have x comma y, then x comma negative y is also going to be on that graph. So you have 1 comma 2, 1 comma negative 2. Another point would be this one right here, which is 7 comma 4. If you reflect across the x-axis, you're going to come down here and you're going to have 7 comma negative 4. Again, if x comma y is on the graph, then x comma negative y is also on the graph. That's a feature of having something that's symmetric with respect to the x-axis. All right, so this is what we want. The graph of this equation is symmetric with respect to the x-axis. All right, for question 10, we want to determine if each function is even, odd, or neither. So we have f of x equals the absolute value of x minus x squared. I think most of you can immediately tell this is going to be an even function, but again, to do the work, you want to check f of negative x and see if that's equal to f of x. So this would be equal to the absolute value of negative x, and then minus, you'd have the negative of x right here being squared. Let me actually copy this. We'll do the work over here on another page. This right here you can break up and say this is the absolute value of negative 1 times x like that, and then basically you'll go minus. Again, you could write this as negative 1 times x like that being squared. And so this is equal to, well, this right here you could break up and say it's the absolute value of negative 1 times the absolute value of x. And then minus, you can break this up into negative 1 squared times, you could have x squared like that. Let's just write it like that for now. And this would be equal to, the absolute value of negative 1 is 1. And then 1 times the absolute value of x is just the absolute value of x. So that's that. And then you have minus. Negative 1 squared is 1. 1 times x squared is just x squared. So at the end of the day, f of negative x is equal to the absolute value of x minus x squared, again, which is what we started with. So that's how you can tell this is an even function. All right, for question 11, we are asked to describe the shift of g of x based on the parent function f of x. We're given f of x equals 1 over x, and then g of x is equal to 1 over x plus 1/2 plus 9. So what I like to do here is just say that g of x is equal to, I'm just going to put this in terms of f of x. So let's go f of, you could think of this right here being plugged in for x right there. So I'm going to take this and plug it in right there. So this is x plus 1/2. So that's on the inside. And then this right here, this plus 9 is on the outside. So we already know when we write it like this, that when we look at what's being done on the inside, it needs to be undone. So if we have x plus 1/2, how do I undo adding 1/2? I want to subtract away 1/2. So that's going to shift me to the left by half of a unit. So this right here, we would say we're going to shift left by 1/2 of a unit. Now, this plus 9 here on the outside is very straightforward. This is just telling me that we're going to shift up by 9 units. So this one right here, we're going to shift up by 9 units. So coming down here, it's going to be this first one. So based on the graph of f of x, g of x is shifted left half of a unit and up 9 units. This is the one that we want. All right, for question 12, we have given the original function f of x equals the square root of x. The graph below of g of x was sketched by applying a horizontal and vertical shift. Find the correct function g of x that matches the given graph below. Let me slide down here a little bit. So this one's pretty easy overall. If you think about your basic square root function, so you have this point which is 0, 0, you have 1, 1, you have 4, 2, you have 9, 3, and it looks something like this. And I'm not a good drawer, but something like that. So let me label this so this is clear. This is 0, 0. This point right here is 1, 1. This point is 4, 2. And this point is 9, 3. Okay, let me make the 3 better. Now, if you look at this point right here and this point right here, what happened? It goes 1, 2, 3, 4, 5 units down and 1 unit to the left. So in other words, this guy has been shifted. So we're going to say shifted 1 unit left. Let me make that better. And I'll say and 5 units down. So if we have f of x is equal to the square root of x, well then g of x would be equal to, again, how do you shift something 1 unit left? Well, you need to do the opposite of that. In other words, you would want f of x plus 1. So you want x plus 1 plugged in there so that when we undo that, we subtract away 1, and that shifts us to the left by 1 unit. And then going 5 units down, that's straightforward. It's just minus 5. In other words, you would want, let me get rid of this. This graph would be g of x is equal to, you could write it as the square root of x plus 1, and then you'd have minus 5 out here. So let me just paste this in. So g of x is equal to the square root of x plus 1, and then minus 5. So this is the one you want. So again, g of x equals the square root of x plus 1. Again, you have to undo that. So you do minus 1. That shifts me to the left by 1. And then you have minus 5 on the outside. Again, that's shifting me down by 5 units. All right, let's take a look at question 13. So we have f of x is the function in red. So that's going to be this guy right here. And then g of x is the function in green. So that's going to be this guy right here. What is g of x in terms of f of x? All right, so this is very straightforward. I gave you a link on Desmos if you want to click that, but without even going there, just think about, okay, if this right here is your f of x, and then this right here is your g of x, is this reflected across the y-axis or the x-axis? We know there's a reflection involved, but which one is it? Well, if you take this point right here, which is 2, 4, and you reflect it across the y-axis, that would mean that I need to be at negative 2, 4. Well, here's negative 2 and here's 4. That point is not on the graph of g of x. Let me make this x better here. If I take this point of 2, 4 and I reflect across the x-axis, so I come down here, now you have 2, negative 4. Same x value, y value has been changed into its opposite. So you'll see that this is reflected across the x-axis. So if you look at 0, 2, now you have 0, negative 2. If you look at negative 1, 4, now you have negative 1, negative 4. So you could say that g of x is equal to the negative of f of x. That's how we get a reflection across the x-axis. So this is what we want. Let me go ahead and grab this. Let me come down here and paste this in. Again, you could look at it with this calculator if you want, but this is the one that we want. All right, for question 14, we have f of x equals 3x minus 5, and then g of x equals negative 3x plus 4. So we want to find 4f minus 3g of x. So how do we find that? Well, this would be equal to, you're just going to take 4 times this f of x, so it's really just 4 times the quantity, 3x minus 5, and then minus this 3g, that's just 3 times this g of x here, so 3 times the quantity, negative 3x plus 4. And so this would be equal to, all we're going to do is distribute this in. So 4 times 3x is 12x, and then minus 4 times 5 is 20. This right here, let's go plus negative so we don't make a sign mistake. This negative 3 is multiplied by negative 3x. That's plus 9x. And then negative 3 is multiplied by positive 4. So that's negative 12. So this equals 12x plus 9x, that's 21x. And then negative 20 minus 12, that's going to be negative 32. So 4f minus 3g of x is going to be equal to, let me get rid of these steps right here, this 21x minus 32. So 21x minus 32. So we have that right here and nowhere else. Now, in terms of the domain, remember that we're thinking about the intersection of those two domains. So this one and this one. And multiplying by 4 or multiplying by 3, that's not really going to change anything. You have all real numbers here and then all real numbers here. So really the domain, when you put these together as 4f minus 3g of x, you're going to get all real numbers. So this is the answer that we want. We want 21x minus 32, where we say the domain is all real numbers. We're getting an interval notation from negative infinity to positive infinity. All right, for question 15, we have f of x equals 5x squared minus 3x, and then g of x is equal to 6x minus 7. So we want to find this 2f plus 3g. We want of 2z, but for now, let's just go of x. We're going to start with this, and then I'll plug in a 2z for x. So this would be 2 times, again, for f of x, you have 5x squared minus 3x, and then you have plus your 3 times. Your g of x is 6x minus 7. So this equals, you're going to use your distributive property here. 2 times 5x squared is 10x squared, and then minus 2 times 3x is 6x, and then plus, again, you're going to use your distributive property. 3 times 6x is 18x, and then minus 3 times 7, that's going to be 21. Okay, clean this up. So you have 10x squared, nothing you're going to do with that. Negative 6x plus 18x, that's plus 12x, and then you have minus 21. What we want to do is find 2f plus 3g of 2z. So let me go 2f plus 3g of 2z. So I'm going to take this, and everywhere there's an x, I'm going to plug in a 2z. So 10 times, you want 2z, like that, and this is going to be squared, plus 12 times, you're going to have 2z, and then minus 21. Well, 2z squared, again, the 2 needs to be squared, and also the z needs to be squared. So this is 10 times, 2 squared is 4, and then times z squared. So you can put that together now and say that's going to be 40z squared. So 40z squared. And then plus 12 times 2z, that's 24z. And then minus 21. Again, let me get rid of these middle steps here. And I think I can fit this up here. Maybe not. Let me move this down like that. Move this over like this. And I think we're good to go now. So looking for the answer, this is the one you want. So 40z squared plus 24z minus 21. All right, for question 16, we want to find the difference quotient. So remember, we have this formula f of x plus h minus f of x over h, again, where h is not 0. So all we're going to do, let me just copy this. We have f of x is equal to 9 over x minus 7. No way we can fit this here. So let me go down here to a fresh piece of paper. And basically, let me write out that f of x plus h would be equal to 9 over, you just plug in x plus h where there's an x. So just x plus h minus 7. That's all it is. So let me write this out. So f of x plus h minus f of x all over h would be equal to, this is your f of x plus h, so it's 9 over x plus h minus 7, and then minus your f of x is 9 over x minus 7, then this is all over h. All we need to do, let me actually copy this or move this over here so I have enough room. So what we're going to do is multiply the numerator and denominator of this complex fraction by the LCD, again, of all these individual denominators. You have x plus h minus 7, x minus 7, and then 1. So the LCD is the quantity x plus h, and then minus 7, and then times the quantity x minus 7. So we'll put that in the numerator, and then also in the denominator. Just do the same thing so that it's legal. So this right here is going to get distributed to this, and then to this. Let me put equals here. So when this gets multiplied by this, again, this would cancel with this, and you're left with 9 times the quantity x minus 7. Then you have minus. I'm going to put brackets here so I don't make a sign mistake. When this gets multiplied by this, the x minus 7 cancels with the x minus 7, and you have 9 times the quantity, x plus h minus 7. We'll close all that down. And then this is over. This gets multiplied by this. So basically, we'll just show that as h times the quantity x plus h minus 7 times the quantity x minus 7. Now, you do not want to distribute this in. Again, the goal for this problem is to make this h cancel away. You could erase this and write this as plus negative 9 like that. I think it'll make it a little bit easier, or you could do it the other way. It's really up to you. Maybe I could do that one more time and make it better. Let me put equals here, and we'll go through and distribute. So 9 times x is going to be 9x, and then minus 9 times 7, that's 63. And then here you have negative 9 times x, that's negative 9x. and then negative 9 times h, that's minus 9h, and then negative 9 times negative 7, that's plus 63. So what you're going to see is that this is going to cancel with this, and this is going to cancel with this. So you have this negative 9h that's left. So I'll leave this like this. I'm going to put this over. We have h times the quantity x plus h minus 7 times the quantity x minus 7. So at this point, with all these things canceled away, you're going to be able to cancel this h with this h right here. So we're going to have negative 9 in the numerator, and this will be over in the denominator, the quantity x plus h minus 7 times the quantity x minus 7. So we're looking for this answer right here. So negative 9 over, you have this quantity x plus h minus 7 times the quantity x minus 7. All right, for question 17, we are asked to find the difference quotient. So again, this f of x plus h minus f of x over h, where h is not equal to 0. So let's look at our f of x equals the square root of x minus 10. So let me write f of x is equal to the square root of x minus 10, and then you need f of x plus h, which is equal to the square root of x plus h, just plugging that in for x, and then minus 10. So we want f of x plus h, which is this right here, minus f of x all over h. So this would be equal to, I'm going to write this down here because, again, we have a lot of work to do, so we have to fit everything on one line there. So let me put the square root of x plus h minus 10, and make this x better here, and then minus the square root of x minus 10. So that's your f of x plus h, this guy right here, and then your f of x, this guy right here. So f of x plus h minus f of x. Okay, then this is all over h. Now, your goal with these problems, as I've talked about in the lesson, is to eliminate h from the denominator. When you get to calculus, that'll be obvious why you need to do it. For right now, just trust me, that's what you want to do. So in this particular case, you want to rationalize the numerator. So to do that, you use the concept of conjugates and multiplying them together. So a plus b times a minus b is going to give you a squared minus b squared. In other words, this is your a and this is your b. So all you're going to do is multiply the numerator by the square root of x plus h minus 10. So this and this are going to match. The signs are going to be different. So that's a minus. This will be a plus now. Then this and this are going to match. So the square root of x minus 10. So it's the same thing as having a minus b times a plus b. It's just a little bit more complex, but it's the same concept. Then this is over. To make it legal, you'll have the same thing. So the square root of x plus h minus 10, this 10 could be better, and then plus the square root of x minus 10. Let me slide down here a little bit. Let me put equals here. And just thinking about this multiplied by this. So again, you're going to use that formula. This times this is done first. So you can just say that's going to be the radicand. Let's just say that that is x plus h minus 10. And then here's where you have to be very careful. You're multiplying this times this, but you have opposite signs, so you want a minus there. You need to subtract away the result. So I would use some parentheses or some brackets, whatever you want to make sure you don't make a sign mistake. But essentially, square root of x minus 10 times square root of x minus 10, let's just say that that is x minus 10. We'll just take the radicand. Again, to remove the brackets here or parentheses, you've got to change the sign of each term. So this would be a negative, and this would be a positive. Then this would be over h times this quantity, the square root of x plus h minus 10, and then plus the square root of x minus 10. Let me close that down and make this a little bit longer. Actually, I'll just redo it like this. Okay, so looking at the numerator, a lot of stuff's going to cancel. So x and then negative x, negative 10 and positive 10. So you see you just have the h there. And that's what we're looking for because we want to cancel that away. Let me slide down here a little bit. So I have h over h times the quantity, the square root of x plus h minus 10, and then plus the square root of x minus 10. Okay, so this right here is going to cancel with this right here and give me a 1. So this equals, let me slide down. We have 1 over, you have your square root of x plus h minus 10, and then plus the square root of x minus 10. So that's what we want for the answer. Let me go ahead and grab that. So we want this one right here. So it's 1 over, you have the square root of x plus h minus 10 plus the square root of x minus 10. All right, for question 18, we want to find f of g of x, given that f of x is equal to 2 over x, and then g of x is equal to 2 over x as well. So if we have f of g of x, again, just take your f of x, which is 2 over x. So we have 2 over. For x, you're going to plug in g of x, so 2 over x. So to make this easier, let me write 2 over 1, and then over, we're going to put 2 over x, like that. So this becomes what? You have your 2 over 1 times, take the reciprocal of this, x over 2. Let's go ahead and cancel this with this and say that we have x. So f of g of x is just going to be equal to x. So this right here is the one that we want. All right, for question 19, we have f of x is equal to x over, we have x plus 2, and then we have g of x is equal to 7 over x. So we want to find the domain of f of g of x. It doesn't ask us for f of g of x. So for the domain, you want to consider what's getting plugged in, and then also the composite function. So the g of x is being plugged in, and here we see that for the domain of this guy, x cannot be 0, because you have an x down there. Again, if you plugged in a 0, you'd have division by 0, which is undefined. If you looked at f of g of x, this is equal to, again, where there's an x, you're plugging in 7 over x, so 7 over x over. Here there's an x, so 7 over x, and then plus 2. Okay, so what I'm going to do is multiply this by x over x. Again, this is legal because we know that x is not 0, so this is okay. And if I multiply this by this, you're going to get just 7, right? X times 7 over x would just be 7. This would be over. X times 7 over x, again, is 7. And then plus x times 2 would be 2x. Okay, let me get rid of the scratch work here. So now what you want to do is consider the domain here. So we can see that we don't want this right here to be 0. So you could say 2x plus 7. Where is that equal to 0? Subtract away 7 from each side. This cancels. You get 2x is equal to negative 7. Divide both sides by 2. This cancels. You get x is equal to negative 7 halves. So here, x cannot be equal to negative 7 halves. So you put these two together and say that it's a set of all x such that x cannot be 0. Again, coming from this guy right here, the g of x, what we plugged in for x in f of x. And then x can also not be negative 7 halves, again, coming from the composite function. So this is the answer that we want. All right, let's take a look at question 20 now. So we have f of g of x is equal to the absolute value of x minus 3 minus 2 times the quantity x minus 3 plus 5. So we want to find f of x and g of x. So this is called function decomposition. And when you do this, there's different ways that you can get an answer. So in other words, there's not necessarily only one answer, but there's a natural intuition that you would probably get when you look at a problem like this. And of course, we're using multiple choice, so we have to go with what's available. So this x minus 3 right here, and this x minus 3 right here, that's a duplicate. So that seems like that's being plugged in for x. So let me say that g of x is equal to that x minus 3. Okay, so if I replace that with x, that would give me f of x is equal to, this would be the absolute value of x, and then minus 2 times x, and then plus 5. So see how I can take this right here and plug it in right there, and then also right there, and I'd end up with this right here. So f of g of x, again, would be equal to the absolute value of, in the place of x, it's x minus 3, and then minus, you have your 2, and then in the place of x, you'd have your x minus 3, and then plus your 5. So this is one way to do it. Again, there's other answers that would be acceptable. Because we're on a multiple choice test, we're going to go with this. So we want f of x to be equal to the absolute value of x minus 2x plus 5, and then g of x to be equal to x minus 3. This guy right there. All right, for question 21, we're asked to describe the transformation from f of x to g of x, and we have f of x equals the cube root of x, and then g of x is equal to 5 times the cube root of 2x minus 10, and then minus 1. Okay, so I have a little calculator there for you, a link for Desmos that you can click on, and you can look at the two graphs. And again, you can always check your work that way. For this one, again, I would write it in terms of f of x, and I would factor. Let me slide down here a little bit. That's going to be cut off. Well, we know f of x is equal to the cube root of x. So let me say that g of x is equal to, you have the 5 out in front, and then times f of what? Again, this right here is getting plugged in for x in that cube root of x. So I'm just going to pull out the 2. So we'll say 2 times the quantity, x minus 5. Close all that down, and then you have minus 1. So again, this is on the outside, it's vertical. This is vertical. Stuff on the inside is horizontal. Again, once you have it in factored form, again, we talked a lot about that in the lesson and the practice test, you can just work left to right. There's other orders that would work, But again, if you have it in factor form, it's just go left to right, and it's very easy to remember. So I'm just going to do this one first, this one second, this one third, and then this one fourth. So that is an order that would work. So this on the outside here, this 5 that's multiplying your function is giving me a vertical stretch by a factor of 5. This says vertically stretched by a factor of 5. This says vertically compressed. Get rid of that. Vertically stretched by a factor of 5. This one says reflected across the y-axis. We're not doing that here. That would be a negative on the inside here, so you can get rid of this. That's out. And then when we look at the second thing here, this on the inside, you have to undo that. If it's multiplication by 2, you undo that by dividing by 2 or multiplying by half. So you're looking for horizontally compressed by a factor of 2. So you have that here. This one says horizontally stretched by a factor of 2. So that's out. So this is the only one that's left. You have this minus 5 next that you would undo. You add 5, so that would shift you to the right 5 units. This says shifted 5 units right. And then you have this minus 1 on the outside. So that's where we get this and shifted 1 unit down. So this is the one that we want. Again, if you want to look at that calculator, and I circled over it. Again, you have that link where you can just click on it. If you look at sum x comma y, and you have a point there, and I gave you 2 that you can check this with. And basically, for your x value, you're going to divide by 2 first and then add 5. So it's x over 2 and then plus 5. And then for the y value, you're going to multiply by 5 first, so 5y, and then subtract away 1. So something like 0, 0, so I gave you this point, that's going to go to, well, you would have, this is going to be 0 and this is going to be 0, so it's just 5, negative 1. That's one you can check. Another one I gave you was 8, 2. Again, if you take the cube root of 8, you get 2, and that's going to go to, 8 divided by 2 is 4, 4 plus 5 is 9, and then 5 times 2 is 10, 10 minus 1 is 9, so this point 8, 2 is going to go to 9, 9. So I gave you these 2 on the graph if you want to check that, and you can try other points if you want to get some more practice. All right, for question 22, we want to describe the transformation from f of x to g of x. So f of x equals x cubed minus x, and then g of x is equal to 2 times the quantity negative 1/2 x plus 3 cubed minus 2 times the quantity negative 1/2 x plus 3, and then plus 1. All right, so this one, you just want to write it in terms of f of x. So g of x is equal to what? Notice that you have a 2 here and you have a 2 here. So think about the fact that if I multiplied 2 times f of x, I would have 2x cubed minus 2x. So let me start by putting 2 times f of, and then you're plugging something in for x. Notice you have this right here and this right here. That's a duplicate. That's getting plugged in right there and right there. I'm going to go ahead and pull out the negative 1/2. So negative 1/2 times the quantity. This would be x. And then what goes here? Again, how do I undo multiplication by negative 1/2? You want to multiply by negative 2. So 3 times negative 2 is going to be negative 6. So this is minus 6. Close that down, close this down. And then you have this plus 1 on the outside. Okay, so looking at this now, it's very simple. And we can just, again, work left to right. So once you put it in factored form, you can just work left to right. So this would be 1. This negative here, let's say that's 2. This is going to be 3. This is 4. And this is 5. And I wrote those numbers kind of small, so maybe they're not legible. This is 2, 3, 4. Okay, so starting with number 1, all the way to the left, we're multiplying by 2. Again, this is on the outside. This gives me a vertical stretch by a factor of 2. So this one says we're reflected across the x-axis. You would need a negative out in front to do that. You can get rid of this. Vertically compressed by a factor of 2, get rid of that. Vertically stretched by a factor of 2, vertically stretched by a factor of 2. Okay, the next thing is you have a negative right here on the inside. Again, that's going to give you a reflection across the y-axis. That's a horizontal reflection. So right here it says reflected across the y-axis. This says reflected across the y-axis. Then moving here, again, if I'm multiplying by 1/2, to undo that, I want to multiply by 2. So that's a horizontal stretch by a factor of 2. This one says horizontally compressed by a factor of 2, so that's out. Minus 6 there. To undo that, I want to add 6. So I'm shifting to the right by 6 units. And then outside here, I have this plus 1. So I'm shifting up by 1 unit. So this is the one that I want. I want to say vertically stretched by a factor of 2, reflected across the y-axis, horizontally stretched by a factor of 2. Again, undoing that multiplication of 1/2, you need to multiply by 2. So that's the horizontal stretch by a factor of 2. And then shifted right by 6 units. Again, this minus 6 here, you're undoing that. You're adding 6. That's why I'm shifting to the right 6 units. And then on the outside here, you have plus 1. That's giving me the shifted up by 1 unit. Again, if you want to write this in terms of some x comma y, going to what on the other graph of g of x. Again, I gave you a link on Desmos if you want to click that. I gave you 2 points. Well, this is going to be, in terms of x, you're going to do negative 2x and then plus 6. And then in terms of y, you're going to do 2y and then plus 1. Okay, so 2 points I gave you 0, 0. That's going to go to, this would just be 6, 1. That one's really easy because this goes away and this goes away. And then I gave you 2, 6. That's going to end up going to, if you plug in a 2 here, negative 2 times 2 is negative 4. Negative 4 plus 6, that's going to be 2. And then if you plug in a 6 here, 2 times 6 is 12. 12 plus 1 is 13. So 2, 13. These are the points you'll see if you click on the link. All right, let's take a look at the quiz. So for the first question, we're asked to determine if each function is 1-to-1. We are given f of x is equal to 2x minus 5. Now, in this one, I've already given you the graph, so you don't even have to go to Desmos or anything. You're just going to look at it and see if any horizontal line would impact the graph in more than one location. Again, if it does, that means that a given y value, so remember, a horizontal line is y is equal to k, so that given y value is associated with more than one x value, and it's not the graph of a 1-to-1 function. For this one, you can easily see that no horizontal line would impact the graph in more than one location. I'll just put one line in for the sake of the tutorial. So this is y is equal to 3. And basically, it only impacts the graph right there. So let's say that this point would be, we're going 4 units to the right and 3 units up. So this is 4, 3. And then basically, any other horizontal line that you sketch here is going to be the same. It's only going to impact the graph in one location. So coming down, I'm going to circle this one. So this function is 1-to-1. All right, for question 2, again, we're asked to determine if each function is 1-to-1, and we have f of x is equal to the quantity x minus 3 cubed and then plus 1. So again, looking at our graph, we can see that no horizontal line would impact the graph in more than one location. Again, a lot of people get confused about this part right here. If you want to graph this on Desmos on your own, you can really zoom in here and see that the y values are always changing. So if you actually draw a horizontal line, so right here, this would be y is equal to 1. Let me do that in a different color so it shows up a little bit better. So again, let me say y is equal to 1. Well, basically, this horizontal line is only going to impact the graph right here. So this would be the ordered pair, 3, 1. And basically, you can plug in a 1 in the place of this f of x and solve, and you can prove that to yourself. Let me just do that over here real quick. So let's say we do 1 is equal to the quantity, x minus 3 cubed, and then plus 1. Well, if you subtract 1 away from each side, you basically have that this guy right here is equal to 0. If I take the cube root of each side, I would say that x minus 3 is equal to the cube root of 0, which of course is just 0. And here I would just add 3 to both sides, and you would get that x is equal to 3. So x is equal to 3. So you see that point is 3, 1. So there's no other x value that's associated with a y value of 1. So again, if you get something that's a little bit unclear, you can investigate further by just plugging the y value in that you're curious about and then solving for x, and then see if you get one and only one x value. So here we can see that this function is going to be 1-to-1. So no horizontal line is going to impact the graph in more than one location. So I'm just going to circle this function is 1-to-1. All right, let's take a look at question 3. So again, we're asked to determine if each function is 1-to-1, and we are given f of x is equal to the quantity x plus 4 squared, then minus 1. So obviously this is the graph of a parabola, and so this is not going to be a 1-to-1 function. Let me just give you a specific example here. So let me draw a horizontal line y equals 3. And so let me write that this is y equals 3. Now this horizontal line, y equals 3, impacts the graph in two locations. So right here and then right here. So for this one right here, let's just say from the origin, we're going 2 units to the left and 3 units up. So this point right here is negative 2, 3. And then this point right here, from the origin, I'm going 6 units to the left and 3 units up. So this is going to be negative 6, 3. So the idea is that this horizontal line impacts the graph in more than one location. And so this y value of 3 is associated with two different x values, negative 2 and negative 6. And if you want to see this from the equation, again, you could plug in a 3 for your y or your f of x. So let me slide down here a little bit, and I'll just say that 3 is equal to the quantity x plus 4 squared minus 1. Just add 1 to each side. So this becomes 3 plus 1 is 4. Let me write this over here. And basically by the square root property, you know that this would be x plus 4 is equal to plus or minus the square root of 4. So the square root of 4 is 2. So you get x plus 4 is equal to plus or minus 2. So that leads into x plus 4 is equal to 2. So let's say that x plus 4 is equal to 2, or x plus 4 is equal to negative 2. So for this first one right here, if we subtract 4 away from each side, this cancels. You get x is equal to 2 minus 4 is negative 2. So that's going to be this negative 2 right here, which is associated with that y value of 3. So that's where that one's coming from. Then, or over here, if you subtract 4 away from each side, you're going to get x is equal to negative 2 minus 4. Let me make this negative 4 here a little bit better. That's going to be negative 6. So that's this x value of negative 6, which is also associated with a y value of 3. So this guy right there. So clearly you can see this is not a one-to-one function. For each y, there's not one x. Let me slide down here real quick and just say this function is not one-to-one. All right, let's take a look at question 4. So once again, we're asked to determine if each function is one-to-one. And this one's a little bit tricky. So this is f of x is equal to 1/8 x cubed and then minus 1/2 x. So if you look at this part of the graph or this part of the graph, I think you would determine that the function is one-to-one, but the problem lies in this part right here. You're going to see that a horizontal line, you could just do y equals 0, would impact the graph actually in 3 locations. Let me just sketch that in real quick. So this right here would be y is equal to 0, which of course is the x-axis. And you're going to see that you hit 3 times here. So this one right here, this would be negative 2 comma 0. So this is negative 2 comma 0. This one right here, of course, is the origin. So this is 0 comma 0. And then this right here is going to be at 2 comma 0. Now you can verify this by plugging in. You could do f of negative 2, f of 2, and f of 0. And in each case, you're going to get a y value of 0. So that tells me that y value of 0 is associated with more than one x value, so it's not one-to-one. You can also prove this. Let me just copy this real quick. You could erase this and just plug in a 0 for your y or f of x. And you can actually solve this and see you get those 3 different x values. The way I'm going to do it is I'm going to factor out an x from the right side. Let me actually flip this over. I like what I'm solving for to be on the left. So if I pull out an x, you're going to have 1/8 x squared minus 1/2. And of course, this equals 0. So from the 0 product property, you get 1 right away. You're just going to say x is equal to 0. So that's this part. And then, or you're going to get 1/8 x squared minus 1/2 is equal to 0. This is very easy to solve. You just add 1/2 to both sides of the equation. So let me actually just erase this and put this as equal to 1/2. And I would multiply both sides by 8. Let me put this or over here for right now. So multiply this by 8 and multiply this by 8. So this would cancel. 8 divided by 2 is 4. So now you get x squared is equal to 4. And of course, by the square root property, that tells me that x is equal to positive or negative square root of 4, which is 2. So plus or minus 2. So that's where you get those 3 different x values. You get 0, positive 2, and negative 2. So let me go ahead and grab this real quick and come back up here. I guess I don't need to paste this in. We already know this, so I'll just erase that. But let me slide down here and say that clearly this function is not one-to-one. All right, for question 5, again, we're asked to determine if the function is one-to-one. And now we have f of x is equal to 2 times the square root of x. So obviously looking at this, no horizontal line would impact the graph in more than one location. Let's just make a horizontal line for the sake of the tutorial. So this is y is equal to 4. So looking at this, this only impacts the graph right there. So basically this point would be 4 comma 4. So this y value of 4 is only associated with the x value of 4. And again, no horizontal line that you draw is going to impact the graph in more than one location. So this is going to be a one-to-one function. So let me slide down here and say this function is one-to-one. All right, let's take a look at the quiz. For the first question, we're asked to determine if the function is one-to-one. We're doing this using the algebraic approach. So we have f of x is equal to 1/4 x minus 3. So of course, this is just a linear equation in 2 variables. We know this is going to be one-to-one, but how do we prove this algebraically? Let me actually just grab this real quick and come down here. you're going to set up a little test where basically you say that if f of a is equal to f of b, this, again, implies that a is equal to b. So basically, if you have the same y value, then that has to be produced from the same x value if you have a one-to-one function. So basically, let me go f of a. This would be equal to 1/4, and then I'm just replacing x with a. So 1/4 a minus 3, and then f of b would be 1/4. I'm replacing x with b, and then minus 3. So you're just going to set these guys equal to each other and see if a equals b. That's all you're doing. Let me come down here and basically say that we would have 1/4 a minus 3. So that's f of a. And we would say this is equal to, my f of b is 1/4 b minus 3. Okay, so we have -3 here and -3 here. Let me just add 3 to both sides of the equation. That cancels, that cancels. You have 1/4 a is equal to 1/4 b. You can multiply both sides by 4. And so this is going to cancel and this is going to cancel. And you're left with just a equals b. So of course, this is a one-to-one function. Let's come back up here and say this function is one-to-one. All right, for question 2, once again, we're asked to determine if the function is one-to-one. So we have f of x is equal to the quantity 2x minus 3 squared minus 5. So of course, this is a parabola. We all know that at this point, so it's not going to pass the horizontal line test. So it's not going to be a one-to-one function. But let's go ahead and prove this algebraically. Let me move this over here. Let me write this rule here in case you're a little bit lost. Again, if you have a one-to-one function, then f of a being equal to f of b, so the same y value here, this implies that a equals b. So that's only produced from the same x value. So f of a is equal to, this would be the quantity 2. And again, I'm just plugging in an a for x. So this is a minus 3. This is quantity squared, and then minus 5. And then f of b is going to be equal to the quantity 2b, just plugging in a b for x, minus 3, and then squared, and then minus 5. Okay, so we're going to set these guys equal to each other. So we have the quantity 2a minus 3 squared minus 5 is equal to the quantity 2b minus 3 squared minus 5. So this is f of a, and this is f of b. So we're going to try to see if we can get a being equal to b. Of course, we won't be able to. The first thing I would do here is just add 5 to both sides of the equation. So this is going to cancel, and this is going to cancel. And now we have the quantity 2a minus 3 squared is equal to the quantity 2b minus 3 squared. Now, there's different ways to approach this problem. The simplest way is to take the square root of each side. So let me come down here, and I'm going to say this is the square root of this quantity 2a minus 3 squared is equal to the square root of this quantity 2b minus 3 squared. Now, here's where you have to be really careful and go back to what we talked about at the beginning of the course. Remember that a lot of times we'll go through here and we'll just cancel this with this, and we'll say we have 2a minus 3. But that's when we make an assumption that this guy right here, the result of this is non-negative. We don't have that assumption here. And so basically the square root of something squared, so something like the square root of, let's say, x squared, this is equal to, by definition, the absolute value of x. We can only say it's equal to x if this x here is non-negative. So we don't have anything telling us that this quantity 2a minus 3 or this quantity 2b minus 3 is going to be non-negative. So what we actually do here is say this is the absolute value of 2a minus 3 is equal to the absolute value of 2b minus 3. And then from there, let me make this a little bit better. You use your rule for absolute value. So basically, two expressions have the same absolute value if they're equal or if they're negatives. So in other words, something like the absolute value of 5 is equal to the absolute value of 5. So it's the same number. Or you could have something like the absolute value of 5 being equal to the absolute value of negative 5. These guys are negatives, but they're going to have the same absolute value. Absolute value of 5 is 5. Absolute value of negative 5 is also 5. So these guys would be equal in terms of their absolute value. So you're basically going to do the same thing here. These guys could be equal. So it could be that 2a minus 3 is equal to 2b minus 3. So just drop the absolute value bars. Or it could be true that they're negatives. So for this, let's say you go 2a minus 3 is equal to the negative of this quantity 2b minus 3. So basically on this one, you could just add 3 to both sides. And this would cancel. And you get 2a is equal to 2b. Divide both sides by 2. And you're going to get that a is equal to b. So up here, you can put that a is equal to b. But this is the one that's going to give us the issue. Here, you distribute that negative to each guy inside the parentheses. You get 2a minus 3 is equal to negative 2b plus 3. So now we would add 3 to both sides of the equation. That cancels. You're going to get 2a is equal to negative 2b plus 6. What I would do is factor a 2 out from here. So basically, this is 2a is equal to, let's pull out a 2. And then you'd have negative b and then plus 3. And then you can divide both sides of the equation by 2. This would cancel and this would cancel. For the or part here, we're going to say that a is equal to negative b plus 3. So of course, this is not going to be a one-to-one function. And if you want to prove that this works, let me copy this real quick. Let me come back up here. Let me get rid of this. And I'm going to go back to this. Let me paste this in. And let me get rid of these like this. So we can plug in here. So if a equals b, well, you could plug in a b for a. You would have 2b minus 3 quantity squared. And over here, you have 2b minus 3 quantity squared. So we know this works. Then for this one, this is where you really have to check. So we're going to come through and say, okay, well, a could be negative b plus 3. So you would have 2 times this quantity negative b plus 3, and then minus 3, and this would be squared. Let me just simplify this real quick. So this would be negative 2b, and then plus, this would be 6, and then minus 3, and this is quantity squared. So basically, 6 minus 3 is going to be 3. So this like this. And so let me write this out, and we're going to look at this real quick. So you would have, over here, negative 2b plus 3 quantity squared. We're saying, is that equal to 2b minus 3 quantity squared? Let me get rid of this. I'm just doing this to show you that this works as a solution. Let me move this over here. So essentially, what's going to happen is, from here, I could factor out a negative 1. So you could say this is negative 1 times the quantity 2b minus 3 like this. And then this is quantity squared. So basically what you can do here is say that this is negative 1 squared times the quantity 2b minus 3 squared, just using the rules of exponents. Remember, this is multiplication, so you're legally allowed to do that. I'm running out of room. Let me come down here. If you had a times b, and this was squared like this is a squared times b squared. So that's all I did. This is negative 1 times this quantity, 2b minus 3, and this whole thing is squared, so this becomes negative 1 squared times this quantity, 2b minus 3 squared. So just applying this rule here. We know that negative 1 squared is 1, so I can get rid of this, and basically I can come back to this right here, where we would say this turns into the quantity 2b minus 3 squared is equal to the quantity 2b minus 3 squared. So this does work as a solution. So we know that we're valid here in terms of what we found. So a equals b, or a equals negative b plus 3. Well, this is not a one-to-one function if that's the case. We don't just have a equals b. So let me come up here and say that this function is not one-to-one. All right, let's take a look at question 3. So we want to determine if the function is one-to-one. So we have f of x is equal to the quantity x minus 5, this is cubed, and then plus 7. Let's come down here and paste this in. And again, I just want to remind you of the rule. So if we have a one-to-one function, then we say that f of a equals f of b. So this means we have the same y value. This is going to imply, so let me write implies that. Basically, you're going to have the same x value. So your a is going to be equal to your b. Now, I want to note for this problem, because we're going to see an issue in a moment, that basically this is valid for all a and b in the domain of f. So in other words, if we solve for a or solve for b, and we get something that's a non-real complex solution, like we're going to see in a moment, then basically you can throw that out. So it's basically whatever's in the domain. So this right here, let me just write this for clarity. The domain of this guy, if we were to think about it, and you can go to Desmos and sketch the graph, you can see it's all real numbers. So I'm just going to say that it's the set of all x such that x is an element of the real numbers. And there's a fancy r that you put there, and I'm just going to put a regular r. The book will make something that looks like this, and I can never make it. But that just means real numbers, like that. So now that we know that, let's go through and set things up. We want f of a, and of course that's just going to be the quantity a minus 5 cubed plus 7, and we want f of b. So this is the quantity b minus 5 cubed plus 7. And let me paste this in here. So basically you're going to say f of a is equal to f of b. So this is the quantity a minus 5 cubed plus 7 is equal to the quantity b minus 5 cubed plus 7. So the easy way to solve this, if you're only looking for the real solutions, just subtract 7 away from each side of the equation, and you're going to get the quantity a minus 5 cubed is equal to the quantity b minus 5 cubed. And then basically what you can do is take the cube root of each side. So we'll do that over here as well. And so the cube root is going to undo the cubing, and you're going to be left with a minus 5 is equal to b minus 5. Now this is only for real numbers. So I'm just going to put here that this is for the real numbers. We want to be really specific here. So I'm going to add 5 to both sides, and this cancels, and we get a equals b. Now for the purposes of what we're doing, that's all we need. So a equals b, it's valid, it's going to be a one-to-one function. Now, let me show you what might happen. So some of you might plug this into a computer, and you might get something that's different. I'm just going to show you where it's coming from. I'm not going to go through the whole thing because it would take a long time. But essentially what you could do, let's just subtract 7 away from each side, cancel this and cancel this, and say now you have the quantity a minus 5 cubed is equal to the quantity b minus 5 cubed. And so you can actually subtract this away. So you can say you have the quantity a minus 5 cubed minus the quantity b minus 5 cubed is equal to 0. Now at this point, you could factor this using the difference of cubes formula. I would not try to do it like this. I would make a substitution. So I would do something like, let's let u be equal to a minus 5. And then you can say that w is equal to b minus 5. And so you could factor u cubed minus w cubed. And then once you get that, you could just plug back in. So let me just give you this in case you want to try. So we're going to say this is equal to, this would give me u minus w, so that quantity, and then times the quantity, you would have u squared, and then plus uw, and then plus w squared. So most of you remember that formula. Now at this point, you basically can erase this and move this over and say that this would be equal to 0. So this would match this. Again, you've got to go through and make the substitutions again. I'm not going to do it here because it's going to take a really long time. And the extra solutions we get are non-real complex solutions that we don't even need. So I'm not going to waste time. So I'm just going to show you this. If you want to pause the video and try it on your own, you're welcome to do that. But again, in the case that we're looking at here, we don't need those solutions. So we're just going to go up and say that this function is 1-to-1. All right, let's take a look at question 4. So once again, we're asked to determine if the function is 1-to-1. So we have f of x is equal to 1 over x to the 4th power. And let me come down here and paste this in. So let me do this like this. Again, if you have a 1-to-1 function and you have f of a is equal to f of b, this implies that a is equal to b. All right, so looking at this, if I want to do f of a, so f of a, this is equal to 1 over a to the 4th power, and then f of b is equal to 1 over b to the 4th power. So all you would do here is say that you have 1 over a to the 4th power is equal to 1 over b to the 4th power. Now, when you solve this one, you're going to run into the same issue that you did in the last problem. You're going to get some extra solutions, some non-real complex solutions. I guess it doesn't really matter here because either way, this function is not going to be 1-to-1. I'm just going to slide this out of the way, that the domain, so the domain, just for clarity, is going to be, let me make this a little bit better here. So the set of all x such that x is not 0. So basically, x is some real number that's not 0, because if you plugged in a 0 there, 0 to the 4th power is 0, you'd have division by 0, which is undefined, but any other real number is okay. But we're not going to plug in non-real complex numbers here, so basically we want to keep that in mind. So let's grab this real quick, and let's paste this in. I would cross multiply, so I would say this is a to the 4th power is equal to b to the 4th power. Again, you can just do this, and I like a to be on the left in this particular case, so that's how I set that up. And then at this point, if you're just looking for real solutions, so real solutions, well, all you have to do is take the 4th root of each side. So you would have the 4th root of a to the 4th power is equal to the 4th root of b to the 4th power. Remember the rule for this. The 4th root of a to the 4th power, we're not going to assume that a is some positive real number. We're going to assume that a is just any real number. So we really have to say this is the absolute value of a is equal to the absolute value of b. And so this gives me a is equal to b, or a is equal to negative b. Again, this is solving where we have real solutions, but you can see either way it doesn't work, right? So this is not going to be a one-to-one function. Now, if you wanted to look at the other guys, so something that the computer would give you, you can do it that way as well. Let me get rid of this. This one's a little bit easier than the last one if you want to go through it. You can subtract b to the fourth power away from each side. So a to the fourth power minus b to the fourth power is equal to 0. You could rewrite this as a squared squared minus b squared squared. So this equals 0. Let me actually get rid of all of this. We don't need it. We'll use the room. And at this point, you can use your difference of squares formula. So you can say that this is a squared minus b squared. And then this is a squared plus b squared, and this equals 0. Now this would further factor. So this factors into a plus b times a minus b, and this you can't factor. So you say a squared plus b squared like this, and this equals 0. So now what you have is basically this right here turns into a equals negative b. This right here turns into a equals b. And then this right here, this a squared plus b squared, that's where you're going to get these non-real complex solutions. Again, if you want to pause the video and go through that on your own, that's fine. But it doesn't really change our answer here because we're only looking at things that are in the domain for a or b. So x values that would be in the domain, and this would not be in the domain, the solutions for this part right here. So coming back up, I'm just going to say this function is not one-to-one. All right, let's take a look at question 5. So we want to determine if the function is one-to-one, and we have f of x is equal to the cube root of x minus 7, and then we have plus 5. Come down here and paste this in. Again, let me write the rule for you. So if we have a one-to-one function, so f of a equals f of b, so basically we have the same y value. This, once again, implies that this is coming from the same x value. So a is equal to b. All right, so let's start with f of a. So this is equal to the cube root of a minus 7 and then plus 5. So just plugging in an a for x there. And then for f of b, this is equal to the cube root of b, so plugging in a b for x, minus 7, and then plus 5. Okay, let me grab this real quick. So let's take f of a, which is the cube root of a minus 7, and then plus 5, and set that equal to f of b, which is the cube root of b minus 7, and then plus 5. Okay, subtract 5 away from each side of the equation. This cancels and this cancels. So we get the cube root of a minus 7 is equal to the cube root of b minus 7. And of course, I can just cube both sides. So I'm just going to cube both sides. And in each case, you're just going to get the radicand. So here I would have a minus 7, and here I would have b minus 7. So let's say a minus 7 is equal to b minus 7. And of course, if you add 7 to both sides of the equation, so this would cancel and this would cancel, and you're going to get a is equal to b. So because we get a equals to b, we're going to say this function is one-to-one. All right, let's take a look at the quiz. For the first question, we're asked to find the inverse of each function, and we are given f of x is equal to negative 1 over x, and then minus 2. I'll just tell you in advance, this is a one-to-one function. Of course, you can graph this on Desmos and see that it passes the horizontal line test. So the procedure is you're going to replace your f of x with y. So we're going to say y is equal to negative 1 over x, and then minus 2. Then at this point, you're going to swap x and y, or the book will say interchange x and y. So in other words, the y will become an x, and the x will become a y. So x equals negative 1 over y, and then minus 2. So at this point, all you really need to do is solve for y. So you have that y right there. What I would do is start things off by just adding 2 to both sides of the equation. So this is going to cancel, and you'll have x plus 2 is equal to, let's write this as negative 1 over y. There's lots of ways you could do this. Let me write this as x plus 2 over 1. What I'm going to end up doing is multiplying both sides by y over x plus 2. There's other ways to do it, but this is how I like to do it. I think it's the easiest way to explain what's going on. So essentially, these y's would cancel. And so let me wrap this for clarity. So the quantity x plus 2 over the quantity x plus 2, that's going to cancel and give me 1. So I'm going to have y is equal to, this would be negative 1 over x plus 2. Again, lots of ways you could have gotten to this. Let me slide down a little bit. You're now just going to replace this y with your inverse notation. So f inverse of x is equal to negative 1 over x plus 2. I'm going to want this one right here. So let me explain why it looks a little bit different. You see that this, if I write it out, is f inverse of x is equal to 1 over, you have negative x minus 2. So essentially, it's the same thing as this right here. You're just taking this negative and you're applying it to the denominator. So basically, it would be negative x minus 2 down here if you distribute that negative to each guy. But I'm just going to write this like this in another form. So if you were answering this and you didn't have choices to go through, basically you could give it this way or this way. It's the same thing. So I'm just going to say for the purposes of our quiz that this guy right here is the answer. So f inverse of x is equal to, we're going to have 1 over negative x minus 2, or of course f inverse of x could be equal to negative 1 over x plus 2. All right, let's take a look at question 2. So we want to find the inverse of each function. We are given f of x is equal to, we have 2 over, we have x minus 1, and then minus 3. So again, this will be a one-to-one function. Let me replace f of x with y now. So y equals 2 over x minus 1, and then minus 3. At this point, you want to interchange x and y. So again, just swap them. So x is equal to 2 over y minus 1, and then minus 3. So this y became an x, and this x became a y. So now you want to solve for y. So you have a y there. Okay, so just like in the last problem, you can go about this in different ways. What I would personally do is just add 3 to both sides of the equation, so that cancels. You would have x plus 3 is equal to 2 over y minus 1. Let me slide down here a little bit. So again, what you do here is up to you, but I'm going to multiply this by y minus 1 over x plus 3. So let me wrap that and wrap that. So basically, these guys are going to cancel. Let me do that over here. So basically, this is going to multiply by, you'll have your y minus 1 over x plus 3. Let me wrap that, and let me cancel this with this. And what you have is y minus 1 is equal to 2 over x plus 3. And then to finish things up, let me just go ahead and add 1 to both sides of the equation. Let me do that over here. So this would cancel. Slide down. And you're going to have y is equal to 2 over x plus 3, and then plus 1. Now, I don't remember what the answer was. I might have gotten a common denominator, and I might not have. But this would be a perfectly acceptable answer. You just need to change your notation. So we can say f inverse of x is equal to 2 over x plus 3, and then plus 1. Let me grab this real quick, and let me come back up here. And let's see what we have. So basically, it looks like we're going to have to change this over. So essentially, you'll have f inverse of x is equal to 2 over x plus 3. So we're going to get a common denominator, so our answer will match. So basically, you're going to multiply 1. Let's go 1 over 1. So times, you have x plus 3 over x plus 3. So essentially, this would be 2 plus this x plus 3. 1 multiplied by that would just be that. So let me write this in a more clean way. So basically, you would have 2 plus x plus 3 over that common denominator of x plus 3. And 2 plus 3 would be 5. So let's write this as x plus 5 in the numerator. Let me slide this over a little bit. And so looking through my choices, it looks like I want this guy right here. So you have your f inverse of x is equal to x plus 5 over x plus 3. Again, if you didn't have answers to select from, you could give this as an answer. It's perfectly acceptable. But because we're on a multiple choice test, we're going to go with this f inverse of x is equal to x plus 5 over x plus 3. All right, let's take a look at question 3 now. So we want to find the inverse of each function. We are given f of x is equal to the cube root, so the cube root of x plus 3, and then minus 2. Okay, so again, this is a one-to-one function. And so what we're going to do is replace f of x with y. So we'll say y is equal to, let's go the cube root of x plus 3, and then minus 2. At this point, we want to interchange x and y. So you're going to put x is equal to the cube root of y plus 3, and then minus 2. And essentially, I would add 2 to both sides of the equation, so that cancels. And you're going to have x plus 2 is equal to the cube root of this y plus 3. So the idea is that you want to get rid of this cube root guy, and to do that, we're going to raise both sides to the third power. So let me go x plus 2. That would be cubed. And this would be equal to the cube root of y plus 3. And of course, this right here would be cubed. Okay, so on the left, you have your quantity x plus 2 being cubed. And this equals on the right. So essentially, this will undo this. And you're left with that radicand there, which is y plus 3. So y plus 3. And to finish things up, I like what I'm solving for to be on the left. So let me write this as y plus 3 is equal to the quantity x plus 2 cubed. And I'm going to subtract 3 away from each side of the equation so I can isolate y. So this would cancel. You get y is equal to the quantity x plus 2 cubed and then minus 3. Okay, let me slide down here. I'm just going to replace this y with f inverse of x. And this equals, again, the quantity x plus 2 cubed and then minus 3. And let me paste this in here. And so essentially, looking through my choices, it looks like I want this one right here. So we have our f inverse of x is equal to x plus 2, so that quantity cubed and then minus 3. All right, let's take a look at question 4. So again, we want to find the inverse of each function. And we are given f of x is equal to, we have 6 minus the fifth root of 16x. Let me extend that. And then this will be over 2. Okay, let me grab this real quick. Come down here and paste this in. This one is a little bit tricky. So let me go ahead and say that, again, this is a one-to-one function. So to find the inverse, we're first going to replace f of x with y. So y equals 6 minus the fifth root of 16x, and this is over 2. So at this point, you want to interchange x and y. So in other words, you want to take this y and make it into an x, and this equals 6 minus the fifth root of your 16. Instead of x, it will be y, and this is over 2. Okay, let me slide down here. So there's a few steps we need to do. First, I would multiply both sides by 2. So I'll do that over here and then do that over here. So this is going to cancel away. And what you're going to have is 2x is equal to 6 minus the fifth root of this 16y. Let me make this 6 a little bit better. Now at this point, I'm going to subtract 6 away from each side of the equation. Let me slide down here a little bit. And so this is going to cancel. And you're going to have 2x minus 6 is equal to the negative of the fifth root of 16y. Now, there's lots of different ways you can solve this moving forward, but what I'm going to choose to do is basically factor out a 2 from this, and this is going to be a big help later on. So I'm going to say this is 2 times the quantity x minus 3, and this equals, so you have this negative of the fifth root of 16y. Now, I want to get rid of this negative. You could keep it there if you wanted to, but I don't like it. So what I'm going to do is just multiply both sides by -1. So -1 times, let's write this as -1 times this, and then I'll go -1 times this. So sliding down here, I'll just now say that this is -2 times the quantity x minus 3 is equal to -1 times -1 is +1. So this is just the fifth root of 16y. Let me paste this in and go to a new sheet. So at this point, what I'm going to do is raise both sides to the fifth power to get rid of this fifth root here. So let me do this like this. So -2 times the quantity x minus 3, and this is raised to the fifth power, and this equals, this is the fifth root of 16y raised to the fifth power. Okay, so this one is a little bit tricky if you're not familiar with the rules of exponents. We've talked a lot about those at this point. So hopefully you understand that, again, if this is multiplication here, what happens is this -2 is raised to the fifth power. So this is -2 raised to the fifth power. And then times this quantity here, x minus 3, so that's a factor, and that's raised to the fifth power. And this equals here, this will undo this, so you just have your 16y. So let me slide down here. And basically, I'm going to write this, -2 to the fifth power would be -32, and then times the quantity x minus 3. This is raised to the fifth power, and this equals your 16y. Now, again, I like what I'm solving for to be on the left. So basically, you can erase this from here. Let me just slide this over and put this like this. So 16y is equal to this. Again, that's just my personal preference. So basically, at this point, I'm going to isolate y by dividing both sides by 16. And so, of course, this is going to cancel. And what we have is y is equal to, when I think about -32 over 16, that's -2. So let me mark this out with this, and I'll put this as a -2 here. So we get -2 times the quantity x minus 3, and this is raised to the 5th power. Okay, so now to finish this up, I'll say this is f inverse of x is equal to -2 times the quantity x minus 3, and this is raised to the 5th power. And let me come back up here and paste this in. So f inverse of x is equal to -2 times the quantity x minus 3 raised to the 5th power. So we want this answer right here. All right, let's take a look at question 5. So again, we're asked to find the inverse of each. And what we have is f of x is equal to, we have our 2x minus 3 over x minus 5. Again, this will be a one-to-one function. So let me replace f of x with y. So y equals 2x minus 3 over x minus 5. Let me slide down a little bit here. You're going to interchange x and y. You have to be careful because you have an x here and an x here. So those are each going to become a y. This will become an x. So x equals 2y minus 3 over, you have y minus 5. What I would do is multiply both sides by y minus 5. So let me do that here. And let me move this over here. So x times the quantity y minus 5 like that. So this would cancel. And you're going to have, let's distribute this to each guy. So xy minus 5x. And this would be equal to, now you have 2y minus 3. So you want everything with a y on one side and everything else on the other. So basically I'm going to subtract 2y away from each side. Let me write that over here. So minus 2y like that. Let me slide down here. And so this right here is going to cancel. And then I'm going to add 5x to each side. Let me put that over here. This cancels. So you're going to have xy minus 2y is equal to 5x minus 3. So at this point, you want to factor out that y. So that's going to be common. So let's put that out in front of some parentheses. So y times the quantity, x minus 2, is equal to 5x minus 3. Let me slide down here a little bit more. So at this point, I'm going to divide both sides by the quantity x minus 2. So let's do that over here. This would cancel, and you get y is equal to 5x minus 3 over x minus 2. Let me come down here and paste this in. So at this point, I'm going to change y into f inverse of x. So this equals 5x minus 3 over x minus 2. So it looks like this is what I'm looking for here. So I want f inverse of x is equal to 5x minus 3 over x minus 2. All right, let's take a look at the quiz. For the first question, we're asked to determine if the two functions are inverses, and we're going to use function composition for this. So we're going to check to see if f of g of x equals x, and then also it needs to be true that g of f of x is equal to x as well. So let's check first off by just writing f of x is equal to the 5th root of this x plus 3. Let me actually make that a little bit shorter. So like this. And then we have minus 1. So the minus 1 is outside of that radical. Then we have g of x is equal to the quantity x plus 1 to the 5th power minus 3. So the first thing you would check, or I would say the first thing you could check, you could do it either way. You want to do f of g of x. So f of x is this. Let me write the 5th root of, where there's an x, I like to just leave a space or put some parentheses because I'm going to be plugging in there. And then you have plus 3, so plus 3. And then outside of this, you have minus 1. So let me shorten this up a little bit, and then you have minus 1. So inside of here, you're plugging in g of x, because that's where x is. So this right here is getting plugged in right there. So you have this quantity, x plus 1 to the 5th power, and then minus 3. Now, I just put those parentheses in there to show where x is. You can drop them. You don't need them. You do need the parentheses there. That's wrapping the x plus 1 because that is a quantity raised to the 5th power. So what you would notice is that you have negative 3 plus 3. So that would just cancel away and give you 0. So this becomes equal to the 5th root of the quantity x plus 1 raised to the 5th power and then minus 1 outside. So this 5th power here would get undone by the 5th root, and I'm left with x plus 1 there. So this becomes x plus 1 minus 1. And of course, this right here, this plus 1 minus 1, that's going to cancel. So I just get x. So we know f of g of x equals x. Let me just erase this. We don't need this anymore. And just put that this is equal to x. Now, we're going to go the other way now. So we're going to say that we want g of f of x. And so this is equal to what? Again, so you're going to take this right here. So you have this quantity. Again, where x is, let me just leave a space. Let me put plus 1. And then raised to the 5th power, and then minus 3. So inside of here, again, that's where x is. this f of x is getting plugged in for x in g of x. So you're going to put this fifth root, so this fifth root of x plus 3, and then minus 1 like that. And so you can see immediately that this minus 1 plus 1, those are going to cancel. Let me slide down and say this equals. You would have the fifth root of x plus 3 raised to the fifth power and then minus 3. So the fifth root would be undone by the fifth power there. So you just have the radicand. So let's just go ahead and say that this is equal to x plus 3 minus 3. And again, the plus 3 minus 3, those are going to cancel, and you're just left with x. So let me get rid of this and just say that f of g of x is equal to x. And also, let me write the keyword and here. So, and also, g of f of x is equal to x. So yeah, these guys are inverses. Let me come back up and just make it more clean. And I'll just say, yes, they're inverses. Again, f of g of x is equal to x. And also, g of f of x is equal to x. So we can conclude that they are inverses. All right, let's take a look at question 2. So again, we're asked to determine if the two functions are inverses. We have f of x is equal to the cube root of this x plus 2. And I have parentheses around x plus 2, but that's just because of how I have to write things here. You can drop these parentheses. They're not needed. Then you have g of x is equal to, you have x cubed minus 2. So again, the first thing I'm going to do is check f of g of x and see if that's equal to x. So this would be the cube root of, for x, again, this is getting plugged in for x right there. So this would be x cubed minus 2, and then you would have plus 2. So obviously this is going to work. The minus 2 plus 2, that's going to cancel and give you 0. So you get the cube root of x cubed, which equals x. So this one is okay. So let's put that this is x. Now we need to go the other way and make sure that one works. So in this case, now you're going to take this and plug it in for x there. So we want g of f of x, and that equals, you have this guy cubed. So this is going to be the cube root of x plus 2. And let me wrap that and say this is cubed, and then minus 2. So this cube root would be undone by the cubing operation. So let's say we would just have the radicand here. So we would have x plus 2 minus 2. And this plus 2 minus 2, that's going to cancel and give me 0. So we just have x. So let me erase this. And I'll just say that, again, since f of g of x is equal to x, and I'll just write that keyword in there, g of f of x is also equal to x, we can conclude that these guys are inverses. So let me just circle that they are inverses. All right, let's take a look at question 3. So again, we're asked to determine if the two functions are inverses. So you have your f of x is equal to 2 over x minus 1, and then minus 3. And then your g of x is equal to, you have negative 1 over x minus 2, and then plus 3. So we'll start with f of g of x. And most of you can eyeball this and see it's not going to work. But you would put 2 over, for x, you're plugging this whole thing in. So this has to get plugged in right there. So you have negative 1 over x minus 2, and then plus 3. And then you have this minus 1 here. So minus 1, let me extend this. And then you have this minus 3 out here. So this is one you want to definitely check to make sure you didn't get anything wrong. So you have 2 over, again, you have x right here. So this is my x. This is what I plugged in for x. This is the g of x. So g of x is negative 1 over x minus 2, and then plus 3. So I plug that in. Then I have minus 1. And then outside of all this, I have minus 3. So we know we did this correctly. Let me come down here. So first and foremost, I'll say that this is 2 over, we have 3 minus 1, that's 2. So let's write negative 1 over x minus 2, and then plus 2. Now for this one, what you could do is get a common denominator here, but I think that's a little bit slow. So let me write the minus 3 over here. And what I'm going to do is multiply the numerator and denominator by x minus 2. So you're going to see that that's going to work out quite nicely. So we're going to distribute this to each guy. Let me put this down here and say this equals, you have 2 times the quantity x minus 2. Make sure you use parentheses. Then over the x minus 2, we cancel with the x minus 2. So this is negative 1, and then plus. This is 2 times this quantity, x minus 2. And then you have minus 3 over here. Okay, let's come down. And then let's say that we have, using the distributive property, 2x minus 4 over, this would be, again, 2x minus 4, so 2x minus 4, and then minus 1. So you might as well right now just say 2x minus 5. So 2x minus 5, that's just me doing negative 4 minus 1. Then you have minus 3. So again, this is not going to work out. You can go through and simplify this further. You can multiply this by 2x minus 5 over 2x minus 5. So you can have a common denominator. I'm just doing this for the tutorial. If you're doing this on your own, just stop and say it's not going to work. So let's just say this is 2x minus 4. And then this needs to be distributed. What I would do is go plus negative here and just bring the sign with me so I don't make a mistake. So let's go minus 6x and then plus 15. And this is over the common denominator of 2x minus 5. So this would be 2x minus 6x. That's negative 4x. And then negative 4 plus 15, that's going to be 11. So plus 11. This is over 2x minus 5. And of course, this is not equal to x, so we could just stop. Okay, let's go back up, and let's say these are not inverses. Okay, let's look at question 4. So once again, we want to determine if the two functions are inverses, and we have f of x is equal to negative 2 times the quantity x plus 3 cubed, and then g of x is equal to, we're going to have the fifth root of x minus 2 over 2. Is this going to work? Absolutely not. This is one that you can eyeball and see right away it's not going to work. Let's start with f of g of x. And that would give me what? So f of g of x, this would be negative 2. And then inside the parentheses, you have x. So this right here is getting plugged in for x right there. So you would have the fifth root of x minus 2 over 2. And then you're going to have plus 3. And then this guy is cubed. So really, there's not much you can do there. I'm just going to say it's not going to be equal to x. I wouldn't even bother trying to simplify that because you're really not going to get anywhere. Let me go ahead and just erase this. We know it's not equal to x, so we can just say they're not inverses. All right, let's take a look at question 5. So again, we're asked to determine if the two functions are inverses. So we have our f of x is equal to negative 3 over x minus 2. And then we're going to have minus 3 outside here. And then we have our g of x. This is equal to negative 4 over x minus 2. And then outside we have plus 1. So this is one way you can probably eyeball it and see it's not going to work. Let's start with f of g of x. And here's your f of x. So let's put negative 3 over, for x, you've got to plug this in. This right here needs to go in for that right there. So you're going to have negative 4 over x minus 2, and then plus 1. And then you have this, let me extend this. You have this minus 2, and then you have this minus 3. Let's see what we have here. Let me slide down. So the first thing is down here, 1 minus 2 would be negative 1. So let's write that this is negative 3, and then this is over negative 4 over x minus 2, and then let's write minus 1. So then you have this minus 3 here. Again, what I would choose to do, let me slide this over, is multiply the numerator and denominator by x minus 2. So let me do that like this. So x minus 2 over x minus 2. So we would have negative 3 times the quantity x minus 2 over, this needs to be distributed to this and this. X minus 2 would cancel with x minus 2. So you have negative 4 and then minus this quantity x minus 2. Then you have minus 3. So this is going to get distributed to each guy. You're going to have negative 3x plus 6 over, this would be negative 4. This minus in front of the parentheses, just change the sign of each term inside. So this would be minus x and then plus 2. And we could just do this now. Negative 4 plus 2 would be negative 2. So this is negative x minus 2. And then you have this minus 3. So no way in the world this is going to be equal to x. Of course, you could just stop right now and say they're not inverses. But for the sake of the tutorial, I'm just going to continue until I get something that's simplified. So what I would do here is say I have negative. Let me factor out a negative. That might make this cleaner. So this would be 3x, and this would be minus 6. And this is over. Let me pull out a negative from here. So this would be x plus 2. And you could treat this as if you factor out a negative 1 from the numerator and denominator and just cancel those. And now you say you have minus 3. And let's multiply this by x plus 2 over x plus 2. And let me put this as plus negative here. So I'm going to say that we have 3x minus 6. And then this is going to be distributed here. So this would be minus 3x and then minus 6. And this would be over the common denominator of x plus 2. And so if we look at it, we have 3x and negative 3x. Those would cancel. Negative 6 minus 6, that would be negative 12. Let me just write negative 12 over x plus 2. So that's if you want to take this all the way down to being simplified. Of course, you could have got something different and still have the right simplification, but that's how I'm going to write it. Of course, it's not equal to x, so these guys are not inverses. So let's come back up and just say not inverses. All right, let's take a look at the quiz. For the first question, we're asked to find the inverse of each function, and we're given f of x is equal to the square root of x minus 7, and we're told here that x is greater than or equal to 7. Now, of course, this guy is a one-to-one function. We don't really need to list this domain restriction here because it's implied. If I was to erase this and I asked you, well, what's the domain? Remember, you can't take the square root of a negative in the real number system, so you would take your radicand, your x minus 7, and say, where is that greater than or equal to 0? So add 7 to both sides of the inequality. That cancels. And you get that restriction, so x is greater than or equal to 7. So that is something that you don't have to actually list if you don't want to. In addition, if you want to go to Desmos or any online graphing calculator, you could just key in the f of x equals the square root of x minus 7. Essentially, you see that that's at 7 right there. So basically, your x values are going to be 7 or anything larger. Then in terms of your range, I want you to notice that the smallest y is 0, and then it can be anything larger. That's coming from the fact that this guy right here, the square root of x minus 7, well, you can make that 0 by plugging in a 7 for x, and you can make it larger by plugging in values larger than 7 for x, but you can't make it negative. So coming back, let's just write down that we have f of x is equal to the square root of x minus 7, and I'm going to specifically say that x is greater than or equal to 7, and I'm also going to say that y is greater than or equal to 0. I'm just listing these things because we're going to need this one specifically in a little while when we go through. So you don't have to keep listing them. I'm just going to put it there. You can just write it down for your notes if you want. All right, so what I'm going to do now is just follow the normal procedure. So I'm going to replace f of x with y. So y is equal to the square root of x minus 7, and then you're going to swap x and y. So you're going to say that this is x is equal to the square root of y minus 7. You're going to square both sides, so you can get rid of this square root guy. So I'm going to say this is x squared is equal to the square root of y minus 7. So this being squared undoes the square root. Let me slide down here. I'm just going to say that we have y minus 7 is equal to x squared, and then I'll just add 7 to both sides of the equation. That would cancel, and you get y is equal to x squared plus 7. But this is not the inverse. If I go to Desmos, and let's say I type in g of x equals x squared plus 7, you will notice that this is not a one-to-one function. So this will not pass the horizontal line test. What you actually want is this piece right here. So remember here, the range is where y is greater than or equal to 0. So when you get to the inverse, you want to say that x is greater than or equal to 0. Let me show you that real quick. So now that I put in that restriction, you'll notice that those guys are going to be reflections across the line y equals x. So let me put that in. So once you key that in, you can see that they're reflections across the line y equals x. Notice that you have this point down here, which is 7, 0, and then you have this point right here, which is 0, 7. So basically reflecting across the line y equals x. So that would be the correct inverse. Let me bring this back up and just put a comma here and say that x specifically needs to be greater than or equal to 0, and then we'll just use our inverse notation. So f inverse of x is equal to x squared plus 7, where x is greater than or equal to 0. And let me come back up here and paste this in. So it looks like this is the one we want right here. So your f inverse of x is equal to x squared plus 7, where x is greater than or equal to 0. All right, let's take a look at question 2. So now we're asked to find the inverse of each function, and we are given f of x is equal to the square root of 3 minus x. And again, we're told that x is less than or equal to 3. It's just us listing the domain. Again, we can't take the square root of a negative in the real number system, so you just say 3 minus x. Where is that greater than or equal to 0? You can subtract 3 away from each side of the inequality. Let me just erase that from over here and put this as negative 3. And then you can divide both sides by negative 1. But remember, if you do that, you have to flip the direction of the inequality symbol. So this becomes x is less than or equal to negative over negative is positive. So this is just 3 over 1 or 3. So that's why we have x is less than or equal to 3. Again, if you want to do this on Desmos with me, I think it's helpful. So here is f of x equals the square root of 3 minus x. And then if you grab this with your mouse, you see you have 3 comma 0. So basically, the largest x value is 3, and then it could be anything less. Now, if you think about the range, again, the y value, the smallest it can be is 0, and it can be anything greater. So keep that in mind as we're looking for our inverse. So let me write out f of x is equal to the square root of 3 minus x. And once again, I'm going to replace f of x with y. So y is equal to the square root of 3 minus x. And then I'm going to swap x and y. So this is x is equal to the square root of 3 minus y. And then at this point, I'm going to square both sides. So this is x squared is equal to, so this would be the square root of 3 minus y being squared. Let me slide down here a little bit and just say that the squaring would undo the square root. And so we have x squared is equal to, I'm just going to have the radicand. So that's 3 minus y. And then I want to solve for y. So let me subtract 3 away from each side of the equation. This cancels. And what you're going to have is negative y is equal to x squared minus 3. So at this point, I would divide both sides by -1, or you can multiply both sides by -1. So let's do a -1 times this, and I'll make this as a -1 times y, like that. And then I'm going to multiply this side by -1. Let me move this over here so this is crystal clear. So -1 times -1 is +1. So this is y is equal to, this would be negative x squared and then plus 3. Now, is this the inverse? No, this is not a one-to-one function. So once you key this in, you're going to get this graph in purple. Obviously, that's not a one-to-one function, so it's not going to be our inverse. You have to remember that with this f of x equals the square root of 3 minus x, the range was where y is greater than or equal to 0. So that means in the inverse, the domain will be where x is greater than or equal to 0. So you want this to start right there, basically at this 0, 3, and then any x value that's greater than that. So let's go ahead and key that in here. So you see what that does? It produces this reflection across the line y equals x. Let's key that one in just so we can see it. So again, you have a point right here that is 3, 0. And you have a point here that is 0, 3. Again, reflections across the line y equals x. You can go to Desmos and play around with this if you want. Essentially, we know that we need to restrict the domain of this. So let's go back and let's just say that here, x needs to be greater than or equal to 0. So that would be your inverse. So let's say this is f inverse of x is equal to negative x squared plus 3, where x is greater than or equal to 0. So let's grab this. Let's come back up here and paste this in. So let's look through our choices. So it's not this one, and it looks like it's not this one, and it's this one. So it's f inverse of x is equal to negative x squared plus 3, where specifically we're saying that x is greater than or equal to 0. All right, let's take a look at question 3. So here we're asked again to find the inverse of each function, and we are given f of x is equal to x squared minus 6x plus 11. Now this is not a one-to-one function. Let me go to the graph real quick with you. So again, I've keyed this into Desmos, so f of x equals x squared minus 6x plus 11. This is obviously not a one-to-one function. It would fail the horizontal line test. So if you want to find the inverse, you need to restrict the domain. Now what we did was, came down here to the vertex. To the vertex, I'm trying to point on it. There it is. So it's 3, 2. So we said that x is specifically less than or equal to 3. So that's going to give me this piece of the graph right here on the left. Let me key that in. So once you do that, you see that restricting the domain is going to give you a one-to-one function with the same range. So that's the purpose of doing that. Let me come back and let me put a comma in here and just move this down here and say x is less than or equal to 3. Okay, let's grab this real quick and let me paste this in. Okay, so we're going to go through our normal procedure. The only difference is when you have something that's not one-to-one and you're working on it, you need to make sure you list the restriction in each step. So let me just change this f of x into y. So this equals x squared minus 6x plus 11. And again, I'm going to list that x is less than or equal to 3. And at this point, I want to swap x and y. Now you do have an x here and you have an x here. So let's go ahead and say that we have x is equal to y squared and then minus 6y and then plus 11. Okay, let me list here that in this case, because we swapped x and y, that now y will be less than or equal to 3. So that's going to come into play in a moment. So let me put a little border here. Now let's think about how we can solve this for y. So the first thing is you could use the quadratic formula. So if you're trying to solve for y, you could say that this is y squared and then minus 6y and then plus 11. And you could subtract x away from each side. So minus x and say that equals 0. So what you could do is say that your a value is going to be 1, your b value is going to be negative 6, and then your c value is this right here. So 11 minus x. So we're just going to plug in, let's come down here, and say that y is equal to, we're going to have the negative of b. Let me just write it out. So plus or minus the square root of b squared minus 4ac all over 2a. I know most of you know this, but I thought I'd write it out first. So for b, it's negative 6. So the negative of negative 6 is positive 6. So let's just put 6 there. Then you have b squared. Well, b is negative 6. Negative 6 is squared. So that would be positive 36. Then you have minus 4ac. So this is the tricky one. So let's put plus, we'll go negative 4 times a, that's 1. Let me actually just not even write that. And then times c, that's 11 minus x. Let me move this down here like that. And then 2a, a is 1, so this is 2. Okay, let me slide down here a little bit. I need a lot of room to simplify this. So we're going to say this is y is equal to 6 plus or minus the square root of, you have your 36, and then negative 4 times 11 is negative 44, and then negative 4 times negative x is plus 4x. Now 36 minus 44 is negative 8. So let me actually write this as 4x minus 8. Okay, then this is over 2. At this point, I want you to look inside of here and notice that you have a common factor of 4. 4 is a perfect square, so if you see that, you need to take advantage of it. So y equals 6 plus or minus the square root of, you have 4 times the quantity, x minus 2, and then this is over 2. The square root of 4 is 2. So in other words, you can break this up and say it's the square root of 4 times the square root of x minus 2, and the square root of 4 is 2. So you just write it like that. Let me slide down. And so you get y is equal to, I'm going to factor out a 2. So 2 times the quantity, 3 plus or minus. If this gets pulled out, you could put a 1, but really you don't need to. So let's just put the square root of x minus 2. And then this is over 2. And of course, this is going to cancel. So now you have y is equal to 3 plus or minus the square root of x minus 2. Now here's where we're going to stop. And again, let's go back to the graph. We said that the domain of this function that we're working with is where x is going to be less than or equal to 3. So you see it's 3 at the greatest, and anything less than that's okay. So when you get the range of the inverse, you want it to be y is less than or equal to 3. We wrote that earlier. If you come back up here, so see we wrote that earlier. So y is less than or equal to 3. So coming back here, let me list that y is less than or equal to 3. Now look at what you have here. You have 3 plus or minus the square root of x minus 2. Do I want the plus? No, I only want the minus. Why do I only want the minus? Because y can be 3. So let's say that this right here, let's say I plugged in a 2 for x, and 2 minus 2 is 0. So this would be 0, so I have 3 minus 0, which is 3. So y can be 3, that's okay. Or it can be anything less than that. If you plug in something here that is greater than 2, you're going to get a positive result here, and 3 minus some positive number is going to be less than 3. So you will satisfy this guy right here. So you do not want plus or minus, you just want the minus. So this is going to be your inverse. You want to say that this is f inverse of x is equal to 3 minus the square root of x minus 2. All right, this one's a little bit harder to see unless you're going to zoom in. So I've keyed everything in. So I have my f of x equals x squared minus 6x plus 11, where again, x is less than or equal to 3. So that's the graph in red that we've been working with. The g of x, that's the inverse. So it's 3 minus the square root of x minus 2. That's going to be this guy in blue. So it's a little bit hard to see. And then you have y equals x. Again, you're showing that this is a reflection. So if you look at this point right here, let me see if I can get on it here. So this is your 3, 2. If you look on the guy in blue, your inverse, you see you have 2, 3. So those guys are reflected across the line, y equals x. Now I want to put another graph in here real quick. Let me just undo this one real fast and put in another one. I'm going to show you if you take the positive, or actually I could just change this real fast. That would be a little bit quicker. So let me do that again. Now notice if I put the plus in here, for those of you who are wondering about the plus one, that doesn't work, right? These are obviously not reflections across the line y equals x. So you know that you need the minus there. So just putting it back to what it was, again, this is how you can tell if you got the right answer. So just key it into Desmos and check it out and see if it's a reflection across the line y equals x. You can immediately tell if you got the right answer or not. All right, so coming back, this is written a little bit differently. So let me write it in that form. So f inverse of x is equal to the negative of the square root of x minus 2, and then you'd have plus 3. So this is how it's written. Again, if you want to do it the other way, if you're answering without multiple choice answers, that's going to be fine. But I'm just going to select this one right here. This is what we want. So f inverse of x is equal to the negative of the square root of x minus 2, then plus 3. This domain restriction of x is greater than or equal to 2, that is actually not necessary when you're listing this, because when you look at this right here, we know we can't take the square root of a negative in the real number system, so you can actually leave that off of your answer. It's not required. I just put it in here specifically because we're dealing with domain restrictions, and so I'm just adding it in for completeness. Okay, let's take a look at question 4. So now we want to find the inverse of each function. We have f of x is equal to 1 over, you have x squared minus 6x and then plus 9. Now I would note that this guy can be factored. This is a perfect square trinomial. If you saw something like x minus 3 quantity squared, this turns into x squared, then minus 2 times this guy, so that's 6x, and then plus this guy squared, which is 9. So you could write this as 1 over the quantity x minus 3 squared, and then what we're going to do is actually restrict the domain. So we're going to say x is greater than 3. So let me go to Desmos real quick. So I'm just writing this as f of x equals 1 over x squared minus 6x plus 9. If you want to do 1 over the quantity x minus 3 squared, that's fine. It'll give you the exact same graph. So right now I have not restricted the domain, and you can see that it's not a one-to-one function. Let me come up here, and I'm just going to type in the restriction that x is greater than 3. So now you get a one-to-one function with the same range. Let's come back up, and let's go ahead and grab this. So this one is a little bit of work. Let me put this down here like this. The first thing I'll do is just write y is equal to 1 over this quantity x minus 3 squared. And we'll say that x is greater than 3. Now I'm going to swap my x and y. So x is equal to, let me make that a little bit better there. So we have 1 over the quantity y minus 3, and this is squared. And now, instead of saying x is greater than 3, we're going to say y is greater than 3. Lots of ways you could solve this. And what I'm going to do, I think this is the fastest way. I'm just going to raise both sides to the power of -1. So you would have x to the power of -1 is equal to, you would have 1 over this quantity y minus 3 squared raised to the power of -1. So this becomes 1 over x is equal to, this would be applied to each guy. 1 to the power of -1 is still 1. Let me actually move this down, kind of in the way. Let me move down here. This 3 looks terrible. Let me redo it. We would say this is over your quantity y minus 3 being squared, that's raised to the power of -1. So power to power rule, 2 times -1 is -2. So this becomes the quantity y minus 3 raised to the power of -2. But again, you can drag this across the fraction bar and change the sign of this exponent. So you can really say that this is y minus 3 squared. So let me move this up here. Now, we're trying to solve for y. Here's where the trouble comes. Again, remember that y is greater than 3. Let me just copy this again. So if y is greater than 3, when we do this and we take the square root of each side, typically we would say that y minus 3 is equal to plus or minus the square root of 1 over x. So if you add 3 to both sides, let me come down here a little bit, what's going to happen is this would cancel and you get y is equal to plus or minus, let's go the square root of 1 over the square root of x, and of course the square root of 1 is 1, and then you have your plus 3. Now looking at y is greater than 3, let me just highlight that real quick. What does this tell me? Do I want plus or minus here? No, I just want the plus. You can get rid of the minus, and the reason is simple. This right here is always going to be a positive real number. Why? Because it can't be 0. For you to get a 0 out of a fraction, the numerator has to be 0, and the denominator has to not be 0. Well, the numerator is 1, so that's never going to happen. You also can't plug in a 0 for x because that would give you division by 0, which is undefined. And you can't plug in a negative because you can't take the square root of a negative in the real number system. So essentially we know that looking at this, this would be something that's a positive real number plus 3. So that's going to be something that is going to give me a y value that's greater than 3. That's what I want. If you choose the negative, you're not going to get that because you're going to have 3 minus some positive real number. That's going to be something that's less than 3. So that's not what you want. So this right here is going to be the inverse. And you can clearly see that the domain here would be where x is strictly greater than 0. And let me slide down here. And the way we wrote the answer was we got a common denominator. So let me write y is equal to 1 over the square root of x. I'm going to multiply this by the square root of x over the square root of x. Let me make that a little bit better there. And then plus, let me write 3 over 1. And basically you're going to get y is equal to, let's write the square root of x over x, and then plus, you're going to go 3 over 1. Let me do this over here. So this would be times x over x. So now this would just be 3x. So 3x over x. So all you really need to do at this point is say y is equal to the square root of x plus 3x over the common denominator of x. And then you just change your notation. So f inverse of x is equal to the square root of x plus 3x over x. All right, so I went ahead and just sketched everything on Desmos already. I had trouble with the hit markers coming up when I mouse over them, so I just put some labels in. This is something you can do if you want. So basically you see that this graph in green, that's the one we were working with initially. So your f of x equals 1 over x squared minus 6x plus 9, where x is greater than 3. And then your graph in red, that's the inverse. So this is g of x, or you could say f inverse of x, but Desmos doesn't take that, equals square root of x plus 3x over x. So that's the guy in red. You can see, again, there are reflections across the line y equals x. If you pick a point on this graph here, you see it's 4, 1. Well, again, if you reflect across the line y equals x, you see the point here on the inverse is 1, 4. Okay, let's come back up here and let's look for our answer. So it looks like we want this one right here. So we want the f inverse of x equals the square root of x plus 3x over x. And again, I just put here that x is greater than 0. But if you're listing this on your own, you do not have to put the x is greater than 0 here, because I can look at this and determine that x is greater than 0. You only need to put that in when you need to put a restriction in that's not obvious. X is greater than 0 is obvious here, so you don't actually have to write it. I'm just putting it in there for this section only. All right, let's take a look at question 5. So again, we want to find the inverse of each function. We're going to see here that we have f of x is equal to, we have x squared minus 4, and then this is over 2x squared. So again, if you go to Desmos and you type in f of x equals x squared minus 4 over 2x squared, you're going to get this graph right here. So obviously this is not a one-to-one function. So we're going to restrict the domain, and we're going to say that x is greater than 0. So you're going to get this right part of the graph right here. So now it's going to be a one-to-one function, and so we'll be able to get an inverse. So coming back, let me put a comma and put x is greater than 0. So let me grab this. Okay, so the first thing is we're going to put y is equal to x squared minus 4 over 2x squared. Now you could factor this. This is the difference of squares, but I don't think that's going to help you. So I'm not going to do that here. So let's put x is greater than 0 here. And let's come down and let's swap x and y. Now you have to swap everything. So in other words, this y is going to be an x, and then this x is going to be a y, and so will this one. So this is y squared minus 4 over 2y squared. And now you're going to say that y is greater than 0. So keep that in mind because we're going to need that. I would multiply both sides by 2y squared. So you would have 2y squared times x is equal to, you would have y squared minus 4. Let me actually show this so nobody is lost. I'm going to multiply this by 2y squared and multiply this by 2y squared. So in other words, this guy right here would cancel with this guy right here. So that's how I got that. At this point, you want to get everything with a y involved to one side. So I would subtract y squared away from each side of the equation. So this would cancel. You're going to get 2y squared x minus y squared is equal to negative 4. At this point, you have y squared and y squared. So just factor it out. So I'm going to say that this is y squared times the quantity 2x minus 1, and this equals negative 4. Okay, so I'm going to divide both sides of the equation by 2x minus 1. So let's do that over here as well. So this would cancel and this would cancel. So now I have y squared is equal to negative 4 over 2x minus 1. Now keep in mind that we said that y is going to be greater than 0. Let me paste this in. And if we take the square root of each side, typically we'll say y is equal to plus or minus the square root of negative 4 over 2x minus 1. But again, I said that y was greater than 0, so I don't want the negative of the square root because that would give me negative y values. I just want the principal square root. Now this is a little bit tricky to simplify. What I'm going to do to not end up with something with the imaginary unit I involved, I'm going to bring this down here, and that's perfectly legal. I'm going to say this is y is equal to, let's go the square root of 4 over, you're just going to apply that negative to each guy there. So I'm going to say this is negative 2x and then plus 1. Remember, that's legal because if you have negative a over b, this is the same as a over negative b, which is just negative a over b. So you can do whatever you want there. So I can legally take that negative and apply it to the denominator. Just make sure it goes on each term. Okay, so let me get rid of this. And now what we can do is split this up. I can say y is equal to the square root of 4 over the square root of negative 2x plus 1. We know the square root of 4 is 2. So let's say that y is equal to 2 over the square root of negative 2x plus 1. Let's rationalize the denominator. So times the square root of negative 2x plus 1 over the square root of negative 2x plus 1. Okay, final step. Let's say y is equal to 2 times the square root of negative 2x plus 1 over square root of negative 2x plus 1 times square root of negative 2x plus 1 would give me negative 2x plus 1. So this would be the inverse. Let's just change the notation. So f inverse of x is equal to, we have 2 times the square root of negative 2x plus 1 over negative 2x plus 1. Okay, so I went ahead and keyed everything into Desmos. So basically you have your f of x equals x squared minus 4 over 2x squared, where x is greater than 0. So that's my graph in green. We saw that one already. You have the line y equals x, and then you have your inverse. Again, I'm keying this in as g of x. So this equals 2 times the square root of negative 2x plus 1 over negative 2x plus 1. So this graph in black. Again, you can see these guys are reflections across the line y equals x. Here's your point that's 2, 0. Reflect across the line y equals x, and you get the point 0, 2. So you can see this more clearly. You can just zoom out as much as you need to. Okay, let me paste this in. So it looks like the answers are slightly different. So the way it's written, so if you wrote f inverse of x is equal to 2 times the square root of, this is basically 1 minus 2x in the answer over, this is 1 minus 2x here. Again, it's the same thing, just a different way to write it. It's going to be this one right here. So this is what we want. So f inverse of x is equal to 2 times the square root of 1 minus 2x, and then over 1 minus 2x. And again, you can list the domain where you say x is strictly less than 1/2, but it's not required here because this is a one-to-one function. If you look at the graph, it will pass the horizontal line test. So there's no need for this. Again, I'm just putting this in for this section only. I just want you to know that if you're asked to find this in the future, you don't want to list this when it's not required. All right, let's take a look at the quiz. For the first question, we're asked which equation matches the given graph. So we're given this graph right here. And I just want to note we have some points that are highlighted to us, and let me call this red, even though it's probably closer to a maroon or something. This point right here, from the origin, you would go 4 units to the left and 7 units up. So let me label that as, let's go negative 4, 7. Then this point right here, you're going 3 units to the left and 3 units up. Let me label that and just say this is negative 3, 3. And then this point right here, from the origin, you're going 2 units to the left and then 1 unit up. So this right here is going to be negative 2, 1. And then this point right here, you're just going from the origin 1 unit to the left. So negative 1, 0. And this point right here, it's hard to see because of the notches, but actually it's going to be 0 for the x value, and then negative 0.5 for the y value. Okay, so you have your points there. Now, how do we get a solution? Well, of course, if you wanted to, you could just take points and you could start plugging them in until you get a match. So you could do it that way. But what I would suggest is actually using graphing transformations, just so you can reinforce what you learned in the lesson and also the practice test. So one thing you would notice, let me go back up for a second, is that this guy is a decreasing function. So over its entire domain, it's decreasing. So let's come back over here and let's think about, you have a base of 1/2, you have a base of 1/2, you have a base of 2, you have a base of 1/2, and you have a base of 2. Well, if you have something like, let's say f of x is equal to 2 to the power of x, this is increasing over its entire domain. If you have something like f of x is equal to 1/2 raised to the power of x, this is decreasing over its entire domain. So right away, I'm going to mark out this choice right here, and I'm going to mark out this choice right here. So I have this one, and this one. Okay, let's look at them. So this one is f of x is equal to 1/2 raised to the power of x minus 1, and then minus 1. Now this one, if you compare it to, let me just write this as g of x. So I'll write g of x is equal to 1/2 raised to the power of x. Well, what's going to happen? This minus 1 right here is going to shift me to the right by a unit, and this minus 1 here is going to shift me down by a unit. So let me just put here that this is going to shift right. I'll just put R1, and then I'll put a comma, and I'll put D for down 1. What about this one right here? So let's go f of x is equal to, we have our 1/2 raised to the power of 1/2 x, and then plus 1. Well, this one, if you look at the 1/2 that's multiplying x, that's giving me a horizontal stretch by a factor of 2. So let me put HS for horizontal stretch, and I'll just put 2. And then this plus 1 right here, that's going to shift me up by 1. So let me put U1. Okay, this one right here, let's go f of x is equal to, let's go 1/2 raised to the power of x plus 1, and then minus 1. Okay, so this is x plus 1, so that's going to shift me to the left by 1 unit. And this minus 1 is going to shift me down by 1 unit. Okay, let's just go down where I've set up a little graph for us. So you can do this as a hand sketch. It doesn't have to be perfect. This graph in black is going to be your, let's call it g of x is equal to 1/2 to the power of x. Now this right here in blue, this is the graph. We're trying to find out what is the equation of this. So f of x is equal to what? Well, basically I have my points already set up for us. I want you to notice that if you look at this point right here and this point right here, well, the x value is -3, and here the x value is -4. So that means I'm going to shift to the left by 1 unit. So let me put left 1. And then this y value of 8 becomes a y value of 7. So that means I'm going down by 1 unit. Let's continue. Let's go on this one and this one. So we have -2, 4 and -3, 3. So I'm going to again shift to the left by 1 unit. I'm going from -2 to -3 and shift down by 1 unit. I'm going from 4 down to 3. So it's the same left 1, down 1. If you keep looking at the points and comparing them, so this -1, 2, and then -2, 1, this 0, 1, and then -1, 0, and then this 1, 0.5 and 0, -0.5, again, you're going to see that same pattern of shifting to the left by 1 and then down by 1. So let's come back up. Here we see left 1, down 1. So this is the answer we want. And I'm going to circle this one right here. So you want f of x is equal to, we have our 1/2, that's the base, raised to the power of x plus 1. So that's creating that shift to the left by 1 unit. And then -1, and that's giving you your shift down by 1 unit. So this is what you want. All right, for question 2, we're asked which equation matches the given graph. So this is what we're given here. So these 3 points, they're very easy to identify. So this one right here, let's say we're going from the origin 4 units to the right and 8 units up. So this would be 4, 8. This one, we're going from the origin 3 units to the right, 2 units up. So this would be 3, 2. And then this one right here, from the origin, we're going 2 units to the right. So let's say this is 2, 0. And this one is tricky. You really don't need it to solve the problem. I'm going to go ahead and give it to you, and then you can just verify it's on the graph later. So this one right here is actually going to be +1, which is easy to see, comma. This is the hard part because you don't know where it is because of the notches. This is just -2 thirds. I want to mention here that this guy is increasing over the entire domain. So coming back here, let's think about what we have. You have a base of 1/3, you have a base of 3, a base of 3, a base of 3, and a base of 1/3. If you have f of x is equal to 3 to the power of x, this is increasing over its entire domain. If you have f of x is equal to 1/3 raised to the power of x, this is decreasing over its entire domain. So what I'm going to do is I'm going to remove this right here, and I'm going to remove this right here. Those are going to be decreasing over their entire domain, so you don't need to worry about them. Okay, now I'm going to focus on what we have left. So let me first write g of x is equal to 3 to the power of x. So I'm just going to compare everything to that. And so this right here is f of x is equal to 3 to the power of x minus 2 and then -1. So what does this do? This x minus 2 is shifting me to the right by 2 units. So let me put right 2 units, so R2. And this -1 here, that's going to shift me down by 1 unit. When I look at this one, we have f of x is equal to 3 to the power of x plus 2 and then +1. Okay, so this right here, this x plus 2, that's going to shift me to the left by 2 units, so L2. And this +1 here is going to shift me up by 1 unit. All right, now looking at this one, you have f of x is equal to 3 to the power of 2x and then -1. That 2 that's multiplying x is giving me a horizontal compression by a factor of 2. So horizontal compression by a factor of 2. So then when we look at this -1, that's going to shift me down by 1 unit. So down by 1 unit. Okay, so let's go down to something that I've already sketched. So this right here is my g of x is equal to 3 to the power of x. Let me make this a little bit better here. Okay, so what I'm going to do is look at this point and just compare them. This is 2, 9, and this is 4, 8. So all I'm doing is my x value is shifting 2 units to the right, and then my y value is shifting 1 unit down. So right by 2 units, and then 1 unit down. So down by 1 unit. This one here, 1, 3. This one's 3, 2. So again, I'm going 2 units to the right and 1 unit down to go from this point to this point. This is 0, 1. This is 2, 0. Again, I'm going 2 units to the right and 1 unit down. This is -1, 1/3. And this is 1, -2/3. So I'm going 2 units to the right, so from -1 to +1, and then I'm going 1 unit down. So from 1/3 down to -2/3. So again, that's how you can figure out where that is on the graph, that point that is a little bit tricky to find. So this is, we're shifting right by 2 units and down by 1 unit from this graph right here. So that would give me that my f of x is equal to, you'd have 3 to the power of, how do I shift to the right by 2 units? I go x minus 2. And then how do I shift down by 1 unit? I go -1. Okay, so that's what we want. So let's come back up here and paste this in. Or again, you can just go with this right here, right by 2 and down by 1, or you can do it this way. It doesn't really matter. Let me erase everything. So let me drag this up here. This is what we're looking for. So it's going to be this one right here. So f of x is going to be equal to 3 to the power of x minus 2, and then -1. All right, let's take a look at question 3. So once again, we're asked which equation matches the given graph. And so going off this, the first thing I would notice is that this guy has been reflected across the x-axis. That's just something I noticed right away. If you go down to the choices, you're going to see that there's negatives in front of everything. So in other words, let's say that you had g of x was equal to 3 to the power of x, or you had something like, let's go h of x is equal to 1/3 raised to the power of x. Well, when you put a negative in front of one of these, you get a reflection across the x-axis. And that's what we see. You have a negative, a negative, a negative, a negative, and a negative. So if I think about this, let me go back up for a moment. Without doing the points yet, if this was reflected across the x-axis, you'd have something that looks like that. So that's going to be increasing over its entire domain. So that means I can get rid of this one right here, this one right here, and this one right here. It's not going to be 1/3 for the base. It's going to have to be 3. So that greatly removes a lot of the choices we have to go through. Now let me go back up for a moment. Now let's just look at some of these points. So this one right here, this is 3 units to the right and 8 units down. So this is 3, -8. This one right here, it's 2 units to the right and 2 units down. So this right here is 2, -2. This one right here, I'm just going 1 unit to the right. So this is 1, 0. And this one, again, is very hard to get. You can say that it's going to be 0 in terms of the x value. And then the y value is actually going to be 2/3. And you can keep those points. You can write them down. I'm just going to go down here. And I'm going to think about how these guys are related to this guy right here. So this negative in front of each one, that's going to give me a reflection across the x-axis. So let me put reflect. I'm just going to put ref. And then I'm going to put x for x-axis. And then this x minus 1, that gives me a shift to the right by 1 unit. So I'm just going to put R1. And this +1 right here, that's giving me a shift up by 1 unit. Then when I look at this one, again, the negative out in front, that's going to reflect across the x-axis. Then when I look at x plus 1, that's a shift to the left, so the left by 1 unit. And then the +1 here is going to be up 1 unit. Okay, so really the only difference between the two is if I'm shifting to the right by a unit or shifting left by a unit. So what I would do is sketch the graph of, let's go g of x is equal to, let me make that better. So this is 3 to the power of x. We know what that looks like. So in terms of figuring out what's going on, I would start with this point right here and this point right here. So how do I get from this point right here to this point right here? Well, again, I know that there's going to be a shift, and it looks like to the right by 1 unit. So let's say, and I don't have a marker for 3, let's just say 3 is right there. Let me make sure that lines up, and yes, it does. Okay, so at this point, I'm just going to say that I would be at 3, 9. That's just me shifting to the right by 1 unit. Then I would reflect across the x-axis. So that would put me down here, and I don't have a notch for that. But let's just say I come straight down here, and let's say that this down here would be 3, -9. So that point right there. Now, the last thing I'm doing is I'm adding 1. So I'm shifting up by 1 unit to get to the 3, -8. So let's go through those steps again. And I'm going to write f of x is equal to, so based on those steps, I know I shifted to the right by 1 unit. Let me put 3 to the power of, shifting to the right by 1 unit is going to be x minus 1. I know I reflected across the x-axis, so I put the negative out in front for that. And then I know I went up by 1 unit, so I'm going to go +1 with that. So this is what I actually want. And again, you can start verifying this with other points. Let me get rid of this and get rid of this. We don't need that anymore. Let's take this point 1, 3. So if I follow this, again, I would go 1 unit to the right. So that would put me right there. So that would be at 2, 3. Let me just label this. So this would be 2, 3. Then I would reflect across the x-axis. So I would come down here. My x value would still be 2, but my y value would be negative 3. So let's just say that's right there. So let's say this would be 2 comma negative 3, and then I would shift up by 1 unit, and I would get to that point right there, which would be 2 comma negative 2. So you see how you can go from this 1 comma 3 to this 2 comma negative 2. And again, you can go through the rest of the points on your own. You'll see that it's going to be the same process. Let me go ahead and grab this real quick. This is going to be our answer. And let me move this up here. So we want our f of x is equal to the negative of 3 raised to the power of x minus 1 and then plus 1. That's our answer. All right, let's take a look at question 4. So we want to find the transformation from f of x to g of x. We have f of x is equal to 5 to the power of x, and we have g of x is equal to 1/3 times 5 to the power of x plus 2, and then minus 3. Let me actually write this out. So here's my f of x. So this equals 5 to the power of x. I'm going to write g of x in terms of f of x. So f of x is 5 to the power of x. Here, you have 5 to the power of x plus 2. So I'm going to say this is equal to, let me put this f of x plus 2, because x plus 2 is getting plugged in for x right there. Then it's being multiplied by 1/3, so let me put the 1/3 out in front. And then we have this minus 3 at the end. So when I think about what's happening, you have this 1/3 that is multiplying your function. That is giving me a vertical compression by a factor of 3. So notice here you see vertically compressed by a factor of 3. Inside the function you have x plus 2. So that's giving me a shift to the left by 2 units. So that's going to be this part right here. Shifted 2 units left. And then outside right here, you have this minus 3. That's going to shift me down by 3 units. So that's this part right here. So this is what we want. We want to say that's going to be shifted 2 units left, vertically compressed by a factor of 3, and then shifted down by 3 units. So this was the one we want. All right, let's take a look at question 5. So again, we want to find the transformation from f of x to g of x. So here, the f of x that we're given is going to be 1/4 raised to the power of x. And then I'm going to write g of x in terms of f of x. So you have 8 times 1/4 raised to the power of x plus 5 and then minus 3. So first, let me put my f of x plus 5. So x plus 5 is being plugged in for x. So that's why I write f of x plus 5. You have 8 that's multiplying this. So 8 times f of x plus 5. And then on the outside here, you have this minus 3. So I'm going to start with this 8 that's multiplying this guy, and that is going to vertically stretch me by a factor of 8. So if I look, I see this one right here, vertically stretched by a factor of 8. What happens on the inside? So we have f of x plus 5. This is going to give me a shift to the left by 5 units. And if you notice, shifted 5 units left. And then this minus 3 on the outside, that's going to shift me down by 3 units. Again, you have this shifted down by 3 units. So it's going to be this one. We're going to be shifted 5 units left, vertically stretched by a factor of 8, and then shifted down by 3 units. All right, let's take a look at question 1. So again, we want to solve each equation. We have 1/36, and this is raised to the power of 3x, then times 6 squared, and this equals 1/6. So let's think about this for a moment. You see you have 36, 6, and 6. So I'm going to use 6 as that common base that I'm trying to get to. Again, let me write this rule out. I'm just going to copy this real quick and come down here. For those of you that have skipped the practice test and the lesson, maybe you're just doing the quiz. Again, if you have something like, let's say 4, we'll say a is greater than 0, so a is some positive real number, and we'll say a is not equal to 1, well, the rule is if you have a to the power of x is equal to a to the power of y, well, then it's going to be true that x is equal to y. So provided these conditions hold. So the idea here is that I would want to get this to the point where I have 6 to some power equals 6 to some power. So that's the idea here. So for this one, 1/36, let's write that as 1 over, this would be 6 squared, and this is raised to the power of 3x, and then times 6 squared is equal to 1/6. Remember, if I want to drag this across the fraction bar, I'm just going to change the sign of the exponent. So I could legally write this as 6 to the power of -2, and then this would be raised to the power of 3x, and then times 6 squared, and this equals 1/6. And of course, 1/6, you could write that as 6 to the power of -1. Okay, at this point, I'm going to use my power to power rule. So 6 would stay the same, multiply exponents, -2 times 3x is -6x, and then times 6 squared, and this equals 6 to the power of -1. Now I'm going to use the product rule for exponents. So this would be 6 staying the same, and you're going to add. So this is negative 6x plus 2. Now you really can't simplify that any further, so you're just going to leave it in that form. And this equals 6 to the power of negative 1. At this point, you have what you want. You have 6 here and 6 here. So you can just use the rule where we say we're going to set this exponent equal to this exponent, and we're going to solve. So negative 6x plus 2 is equal to negative 1. Let's subtract 2 away from each side of the equation. This cancels. And let's say we have negative 6x is equal to negative 1 minus 2 is negative 3. At this point, I'm going to divide both sides of the equation by negative 6. So this would cancel, and we're going to have x is equal to negative over negative is positive. 3 over 6 is going to be 1/2. So x equals 1/2 is the solution. Let's come back up and paste that in. So I'm looking for this answer right here. So x equals 1/2. All right, let's take a look at question 2. So once again, we want to solve each equation, and we are given 5 to the power of 4x. This is times 1 over 625, and this equals 125. So looking at what you have, you're going to want 5 as the base on each side of the equation because you have 5 here. You have 625 here, which is 5 to the 4th power, and then you have 125 here, which is 5 cubed. So let me first just copy 5 to the power of 4x. Don't change that. Then times 1 over 625. Let's write 1 over 5 to the 4th power. And then again, if you want to drag this across the fraction bar, change the sign of the exponent. So I could say this is 5 to the power of negative 4. Then this equals 125 is 5 cubed. So at this point, it's just a matter of using my product rule for exponents to clean up. So 5 would stay the same, and you would add the exponents. So this is just 4x. You could go plus negative 4 or just minus 4. Either way, let me make that a little bit better. And this equals 5 cubed. So again, at this point, you have 5 and you have 5. So we're going to use our rule where it says we can just set our exponents equal. So this guy would be equal to this guy. So you're going to say that 4x minus 4 is equal to 3. And then I'm just going to add 4 to both sides of the equation. So this right here is going to cancel. And you're going to have 4x is equal to 3 plus 4 is 7. Let me slide down here. And I'm going to divide both sides of the equation by 4. And so this right here is going to cancel. And we're going to say that x is equal to 7/4. So let me grab this real quick. Let's come back up here. So this is what I want. I want to say x is equal to 7/4. All right, for question 3, again, we're asked to solve each equation. We have 36 raised to the power of negative x minus 1, and then times 216, and this equals 1. So when I think about 36, it's 6 squared. When I think about 216, it's 6 cubed. So I can say that this is 6 squared raised to the power of negative x minus 1. And then times, for 216, I can say that's 6 cubed. And this equals, here's the trick. You have 1 there. Remember, if you have a 6 here and a 6 here, you're going to want to have a 6 over here. So how can you do that? Well, remember that any non-zero number raised to the power of 0 is going to be 1. So I can put this as 6 to the power of 0, and 6 to the power of 0 is equal to 1. They are the same, so I can make a replacement there. So now what I'm going to do is use my power to power rule and say 6 stays the same, and we're going to multiply 2 times the quantity, so 2 times the quantity, negative x minus 1. So this would be negative 2x and then minus 2. Let me just erase this and pull this up here like that. And then we have times 6 cubed, and this equals 6 to the power of 0. All right, at this point, I'm going to use my product rule for exponents. So 6 would stay the same, and you're going to add. So negative 2x minus 2, and then plus 3. So negative 2 plus 3 is going to be 1. So let's put plus 1 here, and this equals 6 to the power of 0. All right, so at this point, we have what we want. So 6 here and 6 here. And then basically, I'm going to set these exponents equal to each other and solve. So we have negative 2x plus 1 is equal to 0. We are going to subtract 1 away from each side. This cancels. And you're going to see negative 2x is equal to negative 1. Let's divide both sides of the equation by negative 2. This would cancel, and you get x is equal to negative 1 over negative 2. Let's write that as positive 1/2. So let's grab that. Let's paste this in, come back up, And this is what I want. So x equals 1/2. All right, for question 4, we're told to solve each equation, and we have 243 raised to the power of negative 2x, and then times 3 to the 4th power, and this is equal to 3 cubed. So let me go ahead and grab this, come down here and paste this in. Now 243 is 3 to the 5th power. So what I'm going to do is write this as 3 to the 5th power, and then raise to the power of negative 2x times 3 to the 4th power. Let me clean that up a little bit. And this equals 3 cubed. I'm going to use my power to power rule first. So let's go ahead and say that we have 3 stays the same. 5 times negative 2x would be negative 10x. And then times 3 to the 4th power equals 3 cubed. So at this point, I'm going to use my product rule for exponents. So 3 stays the same. We're going to add negative 10x plus 4. I'm just going to write negative 10x plus 4. Basically, you can't make that any simpler. And then this just equals 3 cubed. So now I have what I want. So I have 3 over here and 3 over here. So I can just set the exponents equal and solve. So I'll go negative 10x plus 4 is equal to 3. Let me subtract 4 away from each side of the equation. And let's say that we have negative 10x is equal to 3 minus 4 is negative 1. Let's divide both sides of the equation by negative 10. This cancels, and we have x is equal to negative over negative is positive, so this is 1/10. And let me drag this back up here. So we want this one right here, where x is equal to 1/10. All right, let's take a look at question 5. So again, we want to solve each equation. We're looking at 216 to the power of negative 2x minus 3. And then times, we have our 36 raised to the power of 3x, and this equals 1. So for 216 and for 36, again, you're thinking about a base of 6. 216 is 6 cubed, so let me write that this is 6 cubed, and then raised to the power of negative 2x minus 3. And then times, for 36, that is 6 squared, and then raised to the power of 3x, and this equals, again, for 1, you have to use that rule that says that any non-zero number raised to the power of 0 is going to be 1. So you can really just say this is 6 to the power of 0 because 6 to the power of 0 is 1. So at this point, I would just clean things up, and I would say that 6 stays the same, and you're going to multiply the exponents. So this is 3 times the quantity, negative 2x minus 3. So I'm going to distribute that to each guy inside the parentheses. So basically 3 times negative 2x is negative 6x. And then 3 times negative 3 is negative 9. Let me erase this and just drag this up here like that. And then times, here you're going to have 6. That's going to stay the same. And 2 times 3x is 6x. And this equals 6 to the power of 0. So you can see you're going to have a little bit of a problem because negative 6x plus 6x is 0. So this becomes 6 to the power of negative 9 is equal to 6 to the power of 0, which is a false statement. So when this happens, you would say that you have no solution. So let's come back up and say that there is no solution. All right, let's take a look at the quiz. For the first question, we're asked to solve each word problem. We are given that Beth invested $180,000 in a savings account that pays an annual interest rate of 0.9%. The savings account is set to compound quarterly. So that's 4 times per year. How much is in Beth's account after 2 years? So what we're going to do is just plug into this formula. So remember that A is the future value of the account. So the account balance after, in this case, it would be 2 years. P is the present value of the account or the initial principal. What are you putting in when you first set up the account? R is the interest rate as a decimal. N is the number of compounding periods per year. And then T is going to be the number of years. So let me go back up. You probably don't remember all this stuff, so let me just copy it here. So P, the principal, or the amount invested, that's $180,000. You can just leave the dollar symbol off. So for R, that's the interest rate as a decimal. You're given this as a percentage, so 0.9%. So I'm going to say that's 0.009. Again, if you have this, you're going to delete the percentage symbol and move this decimal point 2 places to the left. So this would go 1, 2 places to the left. Okay, then the other guy is N. That's the number of compounding periods. So that's 4. Again, this is in a year. And then the number of years, that's T. That's going to be 2. So let me grab this, come down here and paste this in. And all you really have to do is just plug in and key this into your calculator. So A is equal to your P is 180,000 times the quantity 1 plus your R is 0.009 over your N, that's going to be 4. So this is raised to the power of T times N. So T is 2 and N is 4. So 2 times 4 is 8. And so we would say this is approximately, let's just punch this into the calculator. So I get about 183,265 point. So it doesn't tell us where to round to, but I'm going to round to the nearest hundredth. So I'm going to say 6.3 here. So let me grab this and come back here and just paste this in. So let me put that there. So I'm going to say this is about $183,265.63. So it's going to be this guy right here. So again, this is an approximation, but it's about $183,265.63. All right, let's take a look at question 2. So again, we want to solve each word problem. So Aya, I think that's how it's pronounced, invested $12,400 in a CD that pays an annual interest rate of 1.2%. The CD is set to compound daily. So that's 365 times per year. Now, when you get these things that compound daily, I know that some people will bring up the fact that you have leap years, but we're just going to ignore that. So we're just going to say it's 365 times per year. So how much is in Aya's account after 1 year and 6 months? So this problem is a little bit tricky because of the 1 year and 6 months. Let me write out some things. So first off, the principal, or the amount invested, is $12,400. Then the interest rate, again, the R as a decimal, is 0.012. So that's 1.2% as a decimal. And then we know that the N, the number of compounding periods in a year, again, because it's daily, it's 365. Again, we're going to ignore leap years. Then for T, this is where it's tricky. It's a year and 6 months. This needs to be in terms of years. So you have to convert 6 months into years, and 6 months is half of a year. So you could write this as 1.5 if you want, or you could write it as 3 halves. So either way is fine. Since you're going to key this into a calculator, I think I would write this as 1.5. It makes it a little bit easier. So just treat 1 year and 6 months as 1.5 years. So let me grab this and let me come down here and paste this in. And we're just going to key into our formula. So A is equal to, for P, you have 12,400 times the quantity, 1 plus, for R, it's 0.012 over your N is 365. Close that down. And then this is raised to the power of T times N. So T is 1.5 and N is 365. If you key that in to make it a little bit easier, this would be 547.5. And so I would just key it in like this, and you're going to get that this is approximately, let's say 12,625. And I'm going to round to the nearest hundredth. So let's say this is 0.2 and then 2. Again, rounding to the nearest hundredth. So let me grab this, come back up and paste this in. So it's going to be about $12,625.22. So this is the one we want. So again, about $12,625.22. All right, for question 3, again, we're asked to solve each word problem. We have that Helen invests in a fixed rate mutual fund with an annual interest rate of 4.7%. The mutual fund compounds monthly, so that's 12 times per year. If after 20 years, the account balance is $127,764.28, how much was the beginning investment? So for this one, you actually want to solve this formula for P. So to do that, you're just going to write that P is equal to, you're going to divide both sides by this right here. So in other words, you're going to divide both sides by this. So you're going to say A over this quantity 1 plus R over N raised to the power of Tn. So this right here is the formula we're going to use. So let me move this over here. And actually, I can get rid of this highlighting. Let me go back up. So we know that the account balance after 20 years, so this is A, this would be $127,764.28. Then the interest rate, the R, is going to be 4.7%, so 0.047. And then the T, the time, is 20 years, so just put 20. And then the number of compounding periods per year is 12. So that's n. So this is 12. Okay, let me grab this. Let's come down here and paste this in. So let me put a little border here. So P is equal to, you have your A. So this is 127,764.28 over. You have this quantity 1 plus. For your R, it's 0.047 over. For your N, it's going to be 12. So close that down. We're going to raise this to the power of t times n. So t is 20 and n is 12. So 12 times 2 is 24. Put a 0 on the end. This would be 240 if you did 20 times 12. So if I key this into the calculator and I round to the nearest hundredth, I get about 50,000. So let's say this is about 50,000. So let's come back up and I'll say that it's about $50,000. Again, rounding to the nearest hundredth. So this guy right there. All right, let's take a look at question 4. So here we want to solve each word problem. And we're given that Nikki wants to buy a car in 3 years. Her parents tell her she must save the 10% needed to obtain financing. Her plan is to place a lump sum in a savings account that pays 10% annual interest and compounds daily. How much does she need to invest if the car she wants to buy costs $20,000? So the common mistake here is to work with $20,000 when you don't need that. So Nikki only needs to obtain 10% of that. In other words, she's going to put 10% down and the car company, or you could say the loan company, whoever it is going to give her the other 90%. So Nikki, let me just write out Nikki right here, needs how much? Well, it's going to be 10% of $20,000. Most of you can do that in your head. It's just going to be $2,000. So $2,000, if you want to do that over here, you just do 20,000 times 0.1. And basically that's going to give you 20,000, move the decimal point one place to the left. Again, this is just 2,000. You can punch that into your calculator if you need to. So this is how much she actually needs. So let me go down to the formula and let's think about this for a moment. Here, we're actually going to be given A. So this right here would be 2,000. So this is 2,000. That's what she wants to get. The P is what we don't know. The R, the interest rate, let me go back up and we'll grab all this stuff. The interest rate is 10%. So let me write R is equal to 0.1. That's as a decimal. Actually, I like to write 0.1. I guess it doesn't matter. And then it compounds daily. So N, the number of compounding periods in a year, I'm going to put 365. The question always comes up on this. What about a leap year? So what about a year where there's 366 days? I would just say ignore it. Again, your teacher might give you specific instructions on that. But generally speaking, if you get this problem, just ignore it and write 365 for N. All right, then in terms of T, which is the number of years, well, she wants to buy a car in 3 years. So I'm going to put 3 there. And that's basically it. Let's go ahead and grab this, come down here and just paste this in. And so I'm just going to arrow to some stuff. So this right here is going to be, let me bring this way down here. This is going to be 0.1. And then this right here is going to be 365. And so this right here, again, is going to be 365. And this T here is going to be 3. So what you'd want to do is solve for P. So basically P is multiplying this. So divide both sides by this whole thing right here. So you're going to have that P is equal to this A over 1 plus R over N. And this is a quantity here. And then raised to the power of Tn. Now let me plug in and I'll move this down. So we know A is 2,000. So this is 2,000. We know R is 0.1 or 0.1. N is 365. So let me put that in there. And then also I'll put that in there. So like that, I'll put a multiplication symbol in. And T is 3. So let's put that like that. Now let me slide down a little bit. This is a little bit busy, so let me move this out of the way. So this is crystal clear. I'll just put a little border here so we can know what we're working on. And essentially, you're just going to key that into the calculator. That's all you have to do. So keying that in, I get approximately $1,481. And let's round to the nearest hundredth. So I'm going to say, and 70 cents. So that's rounding to the nearest hundredth. And let me put a dollar symbol in there. So what she needs is about $1,481.70. So this guy right there. All right, let's take a look at question 5. So Jacob is shopping online for CD offers Again, a CD, in case you don't know, that's a certificate of deposit. Midtown Bank is offering an immediate, so we have $300 bonus for any 5-year CD with a deposit of $2,000 or more. The Midtown Bank CD compounds monthly and has an annual interest rate of 3.9%. Actually, I need to highlight this 5-year part here as well. Downtown Bank is not offering any bonus, but has a significantly higher rate. So their 5-year CD also compounds monthly. Let me put that like this, and I should probably highlight that here as well, and has an interest rate of 7%. Jacob decides to go for the bonus money. He invests $2,000 with the Midtown Bank. Did he make the correct choice in terms of earning the maximum return on investment? What we have to do is consider the two scenarios. So you have Midtown Bank. So Midtown Bank, you could just put M. And you have Downtown Bank, let's put D. Basically, if you start out with the Midtown Bank, what he's getting is $300 as a bonus with a deposit of $2,000 or more. So he put in $2,000, so he gets the bonus. So basically his principal is $2,300 or $2,300. So I'm going to put that A is equal to, you would have the $2,300, that's your P or principal, times the quantity, you're going to have 1 plus, what's the interest rate? Well, there, when you look at the Midtown Bank, it has an annual interest rate of 3.9%. So as a decimal, that's 0.039. And then dividing by the number of compounding periods in a year. So it compounds monthly. So that's 12 times per year. So that's divided by 12. And then close that down. This is raised to, again, T times N. T is the number of years. Well, it's for a 5-year term here. And the compounding periods in a year, again, that's your N, that's going to be 12. So this is 5 times 12, which is 60. Then let's do this other scenario. So for the Downtown Bank, it's A is equal to, he doesn't get the bonus. So it's $2,000. And then times the quantity 1 plus, now the interest rate is 7%. So 0.07 over. It compounds monthly as well. So 12. And then times the quantity. Again, it's a 5-year CD and it compounds monthly. So 5 times 12 is 60. So let me start with this one. So this is approximately what? Let's just key this into the calculator. So I get about 2,794 point, let's say 33 if we round to the nearest hundredth. So let's say if he invests in the Midtown Bank CD, that's going to be about what he gets. So let's just say that it's about $2,794.33. Okay, with the Downtown Bank, let's say we key this one in, and there, let me put this here. So he's going to get about $2,835.25. So he made a mistake. If he would have chosen the Downtown Bank CD, he would have made more. So a lot of times you're presented with this type of scenario in the real world, and you need to be able to key in the information and figure it out. He would have been better off going with the Downtown Bank CD. So when it says, did he make the correct choice in terms of earning the maximum return on investment? No, because the Downtown Bank CD would have given him more at the end of the 5 years. He would have $2,835.25 versus what he gets from the Midtown Bank after 5 years, which is $2,794.33. So I would say no, the best choice is Downtown Bank's CD. All right, let's take a look at the quiz. For the first question, we're asked to solve each word problem. We are told that Amy invests $4,043 in a mutual fund with a fixed annual interest rate that is compounded continuously. After 16 years, the account balance reaches $12,391.21. What is the interest rate of her account? So this one, you just think about the fact that if you see compounded continuously, you're using the formula A equals P E raised to the power of RT. And here, what we're asked for is the interest rate, so R. What I'm going to do is solve for R first, just get that out of the way. A lot of you know you're going to have to use a logarithm for this. I talked about this in the written lesson, and I also talked about this in the practice test at the beginning. Essentially, all you're going to do is divide both sides by P, just to get things started, so that would cancel. You're going to have E to the power of RT is equal to A over P. So at this point, you're going to take the natural log of both sides. So we abbreviate that with ln. So ln of e raised to the power of RT. This equals your ln, so that's the natural log, of this a over p. So at this point, you're going to use your power rule for logarithms. So this right here can come out in front. So in other words, you can say this is RT times the natural log of E, and this equals the natural log of A over P. So this is like saying I have log base E of E, and of course that's equal to 1. So you can just say that this would be RT is equal to the natural log of A over P. Let me get rid of all of this. We don't need it anymore. And let me finish closing this down. Let me bring this up here. And all you're going to do if you want R by itself, divide both sides by T. So divide this side by T, divide this side by T, and so you get R, which is the interest rate as a decimal, is equal to the natural log of A over P divided by T. So what is A in this situation? Let me erase this so I have some room. A in this situation, again, is the account balance after the 16 years. So that's going to be $12,000 and then $391.21. Let me extend this, or actually just make it one piece like that. This is over P, which is the principal or the amount invested. So that's going to be $4,043. And then T, which is your time in years, that's going to be 16. So this is just something we're going to key into the calculator. And I get about 7% if you round to the nearest hundredth. So the answer here is going to be 7%. All right, for question 2, again, we're asked to solve each word problem. So we have that Mary invests $2,177 in a savings account with a fixed annual interest rate that is compounded continuously. After 14 years, the account balance reaches $6,672.19. What is the interest rate on the account? So just like in the last problem, we would solve our A is equal to P e to the RT for R. We already did that, so I'm just going to give it to you. So R is equal to, again, the natural log of A over P, and then this is over T. So all you're going to do is plug in. Let me erase that so I have enough room. So A, that's the account balance here after 14 years. That's going to be $6,672.19. And then your P, your principal, that's the amount invested. That's going to be $2,177. And then T, your time, and this is going to be in years, that's going to be 14. So again, just key this into the calculator. And if you round to the nearest hundredth, I get about 8%. So that's what you're looking for. All right, let's take a look at question 3. So again, we're asked to solve each word problem. So here we have that Jennifer invests a lump sum of money in a savings account with a fixed annual interest rate of 9% that is compounded continuously. After 10 years, the account balance reaches $14,000.06. What was the amount of the initial deposit? So again, going back to this formula, A equals P e to the RT. Now you want to solve for P or the principal. Really easy to do that. You're just going to divide both sides of the equation by e raised to the power of RT. And so this would cancel with this, and you're going to have P is equal to A over E raised to the power of RT. Okay, let me get rid of this. So this is just something you're going to plug into. You have to be careful with this form because it's really easy to make a mistake depending on the calculator you're using. If you're using an online calculator, you're pretty much going to be good to go. But if you're using something like a TI-83, you need to make sure you wrap this with parentheses right here. So I would do it like this. That's how I would show the formula because it's very easy for your calculator to misinterpret what you're trying to do. So let's go ahead and plug in for A. That's the account balance after the 10 years. So this would be 14,000. So 14,000. And then 0.06. Again, $14,000.06. So let me make this a little bit longer here. E, that's a special number in your calculator, so don't worry about that. R here is the interest rate as a decimal. So let's go 0.09. And then times, you have T, which is your time in years, so that's 10. Now, if you want to do this calculation first and put this as e to the power of 0.9, so if you want to write it like this, then you don't really need the parentheses. And again, if you're using an online calculator, usually you don't need the parentheses. And I'm just going to show it like this because a lot of you are just going to key it in like that. So if you round to the nearest hundredth, I'm going to actually end up with this one right here. So let's say that this is about, I'll go 5,692. So this answer right here. So the initial deposit, let me make this 9 a little bit better. Again, the initial deposit was about $5,692. All right, let's take a look at question 4. So here we're asked to solve each word problem. We have that Leah invests a lump sum of money in a retirement account with a fixed annual interest rate of 5% that is compounded continuously. After 14 years, the account balance is $13,300.84. We are asked what was the amount of the initial deposit. Okay, let's write this out again. So A is equal to P E raised to the power of RT. If you're asked for the amount of the initial deposit, you're solving for P, the principal. Again, divide both sides of the equation by E raised to the power of RT. So we're just going to do this once again. So this cancels. So you get P is equal to this A. So this A over this E raised to the power of RT. So what is A? Again, that's the account balance after the 14 years. So that's going to be 13,300.84. So again, $13,300.84. E is a special number on your calculator, so don't worry about it. And then I'm just going to wrap this again for clarity. The R, the interest rate, is a decimal. It's 5%, so that's 0.05. And then times your T, your time in years, is 14. So again, we'll key this into the calculator. And let me make this a little bit longer here. And if I round to the nearest hundredth, I get about 6,605. So this one right here. So in terms of the initial deposit, that was about $6,605. All right, for question 5, again, we're asked to solve each word problem. We have that Larry invests a lump sum of money in a bond fund with a fixed annual interest rate of 3% that is compounded continuously. After 5 years, the account balance reaches $3,387.91. What was the amount of the initial deposit? Okay, so once again, we're going to solve our formula for P. So we know that P is equal to A over E raised to the power of RT. A is the account balance after the 5 years. So that's going to be 3,387.91. And then your R, your interest rate is a decimal. The interest rate is 3%. So as a decimal, that's going to be 0.03. And then your time, your T, that's in years, that's going to be 5. Okay, so let's just key this into the calculator. And I get about 2,916 if I round to the nearest hundredth. So this guy right here, so the initial deposit was about $2,916. All right, let's take a look at the quiz. For the first question, we're asked to evaluate each expression, and we are given log with a base of 25 and then of 5. So what is this equal to? Again, what I like to do for this is just say this is equal to x, and then just put this into exponential form. So this would be 25 raised to the power of x, and then this would be equal to 5. So what does the exponent here need to be for this to be true? Well, a lot of you know that it would need to be 1/2, because 1/2, if you have that as an exponent, that's the same thing as taking the square root, and the square root of 25 is going to be 5. So a lot of you can eyeball that and see it, but just in case you can't, you could go ahead and write this as having a common base with this. So 25 is 5 squared. So you could say that this is 5 squared, then raised to the power of x is equal to 5. And then by the power to power rule, you could say this is 5 raised to the power of 2x is equal to 5. Now I have the same base on each side, so this 5 and this 5. So I could just set the exponents equal to each other. Now the exponent over here is implied to be a 1, so you'd want to write that in and just say now that 2x is equal to 1, divide both sides by 2, and of course this cancels, and you get x is equal to 1/2. So that just means that this right here, let me erase everything, would be 1/2. And of course this is very easy to check. Again, going back into exponential form, you're just saying that 25 raised to the 1/2 power is equal to 5, and all this is the square root of 25 is equal to 5, so you get 5 equals 5. So this is a true statement. Log base 25 of 5 is equal to 1/2, so I'm just going to circle 1/2 as the answer. All right, let's take a look at question 2 now. So we're asked to evaluate each expression, and we're given log base 64 of 1/2, and this is equal to what? So let me just put x here, and basically what I would do is say this is 64 raised to the power of x is equal to this 1/2 here. All right, now if I think about 64 and I think about this 2 here, I can write things with a common base. So I could say that 64 is 2 to the 6th power. So this is 2 to the 6th power and then raised to the power of x, and this equals, for 1/2, I'm going to write that as 2 to the power of -1. All right, let me slide down here a little bit. We'll come back up in a little while. From the power to power rule, you can just say this is 2 to the power of 6x, and this equals 2 to the power of -1. And of course, because we have the same base on each side, a 2 here and a 2 here, you can just set those exponents equal to each other and solve. So 6x is equal to -1. Divide both sides by 6, and you're going to get x is equal to -1/6. Okay, let me get rid of this. And let me replace this with -1/6. And then checking this is, again, pretty easy. So we're going to say that 64 raised to the power of -1/6 is equal to 1/2. This right here, I would say it's 1/64 raised to the power of 1/6 like that. And this equals 1/2. Okay, so now what I would realize here is that this is going to be the 6th root of 64. So in other words, this would be 1/6th root of 64. To make this crystal clear, you could write this as the 6th root of 2 to the 6th power is equal to 1/2 like that. So at this point, this index of 6 would undo this exponent of 6. And so you just have the 2 there. So this would be 1/2 is equal to 1/2, which is, of course, a true statement. So let me get rid of this and come back up here. What we want is -1/6. All right, for question 3, we are asked to find the domain, and we are given f of x is equal to log base 5 of 2x squared plus 9x minus 5. And let me come down here to this fresh piece of paper, and let's think about this. We know that for a logarithm, so something like, let's say, log base a of x, the argument here, this x, needs to be positive. So it needs to be greater than 0, and strictly greater than 0. It can't be 0, and it can't be negative. So basically what we would do here is say that this part right here, the argument of the logarithm, needs to be positive. So 2x squared plus 9x minus 5, that needs to be greater than 0. So we know how to solve a quadratic inequality. It's not too bad. Let's come down here to the number line. Let me paste this in. This is something you can solve using factoring. So let me first just say, where does this equal 0? So I'm going to factor the left side here. Let me make this better. So the leading coefficient here, which is a 2, is a prime number. So I'm going to put a 2x here and an x here. Now we have to think about this last guy here. So it's a negative. So that tells me I'm going to have opposite signs here. I also know that for 5, it's 5 times 1. So basically, I can try a 5 here and a 1 here and see if I can get this to work. This would be 10x and this would be 1x. So if this was a plus and this was a minus, that would work. So the outer here would be 10x. The inner here would be minus x. 10x minus x, that's 9x. So this is good to go. All right, so if you set this up and say, well, 2x minus 1 is equal to 0, or x plus 5 is equal to 0. This one's really easy. Subtract 5 away from each side, and you're going to get that x is equal to -5. So that's going to be one critical value. Let me just mark this off right here. The other one, let me just get rid of this right now. Let's add 1 to both sides. And so this would give me 2x is equal to 1. Divide both sides by 2. This cancels. So you get x equals 1/2. So let's say that this notch right here, we'll just put 1 in. Let's say that's 1/2. So that's a critical value as well. Okay, let me get rid of this. We don't need it anymore. And I'm just going to put this in the factored form. It makes it easier to work with. So first, you just pick a number that is to the left of -5. Doesn't matter what you pick. I'm just going to pick -6. You plug it in, and you want to see if it's greater than 0. Well, if you plug in a -6 here, 2 times -6, then -1, this would be -12, and then -12 minus 1 would be -13, so this is negative. Then over here, if you plug in a -6, -6 plus 5, that's -1, so this is a negative. Negative times negative is positive, and a positive is always greater than 0, so I'm going to put a t here for true. Okay, if you pick something between -5 and 1/2, let's just pick 0 because it's easy to work with, you're going to see that it doesn't work. So if you plug in a 0 here, 2 times 0 is 0. 0 minus 1 is -1, so this is negative. And then 0 plus 5, that's going to be +5. So that's a positive. Negative times positive is negative. That's never going to be greater than 0. So this right here is false. Will not work. Then if you pick something that's to the right of 1/2, so maybe something like 1, it's going to work, right? So both of these would be positive. 2 times 1 is 2. And then 2 minus 1 would be 1. So this is positive. Here, 2 plus 5 is 7. So this is positive. Positive times positive is positive. That's always going to be greater than 0. So this is true. Okay, so what we want to do, again, because it's a strict inequality, you would say that x is strictly less than -5, then or x would be greater than 1/2. So let me grab this real quick and come back up here and paste this in. Now, how you write your domain is really up to you if you're self-studying. Some teachers have a preference, so you might just write the domain like this. So you might do it like that, or you might do it using interval notation, which is how the solution is listed. So from negative infinity, going up to and excluding -5, and then you want the union with anything larger than 1/2. So basically, it's going to be this one right here. Now, you could also use set builder notation if you want. So maybe you want to see that. So in that form, you would say it's the set of all x such that, and you're just going to list this right here. So x is less than -5, or x would be greater than 1/2. So that's another way to list it. All right, if you want to verify this on Desmos, you can just type this in, and basically you'll see that this piece of the graph right here is for x is less than -5. I know you can't see that. I have to zoom in a little bit so you can see the -5. So this piece right here is where, again, x is less than -5. And this piece right here, you don't have a notch for it, but basically it's going to be where x is going to be greater than 1/2. All right, for question 4, we're asked to solve each equation. And so we're given 4 log base 4 of 10x plus 6, and then plus 2, and this equals 14. So we're going to talk a lot about solving logarithmic equations later on. But right now, you just want to isolate this guy right here. So you'll have that on one side and a number on the other, and then you can just put it into exponential form. Okay, so let's go ahead and subtract 2 away from each side. This cancels. You get 4 log base 4 of 10x plus 6, and this equals 14 minus 2 is going to be 12. Okay, let me get rid of this. At this point, what I would do is divide both sides of the equation by 4. And so this would cancel, and now I have this isolated. So log base 4 of 10x plus 6 is equal to 12 divided by 4 is going to be 3. Okay, at this point, what you want to do is put this into exponential form. So you're going to do this. This is your base, this is your exponent, and then this is going to be your answer here. So in other words, you're saying 4 cubed is equal to the argument from the logarithm, so 10x plus 6. Okay, so now that we have this set up, we can just solve. We can say that we subtract 6 away from each side. 4 cubed is 64, so you'd have 64 minus 6, and 64 minus 6 is going to be 58. So let me put, this is 64 here, so that's more clear. This is 58 is equal to 10x. Let me cancel that away. And now what I would do is just divide both sides of the equation by 10. And so this would cancel. And let me say that x is equal to, for 58, it's going to be 29 times 2. And then for 10, let's say that's 5 times 2. Let's go ahead and cancel a common factor of 2 between numerator and denominator. So x would be 29/5. So this guy right there. Now let me check this with you real quick. You're going to see later on that when we work with logarithmic equations, in some cases you get extraneous solutions. This is not one that would produce that, but we'll talk about that later on. For right now, I'm just going to get in the habit with you of checking these. So let's go 4 log base 4 of 10 times. You want your 29/5. I'm just plugging that in for x. Then plus 6, and then you have your plus 2. Does this equal 14? Well, 10 times 29/5, the 10 would cancel with the 5 and give me a 2. 2 times 29 is 58. So this turns into 4 log base 4 of 58 plus 6, and then you have plus 2, and this equals 14. Well, 58 plus 6, we know that's 64. So this is 64. Now, as we move on to the next lesson, we're going to learn that log base 4 of 64, the quick way to do that is to say this is log base 4 of 4 cubed, right? Because 64 is 4 cubed. So basically, if you look at log base 4 of 4 cubed, really the slow way to do it is just to pull the 3 out as multiplication. So this is 3 times log base 4 of 4. And log base 4 of 4 is 1, so this equals 3. You're going to learn another property that says log base 4 of 4 cubed is just 3, and that's going to be the real shortcut there. So at this point, because we haven't got to anything yet, we're just going to take this as a given that this is going to be 3. So 4 times 3 plus 2 is equal to 14. Okay, so now 4 times 3 would be 12. 12 plus 2 is equal to 14. And this is 14 is equal to 14. So this gives me a true statement. So I know x equals 29/5 is a valid solution. All right, for question 5, we are asked to find the transformation from f of x to g of x. Our f of x here is given as log base 3 of x, and then our g of x is negative 3 times log base 3 of x minus 4, and then you have your plus 4. So to put this in terms of f of x, let me write g of x is equal to, you have this negative 3 out in front. So that's going to multiply. What I'm going to do is write this as f of, because you have x minus 4 for the argument of that logarithm, I'm going to put x minus 4 right there. Then you have this plus 4. So let me put plus 4 here. So I'm going to start off by thinking about the x minus 4. That's getting plugged in for the argument right there. That's going to shift me to the right by 4 units. So if you look at all your choices here, and I don't know how well you can see all of them, but you have left, right, right, left, and left. So this one and this one, those are both shifting to the right, and that's what I want. So shifted 4 units right, shifted 4 units right. So let me just go with those two. The other ones won't work. If you had f of x plus 4, that would be a shift to the left by 4 units, but we don't have that. We have f of x minus 4, so we want to shift to the right 4 units. Okay, now looking at the other guys, you have this negative 3 that's multiplying your function here. So basically that's doing two things. One thing that it's doing is, if you just think about the 3 part, that's going to give you a vertical stretch by a factor of 3. And then the negative is going to give you a reflection across the x-axis. So let me look for that. So here we have vertically stretched by a factor of 3. This one says vertically compressed by a factor of 3. So already we know that this is the answer. So let me just circle it and we'll continue. So this one right here, you have your vertically stretched by a factor of 3, reflected across the x-axis. The last thing is shifted up by 4 units, and that's coming from this plus 4 right here. Okay, if you want to go to Desmos and play around with this, I gave you a calculator, so you can just click the link. So the graph in red is your f of x equals log base 3 of x. So that's this right here. So you have a point here, which is 1/3 comma negative 1. You have a point that's 1 comma 0, a point that's 3 comma 1, and a point that's 9 comma 2. Of course, you can make more points if you need them, but I'm just going to go with these 4 points. Now, in the other one, your g of x, this equals negative 3, log base 3 of x minus 4, so that guy right there, then plus 4. That's going to be this guy in blue. So let's go through this point by point. If I start with this point right here, which is 1/3 comma negative 1, how do I end up with this point right here, which is 4 1/3 comma 7, or you can say 13/3 comma 7. That's how I keyed it in. So basically, if you think about what happens here, we're shifting 4 units to the right. So basically, this right here is 1/3, and this right here is 4 1/3, or again, you could say 13/3. Then when you think about the y values here, again, you're multiplying your negative 1 by negative 3. So that's giving me a vertical stretch by a factor of 3, and then it's also reflecting across the x-axis. So if I did negative 1 times negative 3, that's positive 3. So right now, let me see if I can line this up. That would put me, let's just say that's about right here, and this isn't going to be perfect. And then basically at that point, you would be at a y value of 3. You would shift up by 4 units, and that would give you a y value of 7. So that's how this point goes to that point. Then similarly, this 1 comma 0, if you think about shifting 4 units to the right, that's going to put me at an x value of 5. You're going to end up right there at 5 comma 4. Then if you think about what's going to happen to your y value, well, the y value right now is 0. So if you multiply by negative 3, that's still 0. And then if you shift up by 4 units, you're going to get right there to 5 comma 4. For this 3 comma 1, I'm going to shift to the right by 4 units. So now my x value would be 7. My y value would still be 1. I am going to multiply my y value of 1 by negative 3. So let me come down here. Let's just say that's 7 comma negative 3 for right now. And then basically at that point, you're going to shift up by 4 units. So negative 3 plus 4, that's going to put you right back there. So your y value would be 1. So you're at that 7 comma 1. Then the last point we're going to do is this 9 comma 2. Again, if I shift to the right by 4 units, that's going to put me right here. So basically I would be at 13 comma 2. I multiply 2 by negative 3. That would be negative 6. So let's say that puts me down here, let's say right there. So that would be 13 comma negative 6. And then I shift up by 4 units. So that's going to put me right there at 13 comma negative 2. So again, you can play around with this as much as you want, put in additional points, and just go through the process to see the transformation. All right, let's take a look at the quiz. For the first question, we're asked to expand each logarithm. And what we're given is log base 4. We're going to have of this x cubed, and this is over y, and then this is going to be cubed. What I would do first if I'm trying to expand this is move this down out in front, as multiplication, essentially using the power rule for logarithms. So let's say this is 3. Let me put times log base 4 of this x cubed over y. Now, here's where things get a little bit tricky. Remember, this 3 is multiplying by this guy right here. So when we expand this using the quotient rule for logarithms, you have to be careful. The 3 needs to multiply by each guy. A lot of times I'll use parentheses here. Let me erase this. And you can do this if you keep making a mistake. It's not necessary, but it helps me remember. So I always do it. So let's put equals. We're going to go 3 times this quantity now. We're going to have log base 4 of this guy in the numerator, which would be x cubed. And then minus, you're going to have log base 4 of this guy in the denominator. So that's y. Let's close that down. And again, because I wrote this 3 out in front, now I know I need to distribute it to each guy. So let's say this is equal to 3 log base 4 of x cubed. And then minus, you have 3 log base 4 of y. Now we're not done because we have this exponent right here that we can bring out in front, again as multiplication. So bring that out in front like that. Let me just slide down here a little bit and say this equals. You would have 3 times 3, and then times your log base 4 of x now, minus 3 log base 4 of y. So to finish things up, 3 times 3 would be 9, and then times your log base 4 of x, and then minus, you're going to have 3 log base 4 of y. Let me grab this real quick, and I'll put it right there. And it looks like I'm looking for this guy right here. So this is 9 log base 4 of x minus 3 log base 4 of y. All right, let's take a look at question 2. So here we want to expand each logarithm, and we are given log base 8 of, we have w to the 5th power times the square root of u. And let's come down here. Let's think about what we have. So first off, we see we have multiplication. So we can just do our product rule for logarithms. Let's start off with log base 8 of, this would be w to the 5th power, and then plus log base 8 of, this would be the square root of u, which you could write as u to the 1/2 power. And let me make this 5 a little bit better there. And then let's say that this is equal to, in each case, I'm going to bring the exponent down in front as multiplication using my power rule for logarithms. So let's say this is 5 times your log base 8 of w plus, this would be 1/2, or you could say dividing by 2, but let me put it as 1/2 times log base 8 of u. I think the answer is probably written this way, so over 2. The software that I use to generate the problems usually puts it this way. I'd be surprised if they put it the other way. So let me bring this back up. So let's paste this in here, and let's look and see. So it looks like we want this one. So this is 5 log base 8 of w plus you have log base 8 of u over 2. Again, if you wanted to write this as 5 log base 8 of w plus 1/2 times log base 8 of u, that's not wrong. You can do that, but because we're on a multiple choice exam or test, however you want to say that, we basically have to go with the answer that's given, so it's going to be this one. All right, for question 3, we are asked to condense each logarithm. We are given 4 log base 2 of x minus 24 log base 2 of y. So if you want to condense something, you're trying to make it into one logarithm. So the first thing I'm going to do is take this, and I'm going to move them back up just using my power rule for logarithms. So let's say this equals, you're going to have your log base 2 of x to the 4th power, then minus, you're going to have your log base 2 of y to the power of 24. And then at this point, you have the same base here, so 2 and 2, and you have subtraction. So you're going to use your quotient rule for logarithms. So let's go ahead and say that this is equal to your log base 2 of, this is x to the 4th power over y to the power of 24. Close that down, and that's going to be your answer. So let's go ahead and grab this. Let's come back here and paste this in. So looking through my choices, it looks like I want this one right here. So log base 2 of, you have x to the 4th power over y to the power of 24. All right, let's take a look at question 4. So here we want to condense each logarithm. So we have 3 log base 6 of u, and then minus 15 log base 6 of v. Let me make this a little bit better here. And let me grab this real quick. And let me paste this in. So this one's, again, really easy. You want to just start by moving these up here using your power rule for logarithms. So this would be log base 6 of u cubed. And then minus, this would be log base 6 of, this would be v to the 15th power. At this point, again, you have the same base, so 6 and 6, and you have subtraction. So you're going to use your quotient rule for logarithms, and you're just going to say that this is log base 6 of, you can have this as the numerator, so u cubed, over. You can have this as the denominator, so this is v to the 15th power. So let's go ahead and grab this, come back here and paste this in. So looking through the choices, looks like I want this one right here. So you want log base 6 of, you have u cubed over v to the 15th power. All right, for question 5, once again, we're asked to condense each logarithm, and we're given log base 7 of c, and then plus, so we're going to have log base 7 of a, and this is over 2, and then plus, you have a log base 7 of b, and then this is over 2. Now we know that dividing by 2 is the same thing as multiplying by 1/2. Let me go ahead and grab this real quick. So we have some room. Let me paste this in here. So that's the first thing I would do. I would say this is log base 7 of c plus, again, dividing by 2 is the same thing as multiplying by 1/2. So let's write 1/2 times log base 7 of a, and then plus, this would be 1/2 times log base 7 of b. Now, at this point, you're going to use your power rule for logarithms in reverse. So this is just coming up here and then up here. So let's say we have log base 7 of c plus log base 7 of a to the 1/2 power. And then plus, you have log base 7 of b to the 1/2 power. Now, when we raise something to the 1/2 power, is the same thing as taking the square root. The way the answer is written is we're using the square root symbol. So we're going to have to convert that over. So let's go ahead and say this equals log base 7 of c plus log base 7 of the square root of a, and then plus log base 7 of the square root of b. All right, so at this point, it's really easy to finish things up. You have a base of 7, a base of 7, and a base of 7, and you have addition and addition. So all you have to do is write that log base 7, so log base 7 of, and you're just going to multiply these guys together, so all the arguments. So you have c times the square root of a times the square root of b. So you could write c times the square root of ab. There's lots of different ways to write this and have it still be correct, but you just have to put something here that's going to match the answers given because it's multiple choice. So let's come back up here and paste this in. And so this is the one that I want. So log base 7 of c times the square root of, here we have ba and here it's ab. Again, the order of the multiplication doesn't matter. We can flip this around and say this is ba like that, and it's the exact same thing. So this is the answer that you want. All right, let's take a look at the quiz. For the first question, we're asked to find the inverse of each function. So we have f of x is equal to 4. We have log base 2 of this 4 to the power of x and then minus 2. Now what you're going to do is replace your f of x with y, and then you're going to swap your x and y. So let's just do that now. Let's just swap these guys. Let's say this is x and this is y, and you want to solve for y. So this one's a little bit tricky. Let me go ahead and grab this, come down here and paste this in. So here's how I would approach the problem. I would divide both sides by 4 to get things started. So that would cancel this with this. And so you would have log base 2 of, you have 4 to the power of y minus 2. And then this would be equal to x over 4. Now, because we're trying to solve for y here, so what I would do is I would take and put this into exponential form. You're going to need to use a logarithm in a moment, but let's start with 2 to the power of x over 4. So 2 to the power of x over 4. This would be equal to this argument here, which is 4 to the power of y and then minus 2. So again, the goal is to solve for y. So how can we do that? Well, first, let me add 2 to both sides of the equation, and we'll just say that this is 4 to the power of y is equal to, this cancels, you have 2 to the power of x over 4, and then you're going to have plus 2. Now, if you're trying to solve for y, and that's in the exponent, Well, you're going to use a logarithm, and here we would want to use the base 4 logarithm because log base 4 of 4 is 1. So let's say that log base 4 of 4 to the power of y is equal to log base 4 of 2 to the power of x over 4, and then plus 2. So this right here, this y, can come out in front as multiplication. We have y times log base 4 of 4. This is going to cancel and give me 1. This equals log base 4 of 2 to the power of x over 4, and then plus 2. So at this point, I can use my inverse notation. So f inverse of x is equal to, let's go log base 4 of 2 to the power of x over 4, and then you have plus 2. So this would be your inverse. Let me go ahead and grab this. Let me come down here and paste this in here first. So I have a graph that I just came up with from Desmos. Again, you can type this stuff in yourself. So your y equals x, that line's in blue, and then you have your original function. So f of x equals 4 times your log base 2 of 4 to the power of x, and then minus 2. That's going to be this guy in red. And then the guy in green, that's your inverse. So it's keyed in here as g of x because Desmos right now does not take f inverse of x. So this is equal to log base 4 of, again, 2 to the power of x over 4, and then plus 2. So if you look at this guy on Desmos, even right here, you can see there are reflections across the line y equals x. So they are going to be inverses. So let me go ahead and grab this real quick. And let me paste this in right here. So looking through, it looks like I'm going to want this one right here. So you have your f inverse of x is equal to log base 4 of, you have 2 to the power of x over 4, and then plus 2. All right, let's take a look at question 2. So again, we're asked to find the inverse of each function. We are given f of x is equal to, we have 5 to the power of x, and then minus 8, and then this is over 3, and this whole thing is raised to the 1/5 power. Okay, let's grab this one and let's paste this in. So the first thing is to replace f of x with y, and then you want to swap x and y. Let's just do that here. So we'll put this as an x and we'll put this as a y. And then if this whole thing is raised to the 1/5 power, what you could do is raise both sides to the 5th power. So let's say this is raised to the 5th power, and then this is raised to the 5th power. So from the power to power rule, 5 times 1/5 would be 1. So you get x to the 5th power is equal to 5 to the power of y minus 8 over 3. At this point, I would just multiply both sides by 3. And so this right here would cancel with this right here. Let's say that we have 3x to the 5th power, and this equals 5 to the power of y minus 8. So what I would do is add 8 to both sides of the equation. That cancels. And let's write this as 5 to the power of y is equal to 3x to the 5th power plus 8. Now, if I want to solve for y, and again, it's in the exponent, well, I can just do log base 5 of 5 to the power of y is equal to log base 5 of this 3x to the 5th power plus 8. We know that this can come out in front as multiplication. So we'll say that y times log base 5 of 5, which again, we know this is 1, is equal to log base 5 of this 3x to the 5th power plus 8. So to finish things up, let's just say f inverse of x is equal to log base 5 of 3x to the 5th power plus 8. Let me go ahead and grab this. And again, I just made a quick little sketch from Desmos, so you can go there and key this in if you want. So your original function is in purple here. So that's going to be f of x equals, again, 5 to the power of x, then minus 8 over 3. This is all raised to the 1/5 power. Y equals x is in blue. And then in black, you have your g of x. Again, I'm just replacing f inverse of x with g of x because Desmos doesn't take the f inverse notation. So this equals log base 5 of, you have your 3x to the 5th power plus 8. Again, you're just looking to see if there are reflections across the line y equals x. And of course, they are. Okay, let's come back and paste this in. So looking through my choices, it looks like I want this first one right here. So f inverse of x is equal to log base 5 of 3x to the 5th power plus 8. All right, let's take a look at question 3 now. So again, we're asked to find the inverse of each function. I have a little note here. So your answer may vary based on the base of the logarithm you want to use. So this is generally always true when you solve these problems. You can get something that looks different, but it would still be correct. But because we're on a multiple choice test here, you're kind of forced to use the answer that I've given you. So let me show you where that's coming from. So we have f of x is equal to, you're going to have -7, and this is times 3 to the power of x. Let me make this 7 a little bit better there. And then you're going to have plus 1, and this is over 3 to the power of x. Okay, let me write this as y right here. And before we copy it, let me just switch everything. So let's put these as y's, and let's put this as an x. Now, let's go ahead and grab this. Okay, let me paste this in here. So the first thing I'm going to do is multiply both sides by 3 to the power of y, just to clear that denominator there. And so this would cancel. And so now you have 3 to the power of y, and then times x, and this equals -7 times 3 to the power of y, and then plus 1. When I think about solving for y, again, you have that here and here. Let me move this over here, and then I can factor out a 3 to the power of y. So let me add 7 times 3 to the power of y to both sides of the equation. So this is going to cancel. And let's say that you have 3 to the power of y times x plus 7 times 3 to the power of y is equal to, we'll just have 1. Okay, at this point, I want you to notice you have 3 to the power of y, 3 to the power of y. Let's factor that out. So let's say that we're going to have 3 to the power of y times the quantity x plus 7. So this would be equal to 1. Okay, at this point, I'm going to divide both sides of the equation by 3 to the power of y. So we know that this would cancel with this. And let's write that we have 1 over 3 to the power of y is equal to x plus 7. Here's where, again, you use your rules of exponents. 1 to the power of y is still 1. So you could put this like this, and then what we could do is legally say this is 1/3 to the power of y. So now we can just say that we want log base 1/3 of 1/3 raised to the power of y is equal to log base 1/3 of x plus 7. Okay, we know this is going to come out in front. We know log base 1/3 of 1/3 is 1. Let me just show this so nobody's lost. So this is y times log base 1/3 of 1/3. And I'm just going to show that this cancels and becomes 1, so nobody's lost. This equals, you have log base 1/3 of x plus 7. At this point, all I need to do is say I have f inverse of x is equal to log base 1/3 of x plus 7. So that's your inverse. Come down here and paste this in. Again, if you want to go to Desmos and just check this out, your graph in red, that's your original function. So that's f of x equals -7 times 3 to the power of x plus 1 over 3 to the power of x. Your line in blue is y equals x. And then your g of x here, which is representing your inverse, this is log base 1/3 of, you have this x plus 7. So clearly these guys are reflections across the line y equals x, so they are going to be inverses. Okay, so coming back and looking through my choices, this is the one that I want. So f inverse of x is equal to log base 1/3 of x plus 7. Okay, let's take a look at question 4. So again, we're asked to find the inverse of each function. I have another note. Your answer may vary based on the base of the logarithm you want to use. So let's start out with f of x is equal to 6 to the power of x, then -7. Let's put this as a y, and then let's swap x and y. So let's put this as a y and this as an x. So this one's pretty easy. We're going to add 7 to both sides of the equation. That cancels. So you would have 6 to the power of y is equal to x plus 7. So for this one, I would take log base 6 of each side. So of 6 to the power of y. So that equals log base 6 of x plus 7. So let's get rid of this. At this point, we know that the left side will be y. But again, for completeness, so nobody's lost, this comes out. This is y times log base 6 of 6. And of course, log base 6 of 6 is 1. And so this would be equal to log base 6 of x plus 7. Now at this point, we can say this is f inverse of x, and it equals log base 6 of x plus 7. Okay, let's see what we have. So it looks like we want this one. So f inverse of x is equal to log base 6 of x plus 7. Again, you can go to Desmos and just key this stuff in. So the blue line is y equals x. the guy in green, this is your f of x equals 6 to the power of x minus 7. And then the guy in purple, that's your inverse. So it's keyed in as g of x equals log base 6 of x plus 7. So again, looking at these guys, you can see their reflections across the line y equals x. All right, for question 5, we're asked to find the inverse of each function. So I have a note here again, your answer may vary based on the base of the logarithm you want to use. So we have f of x is equal to 2 to the power of x and then minus 10. Again, let's just write this as y, and then we're going to swap x and y. So let's put this as x and this as y. So let's add 10 to both sides. This cancels. You're going to get 2 to the power of y is equal to x plus 10. Let's get rid of this. And now I'm just going to say that I have log base 2 of 2 to the power of y is equal to log base 2 of x plus 10. At this point, we know the left side would be y, but let's just show it. This comes down. You have y times log base 2 of 2, and this equals log base 2 of x plus 10. So this right here is going to be 1. So you have y is equal to log base 2 of x plus 10. Okay, I'm just going to replace y with f inverse of x. And that's going to be my answer. Let me move this up here. So we're looking through, and we see this one right here is a match. So f inverse of x is equal to log base 2 of x plus 10. Again, if you want to go to Desmos and check out the graphs, you can do f of x equals 2 to the power of x minus 10. That's the original function. That's going to be in black. You have your line y equals x. That's going to be in blue. Then in red, we have our g of x. That's going to be for the inverse. This equals log base 2 of x plus 10. So again, looking at these guys, you can see their reflections across the line y equals x. So they are going to be inverses. All right, let's take a look at the quiz. For the first question, we're asked to use a calculator to approximate each to the nearest thousandth. So this one's a pretty easy one. We have log base 6 of 69. So using a calculator, typically you just have the log key, which is a base 10 logarithm, or you have the ln key, which is a base e logarithm, otherwise known as the natural logarithm. And if you want to use those, again, you use your change of base rule. So you can say the log of this argument here, so 69, over the log of this base here, which is 6. You could also use the ln key. You will get the exact same answer. So however you want to key that in, that's fine. So let's say this is approximately 2.36, and we're rounding to the nearest thousandth. So let's say 3. So it's this one right here. So it's about 2.363. Okay, let's take a look at question 2. So again, we want to use a calculator to approximate each to the nearest thousandth. And we have log base 2 of 45. And again, to key this into the calculator, we'll just go log of this argument here, which is 45, over, we have log of 2, our base here. So this is approximately, let's go 5 point, we're rounding to the nearest thousandth. So I'm going to go 492. So looking through, we want this one here. So it's about 5.492. All right, for question 3, again, we're asked to use a calculator to approximate each to the nearest thousandth. And we have log base 2 of 1.8. So again, we can do ln for the natural log of this argument. So 1.8 over ln, again, your natural log of this base here, which is 2. Let's just key that in. So I get about 0. Let's say 848 if I'm rounding to the nearest thousandth. So this guy right here, about 0.848. All right, let's take a look at question 4. So again, we want to use a calculator to approximate each to the nearest thousandth. And we have log base 7 of 60. And this would be equal to, again, let's just do log of this argument here, which is 60, over log of this base here, which is 7. So let's key this into the calculator, and I get about 2.1. Let's go 0.4 if I round to the nearest thousandth. So this guy right here, again, about 2.104. All right, for question 5, again, we want to use a calculator to approximate each to the nearest thousandth. We have log base 4 of 35, and this equals, we have log of 35. So we're going to use that argument there. And then over, we have log of this base here, which is 4. Let's key that into the calculator. And I get about, let's say, 2.565 if I round to the nearest thousandth. So this guy right here, again, about 2.565. All right, let's take a look at the quiz. For the first question, we're asked to solve each equation. We want to round your answer to the nearest 10,000th, so that's 4 decimal places. We are given 20 to the power of negative 4x minus 6 is equal to 91. I'm going to isolate this part right here first. So let's just add 6 to both sides of the equation. That cancels. You're going to have 20 to the power of negative 4x is equal to 91 plus 6 is going to be 97. Let me just erase things as I go. We'll just keep it on this first page here. What I'm going to do is just use the base 10 logarithm so we can key this into the calculator. If you have an online calculator you're using, then you can use a base 20 logarithm. Again, that's up to you. We're just approximating anyway. So let's go log of, let's go 20 to the power of negative 4x is equal to log of 97. So I just took the log of each side. And again, that's a log with a base of 10. And so this can come out in front as multiplication. So this becomes negative 4x times log of 20 is equal to log of 97. And so what you want to do is isolate x, and I would just reorder this and put this as x times negative 4 like that, times log of 20. And so that way you can divide both sides by negative 4, and then times log of 20 like this. Okay, so we're going to see that this is going to cancel with this, and you're going to have x is equal to, you have log of 97 over negative 4. Let me close that. And then times log of 20. And this is kind of a terrible color to write in. Let me select this and change the color so it's easier to see. Okay, so now it's in black. All right, so looking at this, if you key this into your calculator, you got to make sure you do it correctly. So let me erase this so I can show you that real quick. If you're using an online calculator, don't worry about it. It's just going to calculate it for you. But if you're using something like a TI-83, you have to be very careful about this because of the order of operations. So you want to type in log of 97 and then hit the divided by key. You want parentheses and then negative 4 times log of 20, close the parentheses. Because otherwise, what's going to happen is if you don't have these parentheses, it's going to divide this first and then multiply because of the order of operations. Division and multiplication are on the same priority level. They're worked left to right. So you don't want that to happen. You want this to happen and then to divide. So if you key this in, you will get about, let's say negative 0.3817669. We want the nearest 10,000th. So that's going to be right here. The digit that follows is a 6. So I'm going to add 1 to that 7, and that's going to become an 8. All right, so looking through my choices, it looks like I want this one right here. So x is about, or approximately, negative 0.3818. All right, for question 2, we're asked to solve each equation. Again, we're asked to round your answer to the nearest 10,000th. So this is 4 decimal places. We have negative 4 times 19 raised to the power of 3x plus 3, and then plus 2, and this equals 97. Okay, so the first thing I'm going to do is subtract 2 away from each side of the equation. This cancels, and then you're going to have negative 4 times 19 raised to the power of 3x plus 3 is equal to 97 minus 2 is 95. Now, what I would do at this point is divide both sides by negative 4. Let's do that there and do that there. And so this right here would cancel with this right here, and you're going to have 19 raised to the power of 3x plus 3. Let me make that a little bit better there. And this equals negative 95 over 4. Okay, let me get rid of this. I'm going to just use a base 10 logarithm. So I'm just going to go log of this 19 raised to the power of 3x plus 3 is equal to log of negative 95 over 4. Now, this is a problem because your argument for your logarithm is supposed to be positive. And here it's negative. So if we undo this and we go back to where we were, it's obvious here that we're not going to get a solution. And the reason is because 19 raised to a negative, let's say 3x plus 3 turns out to be something that's negative, well, that's still going to be something that's positive. If this was 0, it's going to be 1. If this was positive, it's going to be positive. So there's no way you're ever going to get negative 95 over 4 out of this guy. So you can just stop and say that there's no solution. All right, for question 3, again, we're asked to solve each equation. we want to round your answer to the nearest 10,000th. So 4 decimal places, we have 10 times 14 raised to the power of 5x plus 3, and then plus 5 is equal to 91. Okay, so let me subtract 5 away from each side. This cancels. You have 10 times 14 raised to the power of 5x plus 3, and this equals 91 minus 5. That's going to give me 86. We're going to divide each side by 10, and so this would cancel. You get 14 raised to the power of 5x plus 3 is equal to, for 86, it's going to be 2 times 43. Let me rewrite this so this is crystal clear. So this is 2 times 43, and 10 is 2 times 5. So of course this would cancel with this, and you could say this is 43 over 5. And now let's take the log of each side. Again, I'm just going to use a base 10 logarithm. You're free to use whatever base log you want to use. So log of 14 raised to the power of 5x plus 3 is equal to log of 43 over 5. Okay, let me get rid of this. We know that this is going to come out in front. So this is 5x plus 3. Now, this is a quantity, so make sure you wrap that with parentheses. And this is times log, let me make that better. So log of 14. And this equals your log of 43 over 5. I think I'm probably not going to have enough room to do this here, so let me go to a different sheet. So for this one, you need to distribute this to each guy. So this is log of 14 times 5x. So you can put the 5x out in front. And then plus, you have log of 14 times 3. So let's go 3, log of 14. And again, you can put a multiplication sign there if you want. It's not wrong. I do it for emphasis. Of course, in most cases, we don't put it there, but I'll just put it there for now. So we'll put equals log of 43 over 5. So looking at what we have here, we want to isolate x. So I would subtract 3 log of 14. Let me put the multiplication symbol in there, away from each side. This would cancel. And let's write this as 5x, or actually, let me redo this. Let me write x times 5 times log of 14, so this is crystal clear, is equal to, let's write negative 3, and then log of 14, and then plus log of 43 over 5. Okay, as a final step, if you're trying to solve for x, let's divide both sides by 5. Again, log of 14, I'll just write it as 5 times log of 14, just for clarity. Let me make that 1 a little bit better. Let me divide over here. So this is 5 times log of 14. Let me change this and make it better. And so let me show this right here as canceling. And what you're going to have is x is equal to negative 3. Let's go log of 14. And then plus, let's go log of, this is probably not going to fit. So let me actually drag this down. And didn't take the whole thing with me. So let me rewrite that part. And so inside this is 43 over 5. And this is over. Let me make that better. We have 5 and then log of 14. Okay, this is not that bad. We're just going to key it into the calculator anyway. So let's punch this in and see what we get. So I get about negative 0.4369. So we'll just stop there. So let me grab this. Let me paste this in. So let me put x is about this. So this is the one we want. So x is approximately negative 0.4369. All right, for question 4, once again, we're asked to solve each equation, round your answer to the nearest 10,000th. So that's 4 decimal places. We have e to the power of 8x times e to the power of 2x is equal to e to the power of 20. Okay, let me just go to another sheet so we don't run out of room here. So what I would do is use my rules of exponents and say this is e to the power of 8x plus 2x, which is 10x, is equal to e to the power of 20. For this one, I would just take the natural log of each side. So let's say that this is the natural log, or ln, of e raised to the power of 10x is equal to ln, or the natural log of e raised to the power of 20. So again, this is just going to be 10x, and then this would be 20. Divide both sides by 10. This cancels, and you get x is equal to 20 divided by 10 is 2. So coming back up, you just want to say x is equal to 2. All right, for problem 5, we are told that we're going to use the formula for continuous compound interest. So a equals p e raised to the power of RT. So if money is invested in a savings account that is compounded continuously, so that's why we have that formula, at 7% annual interest, how long will it take for the investment to triple in value? So triple in value, that means your initial principal is P. Tripling that is 3 times P or 3P. So in other words, instead of A here, the amount we're going to get at the end, we're going to put 3P. That's what we expect to get, and we want to know how long it's going to take. So this equals PE raised to the R, the rate is 7%, so 0.07, and then times T. Let me just do that in a different color for emphasis. Well, first and foremost, you can just divide both sides by P, and you can see that this right here is going to cancel, and you get 3 is equal to, this would cancel, E raised to the power of 0.07T. Okay, let's get rid of this, and let's take the natural log of each side. So let's say that we have ln of 3 is equal to ln of E raised to the power of 0.07 times T. ln of E raised to the power of 0.07t is just going to be 0.07t. This would be equal to ln, or the natural log of 3. To solve for t, we can divide both sides by 0.07. And so this would cancel, and we're going to end up with t is equal to the natural log of 3 over 0.07. And let me bring this up here and just key this into the calculator. And if I round to the nearest hundredth, it's going to be about 15.69. So this is the one we want. So about 15.69 years. All right, let's take a look at the quiz. For the first question, we're asked to solve each equation. We have -3 minus 2, and then you're going to have log base 11 of -9x minus 4, and this equals -7. This problem is really simple. You're just going to isolate this part right here first. So your log base 11 of -9x minus 4. And then once you've done that, you're going to put it into exponential form and then solve the resulting equation. So the first thing I would do here is just add 3 to both sides of the equation. We're going to cancel this. And so you'll have -2 log base 11 of -9x minus 4. And this equals -7 plus 3, that's going to be -4. Okay, at this point, I'm going to divide both sides of the equation by -2. And so this is going to cancel with this. You're going to have log base 11 of -9x minus 4. And this equals negative over negative is positive. 4 divided by 2 is 2. Okay, at this point, we can just put it into exponential form. So we're going to go 11 raised to the power of 2 is equal to this -9x minus 4. So 11 squared is equal to -9x minus 4. And 11 squared is 121, so you can just write this as -9x minus 4 is equal to 121. So at this point, let's add 4 to both sides of the equation. This cancels. You're going to get -9x is equal to 121 plus 4 is 125. Let me slide down here a little bit. Let's divide both sides of the equation by -9. So this is going to cancel. You'll have x is equal to positive over negative is negative, and this would be 125 over 9. Now, this is not going to be able to be simplified because 125 is 5 cubed and 9 is 3 squared. So let me come back up here and paste this in. So we have x equals -125 over 9. Now, that's going to be the correct solution. I've already checked this. I know that it works. In some cases, when you work with logarithmic equations, you could get extraneous solutions, but this is not one of those scenarios. So if you're on a timed exam and you get a question like this, you can just put down your answer and then check it if you get time later on. All right, let's look at question 2. Again, we're asked to solve each equation, and we have log base 9 of 2x squared plus 40 is equal to log base 9 of, let me slide this down here, you have 3x squared plus 6x. So these two bases, you have 9 and 9, those are the same. So what you can do is just set these arguments equal to each other. And so let's say that we have 2x squared plus 40 is equal to 3x squared plus 6x. Okay, so this is a quadratic. So let's move everything to the left and have the right side be 0. So I'm going to subtract 3x squared away from each side of the equation. I'm going to subtract 6x away from each side of the equation. And so this would cancel and this would cancel. So this is 0. Let me slide down here. And let's say that 2x squared minus 3x squared is -x squared. And then we'd have minus 6x and then plus 40. and this equals 0. Okay, if you're going to try to solve this with factoring, I want my leading coefficient to be positive. So just multiply everything by -1. So that's just going to change all your signs. So you'd have x squared plus 6x minus 40. So this was negative, it became positive became positive, positive becomes negative, and this equals 0 times anything is 0, so this is still 0. Okay, let me try to factor this. I think that we can. So let's go ahead and set this up real quick. So you have x here and x here. You want two integers whose sum is 6 and whose product is -40. So let's think about 40 for a moment. You've got 1 and 40, that's not going to work. You've got 2 and 20, that's not going to work. You don't have anything with 3, it's not divisible by 3. You have 4 and 10. Now let's stop there. If you think about 10 minus 4, that's 6. So you can make this work. So if you go positive 10 and you go -4, that's what we're looking for. We can say that we have x plus 10 is equal to 0. Then or you have x minus 4 is equal to 0. Let's subtract 10 away from each side of the equation. This cancels. You get x equals -10. Here, let's add 4 to both sides of the equation. This cancels. So you're going to get x is equal to 4. So x could be -10 or x could be positive 4. Okay, let's come back up and paste this in. Again, this is another scenario where you're not really going to get extraneous solutions. So you can check this just for completeness to make sure you didn't make a mistake. But generally speaking, you're not going to get extraneous solutions with this scenario. So x here would be equal to -10 or 4. All right, for question 3, we are asked to solve each equation, and we have log base 6 of x plus 3, and then minus log base 6 of x minus 6, and this equals 1. So here's one where we have to be very careful. Let me grab this real quick and come down here, and I'll explain what I mean. We know that if we solve logarithmic equations, in some scenarios, we could get extraneous solutions. So pay attention to what happens here when I use my quotient rule for logarithms. We end up with log base 6, because again, the base here is 6 and the base here is 6. You have subtraction, so this is going to be of, you'll have this argument here of x plus 3 for the numerator over this argument here of x minus 6 for the denominator. So the reason this causes an issue, when you think about a negative divided by a negative, that would give you a positive. The same thing is true if you're using the product rule for logarithms to condense a negative times a negative as a positive. So in some scenarios, that's going to create an issue where something that would be undefined in the original form of the equation becomes defined in the transform version of the equation because of that fact. Negative divided by negative is positive, and then also negative times negative is positive. So something like that. So be really careful when you get this scenario. So then we're going to go equals 1. So at this point, it's very easy to solve this. So we're going to go 6 to the power of 1 is equal to this x plus 3 over x minus 6. Let me slide down. 6 to the power of 1 is 6. So this equals x plus 3 over x minus 6. Let's go ahead and multiply both sides by x minus 6. And let's do that here. And let me actually move this down a little bit. So this is times the quantity x minus 6. And so what I'm going to do is cancel this with this. So the right side is just x plus 3. On the left, you're going to distribute this 6 to each guy inside the parentheses. So 6 times x is 6x, and then minus 6 times 6 is 36. Okay, at this point, I'm going to add 36 to both sides of the equation, and then I'm going to subtract x away from each side of the equation. So we're going to say that this would cancel, and this would cancel. 6x minus x, that's going to give me 5x, and this equals 3 plus 36, that's going to be 39. Let's divide both sides of the equation by 5 to finish this up. This cancels. You get x is equal to 39/5. Okay, let's grab this real quick and come back up here. So for this scenario, I recommend checking for extraneous solutions. In this case, this solution is actually going to work. But if you get something like we talked about earlier, I would just check it to make sure. So let's go ahead and plug in. We have log base 6 of, you have x plus 3. So let's write 39 over 5 for x. And then plus for 3, let's write 15 over 5. So this would end up giving me 54, because 39 plus 15 is 54. So 54 over 5. 54 over 5. Okay, let me move this like this. And then minus log. We have base 6 of x minus 6. So 39 over 5 minus, you could go 30 over 5 to write 6. So 39 minus 30 is 9. So this would be 9/5. So this is 9/5. And this should equal 1. Well, there's lots of ways you could split this up. I think the fastest way to do this is to basically say that this is log base 6 of, so I'm going to take this as the numerator, so 54 over 5, And then we're going to divide by this argument here. So if we're dividing and we're working with fractions, remember we take the reciprocal of the fraction and we multiply. So this would be times 5/9. Close that down, and let's say this equals 1. So let's go through here and say that these would cancel. And then 54 divided by 9 is 6. Okay, so you can easily see this is going to work out. You would have log base 6 of 6. And of course, that does equal 1. So you get 1 equals 1. So this is a valid solution. This x equals 39/5. So let's just circle that here. Okay, let's look at question 4. So again, we're asked to solve each equation. You have log base 6 of a negative 3x squared plus 9, and then plus log base 6 of 4. And this is equal to, let me slide this down here, log base 6 of 9. So for this one, you have a base of 6 and a base of 6. And again, this is addition. So what I'm going to do is just write this as log base 6 of, you're going to multiply these guys together. So 4 times the quantity, negative 3x squared plus 9. Make sure to use parentheses here. The 4 needs to be distributed to each guy inside. So this would be equal to log base 6 of 9. Let me slide down here a little bit. Now this condensing is not going to create any problems, so you won't get extraneous solutions from this because this is a 4. So you won't have to worry about this unless it's an algebraic expression with a variable and then an algebraic expression with a variable. If those two get multiplied together, well then you could have something where it's a negative times a negative gives you a positive, and that's where you get an issue. Okay, so for this one, let's go log base 6 of, this would be negative 12x squared, and then plus 4 times 9 is 36. Let's close that down. And this equals log base 6 of 9. At this point, because you have the same base here as you have here, you can set this argument equal to this argument and then solve. So you can say that negative 12x squared plus 36 is equal to 9. You can subtract 36 away from each side of the equation. So this is going to cancel. You get negative 12x squared is equal to 9 minus 36. That's going to be negative 27. Let's divide both sides of the equation by negative 12. Cancel this with this and say x squared is equal to negative over negative is positive. And then let's think about 27 over 12. Each one there is divisible by 3. 27 divided by 3 is going to be 9. And then 12 divided by 3 is 4. So basically you get that x squared is equal to 9/4. So by the square root property, you would say that x is equal to plus or minus the square root of 9/4. So that's going to be plus or minus the square root of 9, which is 3, over the square root of 4, which is 2. So plus or minus 3/2. So this is what we want. Let's go back up and let's paste this in. And this is the solution that we want. Again, you can check this if you want. I'm just going to tell you that it works. In this scenario, because this is a 4 right here, and this is an algebraic expression right here, you're okay. You're not going to end up with extraneous solutions. Okay, let's look at question 5. So again, we want to solve each equation, and we have the natural log of 2 plus the natural log of negative 2x squared plus 9 equals the natural log of 17. Okay, let me slide this down here. And again, I'm just going to use my properties of logarithms, and we're going to multiply here. So let's go that we have the natural log of, this would be 2 times the quantity, negative 2x squared plus 9. So because this is a 2 here, you're not going to run into any problems or any extraneous solutions because this can never be negative. This is always going to be a positive 2. So you don't have to worry about that here. So this is going to be distributed to each guy inside of the parentheses. And let me close this down, and we'll say this equals the natural log of 17. Let me go ahead and grab this, and I can actually just erase this. Come down here and just paste this in. So we have ln of 2 times negative 2x squared is negative 4x squared, and then plus 2 times 9 is 18, and this equals your ln of 17. Okay, let me make this 8 a little bit better. So at this point, again, you can just set these arguments equal to each other, and we're going to say that negative 4x squared plus 18 is equal to 17. Let's subtract 18 away from each side of the equation. Let's come down here, and let's say that this is going to cancel. So we have negative 4x squared is equal to 17 minus 18 is negative 1. Okay, I'm going to divide both sides by negative 4. So that's going to cancel. You're going to get x squared is equal to negative over negative is positive. So this is 1/4. All right, as a final step, we're going to use our square root property and say x is equal to plus or minus the square root of 1/4. So we know the square root of 1/4 is 1/2 because it's the square root of 1, which is 1, over the square root of 4, which is 2. So let's write this as x is equal to plus or minus 1/2. Again, this would be your solution. You can check it if you want. It does work. Again, in this scenario, because this is a 2 here, you're not going to end up with extraneous solutions because when you condense and you multiply them together, you don't have something that could potentially be a negative times a negative, which gives you a positive. This is always going to be a positive 2, so it's not going to be an issue. So feel free to check it if you want. I've already verified that these work. So x is either positive or negative 1/2. All right, let's take a look at the quiz. So here we have 27 raised to the power of x plus 1, then times 27 raised to the power of negative 2x plus 3. And this is greater than or equal to, we have our 1/9. Okay, let me just grab this, and I'm going to come down here and paste this in. So obviously you're going to be able to write each side with a common base. So we can just use our little rule for this. And I'm going to choose a base of 3, although you could choose a different base if you want to. It's really up to you. So 27, we know that's 3 cubed. So I'm just going to write this as 3 cubed, and then this would be raised to the power of x plus 1, and then times, again, for 27, that's 3 cubed, and then raised to the power of negative 2x plus 3. Let me actually slide this down a little bit out of the way. Then this is greater than or equal to, for 1/9, we could write that as 3 to the power of negative 2. Okay, so on the left here, you're going to first use your power to power rule, and you're going to say that 3 stays the same, and you're going to multiply your exponents. So we could say that this is 3 raised to the power of 3 times the quantity x plus 1. So this would be 3x plus 3. Let me just write that here. So 3x plus 3. Maybe that 3 could be better there. And then times, here, the 3 would stay the same. And again, you're multiplying exponents. So 3 times the quantity negative 2x plus 3. So this would be 3 times negative 2x, that's negative 6x, plus 3 times 3, that's 9. So this would be negative 6x. So negative 6x plus 9. Let me make this a little bit better there. Then it's greater than or equal to, you still have your 3 raised to the power of negative 2. Okay, let me slide down here a little bit. Let me make that 3 better there. And then what you're going to do now is use your product rule for exponents. So 3 stays the same. And then you're going to add the exponents. So 3x plus negative 6x is negative 3x. And then 3 plus 9 is 12. So plus 12. And this is greater than or equal to 3 raised to the power of negative 2. Okay, at this point, we're going to use our little rule. We know that if the base here and the base here are the same, and it's greater than 1, so 3 is obviously greater than 1, then you can just take this exponent here, and you keep the sign the same, and then you have this exponent here for your inequality. So in other words, it must be true that negative 3x plus 12 is greater than or equal to negative 2 for this to be true here. So let's go ahead and subtract 12 away from each side of the inequality. So this is going to cancel. You get negative 3x is greater than or equal to negative 2 minus 12, that's negative 14. Let me slide down here a little bit. Now we're going to divide both sides of an inequality by a negative. So when we do that, remember you have to flip the direction of the inequality symbol. Let me just write flip so we don't forget. So this is a less than or equal to now. This is going to cancel. So you get x is less than or equal to, negative over negative is positive, and you get 14/3. Come back up here and paste this in. So I want this one right here. So x is less than or equal to 14/3. You don't want the greater than or equal to. You want the less than or equal to. If you're getting the wrong answer here, it's usually because you're forgetting to flip the sign. Now let me show you the graph. I put it here. If you want to click on it, you can look at it. And the way you're going to generate that, you're going to say 27 raised to the power of x plus 1, and then times 27 raised to the power of negative 2x plus 3. You're going to subtract 1/9 away from each side of the inequality. So you want to know where that's greater than or equal to 0. All right, so if you come to Desmos, and I'll just do this with you really quickly. Let me zoom in just a little bit so we can see what's going on. We're looking for where the y values are either 0, so that means you're on the x-axis. So that's going to be right there. Let me see if I can click on it. So 4.667, that's 14 divided by 3 if you give an approximation for that. So it would be there or anything to the left of that. So that's where we're going to be either 0 for the y value or above that. So we would say x here is less than or equal to our 14/3. All right, let's take a look at question 2. So again, we're asked to solve each inequality. We have 1/9 raised to the power of x minus 28 over 3 raised to the power of x plus 1. And this is less than negative 3. Okay, for this one, you might have found it a little bit tricky. I gave you some hints. So I said this is quadratic in form. So that's how we're going to solve this. And then also, I said that 3 to the power of x plus 1, so this right here, can be rewritten using the product rule for exponents. So just keep that in mind. Let me go ahead and set this up. So 1/9 raised to the power of x, and then minus, we have 28 over 3 to the power of x plus 1, and this is less than -3. Okay, let me grab this real quick, come down here and paste this in. And the first thing I'm going to do is actually write this right here as 1 over 3 squared like that. Now, you know that you can pull this 2 out because I could say this is 1 squared over 3 squared. So in other words, I can legally write this as 1/3 being squared. And then you could raise that to the power of x like this. But I'm actually going to change the way this looks because it's going to be, again, in quadratic in form. So I'm going to put the x here and the 2 here. It's the same thing. This would be 1/3 raised to the power of 2x. Okay, let me move this over here a little bit. And then I'm going to go minus. I'm going to break this up and say this is 28 over. You have 3 to the power of x plus 1. So we know that's 3 to the power of x times 3 to the power of 1. So really what I could do legally is write this as, let me actually erase this real quick and do this as a different form. So we'll have 28 over, I'm just going to have 3, or you could put 3 to the power of 1 if you want, and I'm going to put times 1 over 3 to the power of x. So all I did was break this up to where it's going to be completely obvious what we're going to do. So you can, again, take this x, because you could do 1 to the power of x and that's still 1, you could really write this, let me actually move this over here, as 1/3 being raised to the power of x, and then times your 28 over 3. I'm going to add 3 to both sides. So let me go plus 3, and let's say that's less than 0. Okay, let me slide down here a little bit. And what we're going to do now is make a substitution. So I'm going to let something like u be equal to this 1/3 raised to the power of x. And basically what you're going to have is this would be u squared. And then minus, let's put this out in front. So you'd have 28 over 3. And then times your u. And then plus 3 is less than 0. Now, we pretty much don't want to work with fractions. I mean, you can if you want. It's very easy to clear the fractions. You would just multiply both sides of the inequality by 3. So let's just say we have 3u squared minus 28u, and then plus 9 is less than 0. That's going to make it a lot easier to solve this using factoring, which is something that I want to do. So the first thing you would do is replace this with equals. And let's go ahead and just factor the left side here and see what we get. This is 3, so it's a prime number. So I know this would be a 3u, and this would be a u. In terms of 9, you really have 9 times 1 and 3 times 3. Notice that this sign right here is negative, and this one's positive. So I know this means this is a negative, and this is a negative. So let's start with trying 9 and 1. You put a 9 here and a 1 here, and that's actually going to work. So this outer here would be negative 27u. And the inner here would be minus u. So negative 27u minus u is negative 28u. So this is what we want. So to find the critical values here, you just say 3u minus 1 equals 0, or u minus 9 equals 0. Add 9 to both sides over here, and you get u is equal to 9. So let me put plus 9 here. That's going to be a critical value. And then let's add 1 to both sides. This cancels. You get 3u is equal to 1. Divide both sides by 3. And this cancels, and you get u is 1/3. So you can put plus for positive 1/3. Okay, let me get rid of this. And again, you can use the test point method if you want. You can do a sign analysis, which is what I'm going to do with a little number line real quick. Let me put this right here. Let me draw a number line. I'm just going to make something basic here real quick. And let's just say that 1/3 is here. And also, let's say that 9 is here. The scale doesn't matter. We just need something to organize our information. Let's say that this is A, so that's anything less than 1/3. Let's say that this is B, so between 1/3 and 9, I'm not including anything. And let's say this is C, so anything greater than 9. So let's pick something in A. I'm just going to pick 0. 3 times 0 is 0. 0 minus 1 is negative 1. The main thing is this is negative. If you do a 0 minus 9 here, that's negative 9, so this is negative. Negative times negative is going to be positive. That's not less than 0. So this right here, let's put an F for false. It's not going to work. Then what we want to look at is something in B. So you could pick 1. 3 times 1 is 3. And then 3 minus 1 would be 2. So this is positive. And then here, 1 minus 9 would be negative 8. So this is negative. Positive times negative is negative. A negative is less than 0. So this is true. Okay, for C, let's pick 10. So 3 times 10 is 30. And then 30 minus 1 is 29, so this is positive. And then 10 minus 9 is 1, so that's positive. Positive times positive is positive, so that's not less than 0, so this is false. It's not going to work. Okay, let's get rid of this. The solution here would be anything between 1/3 and 9. Those will both be excluded because we have a strict inequality. So let's say that u, remember we're working in terms of u, is strictly greater than 1/3 and less than 9. Okay, let's get rid of this, and let's come back here to this point. So we let u be equal to 1/3 to the power of x. So you can write this in the middle. It's kind of hard to think about it this way, so I'm going to break it up. Let me write it like this so that you understand what we're doing. So 1/3, like this, to the power of x. How would you solve something like this? Well, what I would do personally is break it up using the keyword and. Remember, with this three-part inequality, you would say something like 1/3 to the power of x is greater than 1/3, like that. And then you would use the keyword and. You would say 1/3 to the power of x is less than 9. So we're going to solve these two. Now, when you work with a base that is between 0 and 1, with both being excluded, remember you have to flip the direction of the inequality symbol that you're setting up. So let me get rid of this and make it like this. Let's say this is a 1 here, just to show the exponent. You are not going to say that x is greater than 1. That would be wrong. Again, because this base is between 0 and 1, with both being excluded, when you set this up, you're going to say that x, and then you're going to flip this. So you're going to flip is less than 1. So that's the first part. Then you can write the keyword and. Over here, you could write this with a base of 3 if you wanted to, but I think it's probably easier to just write this as 1/3, and this would be raised to the power of -2. So for this one, again, you have to flip. So let's put this down here and say we have to flip. So this would be x is greater than now -2. So let me put the keyword and in like this. And now if you want to put your solution together, you can write it as a three-part inequality again. So let's say that x is going to be greater than -2 and less than +1. So let me grab this real quick. And let me come down here and paste this in. It's kind of hard to see all the solutions, so let me slide down here. And we want to select this one, so x is greater than -2 and less than 1. Okay, I'm going to go to Desmos now. Again, you can just click that link. If you add 3 to both sides, again, all you're doing is you're graphing the left, and you're looking for where it's less than 0 and strictly less than 0. So coming to Desmos, you can see, let me make this a little bit smaller. You can mouse over this right here, and maybe I can get it to stay. So this right here is -2, 0, and this right here is 1, 0. So those right there would be the critical values if you're thinking about solving this. And basically you can see between those values, between -2 and 1 with both being excluded, that's where the y values are going to be less than 0. So that's going to be your solution. All right, let's take a look at question 3. So here we're asked to solve each inequality, and we have the log of x plus 23. Remember, this has a base of 10. Let me move this over here. Then plus, we have log of x plus 8. Again, this has a base of 10. And this is less than or equal to 2. Okay, let's grab this real quick and come down here and just paste this in. So what I would do here is just use the test point approach. Again, there's other ways you can do this, but I like the test point approach for this type of problem. So I'm going to go ahead and just replace this with equals for right now and just see what are the critical values. So let's go log of x plus 23, and then plus log of x plus 8. Where's that equal to 2? Now, when you look at a logarithm, we know that the argument needs to be positive in each case. So this would need to be positive. So you have x plus 23 is greater than 0. And you want to use the keyword and. You have x plus 8, that argument there, needs to be greater than 0. These are really simple. Here you subtract 23 away from each side. You get x is greater than -23. And then and. Here you subtract 8 away from each side. You get x is greater than -8. So this one right here is more restrictive. So you want x is greater than -8 when you consider the domain. So let me just write off to the side here that x is greater than -8. And actually, let me pull this below this like this. We'll come back to the inequality in a moment. Let's just come down for right now. Okay, to solve this, you're going to condense. So you're going to say that this is the log of, you're going to multiply these together. So let's go x squared and then plus, you would have 8x plus 23x, that's 31x. And then plus 23 times 8, kind of hard to do without a calculator, but it's 184. Okay, so this equals 2. At this point, just put it into exponential form. Remember that this base here is implied to be 10. So let me scooch this down and put a 10 in there. So you get 10 squared, so that's 100, is equal to x squared plus 31x plus 184. Okay, for this one, it's just a standard quadratic. It's something you can solve with factoring. You can subtract 100 away from each side. So let me say this is equal to 100 like this. Again, subtract 100 away from each side. So this would be 84, and then this would be 0. So at this point, you can factor the left side. And I know we don't work with 84 very often, but if you think about the factors, you'd have 1 and 84. Let me write x here and x here. That's not going to work. Then you'd have 2 and 42. That wouldn't work, but 3 and 28 would work. So you could go plus 3 and then plus 28. Well, 3 times 28 is 84, and 3 plus 28 is 31. So this is what we want. So let me get rid of this. And all you have to do is say x plus 3 equals 0. So you know that that would be x is equal to negative 3. And then x plus 28 is equal to 0. So that would be x is equal to negative 28. Now, when we look at the restriction, we say that x is greater than negative 8. So this one right here is extraneous. It will work in this equation that we set up by condensing, but it will not work in the original equation. Because if you plug in a negative 28 for x, well, it's not going to work here, and it's not going to work here. It's going to work in neither one. So basically, you can just remove that and just say that x is equal to negative 3. So that is your boundary. Let me go ahead and put this right here. But you also have to consider this right here. Let me actually get rid of this, and we're going to go back up. Again, you can just draw something basic. It does not have to be perfect. You're going to put negative 8 there, and you're going to put, let's say, negative 3 here. It doesn't matter if it's the scale. You just want something to organize the information. I know that x has to be greater than negative 8. So anything that's less than negative 8 or negative 8 itself, I'm just going to do like this. This basically wouldn't work. You just put an F or false. You're going to look between negative 8 and negative 3, and then you're going to look at anything greater than negative 3. This is a non-strict inequality, so negative 3 will work. We know that. But let's just test something here, and you can subtract 2 away from each side and say, where is this less than or equal to 0? Let's say you pick something like negative 5. You're just going to plug that in. So you would have the log of negative 5 plus 23. So negative 5 plus 23, and then plus the log of negative 5 plus 8 minus 2. And you want to see what this is with your calculator. And I get something that's, let me say this is approximately negative 0. Let's just go to 7. It doesn't matter what the value is or where you round to. Is it negative? Yes. So I'm just going to put a true here. It's going to work. Okay, let me erase this and erase this. I'm going to go with 0 for the next guy. So you'd have the log of 23 plus the log of 8 minus 2. And you want to know what this is going to be. So here I get about, let's say 0.26. So this is positive, so that's never going to be less than 0 or equal to 0. So this one right here is going to be an F or false. Okay, let me get rid of this. So now we know that the solution would be x is strictly greater than negative 8. Again, it can't be negative 8 because x has to be greater than negative 8. So it has to be excluded. And then less than or equal to negative 3. Again, negative 3 is included because the left side is 0. You'd have 0 is less than or equal to 0, which is a true statement. So let's go ahead and grab this. And let's come back here and just paste this in. So you want this one right here. So x is greater than negative 8 and strictly greater than negative 8 and less than or equal to negative 3. Okay, so once again, if you want to go to Desmos and just click that link that I gave you, this right here, if you mouse over it, you get negative 3 comma 0. So again, at an x value of negative 3, you get a y value of 0. So that would work. And then anything to the left of negative 3 would work up until you get to the point where its x is greater than negative 8. It can't be negative 8. You'll see that this guy is going to approach where the x value is negative 8, but it's never going to be able to get there because x needs to be greater than negative 8 for these two logarithms to both be defined. So here your solution would be x is greater than negative 8 and less than or equal to negative 3. All right, let's take a look at question 4. So we have log squared of x. So remember, that's just notation for the log of x being squared, plus log of x is greater than or equal to 6. All right, I gave you a hint on this one. It's quadratic in form. We did a similar one in the practice test. It's very, very easy to solve this. So let me write log squared of x plus log of x. Let me go minus 6 is greater than or equal to 0. Let me grab this real quick. So for this one, you're going to immediately make a substitution. You don't have to, but I like to do it. So let's just let u be equal to the log of x. So you're going to get u squared plus u minus 6 is greater than or equal to 0. So let's just go ahead and factor this right away. and see what that gives us. This is a u and this is a u. I need two integers that sum to positive 1 and have a product of negative 6. That's going to be plus 3 and then minus 2. So your critical values here, again, if you replace this with equals, you would have u plus 3 is equal to 0. So you get u is equal to negative 3. And then you have u minus 2 is equal to 0. So you get u is equal to positive 2. So when I look at these two guys right here, those are the critical values. If I put this back to a greater than or equal to, you're going to use those to split the number line up. Again, let's just make a little basic number line here. Let's just say that negative 3 is here and 2 is here. Again, it doesn't matter if it's the scale. You just want something to where you can organize your information. Let me get rid of this. We don't need this anymore. So basically, I would pick something to the left of negative 3 and just see if it works. Let's say you pick negative 4. So negative 4 plus 3, that's negative 1. So this is negative. Negative 4 minus 2, that's negative 6. So this is negative. Negative times negative is positive. So that's going to be greater than 0. So this is true. Then if you come between negative 3 and 2, you could pick 0. So this would be positive 3. This would be negative 2. So obviously a positive times a negative is going to give you a negative. That's never going to be greater than 0. So this one right here would be false. Then for something greater than 2, you could pick 3. And so 3 plus 3 is 6. So this is positive. And then 3 minus 2 is 1. So this is positive. Positive times positive is going to be a positive. So it's always greater than 0. So this is true. Okay, so to solve this right here, these would be included because it's a non-strict inequality. So you would say that in terms of u, it's less than or equal to negative 3, then or u could be greater than or equal to 2. So this way or this way. If you want to do this graphically so it's crystal clear, this is your solution like this. That's what it looks like. At this point, you're just going to replace u with log of x. So you have the log of x is less than or equal to negative 3, then or the log of x is greater than or equal to 2. This one is a little bit more tricky to solve. This one right here, again, all you really have to do is put this into exponential form. So your base here is 10, so you don't have to flip the sign or anything like that. This would be 10 squared or 100 over here. And you keep that sign the same, this would be x over here. So x is greater than or equal to 100. So that's one part of this. So x needs to be greater than 0. So keep that in mind. Let me put this off to the side and say x needs to be strictly greater than 0 for this guy to be defined. With that being said, let's go ahead and say 10 to the power of negative 3. That is 1 over 10 cubed, or 1 over 1,000. So it's a 1 followed by 3 zeros. And let's put this same symbol in here. Again, this base is 10. This is an x right here. Okay, so x is less than or equal to 1 over 1,000, but x has to be greater than 0 for this to be defined. So you're going to say x is greater than 0 and less than or equal to 1 over 1,000. Then or x is greater than or equal to 100. So that would be your full solution. Let's come back up here and paste this in and see if we can find it. So it's this one right here. So x is greater than 0. Again, you need that for this guy to be defined. And less than or equal to 1 over 1,000, or x can be greater than or equal to 100. All right, now the graph for this is really hard to work with, so you have to do some zooming. If you click on this point right here, you get this 0.001. So that's 1 over 1,000 if you convert it into decimal form. So you can see that the y value there is 0. What's going to happen is anything to the left of that, but that's still greater than 0, and it's really hard to see here, that's going to work, right? So your y values would be greater than 0. And then let me zoom way out now. So zoom way out, and this is going to go off the screen. Actually, I can do this. I think I'll keep it on the screen. If you come over here to 100, so you have that 100 there. Let me click back on that. So you have 100 here, and you see the y value is 0. So between those values, that's not what we want, right? We want y values that are greater than 0 or equal to 0. So those two values would be included. So here, anything greater than 100 or equal to 100, that part's obvious. Here, it's anything that is greater than 0 and less than or equal to this 0.001 or 1 over 1,000. So you can play around with the graph. This one's a little bit hard to get on your screen, especially if you have a smaller screen like a phone or something like that. But you can play around with it and verify the solution. All right, let's take a look at question 5. So again, we want to solve each inequality. And so here we have log base 9 of x plus 5 is less than or equal to, you have log base 5 of x plus 5. Now I gave you a hint here. It says use the change of base rule. So let me go ahead and do that. So I'm going to write this with a base of 9. So we can go log base 9 of, you're going to use the argument, so x plus 5. And then this is over, log base 9 of your 5 there. Now this down here is a number. Let me write that off to the side. Actually, I'll just slide down here. And I'm going to write, for this one, if you want to key it into your calculator, you can go log of 5 over log of 9 like that. And you're going to get about, let's say 0.73 and just stop there. It doesn't really matter how many digits you put here. You know that this number down here is between 0 and 1, with both being excluded. Well, I have that as the second hint. What do you know about division by a number between 0 and 1? Well, you know that, let me just do this off to the side. Let's say I take the number 1 and I divide by, let's say 0.5, so 0.5. You do that in a calculator, you're actually going to get 2 here. When you divide a number, let's just say 1, and it's a positive number, by something that's between 0 and 1, this is going to increase, right? So it went from 1 to 2. So what we can conclude from that, if you just say, okay, well, this is divided by 1, so this is always going to be the same. This, as long as log base 9 of x plus 5 is a positive number, well, then this divided by this will give me something that's larger than this over 1. All we have to do now is just think about where this would be positive, and then for the or equal to part, just think about where it would be 0. So essentially you want to solve where is log base 9 of x plus 5, where is that positive, or you can actually say where is that greater than or equal to 0? Because again, if it was 0, so if this was 0, 0 divided by 1 is 0. And again, if the result of this is 0, 0 divided by a non-zero number is going to be 0. You're going to get 0 is less than or equal to 0, which is a true statement. Okay, let me slide down here. We're just going to solve this really quickly. So this base here is 9, so you don't have to change or flip the inequality symbol. You have 9 to the power of 0, so 9 to the power of 0. And this over here, you have your greater than or equal to. Now you have your argument, which is x plus 5. Okay, so 9 to the power of 0 is just going to be 1. And then we're just going to subtract 5 away from each side of the inequality, and you get x is greater than or equal to 1 minus 5 is negative 4. So as long as x is greater than or equal to negative 4, this will be a true statement here. And we'll just say that x is greater than or equal to negative 4. Okay, we're going to go to Desmos. So we want to know where log base 9 of x plus 5. Let me show you that first. So this is your log base 9 of x plus 5. That's in black. The other guy is log base 5 of x plus 5. And I wrote that twice just so you could see it's the same form. So the first one I wrote is y equals log base 5 of x plus 5. And then I have y equals log base 9 of x plus 5 over log base 9 of 5, just the change of base rule. If you get rid of this red guy right here, you see it lights up as purple. If you click on that, it just draws over it. Okay, so just showing you it's the same thing. You want to know where the graph in black, the log base 9 of x plus 5, is less than or equal to the graph in, you could go red or purple, however you're displaying that. Well, they're equal right there at negative 4. That's because this guy is 0 and this guy is 0. And then anything to the right of negative 4, well, the black graph is below the red graph. So you can say that this guy right here, this log base 9 of x plus 5, is going to be less than this log base 5 of x plus 5. Again, they're equal at negative 4, but anything to the right of that, that's where the less than is going to kick in, because the black graph, again, is underneath the red graph. All right, let's take a look at the quiz. For the first question, we're asked to solve each word problem. So we have a certain breed of kangaroo was introduced onto a small island 1 year and 8 months ago. The current kangaroo population on the island, so again, this is going to be after the 1 year and 8 months, is 100 and doubling every 10 months. Let me highlight doubling as well. What is the kangaroo population on the island after 5 years? What you have to do for this problem is think about the model in general, and you don't know the initial amount, so the n sub 0. So you have to figure that out first. And then once you have that, you can plug into your formula and figure out what is the kangaroo population on the island after 5 years. So just start with the general model. So n of t is equal to n sub 0 times, you can use a base of e if you want, but because it says doubling every 10 months, I would use a base of 2. So then you have this raised to the power of t over a. So a is going to be the amount of time it takes to double, and here it's every 10 months. So I would put a 10 here, and I would make it crystal clear that t here is in terms of months. So in months. It's very important to specify this, especially with this problem, because it's giving us stuff with 1 year and 8 months, and it's giving us 5 years here. So everything has to be converted into months to plug into this formula. So that's really important. Now, the first step here would be to figure out what is n sub 0, because we don't know what it is. We only know that after a year and 8 months, which is going to be 20 months, the current population is 100. So in other words, you're going to say that 100, that's your n of t, is equal to n sub 0, we don't know what that is, times 2 to the power of, well, the time in months, again, it's 1 year and 8 months, so that's 20 months. It's 12, that's for the 1 year, if you convert that into months. And then you have another 8 months, so it's 12 plus 8, that's 20. So you're going to plug in a 20 for t over 10, and that's basically going to give me 100 is equal to your n sub 0 times 20 over 10 is 2, and then 2 squared is 4. Divide both sides of the equation by 4, and basically this is going to cancel, and you get that n sub 0 is equal to 100 over 4, which is 25. So we know at this point that n sub 0, or the initial amount of kangaroos that they put on this island, is 25. So now, if you want to answer the question, what is the kangaroo population on the island after 5 years, you're just going to plug in for t. But you need to plug in terms of months because that's how the model's built. You cannot put a 5 in there and get the right answer. You're going to have to do n of 60 because 60 is going to be 5 years in terms of months. 5 times 12 would be 60. So this equals 25 times 2 to the power of 60 over 10. And so 60 over 10 is 6. So this would be equal to 25 times 2 to the 6th power. That's going to be 64. And if we do this on the calculator, we get 1,600 or 1,600. So this is the answer that we want. So when it says, what is the kangaroo population on the island after 5 years? It's going to be 1,600. So I know this might be a little bit hard to see. I'm actually going to give you a link for this graph so you can play around with it on your own. So basically what you're looking at here is the model y equals 25 times 2 to the power of x over 10, where x is greater than or equal to 0. So in this case, your y is your n of t, and your x is your time in months. So here x is greater than or equal to 0 because time is not going to be negative. It's either 0 at the initial time period or basically some positive value. You can see that we can check a few things. So using this model, again, the initial is going to be at time 0, you're going to have 25 kangaroos. So 0, 25. Then basically if you look at 20 months, again, that's the 1 year and 8 months that we talked about, you're going to see that you're going to have 100 kangaroos. So 20, 100. And then what we're asked to find is 5 years. So in terms of months, that's 60 months. So you see you have 60 here, 1,600. So the 1,600 is for the number of kangaroos. So if you want to see this to check your answer, you can click the link and visit Desmos and play around with the graph. All right, let's take a look at question 2. So once again, we're asked to solve each word problem. And we have that a culture starts with 5,000 bacteria and the number doubles every 20 minutes. Find the function that models the number of bacteria after t hours. This is actually a very simple problem, but you have to realize that the doubling time is given to you in terms of every 20 minutes, and you're looking for something in terms of hours. So you have to make that connection. The first thing is, I would say that since it starts with 5,000, let me go n of t is equal to, the n sub 0 is 5,000, so we know that. We don't have to solve for that. And then generally speaking, if you're given something that's doubling every 20 minutes, you'd want to go times, you're going to use 2 as the base. We have a base of e, but I'll show you how to do that in a moment. But you go 2 as the base, raised to the power of t over a, where a is the amount of time it takes to double. Now, this is given to us in terms of minutes, so you don't want to put 20 down here for 20 minutes. What you want to do is convert this over into hours. So I think everybody knows that 20 minutes is going to be 1/3 of an hour. So what you'd want to do is put this in terms of the amount of time it takes in terms of hours to double. So let's write t over, for a, you're going to put 1/3. And we know that this would be t over 1 times, take the reciprocal of this is 3 over 1. So this is 3t. Does that make sense? It should, because let me erase this real quick and put 3t here. If you think about this, if an hour has passed, well, you're going to have doubled 3 times because you double at the first 20 minutes, then at 40 minutes, then at 60 minutes. So we're saying 3 of these periods have passed in that given hour because this right here is in terms of hours. So just so that's clear. Now, the next thing we need to do, or the next challenge here, is to actually put this with a base of e. So we know that something like e to the power of ln of 2 is equal to 2. So I'm just going to use that to make a replacement here. And I'm going to write the model as n of t is equal to 5,000. And then times, you're going to do e. Let me move this down here. to the power of ln of 2. So that's just 2. And then basically you're going to have this 3t. So you can put times 3t like that. You could put the 3 out in front here. I think a lot of people would probably prefer that. So let's do it like that and then put the t there. So that would be fine. But we're given some things here that have been approximated. So we need to punch this into the calculator. So we want to do 3 times the natural log of 2. And let me do this over here. So 3 ln of 2 is approximately 2.07944. And I'm just going to stop there. So you see that matches with this right here. So what you could do is write this as n of t is equal to 5,000. Then e raised to the power of, instead of 3 ln of 2, again, we're going to use an approximation. So let's go about 2.07944 and then t. So this is the one that you want. So n of t is equal to 5,000 e to the power of 2.07944t. So again, that's just approximating this 3 ln of 2. If you want something that's going to give you an exact value, this is the model you're going to use. But in most cases, this is okay. Just in case you want to check this, if you look at Desmos and you type in y equals 5,000 e to the power of 2.07944x, where x is greater than or equal to 0, I put some points here. So if you plug in a 1 for your x, you're going to get about 40,000. It's not exact, but it's very, very close. And then if you plug in a 2 for x, you're going to get 320,000. Again, not exact, but it's very, very close. Well, think about the fact that going from 1 to 2, so from 1 hour to 2 hours, you would have had 3 doubling periods. So you go from 40,000 to 80,000, from 80,000 to 160,000, and then from 160,000 to 320,000. So again, if you want to look at this graph and play around with it, I'll leave a link for you. All right, let's take a look at question 3 now. So we want to solve each word problem. And we're told that the half-life of radium-226 is 1,600 years. So this right here, again, if you're working on a problem and they give you a half-life, just take it as a given. A lot of times people will look things up and it's not exactly that, but they're just giving you an estimate. So if you want a matching answer, just use this. So a lab obtains a 40 milligram sample. So that's your initial amount. After how many years will 32 milligrams of the sample remain? We want to round your answer to the nearest year. Okay, for this one, let me come down here and let's start with a little formula. I think you've probably seen this in the lesson, but maybe you're still a little bit lost about it. If you have m of t, and m is just for mass, and this equals m sub 0, that's some initial amount, and then times your e raised to the power of RT. With these problems, you need to figure out r, so that's the starting point. Sometimes the book will give you a formula, and you'll see r is equal to negative ln of 2 over h, where h is the half-life. You might also see this as r is equal to, you have ln of 1/2 over h. Remember, this right here is negative, and this is positive, so you'd have something that's negative. You might also see a negative out in front, and then you're just plugging in ln of 2 over h. So lots of different ways that you can see this. I'm going to derive this once again, and then we're just going to plug into the formula. So basically what you do to derive that, you just say that after h, so in this case it's 1600 years, but let's just say h. So that time period, you would have half of the initial amount. So you have 1/2 m sub 0 is equal to m sub 0 e to the power of r, and then the t is replaced with h because that's the amount of time that's passed for you to get 1/2 of the initial amount. Divide both sides by m sub 0, and this would cancel here and here. So what you're going to have is e to the power of RH is equal to 1/2. If you take the natural log of each side, you're going to get RH is equal to ln of 1/2, and then you could just divide both sides by h. So let me do that right there. And again, if you wanted to, you could write this as 2 to the power of -1, like this, and then from the power rule, you can bring this out in front and say that your r is equal to the negative of ln of 2 over h. Just makes it a little bit easier to write versus ln of 1/2 over h, but you can do whatever you want. So h here is 1600 for 1,600 years. And that means that t is going to be in terms of years. So let me write this as the negative of ln of 2 over 1600. And then you have your t. So this is going to be in terms of years. Let me get rid of this. And let me just arrow to this and put in years. It's really important. All right, so m sub 0, the initial amount, is 40 milligrams. And we want to know how many years it's going to take to get to 32. So let me come back and let me put this as 40. And then basically you're just going to plug in a 32 here. And that is it. You're just going to solve for t. So divide both sides of the equation by 40. So this is going to cancel. 32 over 40, each is divisible by 8. 32 divided by 8 is 4. And 40 divided by 8 is 5. So this is 4/5. And this equals, you're going to have this e to the power of a negative ln of 2 over 1600, and then times your t. And then you would take the natural log of each side. So let's say that, I'll just show this fully. So ln of 4/5 is equal to ln of e raised to the power of negative ln of 2 over 1600, and then times t. Of course, on the right here, you're just going to be left with this exponent. I'm going to write that on the left because I want to solve for t, and I like my variable that I'm solving for on the left. So I'm just going to say negative ln of 2 over 1600 times t is equal to the natural log of 4/5. Okay, to finish things up, we can multiply both sides by the reciprocal of this. So I'm going to go times. You could put negative 1600 over ln of 2, like that. You can put the negative down here if you want, it doesn't matter. So I'm going to do that over here as well to make it legal. Scooch this down. So let's go negative 1600 over ln of 2. And so basically, this is going to cancel away completely. It's going to be 1. And I'm left with t is equal to, we have the natural log of 4/5, and then times, let me put the negative out in front. Let me put the negative of the natural log of 4/5 times 1600. And then this would be over the natural log of 2. So we're just going to punch this into the calculator. And I get about, let's say, 515. You could go 0.08, but they told us to round to the nearest year. So it's about 515 years. Let me come back up and say it's going to be about 515 years. Now, once again, if you want to go to Desmos, I'll give you a link. You have y equals 40e to the power of negative ln of 2 over 1600 times x. So x is the time in years, and x is greater than or equal to 0. Again, you can't have a negative time period in this problem. And just looking at it, we can see that the initial here is going to be at 0, 40. So at time 0, we have this 40 milligrams of the substance. It was radium-226. And then over time, things are going to decay. And so basically, after 515 years, we're going to have 32 milligrams of this sample remaining. You could see that point there. This is approximated, but about 515, and then comma 32. All right, let's take a look at question 4 now. So we want to solve each word problem. We have, at an archaeological dig site, a piece of fossilized bone from an animal was found to contain 30% of the carbon-14 that it originally had. If we use 5,600 years as the half-life of carbon-14, when did the animal die? So again, use this half-life here if you want to get a matching answer. I know a lot of people will look this up and say, well, the half-life of carbon-14 is 5,730 years. But again, this is going to vary based on the book that you're using. So just use the half-life they give you. It's always an estimate anyway, so you can get a matching answer. So we know that from the last problem, you have something like m of t is equal to m sub 0 e to the power of rt. And again, for r, we just did it in the last problem. This is equal to, you can go negative ln of 2 over h. Well, h is the half-life, and here the half-life is 5,600 years. So 5,600 is going to go in there. So let me move this down here. I'm just going to rewrite the model. So we have m of t is equal to your m sub 0. We don't have anything about an initial amount, so we're just going to put that. And then e to the power of your r is negative ln of 2 over 5,600, and then times your t. Now, t is going to be in terms of years because the half-life here is in terms of years. So let me put in years. Always want to make sure you're straight in terms of that. Now, let me get rid of this. What are we told here? We're told that at an archaeological dig site, a piece of fossilized bone from an animal was found to contain 30% of the carbon-14 that it originally had. So originally, it had m sub 0 amount. So basically, at this time, it has 30% of that. So over here, you're just going to say that it's 0.3 times m sub 0. That's it. You're going to divide both sides by m sub 0. And this is going to cancel, and this is going to cancel. So you're going to have e, let me slide down, I'll come back up in a moment. So you're going to have e to the power of negative ln of 2 over 5600 times t is equal to 0.3. So very easy to solve this. Let me actually get rid of this. We don't need it anymore. Get rid of that. As long as you know t is in terms of years, you're good to go. So I'm going to take the natural log of each side. And so I'm going to have negative ln of 2 over 5,600, then times t is equal to ln of, let's go 0.3, so that's more clear. I'm just going to erase this and drag this up here. Okay, we want to solve for t. So all you have to do is say that t is equal to, you're going to multiply both sides by the reciprocal of this. So the natural log of 0.3, and then times, you're going to have 5,600 over negative ln of 2. So let's just write this like this. And I like to bring the negative up into the numerator. It really doesn't matter. And this is just something you're going to key into the calculator. Let me get rid of this. And bring this up here. And let's see what we get. So I get about 9,727. And I get point. Let's go 0. Let's go 1, like that. This is rounded to the nearest year. So if you look at this, you would just say about 9,727. So looking through the choices, it's this one. So about 9,727 years ago. Okay, you can still check this with a graph. What you would do is go with your model and just put in some amount. It doesn't matter. I just used 100, but it could be anything. We're just told that it's going to be 30% of that amount. So if it starts at 100, well, then it should go to 30. That's 30% of 100. So y equals 100e to the power of negative ln of 2 over 5,600, then times x, again, where x is the number of years that has passed, and x is greater than or equal to 0 here. So you see we have a point here that's 9,727, comma 30. In other words, after 9,727 years has passed, the amount of carbon-14 is now going to be 30. Again, initially it was 100. So again, I'll leave the link for this if you want to look at it. Again, you can play around with it and look at other points if you want to see them. All right, let's take a look at question 5. Again, we're asked to solve each word problem. We have a bottle of orange juice has an initial temperature of 70 degrees Fahrenheit. The orange juice is placed in a cooler that has a temperature of 45 degrees Fahrenheit. After 10 minutes, the orange juice has a temperature of 55 degrees Fahrenheit. What is the temperature of the juice after 15 minutes? For this one, we're going to use Newton's law of cooling. So you have big T of little t. This is temperature and this is time. And this equals your T sub S. So that's going to be the temperature for, in this case, the cooler. So where you're placing your item. And then plus you have D sub 0. So that's the initial temperature difference between the orange juice in this case and the cooler that it's being placed in. And then times E to the power of, you can just use R, it doesn't matter. Some books use K. Let's just say RT. So something like that. So let's go ahead and say that this right here is going to be 45. So that's the temperature of what you're placing this into. It could be a room, could be a cooler, whatever it is. It's going in a cooler that has a temperature of 45 degrees Fahrenheit. So put 45 there. This D sub 0, again, that's the temperature difference. So you have your 70 degrees as the initial temperature, and then minus 45 degrees. That's basically where you're putting it into the room. So if you do this, let's borrow here and say this is a 6, this is 10. Let me make that more clear what I'm doing. 10 minus 5 is 5, 6 minus 4 is 2. So this is going to be 25. Let me get rid of this and put this as 25 here. And then basically you need to figure out R. So you're going to say that after 10 minutes, the orange juice has a temperature of 55 degrees Fahrenheit. So you go 55 is equal to 45 plus 25e to the power of, the time here is 10 for 10 minutes, and then times your R. So you want to use this to solve for R. Let me do this on another page. You would subtract 45 away from each side of the equation. And so this is going to cancel. You'd have 25e to the power of 10r is equal to 10. That's just 55 minus 45. That's where I get 10 from. You're going to divide both sides of the equation by 25. So this would cancel. Let me slide down here. And let's say that this is e to the power of 10r is equal to, for 10 over 25, 10 divided by 5 is 2. And 25 divided by 5 is going to be 5. So now just take the natural log of each side. You would have 10r is equal to the natural log of 2/5. And then basically just divide both sides by 10. And so that's going to be your r. So it's going to be that r is equal to the natural log of 2/5 over 10. Now, if you want to approximate this, you can. I get about negative 0.0916. So you could use that value if you want. I'm just going to go with this one. It's really up to you. It's not going to change things much. So let me paste this in here. And let me erase this and put that your r is ln of 2/5, and then basically over 10, and then this is times t. Again, t is in terms of minutes. So let me put this as minutes here. That's the most important thing to think about when you set these things up. A lot of times you get problems where there's a little trick in it, and it'll give you different time units, and so you have to make a conversion. So at this point, we're basically ready to go. It says, what is the temperature of the juice after 15 minutes? Now we can just plug in. So you have T, big T, of 15. Again, this is the time in minutes. This equals 45 plus 25e to the power of ln of 2/5 over 10. And then this would be times 15. So when I punch this into the calculator, I get about 51.32. And this would be in terms of degrees Fahrenheit. So we would round here. So it looks like this is the closest one. We would round to the nearest degree. So we would say that it's about 51 degrees. Again, if you want to go to Desmos, you can just use that link. And you have y equals 45 plus 25e to the power of ln of 2/5 over 10. Then times x, again, where x is greater than or equal to 0. And x represents the amount of time that's passed in minutes. So you can see, let me zoom out a little bit. If we come up here, the initial temperature is going to be right here. So that's at time 0, and basically the temperature is 70 degrees. As the time passes, we go closer and closer to this 15-minute guy. And basically at 15 minutes, you're going to see the temperature is about 51.325 degrees, just an approximation. So you could say it's about 51 degrees if you wanted to round to the nearest degree. So again, you can check this on Desmos if you want to look at any other points or make some other questions and then just use it to check your work. All right, let's take a look at the section quiz. For the first question, we're asked to determine if the given function is a one-to-one function. And we have f of x equals 3x squared minus 2x plus 4. So for this one, if you want, you can go ahead and just graph it on Desmos. And I have this set up for us. So I have f of x equals 3x squared minus 2x plus 4. I know this is really small, so maybe you can't see that. But you can go to Desmos and just sketch this graph. Or of course, you could just do it with a piece of paper. Now I've also sketched the line y equals 8. So that's this horizontal line right here. And basically what you can see is that it's going to impact the graph in more than one location. So immediately we can conclude that this is not the graph of a one-to-one function. Of course, we know this parabola shape is not a one-to-one function shape. So if we come back up here, we're just going to select this function is not one-to-one. All right, let's take a look at question 2. So once again, we're asked to determine if the given function is a one-to-one function. And now we're given f of x is equal to 1 over x squared. And we're told specifically that x is greater than 0. So this is a domain-restricted function. So let me grab this real quick. I'm going to do this in two different ways. So of course, the preferred method is to do this graphically. So if you sketch the graph of just f of x equals 1 over x squared, you get this graph right here. So you can do this on Desmos. Now, specifically, we're told that x is greater than 0. So we want this piece of the graph right here, and this is going to be for all the x values that are greater than 0. So to the right of the y-axis. So if you put that into Desmos, you're going to get this graph right here. Again, this is including our domain restriction. You can key that in with these little curly braces here and just put x is greater than 0 inside. And so basically, if you look at this, it would pass the horizontal line test. And so it is a one-to-one function. Let me come down here and let me paste this in. I'm also going to do this algebraically for you in case you want a little practice with that. So that's a little bit more involved. But we would say if f of a is equal to f of b, so basically you have the same y coordinate, then this implies, let me put, this implies that your A is equal to your B. So in other words, if I have the same Y value, it can only be produced from the same X value if the function is 1 to 1. Let me put that A is equal to B here. So first I'm going to start off with f of A. So f of A is equal to, instead of 1 over x squared, you have 1 over a squared. And remember that x is greater than 0. So here, if I'm plugging in something for x, it's got to take that on. So here I'm going to say that a is greater than 0. And then over here, let's go f of b, and that equals 1 over, instead of x squared, you'd have b squared. But again, I'm plugging something in for x, so it's got to take on this guy right here that says x is greater than 0. So we're going to put that b is greater than 0. All right, so looking at this now, what you would want to do is set f of a equal to f of b, and then see if you can get a equals b. So you're going to have 1 over a squared is equal to 1 over b squared. But specifically here, let me just put a comma. I'm going to say that a is greater than 0. And then I'm also going to put that b is greater than 0. We're going to need this here for this to work. Now you can cross multiply here and set this up as a squared is equal to b squared. And again, let me keep copying this, that a is greater than 0 and b is greater than 0. Now this next step, again, if you don't have these restrictions, that's where you're going to run into a problem. You can take the square root of each side. So you can say this is the square root of a squared is equal to the square root of b squared. And if you don't have these restrictions here, you're going to end up with the absolute value of a is equal to the absolute value of b, and so this would not be 1 to 1. Again, if we go back to this initial graph right here where we didn't restrict the domain, you can see that it would not pass the horizontal line test. So that's what we have right now. When you put in the restrictions, you get this guy right here that does pass the horizontal line test. So let me come back and let me get rid of this. And let's put these restrictions in. We'll say that a is greater than 0 and also b is greater than 0. So if I take the square root of a squared and a is greater than 0, that is specifically going to just give me a. So that is a, again, as long as a is positive. This would be equal to the square root of b squared. Again, if b is positive, well, that's just going to give me b. So you do get a equals b because of these restrictions right here. So that's very important. So this function is 1 to 1 no matter how you do it. Let's come back up here and say this function is 1 to 1. Again, specifically because of this x here is greater than 0. All right, for question 3, we are asked to find the inverse of the given function. So we have f of x is equal to negative 3 over, we have x minus 2, and then plus 1. Okay, let's grab this real quick. Come down here and paste this in. So basically the first step is to replace f of x with y. So you have y is equal to negative 3 over x minus 2, and then plus 1. At this point, you want to interchange or swap x and y. So basically this y becomes an x, and this equals negative 3 over this x becomes a y. And so you have negative 3 over y minus 2 there, and then plus 1. Okay, your goal now is to solve for y. So how do we do that? I'm going to do this in the simplest way possible. So I'm just going to subtract 1 away from each side of the equation. This would cancel. You're going to have x minus 1 is equal to negative 3 over y minus 2. So what I'm going to do is multiply both sides by y minus 2 over x minus 1. Let me do that over here as well. And that's going to work out quite nicely for us. So let me wrap this stuff here so this is clear what's going on. And so basically what's going to happen is this will cancel and this will cancel. So when we see this, we're going to have y minus 2 on the left, and this equals on the right negative 3 over x minus 1. So at this point, you could just add 2 to both sides of your equation. Let me slide down here a little bit. This would cancel. So you get y is equal to negative 3 over x minus 1, and then plus 2. So at this point, you could replace y with your inverse notation and just say f inverse of x is equal to negative 3 over x minus 1, and then plus 2. So that's your inverse. Basically, some computer programs, if you key it in that way, you're going to end up with, let's go f inverse of x is equal to negative 3 over x minus 1, and then plus, they're going to go 2 times the quantity x minus 1 over x minus 1 to get a common denominator. This gets distributed to each guy, so that's 2x minus 2. So this is 2x minus 2. And then here you can add negative 3 plus negative 2, that's negative 5. So that would give you 2x minus 5. So this would be 2x minus 5 over the common denominator of x minus 1. So if you see this in a computer program, that's what they're doing. They're just getting a common denominator. I'm going to go with this answer right here. And before we go up and select that, this is something you can definitely check on Desmos. Again, a lot of this stuff I know you really can't see it, so you just have to key it in on your own. But I have f of x equals -3 over x minus 2 and then plus 1. So that's going to be my guy in green here. So this guy right here and then this guy right here. You have your line y equals x, that's in purple. And then g of x, that's going to be your inverse. This equals your -3 over x minus 1 and then plus 2. So that's without getting a common denominator. If you want to key it in with a common denominator, it'll give you the same graph. That's going to be this guy in black. So I went ahead and did some points here. You can see that this guy in green and this guy in black, they're reflections across the line y equals x. You have this point 0, 2.5 or 5 halves, and then you have 2.5 or again 5 halves, 0. So this going to this. Then this guy right here going to this guy right here. You have this -0.5, 4, and you have this 4, -0.5. Okay, let's come back up and just select our answer. So we have f inverse of x is equal to, you want your -3, so that's going to be right here and right here, and then over x minus 1, so that's right here, and then you have plus 2, so this guy right there. All right, for question 4, once again, we're asked to find the inverse of the given function. We have f of x is equal to the 5th root of x minus 2, and then minus 2. Come down here and paste this in. So the first thing is to replace f of x with y. So you have y is equal to your 5th root of x minus 2, and then minus 2. Then we're going to interchange x and y. So we have x is equal to the 5th root of y minus 2, and then minus 2. Now we're going to solve for y. To do that, I'm going to first add 2 to both sides of the equation. This would cancel. Let me slide down here a little bit. We're going to have x plus 2 is equal to the 5th root of y minus 2. And then we're going to raise both sides of the equation to the 5th power. So you're going to have this quantity x plus 2 raised to the 5th power is equal to, we're going to have the 5th root of y minus 2 raised to the 5th power. So don't expand this. I know a lot of people do that. You'll end up with a very long answer. We're just going to keep this simple as the quantity x plus 2 being raised to the 5th power. Over here, this would undo this, and you're just left with a radicand of y minus 2. So let me write y minus 2 is equal to the quantity x plus 2 raised to the 5th power. And at this point, all I have to do is add 2 to both sides of the equation. This cancels. Let me slide down here and just say that y is equal to the quantity x plus 2 raised to the 5th power plus 2. Again, if you key this into a computer program, it'll probably expand this. So that's why you might get a different answer. But I would just keep it simple like this and say this is f inverse of x, just using our inverse notation. So this is equal to the quantity x plus 2 raised to the 5th power plus 2. And again, I made a little graph for you on Desmos, so you can just key this stuff in if you're interested. So you have f of x equals the 5th root of x minus 2, and then minus 2. That's this guy in black right here. Then you have your line y equals x. That's going to be in red. Then this guy in blue, that's your inverse. So I just key that in as g of x equals the quantity x plus 2 to the 5th power, and then plus 2. So this guy right here. Clearly, these guys are reflections across the line y equals x. Again, you can just play around with some points if you want. Here's -2, 2, and then here's 2, -2. So just reflecting across the line y equals x. This one right here is an approximation, but it's about -3.149, 0. And this one is 0, again, another approximation, -3.149. So these guys, again, reflections across the line, y equals x. Okay, let me come back up here and paste this in. So we're going to want this first one. So f inverse of x is equal to the quantity x plus 2 raised to the 5th power, then plus 2. All right, for question 5, we are asked to determine if the functions f of x and g of x are inverses. So we're given f of x equals 2x minus 10 over x plus 7, and g of x is 7x plus 10 over 2 minus x. So the two functions are inverses if f of g of x is equal to x and g of f of x is also equal to x. So let's go ahead and test this real quick. We'll come down here. I already have this set up. So basically f of g of x is 2 times, this is where an x was in your function f of x, and you're plugging in g of x. So we have 7x plus 10 over 2 minus x, that's your g of x. So then minus 10 over, again, you had an x here in your f of x function, so you're plugging in g of x. So 7x plus 10 over 2 minus x, and then you have plus 7. All right, so to start this off, what I would do is distribute this to each guy in the numerator here. So let's say that this is equal to, you would have 14x plus 20. So 2 times 7x, that's 14x. 2 times 10 is 20. This is over 2 minus x. Then you have minus 10. Now you can just get a common denominator now if you want. So I'm going to go ahead and multiply this by 2 minus x over 2 minus x. So this would be 20 and then minus 10x. So this is 20 minus 10x. Now I do have a common denominator, but I'm going to clean that up in a moment. So let me put this over down here. Let me slide down a little bit. You have your 7x plus 10 over 2 minus x, and then plus, for 7, let's multiply that by 2 minus x over 2 minus x. So this would be 14 minus 7x. Let me just erase that and put 14 minus 7x. Let me say this is equal to, let's say that we have 14x plus 20, and we'll go, this minus is applied to each guy here, so you have to be very careful. So we'll go minus the quantity 20 minus 10x. So that's really important. You're subtracting this whole thing away. This is over the common denominator of 2 minus x. Let me slide down here a little bit more. So then this would be over. You have 7x plus 10 plus 14 minus 7x all over that 2 minus x. We're going to distribute this negative to each guy. We could just do it now. So basically this would be negative and this would be positive. And so you have 14x plus 10x. That's going to be 24x. And then you're going to have 20 minus 20, which is 0. So those basically cancel away. This is over 2 minus x. Then this is over. Down here you have 7x minus 7x. That's 0. That's just going to cancel. And 10 plus 14 is 24. And then this is over 2 minus x. So for this one, we're going to keep this top fraction, the 24x over 2 minus x, unchanged. And then we're going to multiply by the reciprocal of the bottom fraction. So basically this 2 minus x over 24. And so we'll see that 24 cancels with 24. And this quantity 2 minus x is going to cancel with the quantity 2 minus x. And now we're just left with x. So this equals x. So we've shown that f of g of x equals x. That's the first part. Now we have to do this second part. So we have g of f of x. So again, if I look at my function g of x, everywhere there's an x, I'm plugging in f of x. So f of x is 2x minus 10 over x plus 7. So that's how we have this set up. So this equals, again, I'm just going to distribute this to each guy. This would be 14x minus 70. That's just 7 times 2x, that's 14x. And then 7 times negative 10, that's negative 70. Then this is over your x plus 7. And then you have plus 10 right here. So I'm going to get a common denominator, multiply this by the quantity x plus 7. So over x plus 7. So this would be 10x plus 70. So let me write that this is plus 10x plus 70. And this is over the common denominator of that x plus 7. If you want, you can simplify this now. 14x plus 10x, that's going to be 24x. Let's just say that this is 24x. And of course, negative 70 plus 70 is 0. So this is 24x over x plus 7. Then over. We're going to deal with this down here. So let me get a common denominator. You have 2 times the quantity x plus 7 over x plus 7. Then minus, you have your 2x minus 10 over x plus 7. Let me extend this a little bit. Let me slide down so we have lots of room. So here you would have 2x plus 14. So let me write this as 2x plus 14. And then basically you have a common denominator. So you have to be careful though, because you have this minus sign here, and this needs to apply to everything here. So let me write this on a new line. So this is crystal clear. I'm going to go 24x over x plus 7. And this would be over. You're going to have 2x plus 14. Then minus, I'm going to put this inside of parentheses, so 2x minus 10. Again, because the whole thing is being subtracted away. Then this is over x plus 7. Okay, so now this would be 24x over x plus 7. And then over, you have 2x, and then plus 14. This minus becomes applied to each guy. So you'd have minus 2x, and then you'd have plus 10. In other words, the negative of 2x is negative 2x, and then the negative of negative 10 is positive 10. Then this is over your x plus 7. Okay, let's put this equals 24x over x plus 7. And if you want, you can just multiply by the reciprocal now. So times, you have your x plus 7 over. Down here, 2x minus 2x, that's gone, is basically 0. And then 14 plus 10 is 24. So again, you're going to see that a lot of things are going to cancel here. So let's say that x plus 7 will cancel with x plus 7. 24 would cancel with 24. And once again, you get x right there. So this just equals x. So g of f of x also equals x. So coming back up, we can say, yes, these functions are inverses. And again, if you want to look at the graph for confirmation, you're trying to see if these guys are reflections across the line y equals x. And of course, just looking at it, you can tell. Your graph in black, that's f of x equals 2x minus 10 over x plus 7. This guy in red, that's your y equals x line. And this guy in blue, that's your inverse. G of x equals 7x plus 10 over 2 minus x. Again, you can look at a few points if you want. So this one is 0, comma. This is about negative 1.429. This is about negative 1.429, comma 0. And then here you have 5, comma 0, and here you have 0, comma 5. So clearly these graphs are reflections across the line y equals x. So they are inverses. All right, let's take a look at question 6. So now we want to find the inverse of the given function. And we have f of x is equal to x squared minus 18x plus 82. Now we know that this function right here is not one-to-one. Look at the parabola shape. Again, you can just key this into Desmos if you want to look at this. I want to point out that the vertex here occurs at 9, comma 1. So we're going to use that information, and we're going to restrict the domain to create something that's one-to-one with the same range. So now we're specifically going to say that x is greater than or equal to 9. And that's coming from, again, the fact that at the vertex, the x value is 9. So if I have 9 or anything larger, I'm just taking this piece of the graph right here. So that is going to be one-to-one. If you come to this graph right here, this is something, again, you can do on Desmos. You just want to put these curly braces in and say that x is greater than or equal to 9. So again, you get that piece of the graph right here. So this would be a one-to-one function. And so we'll be able to find the inverse. To find the inverse, we are going to replace f of x with y. And we're going to say y is equal to x squared minus 18x plus 82. And we're going to say that x is greater than or equal to 9. Now, let me stop for a moment. Let me go back up and let me specifically write some things out. We know that the domain here, because we restricted it, let me write this out. So the domain is going to be from positive 9 going out to positive infinity. So basically from 9 or anything larger, anything going to the right. Then for the range, that did not change from the original function. So basically anything that is 1 or larger, let's put that here. So 1 or larger. So starting with 1 and going out to positive infinity. Okay, let's come back and let's think about this. When we swap x and y, what we're going to do is we're going to swap the domain and the range. So now what's going to happen is when you find the inverse, the range will be from 9 to positive infinity, and the domain will be from 1 to positive infinity. So coming back down, if we write x is equal to y squared minus 18y plus 82, well, instead of x being greater than or equal to 9, now it's going to be that y is greater than or equal to 9. And we're going to see that this is going to come into play when we get to the final step. All right, so now what we need to do is solve for y. Now, this is where you might get stuck. So we have this part right here where we have y squared minus 18y. So how could we solve this for y? You could use the quadratic formula if you wanted to. I think that's a little bit longer here or more tedious. So I'm actually going to complete the square. Now, I know a lot of people don't like completing the square, but it's going to be easier in this situation. So let me subtract 82 away from each side just to isolate this guy right here. Let me slide down, and I'm just going to put this on the left. I'm going to say we have y squared minus 18y, and this will be equal to, this cancels, so you're going to have x minus 82, and let me just copy that y is greater than or equal to 9. Okay, at this point, we're going to complete the square. What does that do? Again, we're going to transform this into a perfect square trinomial. That way we can factor it into a binomial squared, and then we can use the square root property. So how do we do that? We look at the coefficient right here on the y raised to the first power. So that's negative 18. You cut it in half, and then you square it. So in other words, negative 18, you can multiply by a half, or you can divide by 2, and then you square that. So negative 18 divided by 2 is negative 9. Negative 9 squared is positive 81. So you're going to add that to both sides of the equation. So we're going to have y squared minus 18y. Let me do this in a different color. So plus 81. And then let's go that this is equal to x minus 82. To make this legal, you're going to have to add 81 to this side as well. So I added it over here. And then to make it legal, I added it over here. So then we'll say that y is greater than or equal to 9. Okay, at this point, on the left, you have a perfect square trinomial. So that means I can factor this into a binomial squared. So this is the quantity y minus 9 squared is equal to negative 82 plus 81, that's negative 1. So this is x minus 1, and let me copy that y is greater than or equal to 9. Okay, at this point, we're going to use the square root property. So if the quantity y minus 9 squared is equal to x minus 1, you can say that y minus 9 is equal to plus or minus the square root of x minus 1. Now here's where we have to use this part right here, this y is greater than or equal to 9. You don't want the negative of the square root of x minus 1 when you're doing this. You just want the principal. And let me show you that this is going to work out. If I add 9 to both sides of the equation here, this cancels. You get y is equal to the square root of x minus 1 and then plus 9. Now this is the principal square root here, so we know that by definition, this is going to be 0 or some positive value. You could just say it's non-negative. So if this turns out to be 0 when x is 1, well then I'm going to get a y value of 9. And here y can be 9 or anything larger. If I plug in something that's greater than 1, well, I'm going to get something that's positive here, and some positive plus 9, well, that's going to be where y is greater than 9. So here, y would be greater than or equal to 9 for this guy right here. Let's replace this with the inverse notation. So f inverse of x is equal to the square root of x minus 1 and then plus 9. So that's going to be your inverse. Again, for checking this on Desmos, there's some things you need to key in. I know this is very, very small over here and it's hard to read. So again, you just have to do this on your own. So f of x equals x squared minus 18x plus 82. That's the original function. We restrict the domain. So x is greater than or equal to 9. That's going to be this guy in red now. Okay, and we have this point right here, which is 9, 1. Remember the non-domain restricted version of that was the vertex. So now when we think about the line y equals x, that's in green. And then you have this guy in purple, that's your inverse. So I call it g of x. It equals the square root of x minus 1 and then plus 9. So if you look, they are reflections across the line y equals x. I can grab this guy right here, fold it across the line. I'd get this guy right here. This is 9, 1. This is 1, 9. Here's an additional point. Now, this is approximated here and here, but you have 20, 13.359, and then you have 13.359, 20. So again, just taking this point and folding it across the line y equals x, you're going to get that point right there. Okay, let's come back up here, and we want this one. So your f inverse of x is equal to the square root of x minus 1 and then plus 9. All right, for question 7, we are asked to find the transformation from f of x to g of x. And we have f of x equals 2 to the power of x, and then g of x is equal to 3 times 2 raised to the power of negative x plus 4. Let me write f of x here first more clearly. So this is 2 to the power of x. And then what I'm going to do is write g of x. Let me make this better here. In terms of f of x, I think it's a little bit easier to think about it that way. Well, instead of 2 to the power of x, you have 2 to the power of negative x. So let me write here that this is f of negative x. You have 3 that's multiplying that, so let me put 3 times that. And then you have this plus 4. So let's think about this f of negative x first. What does that do? It gives me a reflection across the y-axis. The reason for that is to get the same y value, I now need the opposite x value because of the negative that's being applied there. You can think about it as multiplying by negative 1, so the x value becomes its opposite, so that's reflecting across the y-axis. So you have reflected across the y-axis, so those two, let me just put a dot there and there. These two, you can just mark them out. Then you have this 3 that's multiplying this guy. That's giving you a vertical stretch by a factor of 3. And this is covered up, so let me move this out of the way so you can see it. I don't know where to put it. Maybe I'll put it down here real quick. So you see how you have vertically stretched by a factor of 3. So already you can stop and say this is the answer. Let me just circle this real quick. And let me move this back up so we can see what's going on. I'll put it maybe right there. And maybe I'll just drop it a little bit and put a little border there so you can see. So now we have this plus 4 to deal with, and that's just going to shift me up by 4 units. So this is what you're looking for. Again, if you want to look at the graph of this on Desmos and just go through a few points, it's pretty easy to do. So you have your f of x equals 2 to the power of x. That's this graph in purple. So we know the points there. You have 0, 1, 2, 4. I didn't put it in, but you'd have 3, 8. So that would be right there. You can put this in if you want. This is 3 comma 8. I'm not going to do the points with that, but you can put it in if you want. You can also do something like 4 comma 16. Again, you can do as many as you want. When we think about the other guy, g of x, this is 3 times 2 to the power of negative x plus 4. So that's your guy in black. So let's just take this point right here, which is 0 comma 1, and let's just go through the steps. The first thing is you will reflect across the y-axis. Well, you're on the y-axis because the x value is 0. So you're not going to do anything there. 0 times negative 1 is still 0. Then you would multiply your y-coordinate, which is 1, by 3 to give you a vertical stretch by a factor of 3. So your 1 becomes 3. So let's just say your point would be right there temporarily. That would be 0 comma 3. Now you want to add 4. So you want to shift up by 4 units. So that's going to put you right there, which is at 0 comma 7. So that's how this point goes to this point. Then the other point I'm going to do is this 2 comma 4. Again, you're going to reflect across the y-axis. So you're basically going to multiply that x value of 2 by negative 1, so that becomes negative 2. So that means your point's going to be right there. Now you're going to stretch the y values by a factor of 3. So you're going to go 4 times 3, that's 12. So let me come up here. So that would put you right there. So you'd be at negative 2 comma 12. And then you're going to add 4 to the y value to shift up by 4 units. So that gives you that negative 2 comma 16. So that's how this point right here, which is 2 comma 4, goes to negative 2 comma 16. All right, let's take a look at question 8. So we're asked to solve each equation. We have 16 over, we have 1/4, which is raised to the power of 3x minus 1. And this equals 64 raised to the power of 2x. I'm just going to solve this by writing things with a common base. So you have 16, you have a 4 down here, and you have 64. You could use 2, but it's probably easier to use 4. Again, whatever you want to do, you'll get the same answer. Let me write 16 as 4 squared. And then let me put this over. 1/4, you could write that as 4 to the power of negative 1. And then this is raised to the power of 3x minus 1. And then this equals, for 64, let's write that as 4 cubed. And then this is raised to the power of 2x. For this one, you're going to use your power to power rule. Let me start with 4 squared over. This would be 4 to the power of negative 1 would multiply this quantity 3x minus 1. So basically you would have negative 3x and then plus 1. So the negative 1 has to multiply by this guy and this guy. So make sure you do that. And then this equals, over here, 4 stays the same. 3 times 2x is 6x. All right, at this point, I would use my quotient rule for exponents. So you have the same base here. So 4 stays the same. You're going to subtract 2 minus this quantity. I would use parentheses here so you don't make a mistake. So negative 3x plus 1. And this equals 4 to the power of 6x. So this is going to get distributed to each guy. In other words, you can put plus negative 1 here if that helps you. And so you would do 4 to the power of 2. And then this is going to be negative 1 times negative 3x. That's plus 3x. And then negative 1 times 1 is negative 1. So then 2 minus 1 would be 1. So let me just erase this and put 3x plus 1. Let me move this over. And this equals 4 to the power of 6x. Okay, so now we have the same base, 4 and 4. So what you can do is just set those exponents equal to each other and solve that very simple equation. So 3x plus 1 is equal to 6x. So let's subtract 1 away from each side. This cancels. Let's subtract 6x away from each side. This cancels. 3x minus 6x is negative 3x, and this equals negative 1. Let's go ahead and divide both sides of the equation by negative 3. And so this would cancel. Let me make this better here. And we're going to say that x is equal to negative over negative is positive, so this is 1/3. So coming back up, we want this answer right here. So x is equal to 1/3. All right, for question 9, we want to solve each equation. We have 27 raised to the power of 2x times 243 raised to the power of negative 2x, and this equals 81. So for 27, you could write that as 3 cubed. So let me say this is 3 cubed raised to the power of 2x, and then times, for 243, that's 3 to the 5th power. This is raised to the power of negative 2x, and this equals, for 81, that's 3 to the 4th power. Okay, let's use the power to power rule here. So 3 stays the same. Maybe that could be a lot better there. And then basically you'd multiply 3 times 2x, that's 6x, and then times, here 3 stays the same. 5 times negative 2x, that's negative 10x. This equals 3 to the 4th power. Here you're going to use the product rule for exponents, and you're going to say that 3 stays the same. And you're going to add 6x plus negative 10x. That's negative 4x. And this equals 3 to the power of 4. So now we have the same base on each side. And so what you're going to do is set the exponents equal to each other. So negative 4x is equal to 4. Let's divide both sides of the equation by negative 4. Let me slide down here. And let's say that this is going to cancel with this. And you get x is equal to 4 over negative 4 is negative 1. So x equals negative 1 here. Let's come back up and just say x equals negative 1. All right, for question 10, we want to solve each word problem. So we have that Sean invests $3,471 in a savings account with a fixed annual interest rate of 9% that is compounded 6 times per year. So what will the account balance be after 8 years? So this is a very simple, what I call plug and chug problem. You just take that information and you plug it into this formula and punch it into your calculator and you're basically good to go. So let's go back up and let's write some things out. So we have $3,471. That's what's put into the savings account. That is the principal. So this right here is $3,471. And then let's go back up. You have the interest rate, which is 9%. You need to put that in as a decimal. So that's going to be right here. So 0.09. That's 9% as a decimal. The n here is the number of compounding periods in a year. So let's go back up. That is going to be 6. And we'll get the years. That's going to be 8. So this right here is going to be 6. And then this right here is going to be 6. And then this right here is going to be 8. So this is something you can just key into your calculator. So we'll say A is equal to, let's write 3,471 times the quantity 1 plus, let's go 0.09 over 6. And this would be raised to the power of 8 times 6. We know that's 48. So let me just put that in like that. Let me slide this down a little bit. Didn't take my A with me. So let me put that like that. And this is something we're going to approximate. If I go back up, it looks like we're rounding to the nearest hundredth. So coming back down, let's go ahead and key this into the calculator. So I get about 7,092 point, let's just go 913, and I'll just stop there. If I'm rounding to the nearest hundredth, I'm going to cut it off at the 1. Basically keep that because we had a 3 there. And so that means I'm just keeping the 1 and cutting everything else off. So this is going to be about $7,092.91. So coming back up, we want this one. So about $7,092.91. All right, for question 11, again, we're asked to solve each word problem. We have that Adam invests $5,112 in a bond fund with a fixed annual interest rate of 6% that is compounded 3 times per year. What will the account balance be after 13 years? Again, just plug into the formula. So the principal is $5,000. So this is $5,112. The interest rate as a decimal, let me go back up, that's going to be 6%. So you're looking at 0.06. Then the number of compounding periods in a year, that's going to be 3, and it's 13 years. So this right here is 3, and this right here is 3. And the t, that's the number of years, that's 13. So just punch this into the calculator. It's very simple. So A is equal to your P, that's 5,112, times the quantity 1 plus 0.06 over 3. This is raised to the power of 13 times 3. We know that's 39. So we can just do that now. Let me move that back up here. So this would be 39. So let's key that into the calculator. So I get about 11,066 point, let's go 17. You can stop at the 5. If you go back up, we're rounding to the nearest hundredth. So we want to go right here, and we want to say that because this digit is a 5, I want to add 1 to the 7, so that would be an 8, and then you can just cut everything else off. So about $11,066.18. So coming back up, you want this one. So it's going to be about $11,066.18. All right, for question 12, we're asked to solve each word problem. We have that Carlos invests $2,054 in a retirement account with a fixed annual interest rate of 6% that is compounded continuously. Let me highlight that. So how long will it take for the account balance to reach $5,696.14? Okay, so this problem is different from the last problems we looked at because the formula is going to change. You have the special number E involved. And so what you're doing here, let me come back up. You're plugging in the information you're given and you're solving for the unknown. We want to know how long. So that means we actually want to solve for T here. So you can do this now or you can plug in and do it. I prefer to set up the formula now. So what you would do is divide both sides by P to get things started. So you would have that this cancels. Let's go e to the power of rt is equal to a over p. Now, what I'm going to do is take the natural log of each side. So we know that's log base e, and log base e of e is 1. So you're doing the natural log of e raised to the power of rt is equal to the natural log of a over p. So this right here will come out in front as multiplication. So you can say this is rt times ln of e. And this right here, you can just mark it out and say it's 1. This equals the natural log of a over p. Now you want to solve for t. So we're just going to divide both sides by r. So we can get t by itself, so that cancels. So you get t, or the time, is equal to the natural log of a over p, and then this is over r. Let me just copy this real quick, come back up here and paste this in, and we can just plug in. So we know a, that's the amount that you get at the end. That's going to be 5,000, and let me get rid of this. This is not going to fit. So 5,696.14. Let me stretch this over. The p, the principal, that's the initial amount invested, so that's 2,054. Close that down. R is the interest rate as a decimal, so that's just 0.06. Let's just punch this into the calculator, and I get about 16 point, my calculator does 9, all these nines. So really, if I want to round this, looking at my answers, it's going to be 17 years, however you want to think about that. So let's just say it's about 17 years. I'll just erase this and say it's about 17, and we'll circle this one and say about 17 years. All right, let's take a look at question 13. So once again, we want to solve each word problem. We have that Mike invests $7,468 in a mutual fund with a fixed annual interest rate that is compounded continuously. So after 16 years, the balance reaches $12,068.84. What is the interest rate of the account? Okay, so let's go ahead and say that if we're looking at this right here, and we want the interest rate, we want to solve for r. So just like we did in the last problem, just divide both sides by p to get things started. So you can have e raised to the power of rt is equal to your a over p. Go ahead and just take the natural log of each side like this. And so basically on the left, this would be r times t. Let me show this so nobody's lost. So r times t times your natural log of e. We know that this guy right here is 1. And this equals the natural log of a over p. So just like we did in the last example. So coming down here, now you're going to divide both sides of the equation by t because you want to solve for r. So this cancels, and you get r, which is the interest rate, is equal to the natural log of a over p, and then this is over t. Okay, let me grab this real quick. So let's just fill this in. So a, that's the ending balance, so it reaches $12,068.84. Your p, your principal, the amount invested, is $7,468. And then t, the time, we're seeing that that's 16 years. So let's put 16. Again, just punch this into the calculator. So let's go 0. I get 0.2999. Let's just stop there. We know that if we round this, it's going to be about 0.03. Let's say we round to the nearest hundredth. And so what that's going to give me, let me just write that out. So let's say it's 0.03, like that. That's going to give me about 3%. All right, for question 14, again, we're asked to solve each word problem. So we're told that Beth invests a lump sum of money in a savings account with a fixed annual interest rate of 3% that is compounded continuously. After 11 years, the balance reaches $5,399.74. What was the amount of the initial investment? Okay, so again, if it's compounded continuously, you're using this right here. But what we want to know is the amount of the initial investment. So you want to solve for p, and to do that, you're just going to say that p is equal to, you would divide both sides by e raised to the power of rt. So this is a over e raised to the power of rt. That's all it is. Let me grab this real quick and come back up here and paste this in. So the a, that's the balance at the end, that's $5,399.74. E is your special number. Don't mess with that. Your R, your interest rate as a decimal, is 0.03. And your T, your time, is 11. All right, so what I get is about, let's go 3,882.001. Let's just say it's about $3,882. So this one right here. If you're getting the wrong answer, be very careful depending on what calculator you're using. If you're using an online calculator, then this is very straightforward to key in. You'll get the right answer. If you're using a TI-83, then what I would do to make sure you don't make a mistake is wrap this right here so that it calculates this first and then raises to that power. And then also for extra clarity, you could wrap this and this. So wrap the numerator and denominator just to make sure you're getting the right answer. So you should get about $3,882. All right, let's take a look at question 15 now. So we're asked to evaluate each. What we have is log base 1/8, and this is of 256. So what is this equal to? Again, to do this, I like to just set it equal to a variable like x. So then you can go 1/8 raised to the power of x is equal to 256. So let's solve this real quick. Come down here. So we have a lot of room to work. So how could you solve this? Well, there's different approaches. If you look at 8 and you look at 256, well, 8 is 2 cubed. So let me write this as actually 2 to the power of -3, and then raised to the power of x. This equals, for 256, it's 2 to the 8th power. At this point, all you have to do is say power to power rule, 2 stays the same. -3 times x is just -3x. And this equals, this is 2 to the 8th power. So 2 to the 8th power. And now you have the same base on each side. So what you can do is just set your exponents equal to each other. So let's say we have -3x is equal to 8. And then I'll divide both sides of the equation by -3. And so what you're going to end up with is this cancels with this. You get x is equal to -8/3. Let's come back up and let's replace this with -8/3. And let's circle that right there. Now, if you want to check this, you would have 1/8 raised to the power of -8/3 should be equal to 256. Is this easy to check? Yeah, it's not that bad. So first off, what I would do is say that this is 1 raised to the power of -8/3, which is just 1, over 8 raised to the power of -8/3, which you could write as 8 raised to the power of 8/3. So then this equals your 256. Now this right here is the cube root of 8. So this is the cube root of 8 and then raised to the 8th power. Well, we know this is going to work out because the cube root of 8 is 2. So this is 2 to the 8th power is equal to 256, which gives me 256 equals 256. So we can say that log base 1/8 of 256 is equal to -8/3. All right, for question 16, we want to solve each equation. We have log base 16 of 8 is equal to x. So for this one, you're going to go 16 to the power of x is equal to 8. Again, if I think about 16, that's 2 to the 4th power. So this is 2 to the 4th power raised to the power of x is equal to 8 is 2 cubed. And let me actually erase this right here and drag this up here so I can do this right on this page. This would be 2 to the power of, multiply the exponents for x is equal to 2 cubed. So at this point, all you really have to do is set 4x equal to 3 and solve that. Let me do that over here. So 4x is equal to 3, just setting the exponents equal to each other, because again, we have this base over here, which is 2, and this base over here, which is 2. So now I'm just going to divide both sides of the equation by 4. This cancels, and you get x is equal to 3/4. So that's what we want. X is equal to 3/4. If you want to check this, let me get rid of this real quick. You can plug in a 3/4 there and see if it works. So let's plug in a 3/4. So 16 to the power of 3/4, is that equal to 8? Well, this would be the 4th root of 16, and then that would be cubed. You could write it like that. Is that equal to 8? Well, this is the 4th root of 16 is 2. 2 cubed is 8. So you do get 8 equals 8. So this x equals 3/4 is a valid solution. All right, for question 17, we want to find the transformation from f of x to g of x. So we have f of x equals log base 2 of x. Let me write that out. So f of x equals log base 2 of x. And then you have your g of x. Let me write that over here. And you can put that in terms of f of x. So basically you have -5 times log base 2 of x and then -1. Well, this log base 2 of x and this log base 2 of x, that's the same. So you have -5 times f of x. And then basically you just have -1. So what does multiplying by -5 do? So in other words, this part right here. Well, the multiplying by 5 gives me a vertical stretch by a factor of 5. And then if I think about the negative, if you had the negative of f of x, what you're doing is you're changing the sign of all the y values. In other words, just like multiplying them by -1. So you're reflecting across the x-axis. So if I look for those, you have vertically stretched by a factor of 5, and then reflected across the x-axis. So the x-axis. Then this -1 here is shifted down by 1 unit. So this is what we want. So we want to say vertically stretched by a factor of 5, reflected across the x-axis, and shifted down by 1 unit. Now again, you can always go to Desmos and play around with this if you want to see it. So I know this is hard to see, but the graph in black here, this is f of x equals log base 2 of x. We've worked with this function a lot. So you have a point here that is 1, 0, and a point here that is 2, 1. Of course, you can get other points if you need them. You could get this point right here, which would be 4, 2. You could get this point right here, which would be 8, 3, so on and so forth. I'm just going to work with 2 points just to make this a little bit quicker. If you look at the graph in red, that's your g of x equals -5 times log base 2 of x, then -1. If you look for some points here, you have this 1, -1, and this 2, -6. Let me start with this 1, 0, and let's do the transformations here. So I'm going to stretch this guy by a factor of 5 vertically. So 0 times 5 is still 0. So that's going to stay. Then we're going to reflect across the x-axis. Again, the y-coordinate is 0 there. Multiply that by -1, it's still 0. And then I'm going to shift down by 1 unit. So that's going to put me right there. So 1, -1, that's coming from this guy. So let me note that that's coming from this. Let me change the color. If I go to this 2, 1 here, well, if I think about a vertical stretch by a factor of 5, well, that 1, that y-coordinate is going to become a 5. So that's going to be right there. Then I would reflect across the x-axis. I'm basically multiplying. Let me write this in. So this right here right now would be 2, 5. I'm multiplying the y-coordinate by -1. So basically it becomes -5. So that's going to come down here to this point right there. And let's say that this is 2, -5 at this point. You can get rid of this. And then I would shift down by 1 unit. So go down by 1 unit. You're going to subtract 1 away from -5 to get you -6 there for the y-coordinate. So that gives me 2, -6. So this point becomes this point. All right, let's take a look at question 18. We want to find the domain. So we have log base 2 of -2x squared plus 5x minus 4. So how do we find the domain? Again, if you're working with a logarithm, you want to make sure that the argument here is positive. So this right here. So we want to solve -2x squared plus 5x minus 4. Let me make that better. So minus 4. Where is that greater than 0? Okay, let's grab this real quick. And let me paste this in here. Now, first off, if you try to factor this, you're going to have an issue, right? You're not going to be able to factor this. So basically what you would do is first think about, you could do the quadratic formula if you want. So in other words, if you're trying to solve -2x squared plus 5x minus 4 is equal to 0, what I would do before I do that is check to make sure that you're not getting two non-real complex solutions. If you were to graph y equals -2x squared plus 5x minus 4, you're going to see that you have a bit of an issue. So this is on Desmos. You'll notice that this graph right here is always below the x-axis. So in other words, it doesn't matter what you plug in for x, the y values are always negative. They're never going to be 0, so you'll never have any x-intercepts here. So let me come back down here. Seeing that from the graph, we're cheating a little bit. One way to speed this up, you could just look at the discriminant. So what is b squared minus 4ac? If that is less than 0, then you get two non-real complex solutions. And so you won't have any x-intercepts. So that means I'm always above the x-axis or below the x-axis. In this case, you would always be below the x-axis. So you know that basically this right here is impossible. This right here would have no solution because you're never going to be greater than 0. Right? You're looking for y values where you're greater than 0, and that's never going to happen. But just to go through this real quick, this would be your a, your -2, this would be your b, and this would be your c. Let me go plus negative here to make that clear. So b squared, 5 squared is 25. Then minus 4 times a is -2. Then times c is -4. Forget about the negatives for a moment. 4 times 2 is 8. 8 times 4 is 32. So basically, this would be negative times negative times negative, which would make it a negative. So this is, you can go plus -32 or minus 32. And this would give me a -7. So because this is less than 0, we get two non-real complex solutions. And at that point, you could stop and say, okay, this is either always going to be true or never be true. So if you don't have access to the graph, all you have to do is plug something in. doesn't matter what it is. You can plug in a 0 for x if you want, because that's easy to work with. And what you would get is you would get -4 is greater than 0, which is false. So once you determine that, you can conclude that this will never be true. So it'll never be greater than 0. Again, just looking at the graph, you can see that clearly. There's nothing you can plug in for x such that you would get a y value that is either 0, that would be an x-intercept, you don't get that, or greater than 0. This is always going to be less than 0. So coming back up here, we know that this right here would never be greater than 0, so it's undefined for all x. Doesn't matter what I plug in, this will always be negative, and so I can't get something that's 0 or negative as the argument for the logarithm, so this is what we want. Undefined for all x, or for the domain, if you're listing that as a set, you'd put the null set. That's the symbol for the empty set or null set. So this right here means the empty set or null set. It just means it's a set with no elements, because in the domain, there's nothing in there, right? We can't plug in anything. Now, one last thing, if you want to see this for yourself, you can go to Desmos and type in either y equals or just log base 2 of -2x squared plus 5x minus 4, and you're going to see that it doesn't do anything, right? It doesn't sketch any graph for you, and that's because no matter what x you try to plug in, this guy's going to be undefined, so it doesn't sketch a graph. All right, for question 19, we're told to expand each, and we have log base 9 of x to the 4th power, then times y, and then this is raised to the 3rd power or cubed. Okay, let me actually do this like this. This is how I like to do it. It's not required, but it keeps things straight for me. Let me make that a little bit better. Let me go ahead and grab this real quick, and we'll come down here so we have a lot of room to work. So the first thing is, when you think about the power rule for logarithms, we know that this 3 right here can come out in front. So let me just put that this is equal to, I'm going to put the 3 times log base 9 of x to the 4th power times y, like that. Okay, at this point, you have multiplication, so you can go ahead and expand this using your product rule for logarithms. So this would be equal to, here's where you have to be really careful. 3 is multiplying the whole thing, so I'm going to put 3, and I'm going to put some parentheses here, and I'm going to go log base 9 of this first factor, which is x to the 4th power, and then plus log base 9 of the second factor, which is y. Okay, at this point, let me slide down here a little bit. You have this 4, that's your exponent. Again, the power rule tells me I can bring that out in front. So let's say that this is equal to 3 times, again, I'm going to use parentheses, the 4 comes out in front. So 4 log base 9 of x now, plus log base 9 of y. So we're almost done. At this point, you're just going to distribute that 3 to each guy inside the parentheses. So it's going to go here and then also here. So 3 times 4 is 12. So 12 log base 9 of x, and then plus, this would be 3 log base 9 of y. Okay, let's go ahead and grab this real quick and come back up here and paste this in. So let's see. So we want 12 log base 9 of x plus 3 log base 9 of y. So this is the one that we want. All right, for question 20, we are asked to condense each. So we have log base 6 of c plus log base 6 of a, and this is over 3, and then plus log base 6 of b, and then this is over 3. Okay, let me go ahead and grab this real quick, and we'll come down here again. We'll do a fresh sheet of paper so we have a lot of room to work. The first thing I would do in this situation is realize that dividing by 3 is the same thing as multiplying by a third. So let me write log base 6 of c plus 1/3 times log base 6 of a plus 1/3 times log base 6 of b. Okay, at this point, you're going to use your power rule for logarithms to bring these back up. So we'll say that this is equal to log base 6 of c plus log base 6 of a to the power of 1/3, and then plus log base 6 of b to the power of 1/3. Okay, let's see what we have here. You have a log with a base of 6, a log with a base of 6, and a log with a base of 6. And you have addition and addition. So all I'm going to do is say, by the product rule for logarithms, I'm just going in reverse here, and I'm going to condense. I'm going to go log base 6 of, you're going to multiply these guys together. Now, this right here, raised to the 1/3 power, is the cube root. So if you want to put these guys together and say it's the cube root, so the cube root of AB, I think the solution is listed BA, but that doesn't matter. And then times, this guy right here is just C. So you can close that down. So that would be condensing. Now, there's different ways you could have written that. You could put the C over here or put the C where it is. You could write AB or BA. It doesn't matter. You could also write AB to the 1/3 power if you want to do it that way. I just think the cube root of AB looks a little bit cleaner. So let me go ahead and grab this real quick. And let me paste this in here. And let's see if we can get a match. So it looks like it's going to be this one right here. So we have log base 6 of, again, you have the C. That's that C right there. And then times, here's your times, you have this guy right here, which is the cube root. So the cube root of BA, again, that's the same thing as the cube root of AB. It doesn't matter the order that you multiply in. So this is the solution that we want. Okay, let's look at question 21. So we're asked to find the inverse. And we have, I'm just going to write f of x as y equals log base 3 of 4 to the power of x. Let me grab this real quick. Before you even do anything here, remember that you could bring the x down. I just want you to see this. So this is y equals, let's say x times log base 3 of 4. What is log base 3 of 4? It's a number. Let's just say it's about 1.26. So if I saw something like y equals 1.26x, I know that's just a linear function, right? That's all it is. So it's going to be a line, right? So when we graph this, you're going to see a line. Let me get rid of this. There's different ways you could write the inverse. But to get the answer to match, what I'm going to do is swap x and y like it is now. So I'm going to say x is equal to log base 3 of 4 to the power of y like that. And then at this point, I'm going to solve for y. And so what I'm going to do is actually just put this into exponential form. So that's one way you could do it. So you would say 3 to the power of x is equal to this 4 to the power of y. Okay, so now I'm just going to use, since I'm trying to solve for y, log base 4 on each side. That's what I'm going to do. So I'm going to go log base 4 of 3 to the power of x is equal to log base 4 of 4 to the power of y. And we know log base 4 of 4 to the power of y is y. So I'm just going to write y is equal to log base 4 of 3 to the power of x, and then just change this over to my inverse notation. So f inverse of x is equal to log base 4 of 3 to the power of x. Now, there are many, many ways that you could write the inverse and it would still be correct. So if you did it a different way, that's completely fine. You can check it on Desmos. Let me come down here. And so I have everything already sketched for us. So this is how I'm keying it in. So f inverse of x, I'm using g of x because at this current time, Desmos does not take this. So this equals log base 4 of 3 to the power of x. That is going to be the guy in red. So that's your inverse. The original function we're working with, remember I told you this is a linear function, this is f of x equals log base 3 of 4 to the power of x. So that's this guy right there. So when you think about the inverse, again, it's a reflection across the line y equals x. I have some points here. They have some approximations in them. And maybe it's a little bit hard to see, but here you have -6 comma -4.755. And then this one is -4.755 comma -6. And then up here, I've got 3.17 comma 4, and then here 4 comma 3.17. Again, some of these things are approximations, so just keep that in mind. But if you go through to Desmos and maybe you got a different answer, you can key it in and see if it matches up with this inverse that I've given you here. So do it a little bit lower and see if it completely covers up this red graph right here. If it does, you got the right inverse. So lots of different ways you can answer this. So let's come back up here and paste this in. And so looking through my choices, I want this one right here. So f inverse of x is equal to log base 4 of 3 to the power of x. All right, for question 22, we want to find the inverse of each function. So we have f of x equals 2 to the power of x plus 6, and this is raised to the 1/5 power. So let me just write this. F of x is equal to, instead of the 1/5 power, let's go the 5th root of 2 to the power of x plus 6. Let's just change this over into y now. And I'll just copy it. Okay, so what I would do again is just swap x and y to start. So x is equal to the 5th root of 2 to the power of y plus 6. You've got to get rid of this 5th root here. Maybe that 5 could be better. So what I would do is raise both sides to the 5th power. Let me slide this down a little bit. So x to the 5th power, and then this guy would be raised to the 5th power. So on the right, you're just going to have this radicand. So let me just reorder this and say this is 2 to the power of y plus 6 is equal to x to the 5th power. Let me subtract 6 away from each side of the equation. That cancels. And what you're going to have is 2 to the power of y is equal to x to the 5th power minus 6. Okay, at this point, I want to get y by itself. So I'm going to use a log with a base of 2 on each side. So let me say log base 2 of 2 to the power of y is equal to log base 2 of x to the 5th power minus 6. Again, this is not the only way you can do it, so you can always check your answer on Desmos. I'll go down there in a moment. So log base 2 of 2 to the power of y is just y, and this equals log base 2 of x to the 5th power minus 6. All right, at this point, I'm just going to use my inverse notation. So f inverse of x is equal to log base 2 of x to the 5th power minus 6. Okay, let me grab this and come down here and paste this in. So basically we have our sketch here. So we have the original function f of x equals the 5th root of 2 to the power of x plus 6. That's going to be your guy in red, so this guy right here. You have your line y equals x, that's in blue. And then the inverse, f inverse of x, again, I'm using g of x for that. This equals log base 2 of x to the 5th power minus 6. That's going to be this guy in green. Now again, if you're keying this stuff in, maybe you got a different inverse and you want to check it, you can key this answer in that I'm giving you, and then below that, key in your answer and see if it matches up with this. It's going to basically cover it up completely, and so you know you have the right answer. And you can see this is a reflection across the line y equals x. Again, looking at some points, some of these are approximations, so this is 1.585, comma 2, and this is 2, comma 1.585. So just a reflection across the line y equals x, and the same thing here. You have 2.07, comma 5, and then 5, comma 2.07. Okay, coming back up here, we have f inverse of x is equal to log base 2 of, you have your x to the 5th power minus 6. So this guy right there. All right, let's take a look at question 23. So now we want to use the change of base formula to approximate the value of each logarithm. We want to round your answer to the nearest thousandth. So that's going to be 3 decimal places. So we have log base 3 of 51. So you could use the base 10 logarithm, known as the common logarithm, or you can use the natural logarithm. In fact, at this day and age, you can just plug this into any online calculator and it'll just do it for you. But for a lot of you, you're still using maybe a TI-83 or something like that. So you need to do this conversion. So we'll just go log of 51. So you go log of the argument over log of the base. So just like that, and you can key that into the calculator. Again, if you want to use the natural log, just put ln here and ln here and key it in. And I get about, let's say 3.5789. Let me just stop there. We're going to the nearest thousandth. So here's the tenths, hundredths, thousandths. So we're rounding to that guy right there. Now the digit that follows is a 9. So basically we're going to add 1 to that 8, and that's going to become a 9, and then just cut everything else off. So I'm looking for this answer right here. So about 3.579. Okay, let's look at question 24. So we want to solve each equation. We have negative 2 times 15 raised to the power of 4x plus 8. And then we have plus 4, and this equals negative 64. All right, so the idea here is that we're not going to use that rule where we have the same base on each side. So we're going to use logarithms to get a solution. So you want to isolate this guy right here. So this right here. How do I do that? Well, I'm going to subtract 4 away from each side of the equation. This cancels. We're going to have negative 2 times 15 raised to the power of 4x plus 8. And this equals negative 64 minus 4. That is negative 68. Okay, let me slide down here a little bit. And what we're going to do is divide both sides of the equation by negative 2. And so this is going to cancel. You're going to get 15 raised to the power of 4x plus 8 is equal to negative over negative is positive. 68 divided by 2 is 34. All right, at this point, what we're going to do is use a base 15 logarithm. So I'm going to go log base 15 of 15 raised to the power of 4x plus 8. This equals log base 15 of 34. Let me make this better here. So we know that log base 15 of 15 raised to the power of 4x plus 8, well, this is just 4x plus 8. And this equals log base 15 of 34. So you're trying to solve for x. So how do you do that? Remember, log base 15 of 34 is just a number. So we're just going to subtract 8 away from each side of the equation. And so this is going to cancel. Let me slide down here a little bit. And we're going to have 4x is equal to log base 15 of 34 and then minus 8. The last thing I'm going to do here is divide both sides of the equation by 4. This cancels. Let me slide down here a little bit and say that x would be equal to, we have log base 15 of 34 and then minus 8. and this is over 4. Now, there's different ways you can do this. You can key it into a calculator and give an approximation. You can give it like this. You could split this up and say that this is over 4, and then you can go minus 8 over 4, which is 2. So you can give your answer like that if you want. Again, a lot of different forms. I'm just going to go with, so the minus 8, and this is all over 4. So we're looking for this one right here. So x equals log base 15 of 34 minus 8, so that's your numerator, and then over 4. All right, let's take a look at question 25. So we want to solve each equation. So we're given 10 to the power of x times x squared. And then we have minus 10 to the power of x, and then times x is equal to 2 times 10 to the power of x. So this is actually a very simple problem. It throws people off because you have the 10 to the power of x everywhere, but really you're going to be able to deal with that quite easily. Let me move this down here and paste this in. What I would do is just subtract this away from each side and just write this side as 0. Now you could just factor out 10 to the power of x. There's other things you could do, but I think that's probably the easiest way to deal with it. So 10 to the power of x times the quantity, you'd have x squared right here. Let me highlight this stuff as I go. You would have this x right here and a minus, so let's go minus x. And then you would have this 2 right here and then a minus. So let's go minus 2, close that down and say that equals 0. So once you set it up this way, you see it's a very easy problem. The first thing is you have 10 to the power of x is equal to 0. That doesn't have a solution. So this does not have a solution. No solution. Because you have 10, if you raise it to something that's negative, that's going to give you something positive. If you raise it to 0, you get 1. If you raise it to a positive number, you're going to get a positive number. So basically, you cannot have this be equal to 0 or something negative. So this has no solution. And then you'd say, or you would go x squared minus x minus 2 is equal to 0. Well, you can just factor this and solve it. This is x and this is x. Give me two integers that sum to -1 and have a product of -2. So that's -2 and +1. Okay, let's come down here. Let's say that x minus 2 is equal to 0 or x plus 1 is equal to 0. Add 2 to both sides, you get x is equal to 2. Then or, over here, subtract 1 away from each side, you get x is equal to -1. So x would be -1 or +2. Now come down here, and you can look at the graph of this guy. So you just key it into Desmos. And you can key in y equals 10 to the power of x times x squared minus 10 to the power of x times x minus 2 times 10 to the power of x. So you get this graph right here. And I obviously can't show all of it, but just look at where it's equal to 0. That's going to be right there. At -1, you see -1, 0. And then right there at 2, 2, 0. So let's go back up and let me paste in the solution. So we're looking for x is equal to -1 or 2. That guy right there. All right, let's take a look at question 26. So we want to solve each equation. We have log base 2 of x minus 5, then minus log base 2 of x minus 2, and this equals 4. So to solve this, the first thing I'm going to do is condense on the left. You have this subtraction here. You have a base of 2 and a base of 2. So what I'm going to do is write this as log base 2 of x minus 5 over x minus 2. Okay, let me close that down. This equals 4. So keep in mind that something that works here might not work here. So we have to check our solutions. So let's go ahead and say that 2 to the 4th power, which is 16, I'll just write that as 16, is equal to this guy right here, which is x minus 5 over x minus 2. So for this one, you could just cross multiply. Let me write this as 16 over 1. So this would end up with 1 times x minus 5, which is x minus 5. Let me put a little border here, is equal to, this would be 16 times the quantity x minus 2. Okay, let me slide down a little bit. We'll come back up in a moment. So this would be x minus 5 is equal to 16x and then minus 32. So just distributing this 16 to each guy inside. So if I subtract 16x away from each side, this cancels. Let me add 5 to both sides. This cancels. X minus 16x is negative 15x. And this equals negative 32 plus 5. That's going to be negative 27. Let's divide both sides of the equation by negative 15. This cancels. We get x is equal to negative over negative is positive. For 27, it's 9 times 3. Let me write this out. So 9 times 3. For 15, that's 5 times 3. So you can cancel the common factor of 3. So you get 9/5. So that is for x. For the original equation, it's not going to work. If you say x is equal to 9/5, well, what's happening is 9/5 minus 5, that's negative. You can't have a logarithm with an argument that's negative. 9/5 minus 2, that's negative. See, what's happening is if you plug in a 9/5 here and here, you're going to get a negative here and a negative here. So negative divided by negative is positive. So that's why it makes it okay. You would actually, if you want to do it, you have 9/5 minus 5. Let's go 25 over 5. This would be over. You'd have 9/5 minus 2. Let's write 10/5 like that. So this would be 9 minus 25. That's negative 16. So negative 16 over 5. And this right here, 9/5 minus 10/5, that would be negative 1/5. So negative 1/5. And so basically this becomes negative 16/5 times, take the reciprocal of this, so negative 5 over 1. This cancels and this cancels. So you get positive 16 out of that. Now, if you look at this and you said log base 2 of 16, yeah, that's 4, because 2 to the 4th power is 16. So it does work in this equation, but again, it's not going to work here because this would be undefined and this would be undefined. So there's no solution to the original equation, even though it works in the transformed one. So you have to make sure you remember that. Let's go back up and we're going to mark that there's no solution. Just in case you want to go further on this and you're still a little bit confused, you can go to Desmos and type in, let me write this out, I know it's hard to see. So y equals log base 2 of x minus 5, and then minus log base 2 of x minus 2, and then minus 4. So look at where this guy would be equal to 0, and you see it's never going to be, right? So this is your x-axis. So you see that there's no x-intercept. There's no place where the y value would be 0. This guy is strictly below the x-axis, so the y values are always less than 0, so you'll never get it to be equal to 0. Now, if we come down here, I graphed both of them just so you can see what's going on. So this is the one I initially graphed. It's in black. It's been covered up by this one because it's lower. So if I graph y equals log, let me write this out. So y equals log base 2 of x minus 5 over x minus 2, and then I do my minus 4 here. So minus 4, I'm looking for where this is 0 now. And basically, I'm looking for the x-intercept. So you see it happens right there. You have 1.8, which is 9/5, comma 0. So it's okay for this second guy, the transformed version of that when we condensed, but it doesn't work in the original. In the original, you just have this graph right here, but in the transformed, you have this piece and this piece. So you do get an x-intercept. So there is a solution for that equation, even though there's not a solution for the original. All right, for question 27, we want to solve each equation. So we have log base 9 of 4x squared minus 6, and then minus log base 9 of 5, and this equals, let me slide down here, so we have log base 9 of 71. All right, so looking at this, I'm going to condense over here. Now, you're not going to have the same problem like you did in the last example, because this is a 5, it'll always be a 5, and this is 4x squared minus 6. So it's not like you're going to be able to divide these guys and have something where you have something that would be undefined, and this guy all of a sudden be defined in the new version. And that's because this number is always a 5. So something that doesn't work here is also not going to work in the transform version. So let's go ahead and say this is log base 9 of 4x squared minus 6 over 5. And this equals, this would be log base 9 of 71. Okay, at this point, since you have log base 9 and log base 9, you can just set the arguments equal to each other, and you can solve that equation. That's all you have to do. So let's go ahead and say that this is 4x squared minus 6 over 5 is equal to 71. You can multiply both sides by 5. So let's do that over here and over here. So, of course, this would cancel. And let me make that better. You're going to have 4x squared minus 6 is equal to 71 times 5 is 355. Let's add 6 to both sides of the equation. This cancels. You get 4x squared is equal to 355 plus 6. That's going to give you 361. And what I want to do now is divide both sides of the equation by 4. This cancels. You get x squared is equal to, you have 361 over 4. Now, you can't really reduce that. And the reason is because 361, that's going to be odd. And basically 4 is 2 times 2. So really nothing you can do there. But you can use your square root property and say that x is equal to plus or minus the square root of 361 over 4. The square root of 361 is 19. The square root of 4 is 2. So this is plus or minus 19 halves. And let me come back up here and paste this in. So you want this. X equals 19 halves and then negative 19 halves. Now, if you want to check this, you can go log base 9 of 4 times, you have this 19 halves squared. Now, it doesn't really matter if it's a plus or minus there because when you square it, the positive stays positive and the negative becomes positive. So you can just leave this as 19 halves. Don't worry about the signs. And then you have minus 6 here. Close that down. Let me actually get rid of this. Let me move this up here real quick. And I didn't take my L with me. So then we have minus, we have log base 9 of 5. This should be equal to log base 9 of 71. Let's see if it is. So this right here, we know if we square it, we're going to go back to 361 over 4. So this is 361 over 4. And if you multiply those together, you're going to get 361. So just like that. And 361 minus 6, that's 355. So that's what you have there. Now, if you do this subtraction here, you can say that it's log base 9 of 355 divided by 5, which would be 71. So you get log base 9 of 71 is equal to log base 9 of 71. And again, this is just a number and this is just a number. It's the same number on each side of the equation. So this is a true statement. So we know that x equals 19 halves and negative 19 halves. Those are valid solutions. And you can also check this graphically on Desmos if you want. Okay, let's take a look at question 28 now. So we want to solve each equation. And I have log of x squared plus 1 is equal to, we have log of x minus 2, and then plus, let me slide this down so I can fit this, we have our log of x plus 3. Okay, let me grab this, come down here and paste this in. So I think most of you know at this point that if you just have log and there's no base given, there's an implied base of 10, right? It's the common logarithm. You can write it in if you need to. So let's go ahead and just put it in for clarity so nobody is lost. And essentially on the right, you're going to condense. So you're going to use the fact that you have a plus here and the same base here, 10 and 10. So let's copy what's on the left. So we have log, and again, you could write the base of 10. I'm just going to leave it off. So log of x squared plus 1 is equal to the log of, I'm going to multiply these two arguments together. So x times x is x squared. And then your outer would be 3x. Your inner would be negative 2x. So that's plus x. And then negative 2 times 3 is negative 6. So minus 6, close that down. Okay, at this point, you have a base of 10 and a base of 10. So that means log base 10 of this equals log base 10 of this. You could just set the arguments equal to each other. So this must be equal to this. All right, so let's go ahead and say that x squared plus 1 is equal to x squared plus x minus 6. So you can get rid of this right away. Just subtract x squared away from each side. So basically you're going to have, let's write this 1, or actually let me flip the sides around. Let me go x minus 6 is equal to 1. Add 6 to both sides of the equation. And you're going to get that x is equal to 7. So x equals 7. Does this work? Let's check it in the original equation and make sure. So if I plug in a 7 here, 7 squared is 49, and 49 plus 1 is 50. So basically you have the log of 50 is equal to, over here, you would have 7 minus 2, that's 5. So let's go log of 5. And then plus, over here, 7 plus 3 is 10. So you'd have the log of 10. Now, the log of 5 plus the log of 10, that is the log of 5 times 10, or 50. So you could write this as the log of 50 as well. And again, this is just a number. So log of 50 equals log of 50. So x equals 7 is a valid solution. So come back up here and just say x is equal to 7. All right, let's take a look at question 29. So we're told to solve each equation. So we have log base 4 of, we have the absolute value of 2x plus 2. Let me write that correctly. So 2x plus 2. And then this is minus, let me slide this over. We have log base 4 of, you have the absolute value of 3x plus 1. Close that down and make that a little bit bigger there. And actually, let me change the colors for this so this is crystal clear, that these are absolute value bars. Some people get confused by that. So let me put that in there. And then this equals 1/2. Okay, let me grab this real quick. Come down here and we're just going to paste this in. This problem is not that difficult. There's different ways you can solve it. So based on how involved you want to be. So we're just going to condense on the left side. Let's go log base 4 of. This is subtraction here. And again, you have a base of 4 and a base of 4. So you're going to put this argument here, the absolute value of 2x plus 2. And then over this argument here, which is the absolute value of 3x plus 1. And then this is equal to 1/2. So at this point, I'm just going to put this into exponential form. So you have the absolute value of 2x plus 2 over the absolute value of 3x plus 1 would be equal to this 4 to the 1/2 power. We know that 4 to the 1/2 power is the square root of 4, so this is just 2. So this equals 2. Now, what I'm going to do here is use a little rule. We know that if you have the absolute value of A over the absolute value of B, this is equal to the absolute value of A over B. As long as B is not equal to 0 or something like that, where you're getting something that's undefined because division by 0 is undefined, then this would be true. So here what we're going to do is just use the same concept. We're going to say this is the absolute value of 2x plus 2 over 3x plus 1 is equal to 2. Let me get another sheet of paper going. We know if we have something like the absolute value of, let's say, u is equal to 2, then u is equal to 2 or u is equal to negative 2. Because if I plug in a 2 there, absolute value of 2 is 2. If I plug in a negative 2, the absolute value of negative 2 is also 2. So I get two different solutions here. The same thing is going to be applied here. So I'm just going to say that this right here is 2x plus 2 over 3x plus 1. So if this was equal to 2, so in other words, if I find an x such that the left side is 2, well, if you get a 2 here, the absolute value of 2 is 2. Then, or it could also be true that 2x plus 2 over 3x plus 1, so this part right here, could be equal to negative 2. So if I find an x such that this right here becomes negative 2, well, the absolute value of negative 2 is 2. So it would be satisfied in either case. So let's come down here and just solve these. They're pretty easy overall. Let me put this over 1 and this over 1, and I'm just going to cross multiply to set things up. So this would be 2 times the quantity 3x plus 1 is equal to 1 times anything is itself, so 2x plus 2. And then over here, it's going to be the same thing, you just have a negative out in front. So negative 2 times the quantity 3x plus 1, and this equals your 2x plus 2. Okay, let's slide down here a little bit, and maybe I can slide this over so it fits a little bit better. All right, over here you need to distribute, so this is 6x plus 2. So this 2 is getting multiplied by the 3x and also by the 1. And this equals 2x plus 2. And then, or over here, let's distribute this. You're going to have negative 6x, and then minus 2 is equal to 2x plus 2. Okay, over here, let's subtract 2x away from each side of the equation, and let's subtract 2 away from each side of the equation. So basically, this is going to cancel, and this is going to cancel. 6x minus 2x is 4x, and this equals 2 minus 2 is 0. Over here, let's add 2 to both sides of the equation, and let's subtract 2x away from each side of the equation. Let's cancel this, and let's cancel this. Negative 6x minus 2x, that's going to be negative 8x, and this equals 2 plus 2 is going to be 4. Okay, let me slide down here a little bit. Let me put or in here. Divide both sides over here by 4. This cancels. You get x is equal to 0. Then or, over here, divide both sides by negative 8. This cancels. You get x is equal to 4 over negative 8 is negative 1/2. So x can be equal to 0 or negative 1/2. Now you can look at this graphically if you want. I went ahead and sketched this on Desmos. So y equals log base 4 of, you have the absolute value of 2x plus 2, then minus log base 4 of, you have the absolute value of 3x plus 1, and then minus 1/2. So because I subtracted 1/2 away from each side, what I'm doing is looking for y is 0. So right there you get negative 0.5, which is negative 1/2, and then right there you get 0. So let's just come back up here and select this, x equals negative 1/2 and 0. If you want to plug those in and verify they work, you saw it on the graph, you can do that real quick. In fact, let's just do it real fast. It won't take that much time. So log base 4 of, you have the absolute value of 2, and then we're going to plug in something for x, and then plus 2. Close that down, and then close that down. Let's go minus log base 4 of, you have the absolute value of 3 times plug in something for x, plus 1, close that down, close that down. This should be equal to 1/2. If I start with 0 here and here, just plugging that in for x, well, basically you have the absolute value of 2, which is 2. So you have log base 4 of 2 minus, this would be 0 and this would be 1. You'd have log base 4 of 1. The absolute value of 1 is 1. And so is this equal to 1/2? Yes, because this right here, log base 4 of 1, that's 0. 4 to the power of 0 is 1. So this right here is 0. So basically you have log base 4 of 2, and that's 1/2. 4 to the 1/2 power is 2, so you get 1/2 equals 1/2. So 0 is a valid solution. Now the other one is going to be negative 1/2. Let's punch that in and see what we get. That one's probably more involved. So 2 times negative 1/2 is going to be negative 1. So negative 1 plus 2 is 1. So this becomes the absolute value of 1, which is 1. Log base 4 of 1 is 0. So this would be 0 minus. For this part right here, 3 times negative 1/2 is negative 3/2. Let me just do this off to the side. So negative 3/2 plus 1, so let's go 2 over 2. If you add these guys, you're going to get negative 3 plus 2, that's negative 1, over 2, so that's negative 1/2. So at this point, let me just get rid of this. Let me get rid of this, and we'll do this like this. So let me put the 0 right here, and let me change this into -1/2. And if you take the absolute value of that, you get +1/2. Okay, so let's think about this. 4 to what power gives me 1/2? Well, it's actually going to be -1/2. So 4 to the power of -1/2 would be equal to, you'd have 1 over 4 to the power of 1/2. So that's 1 over the square root of 4, which is 2. So this right here, log base 4 of 1/2, that is -1/2. Let me get rid of this, and get rid of this. And this is -1/2, like that. So 0 minus a -1/2 is 1/2. So again, you get 1/2 equals 1/2. So our x equals -1/2 and also 0, those are both valid solutions. Of course, we saw that on the graph, but you can also plug in and prove it that way. All right, for question 30, we're asked to solve each inequality, and we have 1/2 raised to the power of 2x times 2 raised to the power of x minus 1, and this is greater than or equal to 4. Okay, for this one, I'm just going to write everything with a common base. If you want to use 1/2, or if you want to use 2, it's really up to you. Just remember, if you have a base that's between 0 and 1, when you set up your inequality, you have to flip it. So to avoid doing that, I'm just going to use a base of 2. I'm going to say this is 2 to the power of -1. That's my 1/2 there. Then raise to the power of 2x, and then times 2 to the power of x minus 1, and this is greater than or equal to 4 is 2 squared. Let me just erase things as I go. I'll just stay on this page. So basically, this would be 2 to the power of, multiply here, this would be -1 times 2x, that's -2x. And then times, this would be 2 to the power of x minus 1, and this is greater than or equal to 2 squared. All right, at this point, we're going to use our product rule for exponents. So 2 stays the same. You're going to add -2x plus x minus 1, and this is greater than or equal to 2 squared. Let me just erase things as I go. So -2x plus x is -x. So this is -x minus 1. So again, because this base right here is the same as this base right here, and again, this is greater than 1, so we can just keep the direction of this inequality symbol. We could say -x minus 1 must be greater than or equal to this 2 here for this to be a true statement. So you can get rid of this, and you can just solve this real quick. So let's add 1 to both sides of the inequality. So we'd have -x is greater than or equal to 2 plus 1 is 3. We will divide both sides of the inequality by -1. And we know that we have to flip the direction of the inequality symbol. So let me write flip so nobody is lost. This right here, let's put as -1. This cancels. So you get x is less than or equal to, again, because we're flipping, 3 over -1 is -3. So we want to say x is less than or equal to -3. That's going to be your solution. Okay, if you want to look at the graph, again, all I'm going to do is subtract 4 away from each side. And I'm looking for where this guy is greater than or equal to 0. So we have y equals 1/2 raised to the power of 2x. Let me write this out. So y equals 1/2 raised to the power of 2x times 2 raised to the power of x minus 1. And then we have minus 4. So what I'm doing here is I'm looking for where the y values are either 0, so on the x-axis, or greater than 0. So basically this piece of the graph right there. So the x values would be at -3 or anything less. So again, x is less than or equal to -3 if you want to look at the solution graphically. All right, let's take a look at question 31. So we want to solve each inequality. So we have log base 2 of 2x plus 3 is less than log base 2 of 4x plus 1. Okay, so for this one, again, if the base here and the base here are the same, and it's greater than 1, then you can just set this guy as less than this guy. Now, before you do that, what I recommend with these problems is to figure out where's this guy defined and where's this guy defined. So you basically need to think about something like 2x plus 3. The argument there is greater than 0. And this guy, 4x plus 1, that needs to be greater than 0 as well. So let me go ahead and grab this stuff. We will definitely not fit that on that first page. Let me put this right here. This one, you would subtract 3 away from each side of the inequality. That cancels. You get 2x is greater than -3. So then divide both sides of the inequality by 2. This cancels. You get x is greater than -3/2. Okay, so that's the first part. Let me get rid of that and move this up here. And so here, you want to subtract 1 away from each side. This cancels. You get 4x is greater than -1. Divide both sides by 4. Let me get rid of this. And basically, this cancels. You get x is greater than -1/4. So because these are both greater thans, you want to take the one that is further to the right. So it's going to include fewer numbers. So I want to take x is greater than negative 1/4. If I took x is greater than negative 3/2, again, there would be some numbers that are included in this that are not included in this, and you need it to work in both. So you just want to choose x is greater than negative 1/4. Again, because it's further to the right. So this is what I want. Okay, let me just box that off. And now let me just solve. 2x plus 3 is less than 4x plus 1. So I'm just going to subtract 4x away from each side of the inequality. This cancels. Let me subtract 3 away from each side of the inequality. That cancels. Let me slide down here a little bit. So 2x minus 4x, that's negative 2x. This is less than 1 minus 3 is negative 2. At this point, I'm going to divide both sides by negative 2. And this is going to flip because we're dividing both sides by a negative. This cancels. You get x is greater than now because this is flipping. Negative 2 over negative 2 is positive 1. So this is 1. So you get x is greater than 1. So you put that together with this where it says x is greater than negative 1/4. So you would say x is greater than negative 1/4. And you'll say that x is greater than 1. Well, 1 is to the right of negative 1/4. So this is what you want to go with. Your solution is just going to be to say that x is greater than 1. You don't need that there because as long as x is greater than 1, you're going to be good to go in everything in your inequality. So let's come back up and say x is greater than 1. Again, if you want to look at this graphically, just subtract this away from each side. You're looking for where the y values are strictly less than 0. So where are you below the x-axis? So here is where we have an x-intercept. Now that's not included here because it's a strict inequality. So basically you're looking for this piece of the graph right there. This piece of the graph right there. Let me do my x-intercept in a different color. This is not included here. So basically where x is greater than 1, that's where the y values are less than 0. So you're going to satisfy this inequality. All right, for question 32, we want to solve each inequality. So we have log base 1/5 of x minus 3 plus log base 1/5 of 2x minus 1. And this is less than negative 2. So now you have to be very, very careful. You have a base here that's 1/5. So that's between 0 and 1, and that's where everyone makes mistakes. So if you're a little bit confused about how to solve this problem, remember you can always use the test point approach. You can solve the related equation, so you can just put that as equals, and then basically you get your critical values, and then you test, okay? And you will not make a mistake if you do that. But I'm going to solve it the other way. So first I'm going to say that x minus 3 needs to be greater than 0, and this 2x minus 1 needs to be greater than 0, so do that first. This, if you add 3 to both sides, you get x is greater than 3. For this, if you add 1 to both sides, you get, let me put and, 2x is greater than 1, divide both sides by 2, this cancels, so you get x is greater than 1/2. Now, which one is further to the right? Well, 3 is, right? 3 is to the right of 1/2. So if you have an and situation and they're both greater thans, you want to pick the one that's further to the right because it's going to include all the values. If I pick this one right here, where there's values like, let's say, for example, 1. Well, that works here, but it doesn't work here. So you want x is greater than 3. All right, so to set this up, let's condense. We're going to go log base 1/5 of, this is going to multiply by this. So x times 2x is 2x squared. And then what we're going to do is our outer and our inner. So the outer is negative x. The inner is minus 6x. So you combine like terms, that's minus 7x. And then the last, negative 3 times negative 1, that's plus 3. Okay, so this is less than negative 2. So here's what I'm going to do to avoid confusion. This is where you have to flip the sign, and this is where everyone gets lost. I think to make it easier, what you can do is write this number right here using a logarithm with a base of 1/5. In other words, if you stopped and said log base 1/5 of what? Let's just say x is equal to negative 2. Well, you'd say 1/5 raised to the power of negative 2 is equal to x. So let's just solve that real quick. So basically this is 1 to the power of negative 2, which is 1, over 5 to the power of negative 2, which is 25. So x is 25. So basically what you can do is write this as log base 1/5 of 25. So this, if you punch it into your calculator, you are going to get negative 2. This base is 1/5 and this base is 1/5. If the base is between 0 and 1, like we talked about in that lesson, you have to flip the direction of this inequality symbol when you set this up. So you're going to say 2x squared minus 7x plus 3, flip this, flip. This would be greater than your 25. Okay, so that's how we set that up. So now what we're going to do is just solve this inequality. Let me grab this real quick. Let me paste this in. Subtract 25 away from each side. 3 minus 25 is negative 22. So minus 22. This is greater than 0. I'm going to start by factoring the left side. Let's set this equal to 0 for right now. This is a 2, so let's go 2x here and x here. When you think about 22, forget about the fact that everything's negative here. Just think about 22. You've got 22 and 1, which is unlikely to work. Then you've got 11 and 2, so I would play with that first. If you put an 11 here, that's not going to work. That's going to be 22. That's too big. So if you put the 11 here and the 2 here, now we're looking at something that would work because this is 4 and this is 11, and you see you have 7. Forget about the signs for right now. So this right here, let's just say this is 4x, and let's say this is 11x. What do I need to do in terms of the signs to make that work? Well, if I made this guy negative and this guy positive, that would work because now I have a positive 4x and a negative 11x. Well, 4x minus 11x, that's negative 7x, and then negative 11 times 2, that's negative 22. So this is what we want for the factorization. So now when we think about solving this, you have 2x minus 11 is equal to 0. Add 11 to both sides. This cancels. You get 2x is equal to 11. Divide both sides by 2. And you get x is equal to 11 over 2, or 11 halves. So one solution is x is equal to 11 halves. Then the other guy, we have x plus 2 is equal to 0. Of course, you can just say subtract 2 away from each side, and you get x is equal to negative 2. Now this guy right here is actually not going to work for us. And the reason is if you come back, you see that x had to be greater than 3. So you can leave it in if you want. That's really up to you. So you can just solve this like you normally would and then come back and combine them and you'll get rid of stuff. I think that's how I'm going to do it so it's not so confusing, or you can get rid of it now. So it's really up to you. So what I'm going to do here is just test and make a little number line here. And I'll say that, let's say my negative 2 is here, and this would be my 11 halves. And so you can call this A, B, and C. And you're just trying to see where this guy is greater than 0. So if I look at things to the left of negative 2, what's going to happen? Let's say I pick negative 3. 2 times negative 3 is negative 6. Negative 6 minus 11, that's negative 17. We only need to know that it's negative. Then if I pick negative 3 here, negative 3 plus 2, that's negative 1. That's negative. Negative times negative is positive. So this is going to work, right? So this is going to be a true statement. That's going to be greater than 0. Then in region B, things are not going to work. So basically you can pick something like, let's say 0. So this would be negative 11, and this would be 2. Negative times positive is negative. That's never greater than 0. So this is not going to work. And then in region C, things would actually work. So you have 11 halves here. And it looks a little bit weird. So let me put 11 halves like that. And basically, if you pick something like, let's say 6, well, 2 times 6 is 12. 12 minus 11 is 1. And then here, if you plug in a 6, 6 plus 2 is 8. So that would be a positive times a positive, which is always going to be positive, and that's greater than 0. So this is true. So the solution as of right now, you would say that x is less than negative 2, or x is greater than 11 halves. Now this is going to get cut off. Let me go back up here real quick, and let me paste this in. So basically what you would do at this point is say the keyword and. So this has to be true. X has to be greater than 3 for these both to be defined. If you put in something like x is less than negative 2, that's not going to work, right? So if you plug that in there, let's say you plugged in something like negative 3, where you're going to get undefined here, and you're also going to get undefined here, so that doesn't work. So basically when you combine these two, if you have x is greater than 3 and x is greater than 11 halves, well, 11 halves is the larger number. It's further to the right, so you just want to go with that. So your solution here would just be that x is greater than 11 halves. So coming back up, we want x is greater than 11 halves. Again, if you want to add 2 to both sides, that way you can graph this. Let me write it out now. So y equals log base 1/5 of x minus 3. Let me slide this over a little bit. Then plus log base 1/5 of 2x minus 1. And let's just add 2 to both sides, so plus 2. So now you're just looking for where this guy right here is less than 0, strictly less than 0. So where are the y values strictly less than 0? Go ahead and look at that on Desmos. So this is what I'm keying in here. Here's where it's going to be 0. Let me use a different color here. That's your x-intercept at 5.5, which is 11 halves. And then basically, if you look at anything to the right of that, that's where the y values are less than 0, or we're below the x-axis. So this part of the graph right there. So basically from the graph, you could say that x is strictly greater than this 5.5 or 11 halves. All right, let's take a look at question 33. And what I'm going to read here, we're basically going to repeat in the next 2 problems. So I'm just going to read this once, and then when we get to 34 and 35, we'll just work off of what we've done here. So we say solve each word problem, exponential growth, this is for doubling time. If the initial size of a population is n sub 0, and the doubling time is a, then the size of the population at time t is n of t is equal to n sub 0 times 2 raised to the power of t over a. Let me make this a little bit better here so it's crystal clear. So it says where a and t are measured in the same time units, so minutes, hours, days, years, and so on. Under ideal conditions, a certain bacteria population doubles every 3 hours. So this, every 3 hours here, this is relating to the doubling time, and again, that's your a. So let me write here that a is equal to 3. Initially, there are 1,000, so 1,000 bacteria in a colony, and when you look back, you say that n sub 0, that's the initial size of the population, so let me write that n sub 0 is equal to 1,000. So we're asked to find a model for the bacteria after t hours. So all you're going to do is plug in the information you were given. And so the model would just be, you have n of t is equal to, n sub 0 is 1,000. So 1,000, just plug that in, times 2 raised to the power of, we don't know what t is, but this is over. For a, we know that's 3. So this would be your answer. You can get rid of this. You don't need it anymore. Get rid of that and move this over here. So we're looking for this one right here. So n of t is equal to 1,000 times 2 raised to the power of t over 3. All right, for question 34, I'm not going to reread this because we did it in 33. So it says, how many bacteria are in the colony after 15 hours? Again, what we came up with in the last example, we had n of t is equal to, we said it was 1,000 times 2 raised to the power of t over 3. So all we're doing here is we're saying, if I'm plugging in a 15 for t, that's the time. We're just going to plug that in and evaluate. So in other words, I'm saying, what is n of 15? That's all I'm doing. So this is 1,000 times 2 raised to the power of, for t, you're plugging in a 15 over 3. And so 15 over 3 is 5, so you can just simplify that. And basically, we know 2 to the 5th power is 32. So all this is 1,000 times 32, which is 32,000, so you don't even need a calculator. So it's going to be this guy right there. All right, for question 35, so about how many hours will it take for the bacteria count to reach 100,000? I told you here that your answer will be an approximation. So just using what we did earlier, again, n of t is equal to, you have your 1,000 times 2 raised to the power of t over 3. So we want to know how long or how many hours, that's going to be in terms of t, will it take for the bacteria to reach 100,000. So in other words, where will this left side be 100,000? So let's write 100,000 is equal to 1,000 times 2 raised to the power of t over 3. Okay, to solve this for t, the first thing I'm going to do is divide both sides by 1,000. So we know that this is going to cancel right here. Let me slide down. We'll come back up in a moment. So 100,000 divided by 1,000, you could just say that this is going to cancel 3 zeros away. So basically you would have 100 is equal to 2 to the power of t over 3. I'm actually going to get rid of all of this. We don't really need it anymore. And let me bring this back up like this. And basically, if you want to solve this for t, what you can do is take the base 2 log of each side. So we'll do that. We know that log base 2 of 2 raised to the power of t over 3 is just t over 3. Let me write that on the left. So t over 3 is equal to, you'd have your log base 2 of 100. So multiply over here by 3, multiply over here by 3, and this would cancel. And so we're going to get an answer here that is t is equal to 3 times, let me make this 3 better, your log base 2 of 100. Let me get rid of all of this. And this is something we're just going to punch into the calculator. We'll figure this out. So let me bring this up here. If you want an exact answer, this is what it would be. So I get about, let's say 19.93, around to the nearest hundredth. So looking at the choices, it's going to be this one. So we'll say about 20 hours. It's very close. So about 20 hours for the bacteria count to reach 100,000. If you want an exact answer, you would say 3 times log base 2 of 100.